What you're seeing here is a mirage. We typically would not be able to see this from the Lake Michigan shore. We talked about this last night. Conditions are right on the lake that we're actually seeing a mirage of the Chicago skyline.
We've covered presupposed Earth radius, pressure without a container, angular resolution, perspective hijacking Earth curve. We've covered Boyle's law. We've covered diffraction limit. The one thing we haven't touched on was mirages. Give us the most ridiculous excuse of a mirage that you've had.
Well, the mirage is an interesting one, because this is probably one of my favourite points to make as a flat earther, especially when someone says there's no proof of flat earth. So I'll give you an example. We'll use Ranty and one of his images. So he has a picture of a clock tower at about 20 miles at Barrow-in-Furness, and it's just a picture of a clock. Now, as a flat earther, I look at this picture and say, clock at 20 miles. That's the end of my explanation. As a flat earther, I can make that statement. I'll say it again. Clock at 20 miles. Now, if you're a fundamentalist religious zealot, then that's not a clock at 20 miles. That would be a slightly looming, non-standard refraction hyena holographic projection of a clock from behind the reified edge of a sphere based on an R value and a begging the question proof of nothing perspective hijacking curve calculator to turn a clock which seems to be there into a clock which is not actually there. That's what you have to assert if you're a globehead. So it's not a clock, it's a holographic projection of a clock from behind the reified edge of an Earth curve based on a begging the question proof of nothing perspective hijacking curve calculator. As opposed to me, that's a globehead explanation. I say clock, 20 miles.
You're the man, Nath. You are the man. I love the way it's the way you it's the way you say it. It's the way you say it. It's just you serve people like the Wimbledon final beautifully. It's poetry in motion. It genuinely is.
It is.
That's soundbite classic.
It's not like we're sending people to the moon, but we act like we do.
Gravitation is a theory. You are not spinning round on a giant blue mama greater than the speed of sound. They lied about Apollo. Just look at the lunar lander. The fake moon rocks giving out. Just take a fucking gander. No slander. This is real shit. They lied to the world then. Hollywood got you believing in the completely pretend. A hoax, a joke. At the expense of us all. How many countless trillions go to the cult of the ball? No money for all the problems we got right here on Earth. But getting scammed for every single penny they think we're worth. Water seeks its level. And nature abhors a vacuum. Question everything you got taught in the classroom. Who cares if you're laughed at by those who lack awareness? We were all there once. Try to be strong and bear it. I swear to God, the single root of human incompetence is to claim as fact another hypothetical preponderance. What do you believe? Where does this life lead? What does it mean to be alive in a dream? And not everything is something you can conceive. Take a minute to breathe and tell me, what do you believe? What do you believe? Where does this life lead? And what does it mean to be alive in a dream? And not everything is something you can conceive. Take a moment to breathe and tell me, what do you believe?
Incredulous postulates got you acting obstinate. It's monstrous, the overconfidence you have in flatulence, and blasphemous, the adamance behind your haughty arrogance. Belief is the polar opposite of true cognizance. It's perilous, believing what you want without evidence, and decadent, thinking that your eminence is heaven sent. It's evident for betterment, your time would be better spent pondering possible parallels for parables. Rather than assuming that your ass is an arable, it's terrible. Conversation has become unbearable, and soon your whole thought process will be narrable, cause every word out of your mouth is inferable. From a literal interpretation of the biblical, it's critical, and at the very minimal divisional, claiming that your miracles are anything but mythical and fictional. Walking on water's not empirical, it's mystical. Talking snakes are meant to be cryptical, you imbecile, it's pitiful and bordering on criminal, episcopal, rabbinical, pontifical, subliminals, inimical, despicable, while taxing all that's tittable, dominical domination of the archetypical. You hypocrites know that the book is metaphysical, but still you will claim a staff changes to a snake just as readily as Moses to the pharaoh dots fake. In reality, this fallacy was known before Christ, that the snake is kundalini and the staff is your spine, even though you know damn well oceans can't bend. You believe Jesus walked on them straight to the end. Yeah, I got a big beef with belief, let me tell ya. The lie in the middle of the words, what they tell ya. Believing's what you do when you really don't know. Lying to yourself in order to bestow truth on the things that you really can't show. Stunting your thoughts so your mind can't grow. Believing's what you do when you really don't know.
Right. So flat Earth claim number one, we see too far. There's a prediction, a little bit of math at distance, things should disappear underneath the curve of the Earth, and there should be nothing to be seen. Ultimately, we see further than this prediction. We can see things at 20 miles away when we shouldn't, 30, 40, 100, 1,000 miles away, depending on the technology using and depending on our altitude. Long distance observations demonstrate that we see too far. That's literally first claim. We observe always the Earth to be flat.
Well said, sir. Well said.
Right, you know maths and geometry, right? We're on a ball.
Okay, I'm not gonna lie. I'm not very good at like maths.
Well, no, that's why I'm going to break it down to you. We're on a ball.
Cool.
It's a shape, right? You have to understand that maths can apply, and we can figure things out. You know, the radius, the diameter, the circumference. The radius, the point from the middle to the outside, the diameter across the whole of the circle, and the circumference all the way around. These distances. Now, if we can use math to figure out the drop on say, a curved surface, you at all times, standing on this ball, from every direction away from you, should be curving down. With distance, it's always going down and away. And that means we can use math to figure out what drop in point A, U, and point B, a thing at distance. The calculation is very simple. It's 8 inches per mile squared. Sounds complicated. I'll break it down for you.
So, wait.
I'll try it,
Can I
my
say
friend. Yeah, go on.
Right.
I'm blasting you. Go on.
So, like, at every curve, yeah, you get pi and then you time, like, you square it by the radius and you divide it by 2. Is that what you're trying to say?
Well, at least you know what I'm talking about. You know that maths applies when we're trying to figure out something that applies to geometric shape. So we can figure, like I was saying, between point A, U, on top of the ball, and point B, the thing at distance. The distance, 8 inches per mile squared. So you have to remember it gets worse and worse and worse, further down and down and down, because it's a curve, right? Not a slant, not a hill, a curve. So 1 mile over a water body, say the sea or a lake or something that is water. After 1 mile, it's 8 inches of drop. After 3 miles, it's 6 foot of drop. After 10 miles, it's 66 foot of drop. So very simply, this is something that we should observe, we should be able to measure, and we should be able to practically use. But with this, the observation will dictate to you what you cannot see at distance. Long distance observation supersede this prediction of the ball in sometimes by 100-fold. We see far too far for any explanation ball Earth can give us. So flat Earth claim number 1, guys. You see too far.
I get... Oh, shit. Yeah.
What you also have to remember is this is done over water. Now, water is very specific within this argument because when you have a body of water at rest, say within a cup or your bath or a swimming pool, it's level, right? Apart from the ripples, water is level. We use water level as a tool to find level. We build upon a level, for example. But water is very specific. When it's contained, it is level. What they've got you believing, us and everybody else, is this water level doesn't apply now when you are on a ball. There should be curvature over this water. 71% of the Earth's surface is water, so it should be conforming to the curved shape of the Earth. This is where the geometric calculation about inches mass squared is most relevant. Long distance observations over body of water supersede the prediction. Flat Earth claim number 1, guys, we see too far.
But wouldn't this be a thing about perspective?
Perspective?
Yeah.
Yes, absolutely, because you see the whole world in perspective. So when you make the observation, you are most definitely taking a perspective into account. Perspective works like this: angular size. Put your hand in front of your face, right? It looks big, it's covering all of your eyes, the full angle that your eye can consume. Move your hand further away, it reduces the angle that your hand displays within your eye. Because it gets further away, now, as your hand has not actually changed, you observe it to change size. It apparently changes size.
Our eyesight is unreliable?
No, it means that our eye limit, we have a limitation to how far we can see. Now, ultimately, when we make an observation, we see with our eyes and we move to binoculars, a telescope or a camera with a zoom function, for example. With high-powered optical equipment, we see far too far. So yes, we do have a limitation with what we can see with our eyes, and we will always see things in perspective. And perspective must be accounted for when observing things at distance. Perspective, weird things happen, for example. It makes things appear to ascend from one horizon and then descend down to another horizon. But you know that this actually isn't taking place. For example, a cloud or an aircraft hasn't changed its altitude above the surface of the Earth. It appears to you to rise one horizon and then descend down to another horizon after it's passed over you. It appears, perspective must be taken into account.
I guess I'm just...
You're roboting.
You're roboting, Dad.
The gypsy.
Hey, big man, where's that robot in Discord from?
The gypsy could try disconnecting and reconnecting. That usually helps.
Okay, it helped. Thank you very much.
There's 2 of them in this group, isn't there? One sounds like it's from Birmingham.
Swan Storms and Wangtress sound very similar.
Hello.
Yo.
Can everyone hear me?
Yeah, we hear you.
Hey, Swan Storms, you gonna go to the pub tonight?
Alright, you two, after you got Nando's, you can come off here then if you're gonna mess about.
I'm actually not missing.
No, I'm just asking. I know Mirages.
On a serious flip, sound like you're having a job controlling us. So
I'm not.
Why would we do that? Okay, why would we do that though?
Hold up. Yeah, before we get off track here, we were just answering some questions about the shape of the Earth. So if anyone has any questions, we can get right back on topic because we're not going to veer down this rabbit hole. We're going.
Yeah, I'm still curious about.
To be honest, I'm really considering just banning some people because I've never seen Jedi so calm and nice that I want to be like, fuck these guys right now.
Yeah, it's okay.
Oh, I haven't said
Yo,
anything
Happy,
bad to them. What's going on?
Yeah,
Lambo, why
Happy,
you
did
getting
you?
on
Oh, I'm
Twitch?
sorry. Yep, you can be quiet. Yeah, Happy, did you have a?
Hey,
Whoa.
what?
Okay, you can
Oh,
go.
yeah,
ahead.
I might just jump out my window right now if I'm swear down.
Alright,
well,
man,
you
this
can
man
do
get
that.
originals. That actually get me started.
Oh, yeah.
Okay,
Yeah.
you're muted, boys. You're muted, so don't waste your breath.
Go on, Happy. What was your question, or whoever was asking?
Oh,
Somebody else
okay,
can answer it.
cool.
I've spoken.
Me.
And you're
I was
super
wondering-
quiet, Happy. Can you speak up a little bit?
Sorry. Yeah, sure. So I was wondering about the perspective thing and how we can't know things from other people's perspective. So if we were on the globe Earth, and you're saying that it would dip down on like all around us, if we were on a globe Earth, but like we don't have something to scale for something that small. If it was on Earth, that would make it look flat.
Right.
I've been thinking
I'm
about this.
going to break this down for you very simply. Get a ball, put your finger on it. Right. From every point downwards, every point at distance, it's curving downwards. Relative to your position on the ball, every surface is curving down and away. Because it's curving down and away, you can mathematically figure out how much drop over distance. With a thing at distance of a known height and your altitude above that surface, you can mathematically figure out how much you can see at distance. This is the prediction within the ball Earth model. So perspective is and isn't taken into account with this, but ultimately we're figuring out the drop between you, point A, and every surface descending down and away, point B at distance. The curve of an arc.
Yeah.
So perspective, things will get smaller at distance. Of course they do, right? The car hasn't got smaller, it's just looking smaller. Now, with distance, angular size, and that's all it does to you, the observer. So no, we're not taking anybody else's point of view into it. This is how you see the world. You see it in perspective, right?
Yeah.
So when you observe the Earth, things just get further and further away until you can't see them anymore. Not because there's a curve in the way. Curvature of the Earth does not and is not the cause of things reducing in size, is it? It's just distance.
I see your point.
Oh yeah, and you ain't moving either.
But how would you know if we're not moving?
How would you know that we are? The claim is against what you observe, or what you feel, or what the Earth displays. The Earth displays no movement, right? So the claim is that it does. Where's the proof?
Pardon?
You said where's the proof?
Oh.
The burden of proof is on the assertion against what you observe at this point, and what we all observe, and what the Earth displays, no movement, right? So the burden of proof is on those who assert that there is movement. So where is that proof?
But like, it's just another thing about perspective.
Yeah,
Like,
that's it.
when you're on a train, you don't feel yourself moving unless there's acceleration. And
Right.
people
Well-
outside would say that the train is moving.
I'll answer that.
Okay.
It's just-
Yeah.
So, it's just not analogous, right? Because that train is not exhibiting the movements that they're assuming, right? So, yeah, you have the forward momentum of the train. However, that train's also, if the analogy were to be correct and on point, it would be that the train would also be spinning and moving in a direction, which would create a vectored motion, which you would surely feel because they're two separate conflicting motions. So, I mean, I get the whole train analogy thing. Yeah, you don't feel movement on a train, but again, it's just not analogous to the situation of the Earth spinning, moving, rocketing around the sun, and all of that. So, I mean, yeah, the acceleration, yeah, but even in our model, right, the heliocentric model or whatever, we are accelerating, but you still don't feel anything. Does that make sense?
Accelerating how?
Well, they have it in the model that we are basically in an elliptical orbit around the sun. Okay, and by nature of an elliptical orbit, that constitutes an acceleration, right? Because it's not a perfect circle. So at some point in that orbit, you're going to reach the perihelion, aphelion tangent where you're going to be flung around, right? So there's always acceleration and deceleration going on.
Every 3 months.
Yep. Yeah, but you going back to the point is you don't feel anything, right? Your senses tell you you don't feel anything, right? There's no movement or motion that you feel, right? So again, going back to the assertion and the people making the claim that we are moving, we need proof, okay? Because they're asserting that we are moving. So that's true. What's the proof?
Oh, I see. So you believe the Earth is spinning, but it's also spinning around the sun.
No, I
No.
believe the Earth is stationary. The Earth has actually never moved an inch. Never moved an inch. Ever.
So
The Earth has remained. Huh?
Where's this? Oh, the sun's spinning around the Earth. not
Everything.
Above.
Right.
Yeah. You look up into the sky. Sorry, it's very simple. The floor's on the ground and it's level, and the sky's in the sky. You look up; those are the lights that are in the sky, not underneath you. Up in the sky, right? They move around the North Star, Polaris, and they go from east to west in circular pattern. The sun and the moon come from east and go to west. They come around, give their light, fuck off, it's night. Come back again, here's day. That's what we see. That's what's been observed for thousands of years of stellar observation. The lights in the sky revolving east. That's what they do. Point up, there they are. They're not underneath you. There's not people underneath you in Australia, right? Well, we're going to get to the isn't, but that's what they've got you believing. That's what you think. It's not true. Everyone looks up into the sky and they're alive. There they are, up in the sky. Up is relative to everyone. It's the same fucking up to all of us. It's not out. It's not outwards whilst we're, you know, we said this movement, right? Think about it. Why wouldn't we feel it? It's going in every direction. Have you ever been on a teacup ride? Yeah? You're spinning, you're orbiting an elliptical path, and you're fucking off with the sun in a direction at 500,000 miles an hour, corkscrewing with it. Now, are you trying to tell us that the Earth, fuck you, whether you feel it, the Earth with all of that water, with all of that water attached, would remain attached? And not just attached to it, freely flowing tidal water. Storm systems and perfectly calm lake days. Water is just on the surface of the Earth. It's not going anywhere. Doesn't display like it. Doesn't display like it to me. It would most definitely act differently if it was going around the universe at almost 2 million miles an hour in multiple directions whilst you're spinning. And don't forget, it's 1,000 miles an hour, which is more than the speed of sound at 700 miles an hour around the equator. Move north or south, you slow down, and you're trying to tell us that, okay, in this instance, there's no acceleration or deceleration. Depending on your placement on the ball, you're either in front of it or behind it. It's either pushing up underneath you or in behind, right? Because it's going in a direction while spinning and go. Freely flowing tidal water, calm lake. Now, the Earth doesn't display that it is moving. So where is the evidence that it does? Why do you believe that the Earth is going somewhere? Why do you believe the Earth is a ball?
One happy, and you may not have this evidence, and that's fine. You know, this is why we ask for it. That's fine. You know, maybe take a week or two, or maybe research it. Maybe you can find some evidence that the Earth does, in fact, exhibit motions and spinning, and maybe you could present us to that. We're not asking you like right now, right here. You know, just take a time, chew it over. You know, ask your friends, ask your teachers. I don't know. You know, well, we're all ears, and I'm open for evidence, and you know, that's why we're here. We want to hear what you have to say.
I don't really have any proof for anything that I know. It's all just fed to me, like you guys say. But I just mainly have questions about like how you explain certain things.
Well, if you don't have proof, then you don't know, you believe in it.
Pardon?
If you don't have proof, you don't know, you believe. Well, like I said, you got fed, they told you this, but you don't know this because you don't have any proof. So,
Has proof of anything.
I mean, you should have evidence of something, at least. Other than that, it's just faith.
We have evidence that the water is flat for many miles more than it should be because it's been measured. No, it's been measured with instruments, laser tests, laser lights that shine out in a straight line. There are measurements that have been taken place, and it has gone way farther than it's supposed to. There's more than one test that have been done that proves that the water is flat, and one of them is a laser test. Another one is that it's telescopes. You set a telescope on a tripod up on the beach, and then you can see an island that's 50 miles away. And at 50 miles, it should be over the curb like a half a mile or something. I mean, I don't know the exact calculations. I would have to get my calculator out and whatnot. But at 50 miles, there are land masses that can be seen through a telescope. And there are targets that can be hit with a laser beam. And if it was over the curve, that would be impossible. So we do have some evidence. Yes, we do. We do have those types of evidence. They don't prove the entirety of the flatness of the Earth, but they do prove that it should be way over the curve when it's not. So we do have evidence.
I mean, the black swan is complete evidence where you can see the horizon way further than it's supposed to be on a.
Exactly. That's another one.
So from your understanding on water, how does it work? You fill a cup up, it's level. You fill up the bathtub, it's level. You go to the swimming bars, it's level. A lake is level. When does water start to curve?
I mean, you put a rock under it, it still stays level. It doesn't take the form of a rock.
In your imagination.
Where the water curves?
So Happy, what they're saying is that in reality, when we look at water, like if you were to go to your kitchen and pour yourself a glass of water, the top is always going to be level. And every other body you've ever seen in your life has always stayed level at the top. That's just how water behaves. But they told you gravity is keeping all of this ocean water curving around a ball, but like you've never experienced or seen that yourself. You're just believing that it does that. But
and with water being level, right, and it covering 70% of the Earth, the sphere model kind of doesn't make sense.
Yeah. And like when they measured it, like they realized, oh my God, water does what water does. Water remains flat all the time. Which isn't really a stretch if you thought about it, right?
And what's really interesting about water is if you were to measure curvature, the most easiest place to measure consistent curvature should be water, because water should be getting pulled by the center of mass by gravity, right? It should be conforming to the exterior of a ball at a certain rate, right? Curvature rate. Yeah. And that's why there's the laser tests are very good indications that there is no measurable curvature for the globe day claim, at least. At least in my eyes, the WGS-84 model has been thoroughly debunked with laser tests and long distance observations, and the black swan. It's just destroyed. Would you like me to talk a little bit about the laser test itself and go in a little bit more detail on it?
Yeah, sure.
Okay, so you kind of get the idea of shooting a laser across a large body of water, right? It's supposed to work like a straight edge. I'll give you an analogy that might be a little bit more easy to conceptualize. Like get an orange, put a ruler on the orange. At some point, that ruler is going to diverge away from the orange, right? It's going to get to a point where the orange is just not touching it no more. So that's the part we're measuring, that rate, right? Now, the laser is about a 0.08 millirad, which I'm probably sure you don't know what that is. A lot of people don't. I mean, I didn't even know what it was until not too long ago. The MRAD scale gives you the ability to calculate like the divergence of the beam, like depending on the distance it's going. For this 25-mile test, I believe the 0.08 millirad divergence is close to 3 meters of width. So we can calculate that. Like we can know that the beam is going to spread 3 meters, right? Now, the laser is sitting 2 meters above the, 2 meters above sea level, and it's being shot at 6, 12, and 41 kilometer targets that are 1.5 meters of elevation. So that means there's 3 points of observers that can see this horizontal pan of this laser, right? Now, on the furthest distance at the 25-mile mark, the shortest target on the WGS84 model, which is the oblate spheroid model, is 90 meters. That means in order to observe that laser on line of sight, straightforward, would have to be 90 meters of height, but the people are at 1.5 meters. Now, that's a big discrepancy right there, over a large body of water. And if we even gave the standard refraction model, because I know a lot of people argue that refraction could cause the laser to bend down and make it be observable by the observer, if we gave you the 7.6R standard refraction, that would only shave off 5 meters off the observation, making it an 85 meter, right? You'd have to be 85 meters of height to see it. So that's still not even close to 1.5. So based on all these observations and measurements, the Earth is definitely not the size they claim it is.
Do you know what he means when he says 85 or 90 meters observer's height? You understand what he's talking about there?
Observer's height?
Yeah, I'll post a picture real quick. I'll let you go continue, God's Rocket. Let me just post a picture so she can see the reference. Continue.
You get 3 feet per meter.
Oh.
So basically you multiply the number of meters times 3 to get the feet.
Hello,
roughly.
Rockin', how are you?
Anyway, what that 90 meters is that's the distance that the Earth would have fallen away on if it were a globe. The globe that they say it is, there's a calculation that can be used. The curve calculator can tell you how far down over the curve you should be. And if you're at 25 miles, you should be 90 meters, which is what? How many feet is 90 meters? That's 3 times 9. That's 270 feet. So that means that you would be 270 feet over the edge, and the laser beam would be 270 feet above your head if it were on a ball. If you were on a ball and you were trying to get this laser beam to hit you in the face so you could see it, if you were on a globe, you'd be 270 feet down if the laser beam were shooting straight out over a curved surface. But instead, what's happening is you're being able to see the laser beam at about, like he says, the laser beam expands in size because it comes out of the laser about 2 inches around. By the time it goes 25 miles, it's like 3 meters wide. So the beam does get bigger, but it's 3 meters. It's only like 10 feet, which you're supposed to be 270 feet down over the edge. So this 10-foot size beam really doesn't make that much of a difference. It's still pretty much a straight line. So the only way that you can see that laser beam is if you are up on a level surface, and you could be 10 feet lower than where the laser beam is set, but you couldn't be 270 feet. So the discrepancy is only maybe 10 feet. So basically over 25 miles, it's pretty much flat. Yeah. And in reality, it is actually flat.
Yeah,
so
well said. The one thing I wanted to add to that is so just happy if you could picture it. If you imagine wherever anybody was standing, they're standing on top of the ball. You know what I mean? Because if it's a ball, wherever anyone is standing, they're standing on the top. And if you were standing at the top of a ball with a laser and you shot it, then obviously it's going to shoot a straight line, especially if you leveled it. But then the part that's supposed to be going down and away on a ball, that's never been found anywhere. And that's a big deal, right? Because it's supposed to go down and away if it's a ball.
Over the curved arc, so U, point A, over the distance of that arc to point B is always descended down and away.
Remember the claim when they say boats go over the curvature, over the horizon? That's what they mean.
Yeah.
But it's not actually happening. Boats are not going over the curvature. It's optical.
Yeah.
So what do you think? Do you understand the geometric problem here, Happy? Do you understand what we're trying to...
Yes, yeah.
Okay.
Yeah, because there's numbers, Happy, that they give us that they say this that are the measurements for this globe. And so you were saying, you said something earlier, like, how can we know anything? Or, I don't know if that was your exact words, something like that. Yeah, the thing is, I mean, what people have been trying to explain to you is there's some things we can't know. We can't go to this alleged place called outer space that we can actually explain to you why it's impossible for that place to even exist in the way that they say it does, due to them claiming that it's a vacuum. So yeah, we can't know anything about that. That's the whole problem, is we can't verify a lot of these stories and images that they're giving us. But what we can do is take these numbers that they say is the size of the place we live, and then we can test them in reality and see that we observe things and see things in the distance that we wouldn't see if it were the way they said. So that doesn't mean that we know definitely how it is, or everything about the earth, because we don't, because we have a lot of limitations to exploration. But we do know that it's not the model that they give us. The globe model fails. It doesn't predict what we see. Does that make sense, Happy?
Yeah.
What does it make you think about?
Like, it makes me think how a globe earther would combat that laser test thing.
Yeah.
Doesn't,
Okay.
sorry.
To be honest,
It doesn't have to be a laser. Right now, we understand that light through a medium is going to wiggle and bend a little bit. We can observe this with like time-lapse footage over a distance of water. Like we have a meme here, or a GIF, Skunk Bay. It's an observation, right, over a distance of water to land masses. Some in the near ground, some in the mid-ground, background. Now, with time, the atmosphere changes and things undulate. Basically, what it appears to do. But ultimately, the things are actually directly in front of us. And depending on the atmosphere that we see the light through, it's going to wiggle around a little bit to our observation. So remember when you said earlier we must take perspective into account? Yep. And we must also take in the atmosphere into account. But it's easier to understand that the object we can or cannot see, depending on the air clarity, type, moisture, heat, cold of the day, it will change every observation as time-lapse footage demonstrates. But the objects that we see are still directly in front of us. It's much easier to understand that. But you said the argument with lasers, you can take light out of the equation completely and use beam propagation, signal propagation, radar, for example, things that beam signals from one place to another and then come back again. Now, this doesn't refract through the atmosphere because it's not light-based, right? It's a signal that's progressing through the environment at distance. Now, this is not going to be affected by the curve of the surface it is going over, just going to go direct. But ultimately, it's not going to start bending around corners either, because it just goes out and spreads outward. Because that's what it does. And when you narrow the beam, obviously you narrow the angle and you can beam it anywhere. But ultimately, this type of technology has existed since the Second World War, when we start talking about radar, when we start talking about, like I said, beam propagation and military targeting systems don't rely on laser light, they rely on beam propagation. Now, these distances can go up to, I'm going to give you a conservative estimate of 10,000 miles. I know it's a little bit further, but ultimately it's broken in half. It's, say, 6,000 to 8,000 miles to send a radar out and then get a ping back. It's much easier to explain this on a flat surface. We have a direct line of sight, and it is impossible on a curved surface. So you get a ping of an object 6,000 miles away, where it should have descended by hundreds of miles of curvature, and then get it back again. So this technology exists, and it's prevalent now with militaries, but it's been around since the Second World War. So yeah, you can talk about light, but we use beams and signals and shit.
What he's talking about is microwave.
Yeah, those types of things. There's a guy called Marconi, might ring a bell, communications expert, right? Can give you information that he sent signals over 10,000 miles. This was back in the early 1900s. Not possible on a curved surface. Now they say that they can bounce beams off ions at an altitude of about 70, 100 miles, something like that. Fine, and what? Doesn't prove a curved surface. You can still hit things off of that, right? It's not a problem if it's there. But to have beam propagation off of a curved surface, especially when you're getting radar pings, it's not the way.
Yeah, there's a microwave transmission that's 100 miles, and they have to be point to point. They can't. And microwave transmission for communications doesn't curve. It's a straight beam, like he was just explaining. It's a microwave transmission, and it has to travel in a straight line from dish to dish. And they've got some that are. I know of one that you can look up, and it's 100 miles. It was a world record at the time. And over 100 miles, that would be so far over the curve, there's no way you could hit the other ditch. There would be no communication. That's kind of what, I don't know if that helped explain it, but that's exactly what he's talking about. These technologies are like microwave communications and radar communications. So if you want to try and see if there's a ship out there, you send a signal and it bounces back to you so you can see that there's something out there for military targeting.
There's a technology back in the Second World War, developed from the Second World War, called the RAN. Probably know it better today as GPS. Ground positioning system, global positioning system, whatever. It's on the floor, right? Now, this goes up to 1,600 miles from a mile, so a boat knows where it is. It's been around for over 80 years. It's not going to work, and does not work on a curved surface. See, it's interesting as well when I said earlier that we observe it, we measure it like we have with the lasers. We don't practically use a curved surface, right? So this is demonstrated when we talk about when you send beams around, microwaves has just been explained, TV antennas, from the 40s, 50s and 60s, because that's predominantly what was going on before satellite dish. I love that one, because that's still pointing at an aerial on the floor or an antenna on the floor. So, yeah, whatever. But ultimately, beam propagation across the Earth is only limited by the power and the type of beam, VHF, microwave, whatever it is. But ultimately, curved surface is going to interfere with that stuff. Topography interferes with that stuff. Mountains and shit, right? So the curved surface of the Earth is most definitely going to interfere.
if I drop a bar of lead in, say, mercury, or let's use water. If I drop a bar of lead in water and then an egg, why does the bar of lead drop faster than the egg? They're both denser than water, but one falls faster than the other. Why don't they do that in air? I mean, that's perceivable. You can measure that. So if it's density that's causing the speed at which it accelerates, we should be able to see that in air as well as in water and any other.
Holy crap, dude. Dude, I could have sworn that I already gave you props that you were intelligent, but now you're going backwards.
You did give me props that you were intelligent? I thought all you guys were telling me I'm a fucking...
Were you not paying attention? I mean, dude, look, the problem here is that you're not paying attention to what me and you are talking about. Me and you both agreed that those two things are separate. We already agreed that things go down because they're more dense, period. And we already agreed that the acceleration is separate. So when I'm saying things go down because they're more dense, I'm not explaining the acceleration that you allege exists and that people generally agree happens. They're separate.
Okay. All right.
What I'm telling you is that everywhere we go, we experience down. Everywhere. Ubiquitously, we experience plumb and level. That being said, if you create a matrix of plumb and level, right, you have two axes where one of them is a flat horizontal plane. Therefore, the Earth's a flat horizontal plane. I rest my case again. So my case is rested 3 times, and I'm very well rested. So now it's fresh and ready to take on the day.
You must be rested as hell, dude. I wish I could get that good of a night's sleep.
Yeah, so what we're all trying to wonder here is why the heck in the God's damn earth are you talking about gravity on a flat Earth server?
I don't know. I like talking to you guys. You guys fun.
Yes, but the point I'm trying to make is gravity has nothing to do with the shape of the Earth, brother. Nothing,
right.
Period. Nothing. Zilch.
I'm still going to do this experiment, though, just for the fun of it.
You can do whatever you want, bro. Then I behoove you to do so. But simultaneously, you need to work on your logic skills in understanding why things are or aren't relevant to the point. So gravity has nothing to do with the shape of the Earth, period. The end. Things falling down has nothing to do with the shape of the Earth, period. The end. Why they accelerate has nothing to do with the shape of the Earth, period. The end. So unless you can present a logical contingency of a necessity where the conclusion follows from the premises which are proved in the first instance, that the necessary contingency of the phenomenon of things falling down requires a globe Earth, then my premise stands that plumb and level prove we live on a horizontal plane. Because that is ubiquitous human experience wherever we go. When I go to Florida, it operates the same way. When I go up north, it operates the same way. Where you live, it operates that way. Where Homeboy in England lives, it operates that way. Where every single person present here today, whether listening or in the chat, it operates the same way. You admitted it operates that way. Therefore, you concede the Earth is a horizontal plane. Welcome to Flat Earth. Snacks are in the back. Bathrooms on the right. So who's next?
Come on, I'll round them up. AI swinging punches, mate. Yep, I'll round them up.
So when it comes to talking about the shape of the Earth, how about bring something relevant, like demonstrable measurements of Earth's surface curvature? That'd be cool. Now, don't get me wrong, I don't mind you guys talking about gravity, but eventually I'd like to get to the shape of the Earth. Went to a flat Earth server. All I talked about was gravity.
Man, I've missed all of it because my internet sucks. But there's somebody that is missing me.
Yeah, to our friend who we were just speaking to, you don't have to stop speaking just because I proved the Earth was flat by the evidence you presented. We can still talk. We can still be buddies.
Oh yeah, dude. We're pals. I'm not upset. I was sorry. I was working on trying to design this little circuit that I was working on. But no, I don't. Obviously, I still disagree with you. But that's okay. We can disagree and still be friends.
Oh, God. Having my way. Disagree. How can you disagree with that?
We go tit for tat. We have our little differences. But at the end of the day, you win some, I win some, and there's a mutual respect left over between us. Any respect that you're feeling that's coming from me is a mistake on your part. Then I'll just regress, because I feel like I made myself perfectly redundant. Yes, you have.
I think you mean to say, I do not concede, not I disagree. Because disagree has to do with opinion.
Sure. Yeah, I do not concede.
Oh, excellent. So you have an extraordinary claim on the table. Okay, so my claim is ubiquitous with human experience and demonstrable at all points in reference. Okay? Your claim now is that plumb and level are actually curving around a giant floating space thingy. So now, my friend, where's the evidence for that claim?
Sorry. Well, I hate bringing this one up, but like, it's the easiest one. Pictures from the orbit of the Earth, which you guys will obviously say is fake. Fair enough. But, you know, there's live streams from the ISS. There's a rover on Mars. You know, you guys will obviously say that's fake. That's fair enough. But prove to me that it's fake. And then
Okay, well, hold on. I need to hear the first one you said again because it cut off. So you said three things. I need the first one again.
I said there's images of the Earth from outer space.
Okay, images.
Not exactly what I said, but
close enough. Images, and then the second one was ISS, and the third one was a rover. Okay, perfect. So the alleged images of the Earth from space, okay, are unvalidatable.
How?
The rover being on Mars is unvalidatable. So those two can be thrown out, summarily dismissed. Now, ISS. Okay, so the other two are unvalidatable. If you don't understand how they're unvalidatable, right? Then I don't know how to help you. We can talk about that later, but let's talk about the ISS first. So I don't have to respond to your points in the order in which they're given. Okay, you didn't preface that. That's point 1, point 2, point 3, requirement of in order succession. So I'm going to do the ISS. So
perfectly fine.
Even if the ISS is where they say it is, right, which is a distance away from the Earth, what does that have to do with proving the shape of the Earth?
They claim it orbits the Earth.
Okay, so claiming it orbits the Earth is just a claim.
So you're
how does the claim that it orbits the Earth prove what the Earth is?
So if it were to, so an orbit usually means going around a circular object, I guess.
Mm-hmm.
Right? I don't think if the Earth was flat, the ISS probably couldn't orbit it.
Right. So then you have circular reasoning. The ISS proves the Earth is a globe because it's alleged to be orbiting, and the word orbiting in this connotation means going around a giant floating space ball. Therefore, the Earth is a giant floating space ball. That doesn't follow.
So no, there's images from the ISS and a whole bunch of other space telescopes.
All right, stop right there.
Circular.
Stop right there.
Okay.
So we have images from the ISS doing what?
We have images Of the ISS doing what?
What are the images doing? What are the images showing? What are the images
The
proving?
images show the Earth as circular.
No, they don't. It's categorically false.
Okay.
Let me tell you why.
I know why. Because from
ISS,
a two-dimensional image, you can't perceive 3 dimensions, but you can if there's a succession of images.
Stop talking. For goodness sakes, dude. We only want to focus on one thing at a time.
Okay.
Okay. A circle is most definitely two-dimensional. So you can't say that it's because it's a 2D, 3D problem. What I was going to say is that the ISS is not at a sufficient distance to have the Earth in full frame, and therefore it can't show the Earth as a circle. Which you agree, correct?
Yeah, I agree.
Right, so it only shows a portion of the Earth at a time. So in one viewpoint from the ISS, what do you see?
Sorry, say that one more time.
From one singular viewpoint at a moment in time from the ISS that's alleged to be taken at the ISS, looking at the Earth, what is seen?
Oh, you see something that's perceived. You see the Earth as flat. Is that what you wanted to hear?
I don't know. I mean, have you seen images from the ISS?
Yeah.
That are well, let's just use the word allegedly loosely, so we don't hurt anybody's feelings. So what do they look like?
They look flat.
What? Okay, so then the ISS proves the Earth's flat. Great. I thought you were using the ISS to prove the Earth was a globe. Bro, if you need to take a time out and have an orange juice to get your blood sugar back up, go for it.
Yeah, let me go to the bathroom real quick, dude. I gotta cool down. No, I'm just, so the ISS orbits the Earth, and it can take a lot of images.
Allegedly.
Okay, we can step off the ISS. Let's go to something that can...
No, we're going to stay on the ISS, friend. Okay. Because we have a problem here that you didn't address. You said out of your mouth that the images from the ISS look flat.
Mm-hmm.
So if you have a bunch of images that look flat, you now have even more proof the Earth is flat. So what you need to get me back to the point where you're attempting to prove the Earth is a globe from this.
Let me try and find you an image. There's a specific image I'm thinking of. Hold on one second.
Well, I've seen plenty of images that are alleged from the ISS. I mean...
Yeah. Well, let me show you one more.
I mean, do you want me to help you with your argument so we can progress?
Absolutely. Go ahead.
Okay, so the standard reasoning when people present images from the ISS is that the horizon in the ISS images appears to be curving. And so they say, look, that's prima facie evidence that because the image is curving, the Earth is curving. So would you agree with that?
Can you say that in a different way? Can you repeat that again?
Okay, so the ISS is not at a sufficient distance from the Earth to see the entire Earth.
Right.
So what it sees, in order for it to be used as evidence, right, that the Earth is curving, people look at the images and they see like a dark area of sky, right? And below that is the blue and the ground and stuff. And the line between the two in the image appears to have a curve to it.
Mm-hmm.
So then they make the claim, because I see a curved image, I'm looking at a curved Earth. Therefore, the ISS proves that the Earth is actually curved. That's usually the way people argue it.
Right.
So are you planning on arguing it any differently?
Sorry, I'm just trying to think this. I'm trying to find the best way to explain what I'm thinking.
I think it might be just for the audience's sake, and it's not true necessarily that what I'm going to say applies to you. But many people, when they get into this and they start hearing words like image is curved, therefore the ground is curved, they start to recognize, wait a minute, I know in my lifetime that I've experienced optical distortions and seen fisheye lenses and all of these other things. Maybe this guy is trying to lead me into making a logical error in my reasoning so he can exploit it and show that my reasoning doesn't follow from the premises. So I need to be careful what I'm about to say, because the very fate of mankind is on the line, because if the earth is not a globe, we're all going to die.
Right. I'm really not trying to bullshit you. If that's what you think, if you think I'm trying to be deceitful.
No, I don't think you're trying to be deceitful. What I think is that people are so emotionally invested into the globe paradigm that their brain protects their worldview with a process of rationalization and cognitive dissonance.
Mm-hmm. Do you think you have any like emotional value to your view?
Not really.
Really? So what evidence would you need to believe the Earth is actually a globe and not flat?
Well, the most practicable evidence, right, accessible to the common man would be demonstrable surface curvature. It's the first contingent factor. The claim of the Earth, right, is that the majority of the Earth is covered in water. So if you could prove that the oceans are curving in the manner in which is necessary for the globe to exist, that would be pretty sufficient or compelling evidence, which, by the way, is the majority of the reasons why the majority of people in here are flat earthers. So, for example, I asked CB, why are you a flat earther? Is it because your Fifi's got hurt one day? Well, he doesn't want to mic up. He's too scared.
I'm happy to answer. Drop over distance. Yes.
I'm a flat earther. I'm a flat earther because there's no curvature, no spin, and you can't have a globe in space without a container to contain Earth's air in a vacuum.
So you're a flat earther because the Earth is flat?
Interesting. Right. So
I know it's flat.
Right. So his first go-to point. Okay, let's be clear. Wasn't what gravity is. It wasn't how big Uranus is. It was no surface curvature. So Mr. Jin is convinced that there's no surface curvature. Therefore, by rational deduction, he must assume if something isn't curved, it can only be the things that aren't curved, which are flat things.
Yeah.
Very rational, not emotional whatsoever.
I'd agree that it's rational, but I don't think it's scientific.
Cool. I'm glad you agree. Hey, friend, I'm glad you agree, because nobody in this room right now is retarded enough to equate the shape of something as a scientific proposition. So let me ask another friend here. Heretic, is the shape of something a scientific proposition?
Wait, I missed this one. Come again, AI?
Is the shape of something a scientific proposition?
Oh, no, of course not.
Oh, well, there we go. So now that that's out of the way, let's move on.
Can you give me an example of something that is a scientific proposition?
I can give you something.
No, I'd like AI to answer.
Take the ISS. Let me give you this ISS situation that you think is up there. One you've never seen it falling around an object you haven't proven to exist. But the problem is, back in 1962.
Right, but you're not answering his question.
Jim, you're not helping.
Oh, okay, go ahead.
Yeah, go ahead, AI.
And don't get me wrong, you should listen to what Jin has to say at another point in time, but it's just not the answer to your question at the moment.
Mm-hmm.
Okay, so in this arena, when it comes to natural science and science in general, right? Science is a word, right, which is grossly misused in many fields. And it's attributed to things that don't follow the scientific method, right? Now, classically, things that don't follow the scientific method, which are assumed to be science, are known as pseudoscience. It's the definition of the word. You can look that up, but it's neither here nor there, because we're talking about a specific type of, which is validation through systematic experimentation of a cause and effect relationship, where an if-then statement, if this, then that, if this, thus is caused.
Okay, so
if it's not a cause and effect relationship, it can't go through that methodology. So, for example,
thank you. Yeah, go ahead.
Yeah. So, for example, you could say, why does water boil?
Okay.
That it boils is known. That it boils is known. Right?
Right.
So you say to yourself, why does water boil? You formulate a hypothesis based on the observed phenomena of water boiling. You notice that usually if water's boiling near heat sources, so you say maybe heat causes water to boil. So then you set up your experiment where you manipulate the heat to ensure that that is the present thing that then produces the cause. And you set up a system to isolate variables out to where you can exclusively and independently manipulate that single variable to produce the cause. Sorry, to produce the effect, not the cause. Mm-hmm. Right? And after you do that, and you validate that that's the case, right, you've arrived at a conclusion of an if-then statement, a cause and effect statement, through a methodology known as the scientific method.
Gotcha. So in that example, heat would be the independent variable, right?
Right.
When
now,
you manipulate.
Check this out, though. When you measure the amount of heat you apply, that measurement in itself isn't science in the sense of science as it's applied in this situation. So when you have a ball in your hand or a flat sheet of paper and you put a ruler on it, right? And you say one is planar in nature because it doesn't deviate from the ruler across its entire surface, versus one is curvilinear in nature because it deviates at a drop over distance exponential rate from the plane of the ruler. Science, in the sense that we've previously just described, is not being done. What's being done is called measurement. So when you want to know the shape of an object, the thing you want to apply is measuring, not science.
Okay. Yeah, in other words, it's a geometric question, not a scientific question.
Exactly. So that being said, which is why we earlier said and asked our friends in the field here, why are you a flat earther? And their answer was, because there's no demonstrable surface curvature. Not because water boils, not because, I wonder what causes gravity. No, because they understand, by parsing it out logically, that the proposition in question is whether or not the Earth is a particular shaped object. And that is divined, discerned, and determined by measurement directly, not by all of this other stuff.
Okay. If we can go back to the water boiling experiment really quick. The heat is the independent variable, right? The dependent variable would be what?
Boiling.
So the rate at which it boils, or that it just boils, or what?
That it's hot enough to make tea, which would be boiling water. You can see the bubbles coming up from the bottom of the container to the top. I mean, it's boiling, right?
Okay. So the fact that it boils is the dependent variable in that?
Well, if you had a recipe book, right, and it said bring water to a boil, and then you decided, well, you know what? I could just set my ambient room temperature to 30 degrees, or let's just be more liberal because Celsius and Fahrenheit. So I could set my ambient room temperature to 70 degrees, right, with my thermostat, and 70 degrees, right, times 3 equals greater than 180. So after 3 minutes, my water will boil after being exposed to 70 degrees.
Okay, so the dependent variable is the time to boil.
Oh, holy frick, dude. There's a reason why that guy just laughed.
Poor guy.
Now, my friends, somebody, for the love of God, clip that out and send it to Numpty Clips.
Paging SimpCord.
I think water is boiling when there are large bubbles rapidly moving from the bottom of the container to the surface. I think we can safely say water's boiling when it's doing that. I mean, do we really need to look it up in the dictionary?
Right. So the duration of a consistent amount of temperature applied does not equal a cumulative amount of energy present at a particular moment. Right. So if I set my room temperature to 70 degrees, right, after 3 hours, my room is not 70 degrees times, 3 hours. You see my point now? Until I get to 180 degrees present in a single moment, I don't get water boiling. So no, time applied is not the variable that matters. It's the presence of the heat. So no recipe book says apply 3 minutes to the water. Correct? The recipe book says bring water to a boil. Now, if it was more acute, it might say apply 180 degrees to the water. Problem with that is that there are other concernable factors. For example, your ambient pressure, right? Water boils faster at different altitudes. Also, things like salt content, other things in the water.
It also might be a European reading the recipe, and they might think you're talking about Celsius. Screw it all up.
Right. So that's why it just says bring it to a boil.
Who are you talking to, AI?
Well, the candidate for Scholar of the Year. No, I'm being facetious. He's actually quite intelligent guy.
Hey, thanks, man. Wait, are you talking about me?
The shoe
is it Rhino? Oh yeah, it's Rhino. Rhino's usually on around this time.
Well, I mean, we already got to the point where he conceded that the Earth is ubiquitously flat plane, and the directionality of gravity is perpendicular to level, which means of a necessity that we live on a flat plane. So he then said he disagrees.
Ubiquitous, really quick. Okay.
Well, maybe it doesn't mean what I think it means, but I generally think it means generally the same everywhere generally.
No, you're right. Present. Ubiquitous means present, appearing, or found everywhere. So.
Yeah, like plumb and level.
Yeah.
I thought you would have already been on this side, right now. Why is it taking long? We've had a conversation also. You pretty much seen the light, man. So.
He doesn't trust us, to be honest, and to be fair, he shouldn't trust us because we keep telling people that the snacks are in the back, but none of you are willing to actually restock the snacks.
Yeah, bro. You know how long I've been here and I've yet to get a snack.
Exactly. I was right. He hasn't gotten his snacks.
Not to mention the DJ hasn't ever shown up.
Hey, where's our manners, AI?
You have been listening to excerpts from the 24/7 Flat Earth Discord Live YouTube channel. If you would like to join the discussion, simply type in your address bar discord.gg/flatearth. Thanks so much for listening.
Okay. Yeah, so this doesn't really answer either I'm missing the point or it doesn't answer the initial question, like how would we demonstrate it anyway, considering what we talked about the last 45 minutes.
We need an unchanging standard. Just straight standard against which to measure the curvature and see if it comports more to something flat or something round.
Yeah, but specifically, what would that be? Because we already determined light is not really suitable over long
laser seems to be the standard of choice, or microwave ray propagation. I haven't seen a better one.
Wave propagation.
Well, if you're looking to prove one proposition or another, sometimes it's easier to disprove one or the other. So the easiest way to disprove a proposition is to remove a logically contingent part. So once that logical contingent part that must exist of a necessity for that thing to exist is defeated, then the entire proposition is defeated. So, for example, you have a flat Earth on one side, let's say, and a globe on the other, let's say. Now, a flat Earth could have any boundary, shape, any subterranean shape, et cetera, et cetera. There's all kinds of permutations that it could be, right?
Okay.
Now, a sphere must be a sphere. So it must have a 360-degree curvilinear surface. Now, obviously, we have topology, right? So you're not going to have a perfect sphere. However, according to the globe model, quote-unquote gravity is what's holding the water to the sphere, or what's holding it down. But technically, it's not actually down. It's actually inwards towards the center, quote-unquote. So the water is being pulled inward. Now, if you know anything about water in your lifetime of experience, it adheres to the shape of the boundaries of its container. However, if you leave the surface open, that water will generally lay flat once it goes past the meniscus level, or the level where it can have a cohesive surface property like surface tension to create a little bit of an arc in it, like in a cup or something. You know, a lot of people do that experiment where they make it and they put a coin or a toothpick, right? But you know that once water gets big enough, it just fills its container and the top stays flat. You can then turn the container left, you could turn the container right, but the top surface of that water stays level and flat. This is why they use water in levels on construction sites, etc. Or to do long channels, they put the water level and then they get what the level is. So if gravity is pulling the water down towards the center, or inwards towards the center, then that means that you have a sphere with water being pulled in. Then that means large bodies of water of a necessity are curved to match the radius of the Earth, with a certain amount of discrepancy, of course, because you've got tides, etc. You've got centrifugal forces, etc. However, the waters of the Earth, which are known to us to be about 70% of the territory that we're aware of, would be conforming to the spherical shape. Now, there's a given radius of the Earth, and that means that you can calculate what this curve of water should be within a very narrow band of precision. So all that you have to do to disprove the entire globe model, in totality, completely and immediately, is just prove that water isn't doing this. Once you prove that, it's not possible in any way, shape, or form for the globe model to be true.
Of course, I agree with you so far. My question, because we discussed how Aristoteles doesn't show anything and how our perspective is sort of insufficient to make this measurement.
So far you understand the logical premise that water must be convex between point A and point B. So the correct methodology to discover whether that's true or not is to use a methodology of measurement that would demonstrate that curve not being there. So all you need to accomplish in order to do that is find a large body of water that has an exaggerated amount of curve that's greater than the range of the equipment that you're using. And what I mean by that is the vertical range, not the range into the distance. So like on a job site, what you'd use, heck, we just did it the other day. We set up our laser, okay? We shoot the laser beam. We shoot it over here. The laser stays level. Then we measure down, and it tells us 27. Then we shoot the laser over here, and we measure down, and it tells us 20. So that means that the ground is higher on that side than on the other. The laser didn't change. Now, keep in mind, if that side is a little bit longer, then the spread of the laser will be a little bit longer, but we could still adjust for that variance pretty calculably and accurately. You know, so you may adjust it a quarter inch, whatever. So you take this same premise, right? If somebody walks in between the laser and the mark point, the laser doesn't hit the mark point, correct? You understand that, right? Right. So when the person is standing in between the laser and that, we're like, hey, get the hell out of the way. We got to get over there and, you know, mark the laser. So you take this same principle and you put it from point A to point B on a place where you know there's an exaggerated curve of water supposed to be. You get those measurement differentials. For example, let's just go with 25 miles. That's a pretty good number. So at 25 miles, if you have a laser set 2 meters off the ground, and on the other end you have a laser target of your choice, could be anything, 2 meters off the ground. So you have a variation of 2 meters off the surface, right? So that would mean, in principle, if the laser is shooting dead accurate at the other target, then the maximum amount of physical variation between the 2 points can be only 2 meters. Because if it's any higher, the laser will be blocked, and you'll have to tell Joe, hey, Joe, get the hell out of the way of my laser. I'm trying to get this job done.
I disagree on various parts. Like, in principle,
there's nothing you could disagree with so far. Everything I've said is absolutely factually accurate. So if you disagree with any points, you need to bring them up quick before we move on.
You're assuming that the laser travels straight.
It does. Wow, it does. Are you saying a laser is not a collimated beam of light? Wow. What is the definition of a laser? It absolutely, a laser shoots a collimated beam of light. Yeah, it is straight. By definition.
I'm saying laser shoots light, and light is susceptible to bending. And the reason I'm bringing this up is Aristotelians, because Aristotelians' results show that the light is susceptible to a significant amount of...
Right. True, but sunlight and laser light are not the same. Lasers are created in a very specific way. They're much more focused, much more directed, and they're predictable. Now, the secondary effect you were saying is how they pass through the quote-unquote medium. Now, that can also be accounted for, which is why I mentioned earlier that you account for these errors when you're making your measurements. Okay. So you know the ambient conditions and you account for them.
Okay.
So my premise that I set up to you was, if the laser is shooting dead straight at the target, which means I foregone the other variables to this point.
It doesn't shoot
now
dead straight.
No, listen to me and pay attention very carefully. Lasers shoot straight, period. Your only contention would be that if they pass through a medium, then the laser could be diverted from its path.
They pass through air.
Right, but that doesn't change the nature of the laser.
Yeah, but it passes through a medium, air, therefore it could deviate.
Right. So that is why
right. That is why I said in the setup of my premise, if the laser's shooting straight to the target. Now, the variable of the medium is taken into account after that premise is already established.
Okay.
Now, there's two factors in the laser itself, and well, that is the nature of the light, which is the color of the laser beam, and then also the divergence rate, because obviously some lasers are better than others. At a certain range, they'll be so diffused that you'd be barely able to tell that it is even there, which is why, you know, if you buy a $100 laser at a job site, you're not going to be able to get everything done as easily if you buy a $500 laser that's way more powerful and you could easily see it on the mark that you want to make.
Yeah, plus if the divergence is too big, then you get a very huge cone of target, so you could hit your target even though it's not a straight line. Like
That's only if. All right. You need to stop right now so we can move
Take
on.
a black hole to bend a fucking laser light, and that's only in theory.
Yeah. So we got to move on to the next point, because then you can bring up the cone.
Okay.
Because at this point, it's irrelevant to the point.
Okay.
All right. So all the premises are set for how you would measure this variation, and if all the premises hold true, then the maximum amount of variation would be 2 meters. So now when you put this into the practical reality at a 25-mile range, you end up with a point A to point B at 25 miles. You end up with an arc that, now this is a predicted arc of the globe model between point A and point B. Now the median line between those 2 points and a 90-degree perpendicular drawn to the top of the arc, that hump of water, or the height of the hump, is known as the sagittah, which is basically, you know, what it has to get beyond. Okay, so taking into account that the laser cannot shoot through the water and that it can only shoot directly above the sagittah, the hidden area that the laser cannot reach if it shoots straight is approximately 90 meters. So that means that if you have a 2-meter target and a 90-meter variance that the laser cannot drop below, you're talking, what's that, 90 minus 2. Man, that's hard math. Hold on now. 88? Did I get it right?
Oh, no.
So you're talking 88 meters, 88 meters of variance there. So now you have to take into account the ambient conditions. So first off, you throw in the math of the globe, the terrestrial refraction, that shaves off about 5 meters. Then you take off the beam divergence, which is approximately at that range for the millirads of this laser in question. We'll just call it 2 meters. So now you have 2 plus 5 plus 2, which is, let's see, 2, carry the 3,000, plus 5 is 7, now 9. All right, so you have 81 meters of variance left. So now,
89.
With 81 meters of variance, okay, 81 meters of variance, that means that it is absolutely impossible for the laser to hit the target.
Yeah, you were assuming about the refraction there, right? Like just about 5 meters, right?
Right. That's what terrestrial refraction that's given in all these Earth curve calculators, etc. Now it gets worse. It gets worse. So the principle is this: that means there's only a maximum of 2 meters if it shoots straight, and we have 81 meters of variance. That means that you now have 79 meters that are not there. So if you hit your target, you've proven that this hump of water isn't there.
Well, you have taken assumptions about the refraction, right? You have not measured it.
Okay, so now what you would do to take an account for this refraction is you would set up different targets at different ranges, okay? And each target would be panned horizontally. So the first laser would hit target 1 at a certain range, then the laser would hit target 2 at a certain range, and the laser would hit target 3 at a certain range. And with that pan, you could predict the arc that a refractive index would cause the laser to vary up or down.
That's
So basically this, if you hit all three targets in succession, taking into account all the variables that I just gave you, taking into account the globe prediction of 71 meters that the laser must drop in order to hit the target, there is nothing that exists that can diverge a laser 71 meters that exists in the regular atmosphere. Not gravity, not farting gnomes, not refraction, not anything. So then the answer would be, well, what about the beam divergence? Couldn't that get it over the hump? The answer is no. It would only get it over the hump if you raise the elevation of the laser greater than the sagittah to the angle of the triangle of the divergence. So in other words, if you have a divergent pattern and the laser stays fixed at 2 meters, then the bottom leg of the divergence is still just a straight line. So it's still not getting its way over the sagittah. It's just not happening.
Okay, I will be honest. I will need to wrap my head around that. Thank you for that very clear explanation. I have a follow-up though. And
it's not just an explanation. We can link you a PDF that goes through, I believe, 7 different tests where they began doing laser tests, and I believe it's 7 different measurements.
Appreciate that.
You're correct. Hey, I have a question if someone can help me out with it.
Hey, before you start on that, I want to say one more thing about the laser test. Okay, so when you're panning between a whole bunch of different distance targets, that hump, the so-called, sagittah, the peak of the sagittah, that's the horizon, right? In the globe model, that's where you would see the horizon, the geometrical, the geophysical edge of the sphere would be the horizon. That would be the peak of that hump. Now, how would a laser get at the peak of that hump and at different distances hit all the exact same height at every single distance? That would be that if I'm shooting to one distance, when it reaches the horizon, it takes one angle, and then another distance is somehow magically changes to a different, and then in another distance, it changes to a third angle. That's not really, there's no mechanism that anyone knows of that would allow that to happen.
Okay. Got it.
Smart, where it knows the distance to the object, and it knows to be okay. When I get there, I gotta be 2 meters off the ground.
Okay, so I have a follow-up question. Like, in that whole measurement, in that hypothetical, like for me at this point, hypothetical measurement, we were just saying we could account for the ambient conditions. That means we can. Calculate or predict how light would deviate from a straight line. Going back to Aristotle's, we should be able to calculate how the light deviates from a straight line when we observe it over a long distance between the apparent position of the sun and the Earth. That means we should be able to triangulate the apparent position of the sun like that.
You missed it, bro.
If we account for the
you missed
You're
it.
confusing. Well, hold on, because I'm the one who talked about Eratosthenes. You're confusing two things. Diverging rays is different than refracted rays. So, right, if the sun's a ball and it's closer, it's going to be a round ball. The rays are emanating off of this radially, right? Mm-hmm. So if it's very far away, even though it's radial for all intents and purposes, by the time it reaches Earth from 93 million miles, they're parallel, right? But if the sun's closer, there's more divergence because the sun is closer.
Each way,
what I'm saying?
Yeah, I do see what you're saying. Each wave, though, could be like each single ray. We're basically putting a slaughter on the sun, so that we're considering just that one ray that is just above our shadow that that we measure the length of with the sticks, and this ray could be considered as just one beam of light from a small laser. This one ray, we could build a divergent light source out of many lasers, out of infinitely many lasers. We could build a divergent light source, right? So when we consider just this one ray, we can calculate, we can apply what happens to that ray through the ambient conditions on it, right?
No.
No.
I'm kind of
because you're Yeah, I'm not confused, so I'll take this one. You're confused. You are confused in thinking that a laser and a target is analogous to the sun and a shadow. Here's the problem. I can verify the point source of the laser. I can verify the ambient conditions present between point A and B, and I can verify point B. None of those relationships are present when you're talking about the sun. Nobody can go to the sun and verify anything about it.
Yeah, but I can
nor the medium from the sun to the location of the shadow. So, for example, to measure the refractive index, you can pan the laser. You could also tilt the laser. You can also use two different color laser beams, which will have different variations of refractive index because they have different wavelengths, and then you can see the pattern that all three of those actions I just described cause on the target, which means you have a verifiable methodology of accounting for those conditions when it comes to a laser and a target. You do not have any of that when you're talking about the sun, not even close.
Okay, but I can, let's say there is a medium. The sun is in a totally different realm than ours. Let's say there could be a medium like that. Okay, we don't know it, so there could be. We could introduce it. Then this light from the sun would need to exit that medium and travel through air to reach us, to reach the ground. That's a fact. Okay, so explain how we to explain that there are different that we get different heights for the sun via triangulation of Aristotelians. We will have to assume that there is a apparent position created, that it's different from the actual position of the sun, which lies in a realm that we cannot access.
Right. The fact that the sun...
It's not a triangulation. Okay. It's not even nothing like a triangulation. You're only measuring the elevation angle, basically. But that's not a triangulation. We know that you can't triangulate the sun. It can't be done.
You're doing that for two different places on Earth.
But you're not placing it in 3D space, though. You're only measuring elevation angles. That's it. So if we were triangulating it, right, we would take the shadow, the shadow, and we take the direction of the shadow, see which way is pointed relative to the direction of some other stick, and you would take that measurement simultaneously and take those two directions and intersect them at some point in space, right? And then that would be a triangulation. You take the distance between those two sticks, right? That's your baseline, right? The angles of the shadows where they intersect, and that would be your triangulation. When that's actually attempted, it doesn't actually work. They don't intersect at a point. So it can't be done. This is why when they, it's a problem. This is why they got the distance of the sun by presupposing that Venus was the same size as Earth and using the transit of Venus to get the sun's size, and then once they thought they knew the sun's size, they got the sun's distance. But it's admitted in modern astronomy and even ancient astronomy that they can't get the distance of the sun by looking at the sun directly.
Okay, I'm talking about determining the distance of the sun through Aristotelians, and as you correctly stated, we get different positions which show that the apparent position of the sun is at different places.
Yeah,
right.
Flat or round or pretzel.
Like trying to triangulate a rainbow. It only occurs in the eyes of the observer.
It's called the analemma.
Yeah, but
in other words, you can't make a concrete conclusion from that information.
This apparent position is within the reach of what we can measure. That we can measure that up to that point. We shouldn't have anything else, any other medium influencing the light than air, right?
You can measure an apparent position?
We can triangulate the position or apparent position of the sun, find that it's
if
at different
apparent, then that doesn't mean it's actually there. If it's apparent, that means it's not actual.
Yeah. But we can measure that apparent position, and the light would need to travel through that apparent position for us to have the sun appear at that point, right?
No.
Oh.
I could measure the apparent distance to the horizon. That doesn't mean it's an actual place.
Yeah, that's right.
If you actually follow the path of the sun, the path of the sun is like a small figure eight. It's called the analemma. It even makes everything more confusing because it doesn't prove if we go around it or if it corkscrews above us. Look at the analemma.
What I'm trying to say is where the sun appears to us. That we know how the light behaves through it.
But when you're saying what you're trying to say is that you're looking at something that could be taken any number of different ways and declaring one way that this must be the way it's got to be because you're presupposing your outcome by putting it 93 million miles away and saying, oh, see it, look, it works. That's not accurate in any way.
How are you getting 93 million miles from? That's not what we're talking about.
Well, but the point is that if just looking at something and declaring it one way or the other when it could be many different ways, I mean, that doesn't mean anything.
Yeah. Well, let me give you a concrete example of some of these problems. So, we all experience perspective. We all know that as things recede away from us, they appear to occupy the center of our vision and get smaller or whatever. So what this means is that at a certain distance, the angles that that object is occupying in your field of view will cause it to be rendered approximately in the center of your vision. Now, this object could actually be 1,000 miles to your left or 1,000 miles to your right, but to you, it will appear in the center of your vision. Now, this is a problem because you can't be certain whether it's off to your left or off to your right. And as it moves away from you and it starts to move towards the center of your vision, apparently, you may be mistakenly thinking this is actually physically moving from left to right or physically moving from right to left.
Yeah.
And now at a certain range with no, baselines to go off of, your conclusions about this object, even though they be geometrically correct. For example, you draw your little triangle, you draw a picture of you, you draw a picture of the object, you say it's directly in front of me, you draw a little line from you to it, and you say, well, look here, this geometry that I just did is entirely accurate, so clearly this object is of a certainty in front of me, when actually it's not.
Well, AI, we are talking about triangulation, so I have a second observer looking at it from a different angle.
And they suffer from the same problem I just described.
Right. So
that's why it's impossible to kind of triangulate.
Sorry. From the second observer, the ship is not moving in a direct line.
If two people are standing on the ocean and they're both looking at the sun, and there's an angle of ray of light that's hitting the water coming to each individual person. Okay, two triangulate a rainbow.
For the 200th time, Zanuck.
He's already destroyed this argument for himself earlier today by claiming that you can leave reference frames, you can't leave reference frames. Like, he's already destroyed himself numerous times on this.
I love you, Chocolate.
I don't know
I've
why
got to
this
jump
is.
in.
Yeah, go ahead.
Mike West is in the house. Mick West, even.
Oh, I seen him in the check-in. I didn't think he was real.
Yeah, no, he is real. Bev has been talking to him on Twitter and has managed to get him in. So, just so you all know that he's probably going to come down to the live stream soon.
Oh, fantastic.
Oh, that would be way better than fucking
Yeah,
with
behave yourself, Zanuck. You'll be the
Is
first.
he like famous?
I'll be what?
You'll be muted if you don't behave yourself.
I'll always behave myself.
Yeah.
Isabel got muted a second ago.
I'll be the judge of that one.
Hey, Chocolate, can we just talk about one thing before we let this topic go? The leaving of reference frames?
No more reference frames, please.
No,
My
just a
ears
second.
are bleeding.
There seems to be a misunderstanding. I just wanted to explain it in case there's ever a question.
No one.
Maybe you
no
could
No one
DM.
cares? Okay, I'll leave it out then.
Yeah, we are fine. We cannot eat any more reference frames because they are not healthy.
Yeah, if you confuse me more, I might actually start believing in the globe again.
I'm not trying to confuse you, just letting you know about how you can't leave a reference frame. It's not possible, but you can go to another reference frame if you'd like to. It still exists.
Stop explaining.
Observation point.
No, we didn't ask
It's
you
just
that.
an all-inclusive
All about
reference
observation
frame that we can go to.
What's that?
Could we talk of rainbows while the Midwest is coming?
How about corpuscular rays?
How about these observations and long-distance measurements that are defying the very model that you are preaching here, Zanuck?
Okay.
How do we deal with those on a ball when they directly contradict the supposed curvature that we should be seeing, according to their story?
In the measurements of large mountains at a distance?
Well,
as well
yeah,
as
just long-range
display?
observations in general, right? I mean, there's
Mick
so
West
many-
is coming. Sorry, got to reiterate. Mick West is literally coming in a minute now.
Nice. I'm ready.
Fantastic.
Hello, buddy.
So, yeah, those are interesting observations, right? And a lot of them aren't very accurate. They're looking at, I see the light that should be 100, 200 feet below the horizon. How do we see that? And the answer is, from my perspective, not perspective, no.
Yes, perspective.
Refraction has
saying?
only a small effect, but there could be something called diffraction, which could actually allow those. Yeah, diffraction can actually
Could be.
I'm admitting that I don't know, and I'm interested in that test in replicating it myself.
Could it be that we see what there is without anything?
Yeah, until it's shown otherwise, that's the logical base assumption. So that's where we leave it. I'm sorry. Zanuck.
That's the first step in science,
It looks
right?
like
The
a
observation.
beaver. It looks like
Until-
a beaver. It smells like a beaver. It has
No.
a tail like a beaver.
No, but how come? Then answer me this. Then answer me this. So when I shine that same laser to an 11,000 foot peak, 123 miles away, what do you think we'll see when there's less refraction or diffraction involved? Do you think
Well,
we'll
the fact,
still
the
see
fact,
I don't know.
The
It
fact
doesn't
that you
matter.
can shine a laser on
It does not
something
matter.
100
How
and
can
however
you
many miles away just means there's no curvature.
If we use a laser targeting device to aim a laser at a target, we'll probably hit the target with the laser if you've got a direct line of sight to it. Now, refraction over vast distances will have to be taken into account because quite possibly if you're viewing this mountain over a vast distance, it's going to be refracted to you, the observer, anyway. So you'd have to take account for this, wouldn't you?
But you've shown 200 feet over 20 miles, so we got to see. I mean, a huge amount of diffraction or refraction that's going on over 100 miles, right?
Well, yeah, more distance, more atmosphere, right?
Okay. Well, that would play it into my case here in that when we show a mountain 125 miles away, why is it angularly much lower than it should be for that given distance?
I don't know, because you're comparing a geometric function to refraction.
Yeah, but
you know, this observation of the mountain, you know, you're observing it, the light is being refracted through that atmosphere. More distance, more refraction, possibly, right?
3 degree? We're talking about a refractive
Refraction
index.
over long distances is 7 to 8 inches per mile squared.
Yeah,
Wait,
Zanuck,
refraction-
if you're able to
refraction-
shine a laser on a mountain that far away,
refraction
yeah,
depends
you
on-
shouldn't
you
be
guys
able
got-
to see it due to the alleged curvature.
Refraction, two factors, right? You has your angle of incidence as well as the material, the medium you're shining light through. If it's air, it's very low refractive index. Then you have the angle of incidence on top of that. That no way accounts for the amount of sink those mountains would have at 125 miles. They're 11,000.
How come they're visible? How come they're visible?
We're seeing them being angularly at 7,000 feet. Where did 7,000 feet of that mountain go?
Mick West in the house, people. How you doing, Mick?
Yeah, Mick knows this. Mick knows this very well.
I know. Yeah, I do actually. I know all about the refraction problem. It's very interesting.
Also, welcome to the server.
Yeah,
thank you.
Yeah, I'm pretty familiar with it too, Mick. It seems like the only time you can get light to bend down is in a tank full of sugar water.
Oh no, you can actually do it fairly easy in any type of thing where the refractive index is higher the lower you go down.
Can you demonstrate this?
Yeah.
Ooh, no. Well, then do it. Yeah, I'd like to see. I'd like to see laser light bending down in air. Can you demonstrate that, Mick?
Okay. Yeah. No,
just gonna make a small announcement, guys. Just to make a small announcement, guys. I understand we've got Zanuck and Mick West in, so if we could just dial it back 10% and try and keep them here as long as possible before we start getting involved.
Okay. Yeah. Okay.
You should get married.
No, I'm just asking a simple question. Mick West here is very informed about the. No. Mick West here is really informed about the refraction problem. So I've asked something very simple of him. Can you demonstrate laser light bending down in atmosphere, not a tank of sugar water, please?
Yes, I can.
Cool. I'd love to see it.
All right. Well, I have a video showing how to do it actually, but really simply. The way to do it is just to kind of cool the air lower down, and the laser light will bend down towards the cooler air. And the easiest way to do that is with a large ice pack, just like the type of thing you put in a cooler or an ice chest. You take that and you shine
when it's really cold, and conditions are just right on the lake for us to observe a mirage of a skyline that's about 36, 40 miles away. So those are perfect conditions.
No, well, I wouldn't. I mean, obviously conditions vary, and sometimes they're better than others. But yeah, if a lake is very cold, the light will bend down towards that because it cools the lower air and makes it denser, and more dense air has a higher refractive index. A light bends towards the higher refractive index, though, towards the denser medium, which is why on a hot road, when a road heats up, the air expands, it becomes less dense. And the light bends up, which is where you get that kind of mirage refraction. It looks like a mirror, the typical, like mirage, like pool of water in the desert type thing. That's because it's hot down there. But when it's cold, it bends in the opposite direction.
Is it the same reason that I saw an experiment done with laser and the iron? Iron was heated, normal, like an iron, what you iron your shirts or whatever. And iron was put next to the laser, and it changed the direction of the laser.
Yeah, it is. With hot things, it's kind of tricky to do because hot air moves around a lot more because it rises. Cold air just sinks, so it doesn't move so much. So you get a lot more turbulence with hot air. But you can do it. I have a video. Can I post links in here? So I've got a.
Maybe post.
Give me 2 seconds. I'll give you the appropriate one.
Hey Mick, I got a question for you.
Sure, yeah.
The flat community has done is they did an experiment out there at the Salton Sea, and they basically really simple. Guy sitting in a chair with a camera, guy across the Salton Sea 20 miles had a mirror and was changing the mirror angle up and down, up and down, up and down, and they were shining the sun off the mirror to the person holding the camera, and they did see a flash when they got the right angle from 20 miles away, which would be about 150, 200 feet below level. So my thoughts, and that's when I kind of was interested in, because refraction would only account for so much in air, as we know, 0.003 or something.
It varies though based on the conditions.
Right. But in this case, it was a fairly warm day. They saw the light flash from the camera. We all saw it. Is it a chance, because the light is traveling over an object, water, there could be diffraction involved?
No, diffraction happens around the edges of things. It doesn't really work over a surface like that. Diffraction is when basically when a wave kind of spreads out when it goes up to a corner or something like that. So it's not really an issue, other than, like, I suppose, like atmospheric diffraction, which is just kind of, glow, which really isn't an issue here. What they're seeing there was an actual line of sight from the camera or from the guy's eyes all the way to that mirror, and indirectly to the sun, because it's reflecting an actual beam of light. But because the lake is cooler than the air, the water just above the surface of the lake is cool, and it curves around that curve of the lake.
It seems like hold on. So it curved that much around over 20 miles, it actually followed the surface?
Well, it's not really that much when you think about it, because the Earth, being so large, the curve really isn't very much. It looks flat because it's curving so little, so it doesn't really bend the light very much.
Oh, okay, that makes sense. So the angular change is not that great, but over long distances, it was enough to where it would.
Yeah, exactly. So, like, over 10 miles, it's only got to bend like a few feet, which is hardly anything, really.
This implies duplication of the image, a real image that is giving light rays that are coming more or less straight from the object, and a duplicated image from the light rays bending up and refracting. It's a bit too much to beg the person to believe that a duplicated image, essentially, of the actual object is being shifted up and over a curve with the actual object with the straightest rays possible coming from said object somewhere else.
There are no straight rays coming from it. They're all being bent. If you took, like, the object and drew a ray in every single direction, all 360 degrees, the ones that go across the lake are going to be very slightly curved. The ones that are a little bit above that are going to be slightly less curved, and then the ones going straight up will not be curved at all. So the curve is so small.
What's it got
a bending of the?
This is not on your regular air. We're not talking about sugar water, Mick West.
We're talking about the atmosphere, which is much less of a refractive medium than sugar water. So it only bends a really, really tiny amount. The reason you have to use sugar water to demonstrate it,
it's been proven it's not been. There is no refraction at night, Mick West. Are you kidding me?
There's refraction anytime that there's a difference.
No, there is not.
Refractive.
No, there is not, Mick West. Quit lying.
Ask a question. Let's let West respond. We're starting to harangue him a little bit. Mick West, you had to respond?
Yeah. Lasers at night, no refraction.
Oh, well, yeah. Why are you saying
right there? There's the data. Show me where there's refraction in that data right there. It actually shows none from 6 p.m. to 6 a.m. Literally. That's why tests are done at night, Mick. That's why these laser tests are done at night. Okay.
I have a question. There seems to be quite a lot of change in the angle for a lot of the time there. At some point, like, over a small height variation, sometimes things equalize, because at some point the refraction bends down, at some point it bends up. So there's some time during the day when it
laser light bends up. We've seen it. It bends up because of the humidity rising off the water. If it does, that's why they choose a frozen or a partially frozen lake to minimize that effect. Thank you very much. Prove that it bends up in our atmosphere. Show me, or it bends down in our atmosphere. Please do.
Well, yeah, like I said, I demonstrated it.
It doesn't. We can demonstrate it goes up, Mick.
But I've just said that I personally have demonstrated, and I have a video of me actually showing.
Not in the atmosphere.
Atmosphere. I had to use like an ice pack to cool it locally because. Well, you're accusing me of lying when I actually have a video showing me doing this.
Are you? Yeah, I'm accusing you of being very deceptive. Yes, you are.
We don't need to
just like Dr. John D called you out big time for your calculator and all the other lies and bullshit that you produce.
Oh,
I'm not going to take it lightly with a shill in here.
But if you're just saying I'm lying, then like, how are you? Why are we even having a discussion here? Like,
are you a government agent?
No, I'm not. I'm just some guy.
Well, Mick, going back to the refraction, when refraction happens, not all colors, oh, there's a bit of an echo, sorry, but not all colors of light refract at the same time, which leads to an unstable, hazy image when there's been like miraging and different effects. Now, when you go to a cold layer of air, there is some stability, but you have what essentially amounts to a faded, duplicated, hazy image that is unstable. It is a bit too much to beg the person to believe that a stable image would refract and curve over air. And with the sugar water that you saw, that you showed in a video, or maybe somebody else showed in another video, you see what appears to be the laser hitting a critical angle and bending away after reflecting off of a layer versus, say, bending down through a cold layer. So you have slightly different phenomena. One where you have what appears to be somewhat of a reflection off of a layer of density versus going through a different layer and quality of air going through the medium. So we have a couple things here that are a little hard to believe is really happening with the atmosphere. You'd expect a hazy, unstable image, and you'd expect some duplication because some of the different colors of light refract differently if refraction is happening. So some of them would be refracting off of your eye this way. Some of them would be refracting off of your eye this way, leading to an instability of the image, would it not?
Yeah, and that's why Dr. John D. used two different color lasers on his test. He tested for your refraction and found nothing.
The amount of refraction with
Jesus
different colors
Christ.
is about the same. It doesn't really vary very much. Now, if you look through something like a magnifying glass,
No shit, and he took this into consideration over a distance.
I'm addressing the issue raised by the previous person, and he's saying that different colors refract by different amounts, but they really don't refract by very much difference. When you look through something like some glasses, the light is being refracted a lot. It's being bent a lot, but the colors really don't change very much at all. You get a little bit of coloring around the edges called chromatic aberration, which you see in photographs sometimes, where the blue is bent a bit more than the green. But really, the difference isn't very much. So the color thing isn't really an issue.
Yeah, but isn't that how we establish the difference of rate between a refraction that's happening is by using different colors? So it's not a matter of if it's happening or not. It's the rate at which it does. That's why we use different colors, right, Mick?
Yeah, well, that tells you basically how the wavelength of the light affects it. And that leads to a thing called the green flash. Are you familiar with the green flash on the sun?
Yeah, it's when the sun's setting, right?
Yes, we're familiar with the green flash.
Yeah, and that's the difference there between the red light and the green light kind of shows you really how much the sun has been refracted. You can do the math because we know the different refractions. It's only like 1% or so for the difference between the red and the green. So you can tell by the size of the green flash how much the entire sun has actually been refracted. It turns out it's been refracted by an amount that's about equal to the diameter of the sun. So when you see the sun just above the horizon, in reality, under the conventional model, it's actually just below the horizon. It's being refracted upwards by the standard atmospheric refraction.
Well, another problem with the way that this refraction is applied, you can have 1% from the origin where the light ray is put out, or you can have 1% by the time it reaches the observer. And depending on if you apply it at the start or the finish, you're going to have differences of, miles.
That's not how it works.
If it just goes a degree off of the observer's eye, that's hardly anything. But if you started at the origin, that may go off a couple miles. So how's this refraction even being applied at the start or at the finish?
It applies over the entire path of the light.
Which means that you're going to have a lot of miles that are going to be added to the calculation when really it may only affect the observer and be even less, even smaller than that.
You have to look at what the light goes through every single step of the way from the start to the end. You can't just look at the start or the end or something in the middle. You've actually got to look at the entire path of the entire beam of light, which is why I actually use ray tracing. When I in my more complicated calculator, the refraction simulator, you've actually got to step through the atmosphere one step at a time and see what happens to that one small step, and then bend the ray of light very, very slightly, and then move it again. And I do tens of thousands of calculations on that one beam of light to see exactly how it bends.
In Lemon, when I posted that picture of the ship disappearing, you see only the smokestacks of a 200-foot tall ship. You think if you had a laser pointed at the bottom of that ship out to shore, you'd be able to see the laser when you can't even see the boat from the shore?
Yes.
How much refraction would you have to see the bottom of that boat 20 miles away? all you see is the smokestacks up top.
It's still there. It's just compressing at the eye line of the observer. Something that's above your eye line physically will only compress down to the eye line and no further, and stuff that's below your eye line will compress up to that line but no further. Otherwise, you have an error condition where something can look like it's above you when it's actually below you. It's just the logic of the way that the eye focuses rays.
Okay, I get it.
It's
I get it.
there.
Lemon, nothing has changed proportions. There's no compression. There's no distortion.
There's compression down to the eye line.
No, there's nothing
Usually
there.
is compression down at the bottom.
The bottom's completely visible and not changing shape whatsoever from the moment it was seen 3 miles away to here it is at 20, 25 miles away.
How about this? How come the flat Earth just makes sense at all? How come it's not just the most retarded thing ever when you look into it? Why, just Mick and Zanuck? Why do you guys think that like we believe it so much? Why does it make so much sense to us? Can you like? I want to know if I'm wrong. Am I so confused? Is it because our observations make it look flat and that I'm just wrong because I haven't been high enough?
Essentially, yes.
So when are we going to go high enough? Like,
you don't need to go that high. There's the experiments you can do at a fairly low level, like the Bedford level experiment done by Wallace back in the 1800s was actually a really good experiment.
No, this was even conflated in court. We can't go back and forth with these two scallywags. That's not going to happen.
No, but Mick,
Dr. John he redid the Bedford level experiment anyway.
No, he didn't do it. He didn't do it. Dr. John didn't do it. He had bad weather and he's never been back. So.
But do I think it's? I've never seen the globe, so why should I believe it? Like, all my observations are of a flat Earth. Do you agree? Your observations are all of a flat Earth, right? Are your observations?
You've seen things like. No, my observations are of a globe. The observations I've taken show that there is.
You've never seen curve in your life or motion with your observations.
You've never seen anything. None of us.
I get it.
No, he just wants to beg the question and apply a model to it. He's like the model tree.
But you've never seen it, right, Mick? You've never seen the globe, right? Right? Like us.
See it every day. Here it is.
Nobody has seen the globe.
You see it every day, dude? Are you serious?
You don't see shit, man.
You go to space every day?
Hold on.
Guys,
just
taking it out of hand. I think what you're trying to say is, are you trying to ask him what does he observe? Rather than just repeating the question and shouting it, just ask Mick, what do you observe on a day-to-day basis that shows a ball?
Well, I think Mick and everybody would agree that.
Zanuck, shush. That was directed at me.
My problem is I see a flat Earth every day, and I can't deny that anymore.
We understand that, but Mick, what do you observe?
Well, I see a lot of evidence that to me shows that the Earth is actually a ball. Like the simplest thing is
not the evidence, the observations. What do you observe?
Okay, the observations, like I observe, say, Catalina Island. Like something I used to live in Venice, Venice Beach in California, and there's an island off the coast. It's about 35 miles off the coast, and it's about, I think, 2,000 feet high. And when you look at it from the beach at Santa Monica or Venice next to each other, you see that half of the island is hidden behind the horizon.
What's the horizon?
I just posted.
Hold on, Zanuck, shush. What's the horizon?
Horizon is the line formed by the edge of the curve.
I can't hear. I can't. Shut the fuck up.
All the fucking time.
Shut up.
You're talking about.
I want to know what the horizon is.
Your horizon is about 3 miles ahead of you with the naked eye.
The horizon is a horizontal line.
Who's this?
That's why it's called the horizon.
I'm asking Nick a direct question. What's the horizon?
It's not a physical thing.
I'm not asking you.
By the curve of the ocean.
Platypus. No one is talking to you,
what
dude.
You see of essentially
I don't think he can hear anybody.
Who are you?
All right, so
who's talking to you, bro? Yeah, shut your ass up.
Sorry, y'all. It's just that we have to collectivize a little bit because it's one, group against one man. We just have to collectivize a little bit.
Let Jedi ask his question to Mick.
But we should let Platypus talk at the end because he also has been and seen Catalina. So I want to hear both sides.
I live in LA.
Yeah.
I got a picture.
I want to know.
Check out the picture I posted in the chat of Catalina.
Well, you all know what the horizon is under the standard model. Understand.
I understand the horizon is the limitation of my view. So that's what the horizon is. You're reifying this apparent location into a real location, the apparent leading edge of your sphere. That's what you're doing.
The
horizon is the limitation. The horizon is the limitation of the observer's view over the Earth. It is not an actual location. It is not the leading edge of a sphere, and nothing is hiding behind it.
So this guy just
but it matches exactly the standard model.
Wrong.
No, it doesn't match exactly the standard model. This is what long distance observations are. I mean, if you're at the beach and you're observing something that's 35 miles away, and you can't see the bottom of it, I'll give you your 6 foot tall. This is a very narrow angle of view to the thing you're observing 35 miles away across a flat surface.
You can see curvature.
That's not how vision actually works, though.
What do you mean? I've just pointed out you're observing something from 6 foot above the surface of the ocean that's 35 miles away. It's reduced the angle of size.
You've been to Santa Monica.
Angle. Next person who ever talks to me is going to get muted.
Bulge. You've seen the water curve up and block your view of the shore of an island 30 miles away. You're telling me there's enough curvature across 30 miles to see a giant curve and have the ocean bulging in front of you, and then you don't see the shore.
It's just a smooth curve of the ocean.
Well, hold on, because I hear this argument too, like, oh, I see the curve. Well, where do you see it? I see boats going over it straight ahead. If you're seeing something 35 miles out straight ahead, imagine how long a distance of horizon you're actually seeing, and how many hundreds of miles are in your vision. Like, there should be something else. There should be left and right curve too, if it's real, but it's not.
No, the horizon is flat.
Yeah, but if you're saying it's curving like away from you, it should also be curving left and right. Visually, you should be able to. If you think you can see the curve away from you, then you should also be able to see the curve left and right, because of you're seeing way more distance. You're seeing way more distance.
That's not how it works. That's a different curve.
It's a different curve, but it's still a curve that you can actually see.
It's based on your angle of view, is what it is. The higher up you go, the further you can see, and it's got dip to do with a curve. It's got 0 to do with a curve. You can prove this to yourself by standing on your damn kitchen floor and laying on it. Put your eye next to the floor, and you can't see very much of it. You stand up or even raise up a few inches, you see more of the floor.
Yeah, but you can see the same amount.
This is what happens on a flat surface. Literally.
Yeah, but we're talking about the surface. We're talking about
0.05 arc radians at 30,000 feet. There's nothing to see as far as curve around you. We see the effects away from you. There's a difference.
Well, you know what? Here's the reality. No one has ever seen. Yeah, you're right. No one's ever seen the left and right curve, and no one's ever going to see it because it's not real.
Because you're not,
all you can do in any curve. All you guys can do is take a perception.
0.05 arc radians.
Say that's curve. All you can take.
Hold on, guys. Hold on. Hey, hold on, Hollywood, hold on one sec. All right, guys, and everyone's a little excited because Mick is here. Let's try to keep it constructive, though. Like if Mick's making a point or Xanix's making a point, let them finish, and then continue with the point. Don't bounce a different idea, because this is getting really hard to listen to. All right, guys, let's stay on topic.
I'm happy to answer any questions, but it would be good if we could actually stay on the one question for a second. Like, say that the side-to-side curve. That's a great question. Why can't you see the side-to-side curve? You can actually see it if you go up about like 700 to 1,000 feet. And take a photograph of the horizon with a rectilinear lens, one that keeps straight lines straight and doesn't bend lines. And then you look at that in Photoshop, you'll be able to detect an actual curve. If you take a large straight edge up to about 1,000 feet and you look along it carefully, you will actually see the curve of the horizon curving down a little bit at the ends of that straight edge. So it is actually visible. You won't see it from the beach.
Are you looking for an airplane? Are you looking for an airplane window when you make this observation with a straight edge?
No, you wouldn't be able to see it from an airplane window because it's
right.
too
So you know that you've got distortion at the edges of those two planes of perspex that are convex in nature, especially when pressurized.
Nothing.
So you're making this observation for a curved surface.
Infrared photographs.
Not talking about. We're not talking about airplane.
Question to this?
Yeah, at about 32,000 feet.
About what happens
through a curved lens.
An infrared camera to take pictures of objects that were about 1,000 miles away.
So really through a lens, through another two curved lenses.
A ball that's spinning, but for some reason we were able to do it.
Yeah, so through the camera, the aperture of the lens, which is curved, and then through the window.
That would allow us to see things thousands of miles away at only 32,000 feet.
It wouldn't. So you're misidentifying what you're seeing.
Platypus, I just need to make this clear. Do you hear Jedi?
No, I don't.
You don't hear Jedi? Yeah, you'd like to. You should unmute him.
You're misidentifying what you're seeing. If you think you can see something 1,000 miles away from 30,000 feet, you're not. You can only see about 250, 300 miles or so from 30,000 feet. So you are misidentifying what you are saying.
Why another moderator can't hear me, or why I can't hear another
Mick, I also posted a picture of a HUD display that shows the level line and then the horizon below the level line, which would only be possible if the surface below you is curved.
Dude, that gets so
or sloping away from you, but yes, essentially, yeah. And this is something else you can take. You can take a water level, like 2 tubes that are connected, and you can see that the horizon drops below eye level, which would only happen if the Earth was a sphere.
So
parallel horizontals that
miles
make.
away of the Himalayan range is not possible on a globe ever. 2,800 miles away.
I'm not sure what
from above Dubai. Above
question is,
Dubai in the air on an airplane, and even the pilot admits it. 2,800 miles away, and then tries to explain it away.
Hey, Mick, can I just get
yes, from Dubai. Himalayas and Mount Everest from Dubai, 2,800 miles away.
I think that's probably misidentifying the mountains that you're saying, if that's in fact what's being
watch
claimed.
it. Watch
So,
it.
Mick, did you?
But you say that about Jay Tolan when he clearly pointed out the 700-mile one was perfect.
Hey, Mick.
I mean, but you're going to say that was cloud. No, it wasn't clouds.
Jason Tolan actually shows the curve of the Earth. You can actually see the horizon curving in some of his videos.
Do you disagree with
Have you
Neil
measured
deGrasse
it with a
Tyson
straight
when he
edge?
says that you can't see curvature at 100?
Are you going to try to pull the crap like FTFE, where he tries to show curve by zooming in with a program that shows the actual table that the thing was sitting on curving too? Are you kidding me?
I'm not sure what you're referring to there, but someone asked about Neil deGrasse Tyson. He was wrong.
So how did you come to have better knowledge than Neil deGrasse Tyson on this issue?
But it's not about knowledge. He just said something that was wrong. I'm sure that if you actually asked him in detail about what he meant, he would explain it to you.
Well, he was pretty clear about saying that from 120,000 feet you couldn't observe it.
Yeah, he
So
was
that's-
saying that it
that's a
looked
good
flat, so
thing.
you wouldn't see much of a curve. But it's
he said
technically
it was-
wrong. Yeah,
So
it's
you
not-
said it calculated to be. You say 1,000 feet, and he said you couldn't see it from.
You can't really see it with the naked eye very easily. You have to use like a long straight edge and look very carefully and have good conditions, like clear air and a
So have you
clear
done-
horizon. No, but I've seen a lot of people doing it online.
Do you have any?
Is it possible?
I'd be interested
possible
to
that
see
it's
that.
a circle of vision what you are seeing, not the roundness of Earth? Because we have a circle of vision. We see in circle.
We don't have a circle of vision. We have eyes and we have cameras, and they share the same thing.
No, I don't understand. From your point of view, you see.
It's irrelevant though. Like, let's
You see
don't
the
talk
same
about vision, because vision's irrelevant. What's relevant here is photographs, because the photographs look like what we see. So let's talk about like how a photograph is made. You can make a photograph.
That's not true, Mick. A photograph is not what we see. A photographic is a distortion of reality, actually.
It looks
Did
like
hear that right, didn't I?
if
That
you take a
helps us
photograph of
see-
something and hold it up in front of you, it will look like the thing that you're looking at. Will it not?
But all lenses are curved, so they're going to add curvature. Even the rectilinear lens, it's going to add it after bigger distances and bigger elevation. All lenses are going to do that if they are convex and curved.
Whole camera.
Different cameras will take different images depending on the air clarity of the day. This can be observed with 12-hour time-lapse footage of things in the distance, and the
What a pinhole
midground and the
camera is.
near-ground undulating throughout the day, including the horizon, depending on the air conditions, right? So it does appear that things do undulate. So you're going to tell me that everything that you see at vast distances is exactly what it is all the time? Or is refraction definitely coming into play?
Refraction is usually coming into play. But what I'm saying is that what we see with our eyes is just essentially the same as what we see with a camera. There's nothing special about our eyes other than them being round. If you take a pinhole camera, which doesn't have a lens at all, it produces exactly the same images as a regular camera.
Up close, but up far, not the case.
Yeah, at distance.
So, Mick,
Why would it be different?
Hold on, real quick. Mick, do you have any alternative viewpoints, or are you going to defend the official narrative on everything at all costs? Because I know the official story and all this stuff. Are you gonna provide us with anything like, or do you have any like conspiracies that you kind of think are real or anything like that? Like anything alternative?
You must be new to Mick West. Mick West was actually a big debunker for chemtrails in 9/11, so he's on the wrong side.
He runs a website called Made Up.
I think there's a lot of corruption in the world.
Mick West. Mick West is the antithesis of a conspiracy theorist. He's specifically here to shoot down any conspiracy and tell you that you're just an idiot.
So do you have any?
That's why I called him a shill.
That's what I'm saying. Wait, hold on. Do you have any alternative viewpoints?
Can y'all all
other than the
stop
official
talking at
narrative?
the same time?
I just want to know, do you have any alternative viewpoints other than the official narrative on everything?
Yeah, I think that there's lots of corruption in government, and I wouldn't trust
Give me
anything
an
a politician
example.
says.
Be specific. Like one thing that you're concerned about.
Well, like say the prison industrial complex. Like I think politicians pass laws to increase sentencing based in part on lobbying from the prison industry, and the prison industry gives money to politicians, so they will pass laws like the drug laws that end up with more people in jail.
That's his official narrative.
What
about JFK?
Well, the thing is with these photos, they can add curvature, and even these gyroscopes off of which you have the pendulous vanes in these flight equipment can be affected by pressure and electrical environments that can change the way that the vacuum pump operates, which operates with the gyroscope to provide the high-powered spin for the gyro to operate. So the 3 inches up and down that you may be seeing may due to mechanical error of the gyro going through different pressure environments, affecting the vacuum pump and affecting
do it with the water level.
precession and spin.
You can do it with the water level, though. You don't need to use like the gyroscopic level. So you just take
Yes.
like 2 tubes filled with water, and you can view level, like the horizontal level from that point, and you see the horizon is below that.
Depends on how you're looking. Since there are no such thing as lines, you could be looking at the top part of the quote-unquote horizon line, the middle part of it, the bottom part of it, and if you're off by even a hair's breadth, it may add up.
Along local level. Say you get a carpenter's level. Like a big, you know what a carpenter's level is, right? It's one of those long, 4-foot long levels with a little spirit level in the middle.
Yeah.
And you set that up so it's perfectly locally level, so it's flat and horizontal. If you look along that, you will see that it's above the horizon. If you are high enough, if you go to say 6,000 feet or something like that, just look along that level, and you will see the horizon is below that. Easily verifiable.
Yes,
that is something I have done.
I've done that, mate. Do you want me to get that video?
Distance, okay.
Can I just
It's
ask
a visibility concept that you're just totally disregarding.
Can I just ask a couple of questions again to Mick? So, Mick, firstly, have you ever attempted to reach out to Neil deGrasse Tyson to correct him on his misunderstanding about where you can observe Earth's curvature?
Yes, I did. I tweeted at him.
Oh, did you?
Yes, I did.
Okay. And
long
also,
post explaining why he was wrong. I think if you search for Mick West, Neil deGrasse Tyson wrong or something like that, it will pop up. I'm going to do it right
I'm
now.
interested to read that. If you post it, I'm going to give that a read. But also, because I think Flatopus's question is quite interesting as a kind of starting point for some of these things. So if I just shoot a couple of topics at you, can you just give us your opinion on what you think the story is?
I'm just posting a link to the Neil deGrasse Tyson debunk that I did.
Okay.
But Mick West in the chat.
Well, quickly, just let me finish. Let me just ask a couple of ones. So, what about JFK? What's your stance on that?
I think the Warren Commission was correct.
Okay.
You should see the video of the driver pointing and shooting him to death in the car.
Did I just hear Mick West say the Warren Commission was correct? On
Hey,
JFK?
Mick, was your dad?
Oh my God!
Right. Just a couple more and I'll be done. The moon landings
Happened.
happened as they described, right? 9/11.
Yes, 9/11 was done by terrorists flying planes into the buildings catching fire and collapsing. World Trade Center 7 was hit by World Trade Center 1, caught fire.
You're an absolute buffoon. You're an absolute.
Just getting a quick gauge on that.
Hold on. On the link you sent that 45,000 feet. Whoa, that's a curve.
Everything the news says is real and 100% true all the time.
Okay,
My name is
right.
West, and there's nothing here
Let's go
to.
back to some flat Earth stuff because I just wanted to get a quick gauge on some of those. So, Mick, sorry, go on, Lemon.
I'm sorry. My bad. You're saying?
Hey, we shouldn't torture him because for all we know, he's literally he's being forced to do this.
Yeah, no.
So I kind of feel bad. No joke.
Right?
I mean, he makes some money.
No, that
off
was
this.
forcing.
I'm pretty sure.
No,
the government's paying him.
I don't make money. I'm retired. I actually, I used to be a video game programmer.
He's just been threatened.
I mean, I guess I'm pretty sure he retired.
But Mick, you agree that right now people
Look,
around the world...
can I just address this real quick? Like you say, like I'm being paid, I'm a shill, and I'm scared, I'm being forced to do this. Can I just do you know
said,
like
that's
what
a
my history
possibility?
is?
I never said you were.
Right.
That's a possibility.
Okay. Well, let me explain like why I'm doing this. Like I used to be a video game programmer. I programmed a game called Tony Hawk's Pro Skater, which was very popular back in the day.
I used to like that.
Yeah. So it was a very popular game. I made quite a bit of money doing it, and so I retired from the video game industry, and now I just do things that I basically am interested in and enjoy doing. So I have a variety of interests.
Well,
this is one of them.
So did you know that all video game worlds are flat?
That's not true. There's quite a few video game worlds that
most are
around.
flat, though. Would you agree? Most are
Yeah, they
flat.
are. But
the water's flat. Everything's flat. Like, yeah, I can show you a cool video of a lot of different maps, and they're all flat.
Like I said, I used to be a video game programmer.
Wait, so
is
this your dad was FES?
Question.
So because the video game is flat,
Hang on,
Earth
guys.
is flat?
Hang on, guys.
I'm seeing
Reality. Guys,
I've got to ask this question. Was your dad FES, Flat Earth Society, Mick West?
No, okay.
Huh?
There was a question. There was a question in the chat that wanted...
Because if he was, then you're part of the problem.
Hello? Can I finish? Can I just ask this question?
He can't answer that question.
Yeah, hold on.
Emma.
Just ask him a question.
When somebody pauses and lets me answer, I will answer.
Guys, just
all right. My dad was a member for 1 month of the Flat Earth Society because he did it ironically.
1 month, huh?
Oh,
that's
ironically.
Emma, go and ask your question.
Well,
it's too late now. Everybody bloody jumped in and answered it anyway. So thanks, guys, for talking all over me. Bunch of that.
Yeah, guys, everyone chill out and let's try and do it one at a time.
I think.
Okay, well,
well put, Emma.
The thing is, with the flat Earth, it looks like we have a bunch of lenses that are adding curvature. Even if you look up at that fisheye, fakery up there in the chat, that matches almost perfectly the globe that they give us. It looks like they go up as far as they can before they hit the firmament, turn around and take a picture of as much as they can with a distorting lens, put black background on the photo, and pass it off as the Earth and the blackness of space. It's so simple. Why didn't we see this before? We've been duped.
He's gone anyway.
It's funny. You know what's funny is that he's putting all these pictures that could be photoshopped.
Yeah.
Wait, can I ask Mick a question here?
Yeah, no, he's gone.
Wait, what happened? Did you scare him off with the question about his father or something? What was that?
No, exactly. We were all shouting over. Like, I think this is what I warned when I said calm down.
Maybe
I think the fact that we were all shouting and talking at him probably made him leave. Which is the point why we needed to be respectful
he didn't
and shut
just
up and let
leave.
everyone
He
ask
got
the question
banned.
one by one.
What?
Oh, he got banned.
Yeah, this
You're
isn't
not
okay.
paying
Yeah,
attention
for
to
the
chat,
okay.
are you? Somebody pulled the trigger.
Yeah,
Why?
for the record, just so people know, this isn't Mick West's first time here. Okay, he's been here before. He comes in very seldom, but he does come in here. Okay, and yeah, just before he came in here, there was like 20 people in the chat, and then when he came here, like 40 people joined. Okay, so yeah, I mean, it's a big deal when someone like him joins in. We all kind of want to get at him, because he's a tool, Mick West, the tool,
He's literally a fucking tool, like you said. Nothing but the guy sits on his ass and does nothing but try to debunk conspiracy theories all day long, which he fails at.
Well,
So,
he presupposes
he says he made all this money making video game shit. How do you know that's even true?
Look, look at this
totally
impossible.
I don't care.
We don't know.
Look at this picture I just posted. Look at his leg. His
His
leg on that picture.
he presupposes that the Earth is spherical and has a certain radius.
Dude, he just told everyone.
Out of that, he builds up to what he calls the terrestrial refraction. I don't know if he's doing it personally or if some crew
Hold on.
Metabunk side is, right? But that's what he does.
Look at the picture I just posted from Mick West, supposedly with them and with Tony Hawk developers and whatnot. Look at his leg where he's sitting down next to the other dude. That is so.
Where is it?
2:47 Central Time, whatever.
Do you know what got me? It was the 35-mile away island. I don't understand how I even got that. I mean,
well, these discussions are for people listening because they need to hear both sides so they can make an informed decision. Platypus, weren't you saying something about California or whatever?
Yeah, I was gonna say he set me off with that comment where he said that you're standing on the beach in Santa Monica and you can only see half of Catalina Island. That entire
35 miles away.
That you're seeing curvature at 35 miles away at sea level, which is ridiculous. We'd see sideways buildings pointing in every direction. That just makes no sense.
Platypus, you know, he was kind of being a little deceptive because what he's saying is true. Because there are times during the year that you go to Santa Monica or something like that, and you can't see all of Catalina Island. You just see some of it because it's hazy. But there's very clear days where you can see it perfectly from top to bottom. I know my friend Judas, he actually has videos where he would zoom into the shore from like Santa Monica and stuff like that, like the actual shore, and you can see the boats.
I mean, we have that video. Don't we have that video of that timeline about the water looking like it's rising and covering that island across? I forgot what video is that, but
it's a skunk bay.
Yes, exactly. That's Skunk Bay. So it would be the exact same thing. It's the exact same.
Dude, I can't believe you just told everyone with a straight face that planes brought down the towers. I mean, this is this guy. I mean, this is just unbelievable. I know Valley Girl's smarter than McWest. This guy's just an absolute tool. He should be banned on site.
What else did he come in here to talk about?
Yeah, true.
He just came in here to push his globe line. That's it.
Although
That's
you
all
think
he
he
came
should
in
be
here to
a banner on
talk about.
site, not all of us have spoke to him before, and it would have been nice to ask him some questions that people haven't asked. Although you might think he's viable ban on site,
No, he is.
not all of us
Bambi.
have
This is
spoke
the
to him
case.
before.
No,
It
his
would have been
dad
nice for
was
us
a
to
member
ask
of
him
Flat
a
Earth
couple
Society.
questions.
Mick
There was
West
a
is
bunch of
banned on
people-
site. He's an idiot.
I didn't finish.
Yeah, I
everything.
don't.
There was a bunch of people who were trying to ask questions and were getting talked over. A few people are really upset in the text chat because they were being screamed over when trying to ask a viable question.
Yeah, well, his dad was a Flat Earth Society
I don't
member.
give a
Mick
shit.
West is a
We're-
ban
people
on.
are
Yeah,
trying
okay. Yeah,
to ask
yeah.
questions.
This is
But
no.
could
It's
you join
ban on
So
site.
it's
Okay.
deciding who we
Flat
should
Earth
talk to,
Society is ban on
But
site.
he
Yeah, Flat Earth
wasn't a
Society is
member
ban
of
on
Flat
site.
Earth Society, though.
Oh, doesn't matter. Doesn't matter if he's associated with anyone who.
Hold tight. Let's
Then
try and
Mark
calm this
Sargent
down.
wouldn't be
There's
welcome here,
gold three moderators. Come on, guys. We all know where this is going. Lots of people wanted to ask questions. Lots of people have, understand Mick West and don't want him here. But at the end of the day, it would have been nice to let him hang himself with words. He did twice hang himself because he was reifying an apparent location using misplaced concretism. Reification, right? Which is what they need to do when they presuppose are. So let's try and remember also what's going on as well. Not many people know these things, and it needs to be pulled apart. His Earth curve calculator, the presupposition that it works on, and blah blah blah.
Yeah, I definitely agree.
The part is if he's in here, and although you might not like it, it's not as if he's here every single day. So if you don't like the current conversation with him being in here, he's not going to be here long. Feel free to jump out the live stream. There are people who want to hear this discussion who now no longer have the option.
Bambi,
I mean, it doesn't matter. I mean, the good thing is we haven't recorded. We clip those and just start posting this stuff. So look how his dumb conversations are. I mean, it's just that was been perfect.
But what about our mission? This helps people see both sides. They need to see this themselves so they can make a proper decision. I mean, it's not like he's, infiltrating and destroying the server from within, hopefully. I mean, compared to most of the globers that are, real zealots, this dude was a dream. He was calm. He was collected. He answered questions, I mean, we also have to be careful.
We could have got a lot more out of
He's
that.
better than Zanuck.
Calm conversation.
Zanuck.
There you go.
We could have got a lot more.
To be fair, I like Zanuck more than Mick West.
True.
That whole conversation could have been much more productive, and we honestly ruined our time there.
I don't think so.
Never mind.
I don't
listen,
think so.
listen.
I was talking.
It doesn't matter. He can come back or not.
Somebody message him and tell him to come
Here's
back.
the thing. Here's the thing. It's really hard to. Yeah, it's really hard to have a conversation when there's 80 people in here and there's one McWest. Okay, so it's ideally, it's like, it's easy to say, hey guys, just one at a time, give them a chance. And there's 80 people in here wanting to get a chance to ask McWest a question,
But
and
you have to
he
take
left and
control.
got banned on his own volition.
Yeah,
So
I don't think you understand. There were people who wanted to ask questions, like myself and other people who were staying quiet until the opportunity came around for them to ask.
The moderators need to moderate then better.
Yeah.
Well, see, okay, so Bambi, so now you know though.
Guys,
So, but now you know.
Moderators
Now you know.
talked
Now you know.
all over several
Hey,
times.
listen, guys, let's just move on because he's gone now, so it doesn't really matter. And if there's
I
50
doubt he'll
odd
come
people in
back.
here, there's plenty other people to speak to. And if anyone's got questions or topics they want to bring up, now's a pretty good time. So let's not.
Yeah,
dwell
but
on
he
it.
can't come back if he's banned. Listen to what the moderators are
just
saying
come
when
back
it
if he's
comes to that
banned,
sort
so.
of thing.
I mean, to
the
keep
guy
the
has a huge-
conversation fresh and vibrant, we need to have people come in with all of their concerns, as long as the server doesn't get infiltrated and destroyed. So we need to be
but
able
Lemon,
to, honestly
Lemon,
deal with
why-
people.
Lemon, why did he leave?
What was that?
Why did he leave?
I heard there was a banning, so I don't know. I was in the middle of a comment, and then I didn't hear a response, and I was like, "Oh crap, he probably
His
fucked or something."
statements were so ridiculous, and like 10 people jumped upon them. So ridiculous that he couldn't even answer it.
He was hanging himself anyway. So leave it to the mods to decide, and we'll see
Well,
what
I
happens.
mean,
but-
well, the thing is, we are Legion. I hate to have that satanic reference to the demons of hell, but we devise in a way that we don't just, overwhelm one person. If somebody has covered your question, then me included, be quiet, shut up, let it be covered by one other person, so we don't have 10 people asking the same question, and keep it down to one thing so it doesn't get repetitive. Eat up the airtime that is precious among 80 people and one person. We need to collectivize along certain routes so that we can have a productive 80-on-1 conversation.
Lemon, it wasn't that bad though. You just asked him a couple of simple questions.
You need to elect somebody to do one-on-ones. You just
And
that's
you
how
know-
gotta handle it. You got to get Eric Dubay and.
Can I
To be honest, we're usually pretty good with this stuff, but it's really hard when you get someone in like that to come in. It's bound to happen, man. It happens even when like other fighters come in that are kind of like, well, no, and it's just something that can't really be avoided. But the best we can do is work for at least having a decent conversation, I guess.
Well, what I would like to point out, okay, because this just stands true. Mick West, right? Mick West.
At some point, I'd like to make a point. If someone will let me
Okay,
know
I
at
got you.
some point.
I'll wrap this up real quick, Emma. I promise. Okay, just to make this clear, McWest is this server's literally arch nemesis, and here's why. Okay, he doesn't believe in a single conspiracy. Okay, this is a server for a hotbed. Okay, this is a hotbed of conspiracy topic. Okay, so when we get McWest in here, okay, Mr. I don't even believe a single conspiracy, Mr. Iron Wall of Defense, that no conspiracy will get past me. Okay, it's just you're gonna get tensions flaring. He is the arch nemesis of this server. Okay,
Not a lot of globe earthers. Not all globe earthers like McWest either.
Asshole.
Yeah, I don't like them.
All right, Emma, can you speak now, please?
Emma, what you saying?
Lemon, everyone, stop. Emma, can you speak now?
I would just like to say that we played right into their hands because that was planned. That whole thing was planned. You don't think Mick West just suddenly decided, out of the blue, on Twitter, to converse with Bev while everything else is going on. So no,
Of course, there's an agenda. Either he was trying to feel us out or see what's up.
No, it was a
nowadays.
complete plan because they're all going on the everybody's nasty. And what happened? They came in here, and now we've literally, it looks bad on us, even though it's
We
not.
proved them right.
I don't think it does that.
Well, the
No,
word got
Well, you
spread
haven't seen
around
what's been
quite a
going
bit.
on in the background.
we
I'm
should have
telling
done
you
that.
this. I'm telling you this from experience of stuff that's going on behind the scenes. That
Well,
a
the
few
thing
of
is,
us are watching, and he came in for a reason, and he got what he wanted.
well, it's very disheartening because right now the move is to demonize flat earthers. Even O.M. Benjamin's appearance at the Flat Earth Conference may be used to peg, flat earthers as, crazy anti-Semites or whatever. There is a move to demonize flat earthers and push them out of society on some level. And if we can't get it right here in a friendly space, there isn't much hope for out there in the real world either, with people that are much less, prone to give us the time of day. We need to set the example. Show that, hey, we can have a productive dialogue even if we don't agree with everything that they're saying.
I understand what you're saying, Lemon, but do you think that he didn't have productive dialogue? Did you hear the shit he was
It was very productive. He wasn't yelling. He wasn't ad homing. He was maybe his answers were BS or whatever, but he was answering and being productive. If we can have other people on here that a straw man even more than him, I just don't get it.
Well, that's,
I mean, even with the flatter society,
that's
with good information.
But the hard part is to find an individual like him because he's clearly trained in this. So he's well versed and good at what he does.
Right. Well,
so it's nice to nice to have a worthy opponent, but I kind of get.
Well, if that's the case, let's not give it more time than it deserves, especially when there's so many people in the room. Let's open it up. Is that Gem Panda in the house? It's a full party tonight.
I am indeed. I would be a very, very poor man's Mick West, I feel. But, but I'm here if you.
I wouldn't give it to these assholes the time of day. They're a waste of space. Gem Panda, total waste of space. Mick West, waste of space.
Well, here we go.
If you want to read
Gem
about
Panda.
what they talk, just go to school.
Gem
Everyone
Panda.
knows what all this is.
Gem Panda.
Waste of time.
Hold on.
Let's show
Gem
them
Panda. Gem Panda. So you're saying you don't get paid as much as Mick West?
Yeah, are you just tag teaming in? What are you doing? Like, is this how this works? The Globe guys just tag.
The word spread through other discords, guys. It's not a big conspiracy. This one.
I just thought it'd be interesting to hear what. I thought it'd be interesting.
We're under attack.
I thought it'd be interesting to hear Mick West get challenged on a few things and see what he had to say.
No, they do what I do.
Too bad he ran off with his tail between his legs.
Yeah, we've got people from Gems in here that
got
watch
banned,
what we
not
do,
banned.
and
Hey,
then
can I say
you've got
something?
me in here that watch what they do. So it's all good.
Yeah.
Can
So
anyone hear
Gem.
me?
Oh yeah, go ahead.
Did you?
I
guys
just
hear
want to
that?
say,
Yeah.
Mick's been unbanned, so if he wants to come back, he can.
I
But,
don't know him. I don't have any line of communication with him.
I'm
Well,
just
there you
saying,
go.
if anybody can get the word or whatever,
I'll get
it's
it,
been
guys,
unbanned.
don't worry.
Anyhow, I also want to comment on him generally. He's obviously a crazy shill, and he does believe in conspiracy theories because he believes the official government conspiracy in 9/11. So he is a conspiracy theorist. It just depends on who the conspiracy comes from.
Ooh.
Yeah, so just let the guy talk, let him.
But he said a lot of things which are utterly just nonsense, and
Yeah.
he needs to be challenged on them.
Yeah,
Things
but
like
he's not a conspiracy
pinhole
theorist,
camera
Indio.
is just like
His-
an eyeball.
No,
or
his
a camera
this
is
is-
just like a human eye.
Yep, this is for
that's
the,
just ridiculous nonsense.
Yeah, this is for the audience, guys. So when they come in here, we want them to say what they say so that the people can hear them. The audience all the people who are listening. So when we challenge them on those ideas, they could hear how ridiculous it sounds when he's presenting the globe nonsense. So it would behoove us to let him come in here and kind of spew his nonsense so we could tear it down. One at a time even. Like Lemon had the right idea. So he was calm, collected. We could do this. I mean, just let him come back in here. Let him say what he's going to say. Take one question at a time and then answer him appropriately. We could shut this down. I mean, if we do it collectively, I mean, I do believe that we can do it. You guys are very intelligent. And you're able to, take any argument down. I've heard all of you, speak your mind on the thing. So it's not really a big deal to let Mick West come in here and, say what he's going to say.
Yeah, you guys have to understand what his argumentation is. He's the ultimate hand waver. He will just make claims and assertions without any type of evidence to back it up. Correct. And the best bet is to just expose it. Just demand his evidence for those things. That's people like him. You're not going to change his mind. All you can do is expose him. as a disingenuous person. That's pretty much all.
Well, yeah, I mean, he does run a website. That's pretty much all. Well, yeah, I mean, he does run a website that's an anti-conspiracy website. Yeah, he is like an ironclad like wall who doesn't let conspiracy even like get past him. So yeah, you know.
I'm banned from his website because he had this long post about Canada in his forums. And I stated something about how Snell's law is not applicable in a single medium. And he banned me for that. So, you know,
yeah, he's totally
not an honest
mainstream.
person.
He's not, I don't like him. I never have, but he's way mainstream. Like, won't bend at all, does not have an open mind at all.
Right. And this is the place where, you know, Indio could have got his word in right here. I mean, when he comes into this server, he could have told him, no, why did you ban me for, you know, putting this on there? And people would have to, listen to his response for that. And he would have got exposed in that one single argument. So there's, we got to let him kind of speak what he's going to say so that people can, tear him down with the truth.
Listen, the title of the post had the word refraction in it, Canada refraction, something like that. And he banned me because he said Snell's law was off topic.
Well, what did he
now
even
think
come
about
in here
that.
for,
If you
though?
look up Google refraction, the first thing he'll talk about is Snell's law, and saying it's off topic to refraction just shows, he
that's
he just muted me for no reason.
asking to apply the refraction at the origin or at the end point, because you're going to have a huge angle if you do it at the starting point where the light, quote unquote, emanates, which makes sense. But if it just, affects the observer's, angle, it may just be like, half a degree, which is nothing, based off of the observer. So, there's a lot of ways that we can apply this. I like to build, him back up with the truth, for the people that are hearing this stuff and don't know what to believe, because there's a lot of stuff to dissect.
Why didn't you put him in Cogdis?
You honestly think that Mick West is going to hear the truth?
He may.
Nah, I think he's a perpetrator.
Well, it's a conspiracy in and of itself to not believe any conspiracies. So by that, like, Mick West is a total.
Yeah.
Well, and then
what caused Mick West to come here?
Maybe he's thinking about it. But if there is infiltration, a healthy amount of paranoia is, possibly necessary. But, let's just use the truth to fight bad speech with a better speech.
But I mean, Bong has a point, right? Why is Mick West, right, concerned with fleas like us, right? Why does he even entertain? Why does he? Okay, well, but dude, we're fleas. Yeah, no, literally, this is like a chat full of like 100 people. Like, this is nothing, right? Okay, so why does he even come here?
And to answer Indio's question earlier, to make light of what he was talking about when he was talking about how he didn't want to talk about Snell's law, with the refraction and everything. And it's because of what we were posting and what I've been posting, what Indio posted in here. Was it earlier this week or last week? The refraction index. That at the time they took the photo of Canada, refraction was on its way down and it drops off rapidly. So the amount of refraction they would need for that photo to work out is not possible at that time of the day.
Mick is back.
Hey, everyone.
Hey, welcome, Mick.
Oh, yeah, Canigoo. That's one of my favorite photographs. It's actually amazing how much of the mountain is missing with Canigoo. It's just this tiny, tiny bit that's visible over the top. And it's very difficult to
definitely
explain.
More than 4,000 feet that's visible. You shouldn't even see the tops of them. If you actually calculate in the height of the mountain too, and then put it in with the 16,000 feet of missing curvature, that leaves you with almost a mile of missing curvature to even see the tops.
I don't think so, but let's
it
go with
leaves
that.
4,000 feet, basically, a little over 4,000 feet. How many feet in a mile? 5,280? Yeah, that's pretty close to a mile, man.
So what's with all the missing bits of the mountains there? Why is there
there's mountains
hidden?
in the foreground? There's mountains in the foreground.
So what about when you get
125 miles away? There's 1,800 meter mountains in the foreground.
Yeah, but there's other mountains which are only visible over the ocean, where there's nothing in between, where literally thousands of feet of the mountain are hidden apparently behind the ocean.
No, that's the blur line. That's where your eye can't make out what's going on there. Do you understand perspective?
Where
do you think? Holy shit.
I do understand perspective.
Hold on, everybody. Hold on. Let's do this right. Let's do it one person, all right? Because this is getting annoying. Indio, go ahead.
Oh, if you look at the image, so I'm going to talk about the 443 kilometer one. right? So I'm sure you've seen that one. From
from Pic
so
de
it's peak
Finistral?
Finestral to yes, that one exactly.
Have
So
that
where do you
photograph
think
on
the
my board in
horizon,
front of me.
horizon is supposed to be in that image?
Uh,
The edge, this leading edge of the ball, you think exists? Where do you think that's supposed to be in the image?
It's that kind of like darkish line you can see just below the peak.
But okay, so that's what you think. But if you look at the math, it's supposed to be 128 miles away, and 128 miles away is the far shore of the ocean.
I'm not sure. I have to like see the actual picture you're looking at, but the real issue here is that there are many thousands of feet that are hidden that should actually be visible if the Earth was
and
flat.
I told you why, because there's 4 mountains in the foreground that are 1,800 meters high.
Not with the Pic de Finistral to Barre de Ekrin's photograph. It's
Yeah,
pretty
like
much all ocean.
if you
all
look
the
at the
way.
topographical map, if you look at the topographical map, right, and actually look at it, there's mountains that are 1,800 miles or 1,800 meters tall in the foreground. Before that mountain,
is this guy
so if
asking
you get the angular size, it's going to block off 3,000 meters of the other mountain.
Hold on, but is this guy asking it with the naked eye, or is he asking with some type of optics?
It's an image. It was taken. I think that image was taken with a apochromatic telescope in a Nikon.
Yeah, but what the guy's asking, he's saying it should be visible with what?
You should be able to see the whole mountain.
Visible with the naked eye. Is that what you're asking, guy? Or are you talking
If
about
there's mountains in the foreground, you can't see the whole mountain. That's impossible.
Yeah, but if there are mountains that you can't see over the top of, but we're looking at things that are over ocean.
Flat. Yeah, he's saying it's flat, so you should be able to see all of this. How?
If it was flat.
That's what I want to
Hey guys, hold on a sec. Like, let Indian have a little exchange. Let him get some groundwork because you guys are interrupting and throwing in other ideas, and it's taking away from the points.
Well, I'm going to just give my general opinion, and then I'm going to shut up. Right. So my general opinion is you guys only taking. When I say you guys, I mean people that believe in the globe. When they look at these images, they are only looking at one particular data point. Right. They're not looking like the whole prediction of the globe. Where's the horizon in this image, and where is it relative to the peaks, right? And what distance is it away? So we can look at topographical maps.
Type of thing.
Well, yeah, just listen. All you have to do is come up. You can use your own calculator that you have, right?
Good.
So get the
Google Earth
distance
is
to the
actually really good for
horizon.
this type of thing.
So you can get the distance to the horizon, and you can figure out where that would be in the image. And if you look at it, it's basically the far shoreline, right? And then if you go a little bit further, looking at a topographical map, there's foreground mountains that are 1,800 meters high in the line of sight. And as you know, things that are closer have a larger angular size than things that are further. So if you have mountains that are 1,800 meters high, and there's a mountain that's another 125 miles away, it's going to obstruct a significant portion of that mountain.
But that's not what we're seeing in this image. So in this image, it's basically water pretty much all the way up to Barre de Ekrin's from Pic de Finistrals.
I suggest you apply a negative color filter, and you can see all the foreground mountains.
No, I have the picture. I actually have the picture pinned to my wall in front of me. I've had it there for several months because it's one of my favorite photographs, and I can see quite clearly. You can see the water going all the way up to that mountain in the distance, Barre de Ekrin, and you can see that all you can see of that mountain is this tiny little bit on the top, like 200 or 300 feet. Out of I think, like, what is it, like 13,000 foot high mountain. So there's a huge amount of hidden mountain there, if you look at it carefully.
If I may,
we have a different subjective opinion about what that image shows, obviously. So
we should try to find the image, and so we can be looking at the same thing.
Well, if I may, very quickly,
just go to Beyond Horizon. Let's go to their website.
Well, if I may very
ahead,
quickly, things tend to converge down to the eye line of the observer. Now, if you've ever held a coin up to you in the sky, you can block out the moon. So based off the stuff that's in the foreground, you can block huge amounts of what's in the background in a way that seems to kind of go against what we would expect with stuff converging down to the eye line with perspective. And so with the focus of the camera, you can make the stuff in the foreground back off like the coin in front of the moon, and the stuff in the background loom up like the moon looming up past the coin, depending on your angle. So I think it's the zoom lenses and foreground stuff being zoomed in, zoomed out, raised and lowered by the zooming of the lens.
Really, how it works though, that wouldn't make the bottom part of a mountain be vanished, because the bottom part of the mountain has essentially the same angular resolution as the top part. Why is it?
No, it doesn't. No, it doesn't.
Why does it have? Well, when you've only got like a few hundred feet, when you've only got a few hundred feet of the mountain visible over the horizon, that portion has a way smaller angular size than the lower part of the mountain. So why can you not see the larger part of the mountain?
Up to a point, you are correct. But when the light rays are so smushed and so compressed, no amount of zoom can bring it back unless you have a highly powerful optic that can somehow separate these light rays that are so smushed and merging from two rays into one. So all of these are very complicated interplays.
Why can you
see more than the tops of those mountains?
Can you? Why is it only the top of the mountain above the horizon?
Equal elevations,
not
equal angles. I don't think you're understanding that. Like,
I understand. And
no, you don't. No, you don't. No, you don't. You have no idea.
Listen, you can look this up in a book called Trigonometric Delights, right? So the equal angle. So so say I have 100 meter space, right? If it's at eye level, so if it's at eye level, it's subtends one angle. But if it's below angle or above eye level, that angle subtended is going to reduce.
This math, what you're talking about, is what I used to do every day for like 20 years.
Now, you're not addressing anything I said.
Hold on, Fraud.
You're just like appealing your own authority, like you're using yourself.
Can you math the boat that I've posted a video of that's disappearing over the curvature of the driveway? Can you math that? Can you tell me why that boat is disappearing from the bottom up?
Looking at the right thing here. So I'm just looking. I see it now. That, like, if that boat disappears behind something, that means that the ground isn't flat.
But if it disappears from the bottom up and the surface is flat, and it also creates some, other atmospheric effects at the horizon.
You know how? Do you know how cameras work?
Yeah.
How do they work?
It's time to propose a new model, Mick. You need to talk about the compression at eye line. So you need to have an eye line go out 180 degrees to the flat plane and talk about convergence rates with angles to that eye line.
Right. I think the issue here is that people are talking about optics and cameras and looking at things, but you don't really understand how optics work and how cameras work.
No, I see. In the demonstration, I see a boat disappearing from the bottom up, which appears to be a flat surface. That's just happening.
A flat surface.
Well, I use my eyes.
Is it flat though?
I use my eyes.
Can you shoot it with a laser?
I mean, laser's different. We're talking about observing something.
I observe.
Go ahead.
Hey, whoever's talking, let Jedi talk.
So it's a different function observing something and shooting a laser at something, because this is an optical phenomena. You observe this happening, and you shoot laser, it probably has a direct line of sight. Now, how many videos of this do you want for you then to assert that there's a radius value within every single floor?
What I would like is for you to demonstrate that the floor is in fact flat, and then show the boat.
How level do you want the surface? And don't remember that we're making observations over the sea, which is not flat.
I would like you to make, like, say, use a laser, and just show that it doesn't deviate within.
When would the laser start refraction?
1 millimeter. With a floor, you would hardly get any refraction, so it's irrelevant.
Okay, what if we shot a laser over a distance of water?
That's a different thing. What we're talking about here is you demonstrating that your video, in fact, shows some kind of optical way that a boat would disappear below an apparent horizon on a flat surface, which is kind of what you're saying. That's what the video shows there, isn't it?
Yeah, I'm showing you an optical phenomena, which appears to be, as the angle is decreased to the surface of the floor.
If that's true, if that's true, that would be great, because that means you could actually disprove all these this nonsense optics that apparently people are using in the real world. So why don't you do a bit of work and try to rigorously demonstrate?
I'm just making an observation. You're the one who's coming along and having to math and apply a model.
What I'm saying is that your observation is wrong.
Look, my eyes and the camera are wrong, so you are declaring that this can only happen over a curved surface.
Obviously, what you see is what you see. But your interpretation
over a curved surface. You're saying it can only happen over a curved surface. Even though I can probably go away and give you another 30 demonstrations, which you will just hand wave away and claim there's an R value in the surface of the floor, even if it's a supermarket floor or an ice rink.
It could be an inclined surface with an angle in it. It doesn't have to be curved as such. But yeah, a flat surface inside a building, anything like less than, say, 100 feet, then you would always be able to see the floor from any position above the floor. Because there's a line of sight from your eye to that point. If you can draw a line from something, from your eye to something, then you can see that thing. That's a fundamental law of physics.
That's not always the case. It's demonstrated.
I have tried it in my home with.
Well, that's not true at all, and you know it's not true. I don't even know why you say that.
It is entirely true.
So the Sirius, it's supposed to be 2 stars. So why do I see 1 star?
But if
there's a line of sight to each star, right?
Because there's a difference between being able to see the light from something and being able to resolve the individual thing.
How come I see that the sun and the moon?
You just said we could see it
in the sky?
But if you can't perceive it, if you can't distinguish the difference between 2 objects, then you can't see the object, right? If there's 2 objects there and you see it as one, it doesn't have to be obstructed by something else. One of those things. Right,
so there's an angular size. Yeah, there's an angular size below which you can't resolve things, but you can't say that the top of a mountain, which is smaller than the bottom of a mountain, is visible, and then the lower part, which has a larger angular size, is invisible because of that angular size. If it's big enough,
there's also an angular size where you cannot differentiate 2 objects from one.
Sure, yeah. That's the resolution limit.
I'm saying there's like a smaller size. That's one aspect, but the other aspect is differentiating two particular points of light and seeing them as 2 distinct objects versus 1 distinct object.
Mr. West, as you know, if light rays get too close together when they're refocused, the object effectively disappears as the 2 rays merge into one, which means at your eye line, you're making angles going up and down, and as those light rays are converging up toward that line, you're going to get disappearance and convergence, which would make stuff up here to disappear over a curve if you had that paradigm in your head, or just simply converge at a horizon line optically over a flat plane.
Horizon line is kind of like an irrelevant thing for that, though. Like, let's say you just were looking up at 30 degrees. Where's the horizon line now? Is it always at the same place relative to your
direction, Mr. West? If you look infinitely in that direction, that would be your new horizon line. But over a flat plane, guess where your horizon line will tend to be? In the forward direction infinitely.
So if I were to look down at the ocean instead of looking at the horizon, would that mean the mountain would now be visible because it's now above my horizon line?
You still need a wide enough angle. Are you looking forever in that direction, or is there a flat plane beneath your feet that is limiting how big the bottom half of your vision is? You're only 6 feet tall-ish, so you're only going to have 6 feet or less from your eye line down for the bottom part of objects to converge up toward that horizon line, going straight out over the flat plane.
Not actually how it works, though. Like, what if you were to look up so you can't actually see? What if you were to look upwards so you can't actually see the ocean at all? So the horizon is just below your field.
Wait, you're saying the way we see it is not how it works.
Below is there a 6 feet barrier below your feet angling up 30 degrees as well, infinitely in that direction? Then yes, you would see the same behavior. But if you're looking 30 degrees up and the ground is not in the way, the convergence changes. Now you have infinite room up, infinite room down. The only limit would be how fast it converges toward that point.
Why does it look the same regardless of which direction you point the camera?
Hey, real quick, Mick West, we have 2 members here that have been wanting to ask you some questions. I just want to make room for them before we get onto a quick topic that might last forever. Emma or Bambi, feel free to ask your question now.
One.
It's okay. My question was answered way earlier.
Okay, sorry about that. It's because they've been asking on DMs.
Sorry, I was muted and trying to talk. That's embarrassing. No, what I wanted to know is I've heard a lot about you and communicating with Dr. John D.
Yeah.
What kind of flaws did you see in what he was doing? Like, what do you go against?
Well, he seems to have this really strange misconception of how refraction works, and saying that you can never get downwards refraction. And when he actually did his experiments, he measured. He was quite good actually. The way he did it, he measured the temperature at various levels, but the temperature variations he actually showed in the video were actually enough to create the amount of refraction needed to bend the laser light around the curve. This is the.
Oh my God! What
He
a
did.
Holy shit!
So wait, lasers.
This was the
I didn't know. I didn't know that lasers are able to bend around curvature.
They don't.
They are. Yes.
Yeah, but
No, they don't.
Good
God, man.
On a molecular level, can you show me lasers bending around a curve?
Well, I can just show it. I can show it in my garage. It's quite easy to do.
All right, yeah, all right. So, all right, let's
let me explain. I want to hear the explanation. How do you do it?
All right, you does anybody here actually have a laser?
He changed the temperatures around the laser, trying to create a refraction, is what he did. But the thing is the temperature medium at night,
it's not,
the air has already mixed and is stabilized, and you're not going to get that change.
That's not the question, though. The question was like, can a laser be bent by the air?
Upward, but not downward. No, she was asking about down and around the globe.
So
yeah, I was asking
why
if it could bend around a curve. It's not going to bend upwards around a curve.
Oh, yeah.
The Earth doesn't curve up.
Bend down.
So
you know the basics of how refraction works. Like things get bent towards more dense mediums. Like when something goes into water, it bends down towards it. Yeah. So
the problem is the light has to go from the.
Can we have him answer it, please?
Oh. Go ahead. I'm not really sure how to answer it because, like, it is quite demonstrable that a laser light will bend towards cold air, and you can demonstrate this. Like I said, I do it in my garage all the time. You just take an ice pack, you take a laser beam, and you shine it across the top of the ice pack, and it will bend down. Now, you do have to be careful doing this. Like, you have to actually have a very long line of sight because it doesn't bend very much. But you can actually demonstrate it. And we do know that at night, like the ground is colder. Well, not at night. Like during the day, the water is colder than the air. This is something that is known. Water is colder than air.
Not in the South Pacific.
Most of the time.
Not in the South Pacific.
There is, yeah.
Not where I live.
All right.
Excuse me, I live in Florida. It's the opposite of that.
No,
buddy.
listen. He just backed himself into a corner. So when we do this, when the air is colder, then I guess you're going to have a new excuse, right?
Yeah, no. It varies. Like sometimes the light will bend up, and sometimes it will bend down. And this is something that Dr. John.
This is why you guys get called pretender clowns. You're just pretending that you know this. When did you become the expert on refraction over water? After the flat Earth took off, right? Yeah. Coincident.
Flat Earth Society is in the heezy.
Bill, God.
Anyway, he has no argument with Dr. John D. He can't even argue with the guy. He's a total joke.
I
Mr.
hope you have to argue with Dr. John D. Like he has some other photographs where he took pictures of a headland, like a cliff.
You do realize that we have somebody that was here for that test, the peer-to-peer laser test, in this Discord right now.
Well, no, that's great. That's great.
He's actually on site for it.
Yeah, I thought the test was
none of your shit's going to fly when you talk about all this garbage about refraction. When they were there, they observed this crap.
Being there doesn't actually change.
You're also forgetting this shit doesn't happen at night. I already showed you the refraction index. But you're going to refute what mainstream science shows you, right?
Oh, no. It's a very simple. It's the temperature gradient of the air, and that varies throughout the day. So,
at night it mixes and it becomes stable. And that's why it's nil at night, Mick.
No,
that's what that graph literally shows.
But no, that's not what Dr. John showed, though, is it? No, just one second. I want to address this one point. So this one point first. He said that there was no refraction at night, but his actual own measurements showed a temperature gradient of about like 3 degrees over the first, I think, 2 or 3 meters.
Okay, and they accounted for that. They took into account for everything.
They did
found, and guess what? Yeah, they did. Yeah, he did.
Couldn't be any
Ask CJ. CJ's right here, man, in the Discord. Just ask him. Just ping him and ask him.
Hey, Mitch. Mitch, I have a question for you. So all this talk of refraction, why not get a test that doesn't have refraction as such a major component? I posted one in the chat. I'll do it again real quick. And that shows high altitude view of the horizon versus the level, with the moon in between the two. Then you get rid of all your refractive problems. right? We're in the high atmosphere, very little air. Level.
You still get refraction if you're looking towards the horizon.
The horizon could be all over. We still see the moon, which is quite a bit further than the horizon. So the horizon has to be below it.
Hold on. I have to add, that's a heads-up display.
Correct.
That can be. You can take a camera and point it at a different angle to the heads-up
No, you
display.
can't. That's not how they work.
You're supposed to view those things directly. They're not from angles.
If you're not looking at it directly, you can't see it. They go invisible. That's how they're designed. Otherwise, planes would be crashing.
Hold on,
when pilots are slouching in their seats. It doesn't work that way. This is the way.
Yeah, that's the thing. Pilots would have to not slouch at all. That would be unrealistic.
It's not. No, it's not
unrealistic.
Yeah, their eyes
that's
are allowed
making
to move
it dangerous.
Okay, one at a time. One at a time. Yes,
that
one
makes
at
it
a time.
dangerous. So why would they design something like that that's dangerous like that?
That's why
it is. It's bad. It's poor designing. That's the way it is.
You understand how they.
Mr. West, back to the
garbage anyway. Zanuck, you spew that shit in here every day, man. We don't need to hear anything from you right now. Literally.
Mr. West, back to the refraction. The conditions that we typically find these laser tests in are over water, and water absorbs heat faster than the surrounding air, so you're going to have a warmer layer of air over the water typically, which is going to lead to upward refraction with cooler layers above. So in the
water is
these lasers, that's going to be your typical condition.
You can't just keep talking if I've said something is wrong. If something is wrong, there's no point continuing. If you made a mistake, like you said that water is going to be warmer than the air, the water is not always warmer than the air. It's quite often it's cooler than the air. If the air above the Salton Sea is 100 degrees, you don't have water that's 100 degrees, do you? You have water that's about 70 degrees.
That's because the air above it is warmed up by the water, which absorbs heat from the air, releases it into the air, leading to a warmer layer over the water.
You get a cooler air over cooler water. If the water is cooler than the air, it's going to cool the air.
We have somebody that wants to ask a question. Bambi, I think, was in the middle of asking her question. Go ahead, Bambi.
Yeah, it was about the experiment you did. Like, I was going to get you to explain it and what you did and if you've got any proof of it, but we started shouting over about how lasers don't go up. But that wasn't the question I asked. I wasn't talking about lasers going upward. I was going to ask if you've got any evidence that you've done, or do you want to explain it and break it down?
Let me explain just what I did in a little bit more detail, and I can post the link to the video of me doing it. What I wanted to demonstrate is if a laser is shone over something that is cold, it will bend down. And this is because the air is cold and it's bending down towards the colder air. And the way I did this is I set up a laser at one end of my garage, and I set up a mirror at the other end of the garage. And I set the mirror up so it reflected the beam of the laser back, so it was right next to where the laser was. So you could very easily see any deviations in the beam of this laser. And then I took two things. First of all, I took a lighter, like a cigarette lighter, and I held it next to the laser beam. And I saw that the beam was deflected away from the hot air, because the hot air is less dense. Then I took an ice pack and I held it underneath the laser, and I saw that the laser beam was deflected down because it's deflected towards cold air, because cold air is more dense. And we know that in the atmosphere, these two types of things exist. We get hot air, we get cold air, and sometimes we get air which is colder lower down, and sometimes air that is warmer lower down. So it bends one way or the other. So we can demonstrate that this bending actually exists, and that hot air and cold air can bend laser light. And we know it exists in the atmosphere.
Consideration the temperature and the heat of such things. What if we were to take that into consideration and
that would be great. That would be great. And the problem is that Dr. John didn't actually do that. He did these measurements, but he basically said, and the measurements showed that there was no refraction. But that's not true.
You've done this to prove it. If you're making that claim, you've done these measurements.
Yeah, you said you had a link where you didn't post it.
Every meter you've done these measurements, Nick. Every meter you've done these measurements, Nick.
Also forgetting the fact that the air is already mixed after the sun went down, so you're not going to get your damn refraction, Mick.
Dr. John did the measurements.
You keep avoiding that one specific point.
Nick, where's
Dr.
your
Dr. John.
You prove refraction. Where's your measurements?
What?
Come on, Mick.
You are saying that Dr. John is an expert.
I am asking you where your
Well, he has a PhD in spectrophotometry. What do you got, Mr. Gamer Boy?
I just have a BSc.
Yeah. You got nothing. Exactly.
The experiment you're talking about. The experiment.
That's what you got. Now you tell me where your experiment is. You tell me where you have measured the atmosphere to prove that it is happening. You say he hasn't measured it, so he can't. It isn't. Tell us where you.
Mate, can you put your link in the live stream, please?
Yeah, sorry.
Can
I
you
was
put
trying to answer
video
this guy, but he won't let me get a word in.
Well, first of all, you haven't even looked at the
You
experiment.
will answer what I told you to answer now, or this is over.
Hold on. I still haven't got the link of him doing
I'm not
what
sure
he was doing.
what you want me to do. Like, we know that.
You to show us the measurements that you have taken to prove
Okay,
it is happening.
right. But like, do you think that the air doesn't get
The
colder?
measurements you have taken, Mick, where are they?
Well,
The measurements you have taken, come on.
the measurements of what?
The measurements you have taken.
Well, let me post the link to my video.
Happening.
Let me
That's
find
what
it.
I want. That's what I want.
you
The fucking
tell
video.
me.
Post it, please.
Let me
You
see.
tell me. You tell me. I'm
Refractor.
driving. I'm not watching a video. I am driving.
Okay.
You will tell me.
He can explain it to you in a minute, meme, but I want the fucking video, and I've been asking for a very long time. Please let him send the video, and then he can explain it to you.
Mame, you're also coming in a bit distance. I understand you're driving, buddy, but you're a bit like far away. Not coming in very loud.
So yeah, Mick, if you can please send the link into the live stream and then just explain.
No, I am. I'm just looking for it. I have so many videos that have the word refractive. I had it. I already posted it before, but I got booed. Oh, here it is.
Dude,
Oh,
man.
No, just post it when you get it, and then for me, because he's
I got it.
driving,
I got
can you
it.
just explain it to him? Thank you.
So Mick, real quick, where we post things, I don't know if you're familiar with this Discord, but there's a channel right under the live stream. It's called live stream. Oh, it's above the live stream. Sorry, it's live stream 1 voice text. You can drop it in there, and that's where it's,
I just did.
Awesome.
He's got it, Jose. When I gave him VC verified, I explained that.
Yeah. So that it's basically it's what I explained earlier, and it's showing that that that's my garage, and it's showing the light bending towards cold and away from hot.
No, where have you measured this across the great distance we're talking about?
I used Dr. John's measurements. He posted it in his video. The temperature gradient. He actually measured it. I haven't done it. I'm using Dr. John's measurements. Why? What's wrong with his measurements?
I'm asking you about Dr. John's measurements. I'm asking you about yours to prove that it is happening.
Well, I haven't done a long distance laser measurement like Dr. John measuring the thing.
You haven't done
But
anything.
he has though.
You haven't done anything. Yeah, but what I'm asking
you haven't.
is, where is your measure?
I've done
to
experiments
prove that it
that.
is happening. It's just you saying it. It's just you saying it. It's just you saying it to counter something. That you
I think
say
you're
you
repeating
should be
yourself
accounting
now.
for.
I think you made your point.
This is this. Can I ask a question now? Can I have a real quick one question for Mr. West? Mr. West, please. So I heard your father was part of the Flat Earth Society, and I was wondering, is the Flat Earth is the Flat Earth Society like a bunch of globers that are actually going around trying to make Flat Earth look stupid, and how are you not part of it? You know what I mean? And what do you think of Flat Earth Society?
I tried to make you look stupid. And my dad just did it ironically. I think he did it in the 70s.
He did it ironically, but he told you that the other side needs to be done. That's what you said on JRE. Don't you lie. Don't you lie. You limey.
What am I lying about? I'm not sure what you mean there.
You just said he did it out of irony, but that's not what you said on JRE.
That's what I said. I said.
Well, I'm curious where your loyalty is. I'm curious
if, as a joke.
I'm wondering if you're more, if you're a Flat Earth Society,
he's
if
not
you're
going to tell you his loyalty, Bong. He's not going to tell you his loyalty.
Right, I'm just wondering.
Let's just break apart his fucking stupid experiment first, though. Let's just do that. That'll get him out of here. So let's get back to your experiment, supposed, right? So your laser, what's the intensity of that laser?
Well, it doesn't really matter what the intensity is. It's a visible laser. It's just a laser pointer, but
it
works exactly the same.
So right, it's more exciting. So you said you held it up to a flame, right? next to a flame. Is that correct?
Yeah.
Is that flame putting out more energy than that laser? You would consider at that point it connects?
Probably, yeah. Because it's just heating the air.
All right, but can the
ice pack isn't putting out any energy?
Here's a question for you. Can the laser light heat air? Is that possible?
Not very easily, no, because its air is transparent.
All right, so if you continue to increase the intensity of that laser, what will happen?
Not sure where you're going with this. Could you explain what your point is?
I'm trying to. If you can answer me that, what will happen?
What? Can I increase the intensity of the laser? No, it's a Logitech laser pointer.
All right, but
he's asking, what if you did?
Right.
Exactly. It wouldn't make any difference whatsoever. Zero difference.
Wow, you hear this guy? Wow.
Well, Mr. West, it's a problem because if you take the supposed globe and surround it with concentric rings of air layers, then you would have, say, what you're trying to say is basically a warm layer under a cooler layer toward which the light refracts. Okay, that's fine. But over long distances, you're essentially saying that light goes up into the second layer and goes back down into the first warm layer to hit the eye of the observer. That's a little hard to believe because that would have for the thing to go
I'm not sure what you're saying.
But he just doesn't. This guy doesn't understand lasers. There's no point arguing with him. He just doesn't have no idea.
Wait.
It's got to go.
Here's the whole problem, guys. With his whole entire thing, he's changing with the experiment that he's doing. He's changing the temperature around it, right?
Exactly.
Okay, but what's going on at night with these laser tests is it's stable. It's not changing anymore. So we're not going to see this. This is the problem. You're inducing this refraction. This is not happening naturally because there is no mixture of air where you're having that huge change at night anymore. Literally, you're not having that much change. So guess what's not going to happen? The refraction.
But Dr. John,
Jesus Christ, this is why we posted that damn graph, man, that you're going to deny again.
Well, are you going to deny Dr. John's
measurements?
measurements?
He doesn't know what.
No, the graph he's talking about, Mick West, is I forgot who did it exactly, but it was a bunch of people that got together and they were trying to test the refraction. They tested it for about 72 hours, 3 days in a row, and they got the conclusion that I believe that the most amount of refraction they got was when was it, Reg, exactly? That they got the most?
The day is when you get the most amount of refraction, and in the evening and in the mornings it drops off rapidly, and at night there's none.
And that's why we have to match these conditions one for one, Mr. West. Otherwise, they have a theoretical sugar water abstraction.
And if you look at the reason why. Sorry, Lemon, hold on. If you look at the reason why, you'll notice it's the temperature difference, just like you said. The reason why, though, it goes and it bottoms out and it's nil is because the temperature in the air has already mixed, and now it is constant. There is nothing changing.
But would you agree, then, that you would have to measure the actual temperature gradient at that time?
They did take the temperature at the time they were doing the laser test.
They did do it, and they found that there was a temperature gradient.
But do you understand that there's different types of
Excuse me? Not at night there wouldn't be.
They found it in Dr. John's experiment.
Hold on. Do you know that there's different types of lasers, right? Do you understand that?
Well, sure, yeah. Different wavelengths, different ways of generating them.
And
different kinds of Logitech
lasers. What are different types of lasers used for? What can be the use for a laser? Can it be used as a weapon? Is that...
They used to illuminate things and they used to heat things. And they used for a variety of other reasons.
So why would a laser that's used to heat things be affected by what the fuck you're talking about?
Well, this is the thing with lasers. They're targeting devices. We can use lasers to point at shit and paint targets and say paint because that's what the military do. Now, military use lasers. Yeah, so military use lasers to paint targets over distances that should have to take into account the curvature of the Earth and now your light refraction. These are from vessels at sea. Now, it seems, with a little bit of research, that quite a lot of their ordnance and weapons that they use for the shit out of stuff requires a direct line of sight targeting system, up to and including about 100 miles. So if they can aim lasers at shit up to 100 miles away, you know, that's got a direct line of sight and is directly in front of them from a vessel at sea, and the target device is somewhere about 40 foot off the surface of the water. Excuse me. So if that's happening, practical, everyday use, I think we're fine shooting lasers over 25 miles, right?
You wouldn't be shooting things that are at sea level because you wouldn't be able to see them.
Well, according to you, but right now I've just pointed out, I said military, I should have said Navy. I did say vessel. I did give you a height of 40 foot above the surface of the water, aiming at a direct line of sight to a surface-based target. Now, this is 100 miles, it seems, with a little bit of research. Many of the ordnance they use require a direct line of sight.
I think you're probably referring to rail guns. I think you're conflating two different things.
No, I'm not. I'm actually not talking about railguns.
All right, so like, post a link then.
Yeah, I'll go and get through. But what I'm referencing is military do seem to have lasers that paint targets that require a direct line of sight at distances where Earth curvature and refraction should have to be taken into account.
That's great. Let's go with that then. Let's post me that evidence, and that will prove it.
Yeah, okay. I'm surprised you haven't looked into this before yourself, Mr. Mick West, who knows everything about light refraction and what lasers do. We're talking about a test that's done over 25 miles, or one that's done over 10, or any other laser test or line of sight test that requires, like I just said, a direct line of sight. That's easy to understand light refraction. No flat earther is denying that light refracts through the medium of the atom. Can it be demonstrated to curve around the curvature of your Earth? Not just in a little box where you've got an ice pack underneath it, because we're talking about the majority and most conditions, depending on the air clarity and conditions of the day. Direct line of sight is required when shooting lasers at shit.
Oh, it's,
can you hear me?
Yeah, line of sight is, but not a geometric line.
Yes, we can hear you.
So I want to put in my 2 cents about this. Like the experiment, that would be what you would consider a special case. That is not the general case of the atmosphere. So the basic claim of globe proponents is that the general case, generally, that air will refract light down because of the weather conditions. And that has not been demonstrated, right? Not been demonstrated in the environments that these tests have been done in. Now, of course, you can make a special case test. I think it was Greater Sapien did one over CO2 in frozen ice, right? So, but he didn't take into account that CO2 has a higher refractive index of air, and it's way colder than any environment on Earth. You know, so these are special case experiments. These are not the general case conditions that we find ourselves in. And I think like just showing that light can refract says really nothing. We all know light can refract. Okay?
So you got to look at the actual conditions.
Did it refract in this situation? And what do actual measurements and tests of refraction show?
Look at the actual measurements that Dr. John did. I can post them if you want. I've got them right here.
Mr. McWest, I have one point in your courage test that is wrong, or I have a question for that. You said that in the warm air, it's
just posted the temperature readings of Dr. John, by the way, if people want to check out them. Sorry, but carry on.
Okay, in your courage test, the laser.
I'm sorry, like you said. Oh, my garage test, right?
Garage.
Yes.
Sorry, my English.
Garage.
The laser starts in warm air.
Yeah.
Like maybe 20 degrees Celsius in your garage.
Yeah.
And it goes nearby the ice. And it goes into the colder air. Maybe, I don't know, minus something. The ice was
probably like minus 20, minus 15, minus 20 or something like that.
Exactly. Where does that happen in nature? That your laser starts from a warmer temperature and goes through the colder temperature when you point it across the lake.
If you're on the shore of the lake, then the air around you is say like 90 degrees.
How many degrees
Fahrenheit
difference is in the where the laser starts?
What do you need actually? It's quite interesting. You only need about 1 degree of difference to curve like over the surface of a lake. It's quite interesting just how little of a temperature gradient, because the gradient it's not really the amount, it's the amount per meter. So if you've got a gradient of say 1 degree per meter, that's actually a huge gradient. But because it's very close to the surface of the water, you get this very, very steep gradient just at that point, which is why you have these issues with the lasers, and it's why you also get this very thick line of compression at the bottom of the images just over the horizon, because close to the water, you get this steep gradient.
Okay, so I'm looking at
which is what Dr. Don showed.
Yeah, well, he didn't measure at 2 meters. He didn't measure at 1.5 meters. He didn't do his measurements at 1 meter. He did them at a single elevation, right?
No, it's this 5 measurements there. Oh, sorry, 4 measurements there. Above the water, 0.5 meters, 1 meters, 1.5, and 2 meters. And the difference between above the water is 1.5 degrees.
The elevation that he did, the laser was at, the laser itself.
No, it doesn't matter there, because at some point the laser is going to be skimming the surface of the water.
Listen, it does matter because this is a vertical chart, right?
So either the laser's got to hit the water, or it's going to skim the horizon.
So I think.
So if it's skimming the horizon, that means it
this
goes.
chart is vertical. He didn't shoot the laser vertically. He didn't cross this gradient.
No, it shoots when you go along the gradient. What happens is that the light bends towards the more dense the air, the colder air in this case. This is something.
There's some boundary. There's some boundary.
No,
right?
no. It's actually a very difficult thing, and it took me a while to understand.
I mean, this is all theory, dude. When it comes down to it, like where's like the data sets that actually show this happening? You took an extreme case, 70-degree Fahrenheit, going over, minus 20 Fahrenheit. I don't know what type of environment that is in nature, because I don't know of it ever existing.
It's an extreme example because it's hard to show. But Dr. John's own measurements
just said it was easy. You just said a 1 degree temperature difference will show a significant amount of refraction.
Over that distance, it's hard to show in my garage because my garage is only like 40
1
feet long.
degree, right? So say you have 1 degree per meter difference. Okay, so you shine a laser 15 kilometers. That's 15,000 kilometers. Or 15,000 meters. So if you have a 1 degree difference, it's 15,000 degrees at the other side.
No, it's the vertical temperature gradient. It's again, it's like a difficult thing to explain here.
If you're crossing the vertical gradient.
No, that's the refraction. Look up a thing called gradient index optics. There's a difference between light going from one medium to another and light going through a medium where there's a gradient. It's actually a very different type of thing. Light, even like you know about Snell's law, and the amount it bends when it goes from air to water. Now you think if something was shining parallel to the surface, there would be no bending. And so you think that if something is shining at right angles to the temperature gradient, intuitively you would think there'd be no bending, but there actually is, because a light actually bends towards the more dense medium. It doesn't matter about if it's actually going into a more dense medium; it just bends towards it because it's not actually a line as such. It's actually a wave front. Light is a wave, so it will still bend down, even though the temperature gradient is only vertical.
So
it's
so a
kind
portion
of
of the
confusing.
cone, a portion of the wavefront will go to the medium, and another portion won't. Right?
No, it will.
This is layers, right? This is 4 layers. I'm at 1 meter, so I'm just going off his little data here. This little data set from John D. So say the laser's at 1 meter. He's shining exactly horizontally. Now, and we assume that from the target from the source to the target, the laser is always at 1 meter elevation.
Yeah.
How is it crossing into the 1.5 meter?
It's not. That's the thing. That's the fascinating thing about it, is that it doesn't need to go.
I'm asking you how it's done. How does that happen? I know that there's beam divergence, right? So there's going to be spread. A portion of the wavefront is going to spread out and go higher and lower. But the centroid of the beam is not going to. That's not going to happen.
Light,
the main
light is like a wave,
right?
No, it's not. No, it's not. Light's not a wave. Wait, light's a particle.
Right, it's a particle.
About to get destroyed.
No, it doesn't. Particles don't act like waves. Particles act like particles.
Water is made of particles, and
but light isn't. Light is made of particles. Light's not water. You false equivalence fallacy, knucklehead.
Water is made of molecules, which is
light is made of particles. It's not water.
And
clown show.
It acts like a wave.
Photons are particles.
Act like waves.
They don't.
Stop screaming.
Why do you get like interference and things like that then if they don't act like waves?
Yeah, QE. Look, dude. Okay, we're talking about something else entirely, dude. And you come in here wanting to talk about waves and particles. Look, dude, you're not going to interrupt the conversation and take this in an entirely different direction. McWest, continue talking about refraction.
All right, so yeah.
He was it is relevant though.
Hold on.
About something.
Mick made a claim. Mick made a claim.
From ray optics to wave optics, right?
QE is refuting his claim that he made as part of his argument.
That light acts like a wave, which it does.
No, it doesn't. You can keep on saying it, but you're wrong. To refute light as particles, you have to refute the photoelectric effect, number one. Number two, Compton scattering, number two. Number three, Heisenberg's uncertainty principle. You ready to do that right now?
I don't think any physicist would argue that light does not act
you
like
can't
a wave.
speak. Objection, Your Honor. You
Okay,
can't
QE.
speak to any physicist.
Dude, if you QE, if you don't,
Thank you.
So,
question and answer.
Say again.
Dude, QE, stop yelling. Okay.
Hey, who are you? Who's giving me instruction?
First.
Who's giving me instruction?
No, I mean, for the sake of conversation, like, let's try to keep it civil. You know.
Hey,
like,
Indio, are you in here?
What?
1 second. Indio, are you in here?
Yeah, I'm in here. I'm taking care of it. Just chill.
Okay.
All right. So, can I carry on?
No, you can't. Just wait.
Okay. All right. Yeah.
Yeah, because you sound really stupid.
Yeah, because just like when you stop Living Bird, when he says something wrong, QE is doing exactly the same thing, so don't get mad about that. Or Mick, what?
What is a science communicator, Mr. West? Because you are a science communicator, and so is Neil deGrasse Tyson. What is that?
It's someone who popularizes science and explains it to people, I guess. It's like
stupid people, right?
You don't even know what science is. What's up?
No,
wait a second.
Yeah,
science
you don't even know what
communicator?
lasers are. What the fuck is wrong?
Wait a second, folks. He's a science communicator? Do you even know what a scientific hypothesis is?
Asking me what a scientific
Yes, I'm
hypothesis
asking
is?
you. I'm asking you, what is a scientific hypothesis? What is an let's keep it simple. What are the three constituent hold on a second. What are the three constituent parts of an experiment?
Well, off the top of my head, I don't know. Like, I guess.
And you're a science communicator?
Yeah, but this isn't the type of science that people want to be communicated with. I mean, you have like the independent variable, you have the variable, you have the hypothesis.
I would
wrong.
I would argue communicating a scientific principle is different than communicating a scientific experiment.
Wrong.
Science
Everything, the whole basis of the scientific method is based on experiment.
That's why, like, Dr. John's experiment was actually a pretty good one.
Dr. John didn't perform an experiment. He even told you that. Now, let's get back. You didn't. You're a science communicator, and you don't know what a frigging experiment is? You'd fail 5th grade general science.
Well, I don't think that's really relevant here. Like,
he is also an expert on debunking on what chemtrails.
Would you stop changing
You're an
the
expert,
subject,
right?
But like, you talk about like stuff
he has
like dependent
dedicated
variables.
his life to debunking and making conspiracy theories look stupid. I just want to know what is.
Hey guys, Vaughn, let's stay on topic. Let's not switch it up.
So we got two subjects on the table. One, you don't know what the hell light is. Number two, you don't know what an experiment is.
No, I do know what light is.
No, you don't. It's not a wave. It's a particle. Now,
acts
if you
like
want
a
to refute
wave.
that, listen. If you want to refute
he
that,
has to appeal to physics, to physicists.
I'm
He's not going to answer.
What physics?
Why
oh my God!
Because you're not qualified to answer the question, Mick West. Because you are paid, so you're not qualified to answer that question. Am I right?
I'm not paid. No one's paying me.
So you have to appeal to physicists, right? So you can't answer the question.
Why are you asking me questions?
All right, listen, let's deal with this right now. Richard Feynman, Nobel laureate physics. The first thing Newton believed, light was corpuscular. Turned out that it had very strange properties from that point of view, and it was then explained that many of these strange properties was because, in fact, it was a wave, which was wrong. Turned out he was right. It was a particle. Richard Feynman, lectures on quantum electrodynamics.
Wave. Yeah, I know. It acts like a wave.
It doesn't act like a wave. Particles aren't waves. They don't act like waves.
Can someone mute him for fuck's sake?
Yeah, QE, can you stop yelling like a fucking kid, dude?
I'll tell you what, brother, Mr. Kid. Let's meet up, man. Me and you. Who said that? Who said it?
I said you should be muted, you fucking.
All right, you know.
All right, hold on, guys. Hold on.
Yeah,
Hold on, everybody. This is what's going on. Hold on, everybody. Look, we got a bunch of the people that hate QE in here interrupting. All those people are getting muted because literally I'm trying to hear this discussion between Mick West and QE, and everyone else. Kind of let them go at it for a while and stop interrupting. Please.
Yeah, I'm going to pull over up here. I'm going to go ahead and ban everyone who's been interrupting QE like that because I know y'all don't like him. Okay, congratulations.
From the chair of physics at Yale, Professor Shanker, everything is really particles, all things, electrons, photons, protons, neutrons, they are all particles. So let there be no doubt about that.
Of course, yeah.
Clown show.
Agrees with that. I'm not disagreeing with that. I said it acts like a wave.
That is horseshit.
It's demonstrably true.
It's okay, demonstrate it.
Well, constructive interference, for example.
Oh, here we go.
A wave. The wave function is not a wave. It's a mathematical construct. You're talking about the wave function, not a physical wave.
So Young slits, the Young splits experiment.
Young splits. It's not a split. It's a slit.
I know slits. Young slits experiment.
Yeah.
Demonstrates the wave-particle duality of the nature
There
of
is
light.
no wave-particle duality.
Well, the experiment seems to disagree with you.
Oh, really? Professor Shankar, chair of physics at Yale. So we have to play this game in two waves. It is particles, but its future is determined by a wave. But the wave is purely mathematical. You can output an instrument to measure the energy due to that wave. It's a construct.
You can see the effect.
It's a construct. You're mixing up the concept of a wave with the wave function.
If you can see it.
Misplaced concretism. It's reifying something that isn't real into something
you're
that's real.
reifying the wave function. It's not a physical reality. It's a probability amplitude of possible outcomes. That's all it is.
Exactly.
There's no physical reality.
Exactly.
But you can see it, though. You can see the effect.
You can't see it. Show it to us.
It's visible
right now.
Someone posted.
I can see the green codes falling down like Neo from the Matrix.
Okay, well, let's not yell and hurl insults, man. Just for the PR.
From the University of Tennessee, in one dimension, wave functions are often denoted by the symbol psi. They are functions of the coordinate x and the t time, but psi is not real. But a complex function does not have real. See, don't rumpus me, you clown. You don't even know what an experiment is.
You're denying reality. You can actually see.
Kiss my ass! I just pummeled you. Pummeled you.
Are you denying that you can see the effect of Young's
Oh my God. But the wave function itself has no physical interpretation.
That is a physical interpretation. You can actually see
the University of Tennessee, the professor of physics at Yale, Richard Feynman, and now we got Mick Pseudo-fucking-West telling us the opposite.
Right. Well, if you want to deny the evidence of your own eyes,
deny the evidence. Fine. Bullshit. You don't have any evidence. You just got clobbered, and you already denoted. You don't even know what an experiment is, Mick.
Wikipedia.
you want to know what denying the evidence of your own eyes is, Mick? It's looking at the sun and the moon and thinking that they're different sizes. That's denying your own eyes.
This guy doesn't even know what an experiment is. He doesn't even know.
It's a little weird. It's a little weird that you don't know what an experiment is, and you just said that you teach it.
The thing is, like,
science. You don't know
experiments,
the parts of an experiment.
The vernacular of an experiment is just something that you do to test or to demonstrate a hypothesis.
Yeah, but you need things in this test to conduct it, right?
Oh, you don't. You get the idea that you need a dependent variable, an independent variable, and control.
Idea, that's a scientific method. Yeah, we get that idea from scientific method, and we're trying to demonstrate cause and effect relationships without personal bias.
No, he said
but
you don't
can,
need
you can demonstrate very simple things, like you say, does light does it act like a wave? If it acts like a wave, then if you did a double slit experiment, there would be constructive and destructive interference, and you do the experiment.
That's a wave function for the 10th time.
It's something that actually happens, though. Does it?
What's
does
a
it
function?
happen or not?
Happen.
What's a function? Hold on a second. What's a function? Hold on a second. What's a function, Mech?
In what context? A function is it's basically a mapping of one variable through a mathematical operation to another,
It's
like a sign.
mathematical construct. It's a function, a complex function, Mech.
Okay, let me ask you a question. Is this QED?
You ain't asking me shit. You don't even know what a hypothesis is.
Hey, Quantum.
You don't
Hey,
have to know
Quantum.
all that stuff. You can still do some decent
Quantum.
experiments.
We're on the same side of this fence. But I realize it's like sometimes you have to realize when you're dealing with people that are trying to disprove like
concern trolling with just like that.
Jedi, you hear me, right? It's like you start to
Yeah, I
realize
hear you, mate. Yeah, I get you. But come on.
These guys came here to try to prove to us something that we can prove ourselves with math and logic and science. So at the end of the day, we don't have to start to get upset or like get rivaled or triggered by that.
Yeah, but they're pretender
Make
clowns.
sure. Oh, I already know.
He's just doing his job.
At the moment, what we're doing is we're talking about light and it acting like a mathematical model.
But
now, a mathematical model isn't real, is it?
It doesn't matter if it's real. When you drop an apple, it acts like the mathematical model of gravity.
See, that's exactly what I just said. I just said that. I was like, that's like fucking Neil deGrasse Tyson saying, "This is gravity drops the mic." Are you serious? Is that it?
Bong, I'm on.
Is that all you got, man?
But I'm trying to say, like, at the end of the day, like, if we're on this side of the fence, we should be sitting back in our chair and chilling. Like, we don't have to sweat them.
Hey, you should be.
Like, we have to let them fucking sweat because we already know we've done the math and they haven't done the math. So,
Done the math?
Done the math?
Yeah, done the math.
Bring Neil deGrasse Tyson here, West.
Okay, Mick said he doesn't have to have independent and dependent variables in an experiment, right? He just said that.
Well, it depends what type of. If you want to have a strict
Penn
interpretation
State
of
University. Let's go through these. Can we go through them, Mick? So we have Mick that says you don't have to have Mick.
Yeah, but
can I speak?
You don't have to be frustrated by guys that are just talking shit, trying to fucking waste our time.
Can I speak, please? I'm gonna refute Mick.
Go.
Pseudo McWestian 2 space. I'm gonna refute him right now. Are we ready?
Space. We live in 3 space.
Not according to your friggin' fairy tale gas model, but I digress. We'll get to that in a moment. Experiment. You said you didn't need Mick. You said you didn't need a dependent and independent variable in an experiment, right? That's what you said?
For the common understanding of what an experiment is.
Yeah, I got you on tape, so that's what you said. Here we go. Experiment, Penn State University. There should be 3 categories of variables in every experiment. Dependent, independent, and controlled. The Institute of Physics.
That would be great.
That would be great now, wouldn't it?
That's just one definition of.
That's okay. Let's get another one. Institute of Physics. When planning an investigation,
you're giving the same definition.
Please shut up, Mick. When I'm pummeling you, please shut up.
You're just going to keep doing the same thing over and over again.
Yeah, I'm going to keep refuting your dumb ass.
I'm going to take control, John. Going to take control. If you're just going to turn around in a minute and say, no, I'm just going to keep over talking you, then that's not helping the conversation. Just let him finish. I'm sure he'll finish much quicker if you stop interrupting him.
Yeah, but I know he's going to do the same.
Don't even appeal to me. Next person to speak is going to be John. He's going to finish, and then you're going to answer.
Institute of Physics. When planning an investigation, students need to identify the variables that they consider significant and then select the ones they want to look at for cause and effect. If possible, any other variables that will affect the outcome of the experiment will need to be kept constant during the investigation. The variables are independent variable, dependent variable, and controls. Anne-Marie Helmetstein, PhD, Biomedical Sciences. When you design an experiment, you are controlling and measuring variables. There are 3 types of variables in an experiment: controlled, independent, dependent. Is that enough yet? Do we need to go a little further for you, Mick?
It's fine by me, because I already said that. That's one useful definition of an experiment, scientific experiment. Yeah. I mean, it's the type of thing that Nathan Oakley likes to go on about it. Because when people talk about an experiment, they don't necessarily mean that very, very precise thing.
Doesn't matter what they mean. It in the colloquial sense, experiment, just the broad umbrella experiment.
We were talking about scientific communication.
When I meet a girl at the bar, I want to experiment.
Scientific experiment.
Science.
And you're saying you don't need the IV, DV, and the CV. That's what you're saying.
I think that if you're trying to communicate science, those are not useful concepts to discuss with the general public. Because
the experiment and breaking it down into a very easily formulated method of where your dependent variable comes from, your naturally observed phenomena, and then how you build your hypothesis,
generally
you're answering the question of what causes that. So there's your independent variable. And then obviously you've got a control shit. So there's your controlled variables. You then got to take this forward in your experiment and test your hypothesis. Without these independent variables that are very easily explained, if that you just hand away them away and them in an experiment. It doesn't involve something that you're trying to manipulate to prove a cause of an effect.
Right, and the gold standard is basically that when you change something that you know is the cause independently, since you're independently changing the variable, you get a dependent variable that acts in accordance with your hypothesis to prove with as much proof as possible the causal relationship. And you have controls in the experiment that shouldn't change. If the experiment is properly controlled, all the factors have been factored, and nothing weird is changing in the experiment. If one of your controls changes, well, then perhaps there's another explanation you haven't explored or controlled for. Take with gravity.
Let him answer. Let him answer because hold on. Calm down. He said that you didn't need an independent or dependent variable in an experiment. I provided many citations here that said the opposite. Let him answer, please.
We're talking about scientific communication. And when you talk about things like dependent variables and independent variables and control groups, it confuses things for the general public. It's usually better simply to describe what the experiment does. You can keep that other stuff in the background as useful information. Like, this is why we need these things. We need controls. We need this independent variable. We need a dependent variable. But in terms of scientific communication, it's usually best just to describe what's actually going on and what it shows.
Mick, you baited. Mick, I'm sorry, I'm going to have to stop you. You baited and switched us. I didn't ask you what you were teaching them. I asked you personally, what are the 3 constituent parts of an experiment? And you didn't know.
I couldn't remember off the top of my head at the time, and now I remember.
Man, can I quote you? Can I quote you from Wikipedia? It all stems from a fundamental distrust of science and authority. Are you not trusting science and authority when you say those things? Like, you don't have to explain the variables. Like,
so you're quoting Wikipedia? Like, if you look at the Wikipedia
are these your words or not? Are those your words or not?
Which words?
The word on Wikipedia.
Which ones? What? I'm not sure what you're talking about.
Read them again.
I didn't write anything.
Right. Yeah, just read them again.
It all stems from a fundamental distrust of science and authority. You are always going to get a percentage of people who are true believers. My goal is to minimize that as much as possible, to stop people falling for it and help them get out as easily as possible. What does that mean?
That is what I said.
So we're talking about the scientific method here, accurate. And we're asking for the variables, and you're saying, what are you saying? You don't need those, or what?
I'm saying it's not productive. It's not productive for communication to the general public.
It sounds to me like he's describing atheists when it comes to religion.
But people asked me about science communication. They said, you're a science communicator. What is science? And I was trying to talk about it in the context of science communication.
Did you even know what that is? Did you even know what that is? Makes you a show.
I'm a scientist.
That's such a corporate little turd term. You know that, right? I'm a science communicator. I'm a product communicator. I communicate what the product is. You're an advertiser.
I don't say I'm a science.
I create synergies between.
Advertiser with a stick down your throat.
Well, propaganda is important even in science, saying proof for evolution or, proof of the God particle. Part of it is how you disseminate it to the masses to get funding and get support for your projects. But with gravity, we don't really have an experiment that's properly controlled to say we can tell that this is gravity versus, say, electromagnetism or something else. We don't even have proof that it coalesces things into balls for heliocentrism or makes orbits for heliocentrism's extravagant claims. That's why these experiments preferably would be properly controlled with some decent variables, and sometimes you have to revisit the experiments if you discover something after gravity's formulation, like, say, electromagnetism. Just to see if
we're getting off into gravity and electromagnetism.
Yeah.
Hold on.
I think you're getting off into semantics as well.
Yeah.
Maybe we should get back to
semantics. Words mean things, Mick. So let's summarize. Yeah, words mean things, Mick. But let's summarize. You are a science communicator that didn't know the constituent parts of a scientific experiment.
Off the top of my head.
Fail 5th grade general science. Just to let you know. Okay? Thanks.
That's fine. No.
And light isn't
Well, that's the general pattern. I mean, he knew what we were talking about in general. That's not what's important. What's important is the shape of the Earth, and these experiments that are used to undergird gravity. Light appear not to have been very well controlled, and so we may have bad theory, built on top of bad theory, built on top of bad theory, leading us to where we are.
You don't have bad theories, Lemon Bird. Just stop. There is no bad scientific theories. Scientific theories are validated, confirmed hypotheses. There's a lot of things that go under the term theory that are not scientific theories.
To the general public, the word theory and the word hypothesis are pretty much interchangeable. Sure, not for scientists.
Yeah,
for the general public.
Yeah, that's the problem.
That's scientific theory. You're talking about colloquial theory?
That's intentional.
Or scientific theory?
Yeah, and this is why words mean things.
That's just you changing the meaning of words so you can weasel it around and make it mean whatever you want. And that's been intentional. And politicians,
how people use them.
Politicians have been doing that for a long time.
Really? What?
There's a word that we use quite often, just band it around, hoping it's going to do something that it probably won't because you can't demonstrate it. Refraction. Words do definitely mean things as well. Yeah, go on. Let's get back to this bending of light, and you tell us what light is. Let's go.
Right. All right. Excellent. So the problem is that, like, I brought up the idea that light kind of acts as if it is a wave.
Wrong. You're wrong, Mick. I just drug you through the friggin'. I just drug you around by the short hairs for 20 minutes over this. Okay, please tell me in the photoelectric context how light is a wave. Please, the floor is yours.
Well, what I'm saying is that it appears to act like a wave.
Appears is not reality. I just told you the wave function is what you're talking about. The wave function is not real. How many more times do I need to go through this?
I thought that the entire flat Earth thing was that appearances are reality.
Oh my God!
Can't you just know what you see?
Well, to be fair to Mr. West, the wave function is based off of activity in reality and is a close approximation, ideally, as possible. But it is a mistake to reiterate it as reality if it's math and numbers. It's a model of what we think happens in reality. That's all.
Let's forget this whole wave thing then. Let's just ignore that for now. Let's just go back to just observable refraction. Like you would agree that,
hold on a second. Are you talking about terrestrial refraction?
Talking about refraction as a physical phenomenon.
On Earth, you're using terrestrial refraction. Is that correct?
Oh, I'm talking about light passing through a medium and how the refractive index gradient affects.
Okay. Can you please post? Okay, I got you. Can you please post? Let me pull Discord up in the live stream. I want the formula for refraction, please.
Which one do you want?
Which one?
Law, because that's not the one that's actually applicable.
Which one? No, we want refraction, terrestrial refraction, Mick.
Ah, dear. So this is where we get into problems with science communication, because it gets quite complicated. Refraction happens because of the refractive index slows down light. So light.
I don't want to. Mick, what did I just ask you for?
The equation of refraction. But so I guess if you want an equation, I've got to know what are the inputs to that equation and what's the output.
You're the one that claimed refraction, Mick. What do you want me? It's not my job to support your claims. So please give me how they compute terrestrial refraction. That's all I want. We're going to evaluate the formula to see if there's any begging the question fallacies in it.
Right. So fundamentally, the refraction is governed by the speed of light in a medium. The speed of light in a medium is the speed of light in a vacuum divided by the refractive index.
No, it's not. No, it's not. You don't know this. Don't go into the speed of light, Mick. We want the terrestrial. Go to Wiki, for fuck's sake, at least.
That actually is the underlying formula.
Oh my God!
It's a simplification.
Refraction.
That's actually a simplification.
All right.
But we're not seeing light travel through a vacuum. So why would you invoke that? We're talking about here, right? There are no vacuums here on Earth.
What you're trying to do? Yeah. Do you know what a refractive index is?
Well, the refractive index
unbelievable
travels through a medium, but we've seen 7.6R, we've seen 1/16 of it, R or whatever, or a degree. How about the one that gives the biggest amount of refraction? That'll help hedge in the discussion. How about the equation that gives the highest amount of refraction? Let's go to the limit. How about that?
We just want to see the equation they use for refraction. That's all I asked for.
That is the equation that you use for refraction. It's the speed of light divided by refractive index.
Where do they get the refractive index from, Mick? I want to see every variable in this equation. See, Mick, with equations, right? Every mathematician will tell you that every variable in an equation must be rigorously defined. I want you to post that friggin' equation right now, and I want you to define all the variables. You claimed it, you support it.
You're a programmer. You know that.
There's only two variables here, which is the speed of light. Well, it's not some variable, it's a constant. The refractive index is the only actual variable.
Oh my God.
Now, the varies based on the density of the air, which kind of varies based on temperature and pressure.
It's the optical density, not the mass density.
Humidity. Yeah. The optical density, which defines the refractive index.
There's a square root of epsilon times mu.
So the refractive index
electric permittivity of free space, and mu being the magnetic permeability of free space. So that's the actual refractive index. The values the values of vacuum is 1, and every other medium is set relative to that.
But I think the thing that's missing here is,
obviously.
I think the thing
that's actually pretty straightforward.
Yeah, hold on a second. I think the thing that's missing here is people are assuming that the refractive index is perfectly following the curve of the globe. Over 20, 30, 40, 50 miles is following perfectly.
No,
the refractive index within water or whatever medium that we're talking about is going to be whatever it is. But to assume that it's going to follow the globe perfectly all the way along at whatever distance we're talking about is ludicrous.
It's not what anybody's saying.
It's laughable.
Nobody is saying that. So you can laugh at it all you like, but no one's saying it. So you're laughing at ghosts.
So then at what point does refraction become a moot point? At what point?
It never becomes a moot point.
10 miles? Give me a number so I know, okay, refraction goes up until this point.
Refraction is always there because the atmosphere is always there, but usually you get extinction.
There's no demonstration.
It's actually
It's going to infinity. Give me some numbers so I can put my numbers to it.
The maximum refraction you should have is 7 inches per mile squared. I think the max with 7.6R is 6.8 inches per mile squared. That's why it helps to put this discussion within certain boundaries.
That's a simplification.
Yeah, exactly.
I was explaining earlier.
The boundaries matter.
You have to look at
like the boundaries don't matter. It's like
no, they don't. They don't matter.
Let's put these things within boundaries. Where does refraction bend? How much does it bend? And to what limits does it bend? And if it's beyond the limits of refraction, if we're talking about something that's beyond the limits of refraction, then we shouldn't even be talking about refraction anymore.
We need to look in history for the greatest refraction in history, and let's put that down as the refractive index. Let's try that, and put this thing within certain boundaries.
Exactly. Yeah. Well
That's
said,
not how it
Lemon
works,
Bird.
though.
Well said, Lemon Bird.
You have to use ray tracing.
Of course, that's not how it works. We don't understand.
Oh God, Ray, you still haven't answered my question though. Mick, do you see the live stream?
Yeah, I see the chat.
Yeah. Do you see quantum eraser? Do you see my post right in there?
Yeah, atmosphere is curved, follows the shape of the Earth. Calculations belough. Rough value.
Of course it does.
What are you asking here?
Well, I'm not asking anything. I'm showing you that terrestrial refraction takes into account the radius of the Earth.
Well, that's because the atmosphere is curved.
So, okay, so it's a beg. You have to prove that the atmosphere is curved.
Wow.
Listen, can I bring up a point?
Well,
hold on a second. Let Mick prove that the atmosphere is curved.
We know that the surface of the ocean is curved. We can see that.
Oh, so
wait.
We're not using refraction to curve the curvature of the Earth.
Here, right? That's the only curvature you're about to find.
I don't know. You just said the atmosphere. Now it's the ocean.
Let's say it's not curved. Then let's say we don't know if it's curved or not.
Sure.
Everybody
knows that water does not curve. Everybody knows that.
What I was saying, Mick.
People know that.
What I was saying, Mick.
It's not actually true.
What I was saying, Mick, in the beginning when I said terrestrial refraction, I was trying to lead you to the definition and the equation for terrestrial refraction. As we can see, terrestrial refraction. I'm not done yet, Mick.
I know,
just one second.
I know what you're going to say. So
just one second. Oh, yeah, but this is for the audience.
Okay, go ahead.
What I wanted to say was I was trying to lead you to give us, because you claimed it, I just wanted you to support it. And as we can see, that terrestrial refraction is computed by already assuming the radius, i.e. curvature of the Earth. So to use that, you must first scientifically validate the radius of the Earth, and then we'll let you use your terrestrial refraction.
Yeah,
okay.
So go ahead.
That's fine. No, that's not a problem.
Is that fair? Is that fair?
Yeah.
Okay,
yeah,
so
but we're not using refraction to prove the curvature of the Earth. We use Earth.
What are we using?
Are we using measurements over land? Okay, we've been talking about refraction all this time.
Why were we talking about So why were we talking about hold on,
right,
one at a time.
Cut that out. Timestamp it. 2019. Mick West. Someone quickly.
Well,
that's hilarious.
Okay, listen. He's under. Listen. He's under great stress. We're all pounding on him.
I'm not worried at all. We use observations that are high up, that get above like the worst effects of refraction. So you stand on something like a cliff and you look at a distant mountain. So you're not looking too close to the surface of the ocean. Where you need to use refraction is to explain things like these laser tests or these mirror flash tests that go very close to the surface of the ocean.
Of course. So the ones that are actually measuring the
ground of Earth, that's where we need. I just want to ask a simple question.
No, they're not.
What model of refraction can make predictions? Is like what you just said. That's a post-diction. That's the Earth is curved. I see this, therefore my model. I'm going to fit that observation to my model, as opposed to I have a model, I see an image, and now I know how much refraction, and I'm going to make a prediction based upon weather conditions on what I should see and what I shouldn't see.
Yeah,
that type of
and the assumption that refraction is going to follow.
That's a great question, and
because
I have the answer.
There are hundreds of models of refraction. Yeah, you are aware of that, right?
Listen, I think that the thing that we need to focus on is the fact that they're trying to assert the fact that the refraction is going to follow the curvature of the Earth perfectly without any fucking deviation is insane.
Hold on, guys. We're doing it again. Hold on, Nick. Sorry, one sec. We're doing it again, guys. Someone makes a point, someone brings up another point. Now Mick has 2 points to address. Can you first address what model you, what model do you use or can you use to make refraction predictions?
You use one that incorporates the temperature gradient, and then you use ray tracing to trace the path of rays through that through the medium. And the more detail you can get in the variations of temperature, the better. But if you simply do a vertical temperature gradient and then do ray tracing through that, you can predict what things will look like. And I actually programmed a simulator that does exactly that, which I can share the link with.
So,
Let me look
can
it
you
up.
show us actual measurements or tests to validate that model?
Yes, I can.
Okay, so let's see them.
Well, you want me to actually? I did it with Dr. Johns.
I know they don't exist because I've seen every experiment on refraction ever done in the last 150 years.
Delegate them, Indio.
Used Dr. Johns' numbers, and it came out to be like basically matching what he saw with his numbers.
Indio, he said he had scientific evidence of this.
On a curved.
Indio, he said he had scientific evidence of this. Can he give us? I'm sorry, Mick.
I'm still wondering how it gets sucked. Like it's sucked into other layers. I'm still wondering that. You got a vertical
that's what we were talking about earlier. That's a great question, and I love talking about that because it's something that I didn't understand myself at first, and I actually wrote to this famous refraction expert, Andrew Young. He kind of explained it to me, but yeah, it seems like it shouldn't. If something's going kind of between the layers, as you say, it shouldn't actually get bent down, but it does because
it does because the math says it does, or because it's observed.
No, you can actually demonstrate it. You can demonstrate it.
It sounds like we're assuming curvature.
I just want to see these demonstrations, dude, of these models. Right?
Well,
these
the problem
models
is
that actually make predictions that are accurate.
Yeah. All right. Let me get my refraction simulator link up so you can see it.
Wait a second.
Wait, you wouldn't even give people data on your calculator, but yet you're gonna expect us to believe that crap? Really?
I'm saying
sending
there's
you
models,
a link.
right?
I've got a link
reality,
called...
and we validate models by experiment, right? So where are the experiments validating the models?
Yeah, we want the hypothesis,
I know who A.T. Young is. I've read everything he's published, right? So I know who these people are.
Where at San Diego State University?
Use ray tracing. You're going to get a bend just from the nature of the equation, right? But that's just the equation. But that's fine. That's a model. So where's the actual experimental validations of these models?
Dr. John's experiment.
Controlled experiments.
Dr. John, hold on a second. Hold on a second. We already talked about Dr. John. Dr. John didn't conduct an experiment. He already said as much. You don't know what an experiment is. That's the problem. Hey, Indio, he said scientific evidence. Can you please have him post the natural phenomena? Go through the steps of the scientific method, please, Indio.
The natural phenomenon that he observed? There is
there isn't one. What's your dependent variable?
Let's see, the temperature gradient.
The temperature. So the temperature grading is hold on a second. Hold on. So I'm going to write this down, Mick, because I want to make sure that I got this correct.
Temperature.
It's just what changes. Are you doing the changing or is something else changing based off of your changes? That's it.
Hold on a second. He said hold on a second. Hold on, people. Relax.
That's the dependent variable actually will be the image itself.
So we're going from the temperature to the image now?
Get them mixed up. But it doesn't matter.
Wait, 1 second. So if I manipulate the image, what will I get?
No. If the temperature gradient changes and the image changes as predicted by the model, then that validates the model.
Mick, you have to have a hypothesis because a hypothesis is a scientific prediction. So we're only at the first step. Mick. 1 second. Now, the dependent variable, your observed phenomena is now the image?
Yes, the image.
Okay, what's the independent variable?
I don't know. What would you... Give me an example of an independent variable.
He doesn't even know.
The temperature, the
oh my God. Mick, thank you.
Just want to make sure we've got the right terminology here.
Mick,
so, yes, a temperature gradient.
Mick, it's your experiment. You're asking me for the independent variable for your experiment, son.
Yeah. So
somebody clip
the
that?
temperature gradient varies. It has an effect, which is changing the image. So, an hypothesis. The hypothesis is that there's a model. There's the Earth is.
No. Every time you stop reifying shit.
It's over 5 dozen people in here.
We're already on a ball when this is happening, right?
This is a clown show, Mick.
The hypothesis. Wait, did you really just say the hypothesis is it's a model?
Have you seen my refraction simulator?
Let him describe it. Let him describe it.
Hold on, everybody. Please let him finish. Could you please let him?
Yeah. Go ahead, Mick. Go ahead.
Mick, I'm gonna have you over for a beer.
Cool. So the model. You want me to describe the model that I use?
No, let's just summarize.
Yeah.
1 second. You said the dependent variable was the image. The independent variable was what?
The temperature gradient.
Temperature gradient. Okay, give us your hypothesis.
That if you ray trace light through air that is curved, with the temperature gradient being like the same over every point on the curved surface, then you will get images that match reality.
So I thought you said the temperature gradient was your independent variable. In your hypothesis, I didn't see any temperature gradient being manipulated.
You would take 2 different temperature gradients.
No,
Mick, you can't manipulate temperature gradients because that's what they are.
Then it's not a viable independent variable because your independent variable is number 1, your cause. Number 2, you have to vary and manipulate it.
You vary and manipulate it by waiting to a later time in the day.
Waiting. Very manipulating anything. That's waiting.
So is this proof
yes,
of
but
time?
it changes. It changes.
Are we going to prove time? If your hypothesis is time, is that what we're trying to prove?
Let's say your hypothesis is that you can see better.
You can manipulate
the
distance. Does this have anything to do with the flat Earth?
God, he's Doctor Who.
All right, guys. All right, guys.
We have to.
Mick, thank you very much, sir, for showing what a complete imbecile you actually are. Thank you very much.
This isn't
That'll be all
about
for me.
Midwest. This is about the flat Earth. But we have to assume curvature. So whether or not there is curvature on the Earth, and so if we do not have reliable sources, say because NASA is lying, or because lenses are adding curvature, we may need to revisit the very basis of our hypotheses that we're, making these experiments off of.
Sure.
I think my simulator does actually fulfill the criteria for an experiment if you apply it to real-world situations.
May I ask a quick question, Mr. West? What caused you to join our server today? Like what?
I was invited by somebody. I can't remember his name. It's somebody flat Earth literalist. No, flat Earth level literalist.
Horizontal level.
Thanks, Ben. I thank you for gracing us with your presence. Yeah.
Welcome. I'm
Even
also
though,
to talk about this stuff.
Did he happen
it's
to
very,
ask you
very
if-
interesting. I like the
Did he
variety
happen-
of feedback that I've got, and I know that you think that I'm wrong, but I would disagree. And I would encourage you to have a look at the refraction simulator because it's quite detailed, and it simulates a number of different things.
So
it even does lasers.
Does this refraction simulator simulate the distance with which refraction starts to divert from the curvature of the Earth, or does it just follow the curvature of the Earth all the way around 360 degrees?
When
does the refraction stop? Is my question.
It doesn't stop.
So it goes all the way around
It doesn't
360 degrees.
conform. No.
So when does
look at this?
If it doesn't
Look
go
at this, and you'll
if
see.
it doesn't go 360, it has to stop somewhere, right?
It stops because of atmospheric extinction and scattering.
Okay, but where does it break?
Theoretically,
Where
the
does
problem
the
is
simulator stop working? Is my question. Simple question.
my simulator is only set up to go to really about 200 or 300 miles because I didn't see much point
so we
going
have a
beyond that.
limit to the simulator. Okay.
Yeah, actually, let's see. I think you can set it to be quite a long way, but it's kind of pointless because you wouldn't be able to see that far anyway.
2 to 300
And there's
miles
too much
of
variation.
Is that a flat surface or 200-300 miles of a curved surface?
You can do both. You can set it to be flat or curved, and you can
No,
turn
I mean,
refraction
no,
on and off.
on your simulator.
What's the drop on 300 miles?
Either.
What's the drop on 300 miles? It's like that's a crazy amount of drop, right?
Yeah, no, there is a crazy amount to drop. That
So,
would be,
so,
I don't
so,
know.
so you're trying to say a laser that was shot over that?
Oh no, I'm not trying to say that at all. Not at
all.
all. No, no.
It's not going to hit a target.
No, you're not.
So then, how is it accurate if it won't hit a target over that distance?
It will show you not hitting it.
It'll show you not hitting it, but then it's not accurate. So that means that the distance that it's actually accurate is less than that. Am I wrong?
If I showed it hitting it, would it be accurate?
At 100 miles.
I'm asking you the refraction indicator, whatever the device you're talking
Simulator.
about.
It's a simulator.
The
Have a look at
simulator is
it.
going to tell
Have a
us
look at it.
refraction up to a certain distance.
Let me show you a screenshot
If the
of
laser,
it.
don't interrupt me. If the laser does not hit the target within that distance, that means the simulator is wrong at that distance. That means we'd have to scale it back because the simulator is shit. Maybe the simulator only works for 200 miles or 50 miles or 100 miles, whatever it is. But there's a distance where the simulator breaks and it stops working. So we need to know
Still
what
waiting
that
on
is
that data to support
with a
it,
laser, because if we're talking refraction bullshit right now, there's a limit where the simulator is going to stop working, and my laser's not going to make it around the curve. What's that distance? If you're telling me it goes 300 miles, I need to know what the drop is at 300 miles, given the numbers that NASA gave us. If it doesn't add up, something's broken with the simulator or something's broken with NASA. Nothing's broken with our math on this side. So somebody has to set it straight for us so I get what's wrong here.
Simulator uses like real world situations, so it's trying to like demonstrate what you actually see.
That can go 200, 300
No, it
miles,
doesn't.
But if it doesn't go 200, 300 miles, then something's wrong with the simulator. Is it?
The simulator uses real world conditions to an extent, right? Until you invoke that radius, right?
Well, did you account for the temperature of the water, if there's water in there, and the gradient temperature, whatever, of the atmosphere? Did you account for all that? Like, probably not.
Yeah,
Right.
I don't believe
because you just spoke about how you did an experiment where you put cold, the hot pushes the laser towards the cold, right? Did you account for that?
No, that's not an experiment.
It's basically built into the simulator.
None of that is in
Part
your
of the model.
simulator.
Lasers shoot straight to my eye.
No, it is, 'cause you can
altogether. I don't give a fuck about a simulator.
the
That shit's
temperature
bullshit.
gradient.
Yeah,
You
he
can't
didn't
just
perform.
simulate something you don't have all the variables for.
Refraction is
Yeah,
bullshit.
he didn't perform an experiment. We already established
Try to
that.
fucking distract us. Refraction is bullshit. Straight up.
Yeah. Yeah, and he has no experiments. He doesn't even know what an experiment is.
I'd love to see this fucking
Hold on a second. I just want to finish up. Mick, friend, sir. Hello.
Oh, I'm here.
Yep, you have been erased. Thank you very much. Have a nice day.
Thank you.
Terminated.
The problem with refraction is usually it's only talked about in one terms going up and down. But if light goes in all directions, we should talk about, the image refracting this way, that way, left, right, up, down, in all directions. So the model appears to be inadequate in some ways theoretically, does it not?
Yeah, makes sense.
It's pretty much up and down there because of the gradient usually goes vertically. You do get some side to side. If you look at things like the air over a bonfire, you will see all this kind of shimmering, and that's a bit of side to side movement as well. But in the atmosphere over long distances, it's really only up and down.
Sure, but by the simulator, 300 miles, it follows the curvature of the Earth flawlessly. It's laughable at this point, man. The fact that they say it out loud is embarrassing.
Who's saying that?
I don't know who said it. Somebody said it. I don't know. I didn't look at the names, but like somebody said out loud, like 300 miles.
It's a little bit of special pleading because the picture should be unstable, hazy. How is it stable going over the curve of the Earth in one direction, up and down? I mean, this is just, too much special pleading. And we haven't even factored in perspective at all and how things can, compress to the eye line of the observer based off of the angular resolution of light and the angle that the observer is viewing the object at over possibly a flat plane.
It's all built in. It's built in because I do proper projection.
What curve of the Earth?
Well, the curve of the Earth measured. The data is two totally different things. Your bullshit claim means nothing without data behind it. Prove your calculator's even worth anything. Where's the data that John D's been asking for months?
How dare you?
I was using his data.
Here.
No, he's talking about. Kid. No, did you? Wow, you're not even paying attention.
I don't need to.
I'm talking about your atmospheric refraction simulator. It has not been validated yet. Dr. John D and you had a thing going around about this. You never answered him. You never gave him the data on it yet. So we can't trust that simulator.
See what I just posted? See what I just posted in the chat?
What a photo is not proof of anything.
Oh, that's what Dr. John uses as evidence of things. What I posted is
he's asking for the data for your simulator to validate it, to make sure your simulator is following the proper laws. That's what he's asking for. You're not providing it. You never did.
I gave it.
No, you did.
You can go. You can.
Really? Where's the video of him going over it then? Because it's not there.
He obviously did not. Let me find it. My email that I sent to him.
I have a quick question. I just want to know, Mick, when did you start debunking conspiracy theory?
It's about 2005, but it's kind of stuff I've always been interested in since I was young.
And don't forget, we can find out if he actually communicated with you or not. You know, we have.
Yeah, I've got all these emails here. You a screenshot of my
screenshots of what?
My exchanges with Dr. John.
Screenshot of what? Like I said, it could be anything.
It could be, but
it doesn't have to be you and him. Literally.
But yeah, it could be all lies.
We need to validate that you actually made this conversation with him and not through you. I need to hear it from him.
All right. Well, you can.
I can't trust
CC you on an email if you like.
You kidding me?
No, that's true. That's true. I would encourage you not to trust me. I'm just trying to find where I sent him the data.
Hey, I just looked at the values in your little calculator here. Is that in degrees? The beam divergence?
Which one? Oh, yeah, that's. Let me. I think
degrees are
radians.
I'm tired of the math that they're handing us, bro. I'm just tired of the fucking math they're handing us. The only
beam divergence for the laser.
It's just a bunch of magic tricks.
Only math I want to talk about is the curvature of the Earth math. No other math.
The laser divergence is the standard laser, which I think is like in degrees per 1,000 meters. I'm not entirely sure though. But whatever, like the standard unit of laser divergence.
Well, I'm just going by the screenshot.
Yeah. So it's or per 1,000 feet or something like. I can't remember what it is. I could look it up, but I was looking up something else.
Well, I mean, there's only going to be one angle
in that screenshot.
It isn't going to like. Listen, if it exits,
all the screenshots,
0.5 degree angle, it's going to stay at that. It isn't going to get crazy.
Divergence is greatly exaggerated on the screenshots. You can actually turn that off with one of the options, side zoom. It turns it to flat.
Yeah, I'm not interested.
But anyway,
in that. I want to talk about the measured flat Earth and like why that 8 inches per mile squared. At least that parabolic equation doesn't fucking ever come out the way NASA told us it should. Like that's
because
the
of
only thing I want to focus on.
Because
anything
of refraction, basically.
I'm not even interested in talking about. I don't want to talk about space. I don't want to talk about refraction. I don't want to talk about shit.
The problem is
8 inches per mile squared. Why is it
you got
found by the people that
you've got a big problem? You got a big problem.
That's all I want to talk about. Everything else is bullshit to me. Everything else is word salad. Everything else is obfuscation. Everything else is bullshit. Where's the 8 inches per mile squared? Let's talk about that.
Catalina.
Explain that to me in simple terms, because I'm so dumb. I don't get it.
We know how far away Catalina is. We know how high we are off the ocean. We know how far away Catalina is.
What do we know?
How far away Catalina Island is from Santa Monica. Santa Monica.
And what's the distance?
I believe it was 35 miles.
35 miles. And what does that equate to in terms of curvature?
You mean in terms of how much should be hidden?
Droppage.
Droppage. Well, droppage isn't the important
no, it
thing.
is.
It's the actual...
I should not see how many feet should be obfuscated from my view. That's what I
well, that's not the same as drop. That's the hidden value, which is different because that depends upon the viewer height.
If I can't see it, that means it's no longer in my view. It's obfuscated from my view because it's past the curvature, right?
All right, so 35
parsing words
miles.
How much miles? How many feet?
You should have 682 feet hidden.
682 feet.
Or 576 with refraction. Yes.
Is that what we observe?
Yes,
and that's what we heard. Mick, I got a picture in the chat for you that shows your point.
You can't invoke terrestrial refraction, Mick.
In reality, Zanuck, hold on, I'm talking.
Hold on a second. He invoked refraction again.
Is that
we can ignore that if you like.
Mick, is that what we observe in reality, or can we actually see Catalina Island?
We can see Catalina Island.
You see what I showed you in part of the picture.
Well, that's a problem.
If you
it's
can
not a problem
find
because Catalina Island is like 1,400 feet high or so.
Okay, well, how much of it can we see?
I just did it.
The amount that is expected. Look at the photograph that Zanuck posted.
Let me show you what it looks like without when you're closer in the shore.
I found a video. I just did a quick search, Catalina flat Earth, and here's a video that shows flat Earth and Catalina Island from 48 miles away. So what do you have to say?
I've looked at many photos of Catalina.
What distance is this?
About this guy, he has a video.
Listen, but there's an up close picture.
But his video is just showing that you can actually see Catalina. Of course, you can see the top of it.
48 miles away. 48 miles, not 36. 48 miles.
Did the observation from
not
across
48
the water,
miles.
Catalina Island.
This guy.
Order in the court, guys. One at a time.
You can see the amount of Catalina Island that you would expect.
Useless. We need someone that actually did the entire experiment across the water.
I've been there.
Measured the shoreline. Measured how much we could see.
That wasn't an experiment.
Right. So, do you deny the existence of Catalina Island, or just how
no?
big
It wasn't an experiment. Is the problem?
Not an experiment.
Right,
observation.
You're taking a picture of like the mountain. Like, look, Catalina
Twin
Island.
Harbor's
Like,
there.
what does that have to do with
You can
anything?
see the
We're talking
picture
about
from the shore
the curvature of the Earth.
What about the video I posted where there's 2 minutes of a guy zooming in from farther away than you guys are saying, and there should be no Catalina Island at all.
Look at that real quick.
Oh, we could do the math on that.
From Santa Monica Pier, how far it was?
You can say your little observation, but I just posted a video with the
I got the
alternative.
video. I'm watching it now. What are you saying?
See, but here's the thing. It's like
you're saying exactly what I showed you.
Here's
from
the thing.
48 miles away.
Here's how.
Can you hear me?
What you would expect to see.
Here's the thing.
It's showing exactly what I showed you. See that?
Hear me out on this one. I'm not even gonna watch the video. Let's be honest. Like, I'm not even gonna waste my time with the video. There's so many observations that people have shown, distances that we should not see. So if you post a video that I can see it, I'm like, well, now I'm like, did you doctor it just to fucking make a point? Because like, if we have observations after observation after observation after observation of shit we shouldn't see, why don't you reconcile the shit that is on our side? Don't bring me another video that I've never that I didn't reference, that didn't come from one of us, didn't come from an independent observer. Give me a video that I've seen on my own. You know, make the Chicago skyline disappear, and then we'll have a conversation. Until then,
where are you based?
Chicago skyline disappear.
Do you have a place where you could go? Do you have a do you have a place you can go? I mean, I've been to Catalina and done it myself many times.
Skyline? That's not you can just disappear. I don't know where your video came from, nor do I trust it.
There's lots of videos of the Chicago skyline being hidden.
I'm going to trust you. I don't know who you are.
No.
I don't know who you. I don't know how you make your money. You think I'm going to trust you?
Do an experiment,
Tony Hawk.
The Great Lakes.
Do an experiment, Mick. Wait a second. He said do an experiment. Mick, you didn't know what an experiment was when we first discussed this.
But you're saying that experiment has to have an independent variable, a dependent variable, and a control.
Yeah, I'm not saying that.
And okay.
Penn State, Colorado State, the Institute of Physics, the National Science Teachers Association, they're saying that.
So let's say my independent variable here is my height above the ocean.
Height is not a viable independent variable because it doesn't cause anything, Mick.
But your changing position changes how much you can see of an object.
The independent variable is your cause. Height doesn't cause anything, like depth doesn't cause anything.
Height changes your view position.
No.
It will change what you see.
It doesn't cause anything, Mick.
It's a variable which is tied to a result. There's a direct correlation between the height and what you can see.
Correlation is not causation, Mick. And height is not an independent variable, Mick.
Seriously?
Yeah, height isn't an independent variable.
Well, what is it dependent on?
Time. It has to be something you manipulate, and then you see a change.
No, it has to be your cause. Not only it has to satisfy. Shut up for a second. It has 3 criteria it has to meet. Number 1, it must first exist. Number 2, it must be able to vary and manipulate it. Number 3, it is your presumed
it seems very definite. Very definite.
You
got it wrong.
I'm out of here.
You are able to manipulate height because you're able to give the variable height different values dependent on the angle.
Are you listening to me? It had to satisfy 3 criterion, clown.
It's a variable. Basically,
clown.
You vary the input.
Clown.
You do a different experiment. You take
clown show.
Let's see if it hits all 3 criteria.
He just won't shut up.
Let's see if it hits all the 3 criteria that we've spoken about. So the first one, height. Is it real? Discuss. Is height real?
It's real. It's a real variable. Something you can change, and it has an effect. When you change the height, things change.
You clown! Let me ask you a question.
Stop calling him a fucking clown. Stop insulting him. The fucking behavior here is goddamn ridiculous. Shut the fuck up.
You clown.
I'm a fucking mod here,
You're a
so
clown
shut the fuck
too.
up. Stop.
Yeah,
Fuck you. I'm a goddamn mod here, so shut the fuck up. Stop insulting.
Okay, so listen. So listen.
It's goddamn ridiculous.
Let's do it the other way.
This is the Wild West.
Yeah. Fuck.
Yeah. Height is an independent variable. Thank you very much. I appreciate that. Clown.
Fucking children. Shut the fuck up.
The output is how much of the island you can see. So that's the dependent variable.
You see what you've
done. So
done.
it's a mathematical relationship that you can measure.
What's your naturally observed phenomena?
What?
See what you have caused.
The hiding of islands behind the horizon.
What's the horizon?
Persuaded by these guys.
The edge.
What's the horizon?
It's the.
What's the horizon?
It's the edge of the ocean.
No, what's the horizon? Is it the?
Just told you what the horizon was.
I suppose
told you where the edge
of the sphere.
Edge of a sphere. Yeah, that's a
Not
good way of
actual
putting
though,
it.
is it? This horizon. It is the limitation of
seems
your
to
view
be.
when you observe across the plane of the Earth. It's not
Why does the
actual.
why does the
But
definition
no.
say apparent? Why does it say apparent
Which definition?
of horizon?
Probably they're saying apparent because refraction is a factor.
The line at which the Earth
it's not
the line
actual.
listen, the line at which the Earth's surface and the sky appear to meet. Appear.
Yeah, that would mean because it's
I guess
not actual.
someone cut out there,
not
but
because of
did they say
refraction.
appears to meet? I mean, they appear like they're meeting, but they don't actually meet. Obviously, one is just obscuring the other.
Yeah, that's why they call it apparent, Mick. It's where the sky appears to meet the ground. It never does.
Yeah, of
That
course
means
it
it's
doesn't.
apparent, Mick.
Hey,
yeah, of course.
Can I ask?
Obviously.
I'm dying to ask this question before he gets banned again. Mick, do aliens exist? Yes or no, please.
I don't know.
That's.
I have a question.
Go on.
Is level curved?
Let me do that, chocolate. That's my,
I'm sorry, Bev.
Not even had a chance to go yet.
Bev, get in there. Get in there. Go ahead.
Listen, anyone that wants to ask Mick, since he's our guest here, a question, like just speak up and so we know who wants to ask.
I'm going. It's my turn.
Give it back.
Okay.
Get it.
I want to ask Matt. Do you want to ask a question next? Matt Philosopher?
Yeah.
Need some more lube?
No, wait till Bev and then you go next, okay?
Put him on the list.
All right. Yeah. I'm good. Go.
Sweet Mick, you still here?
Don't forget the KY.
Yeah. No. Are we going to get onto the level being curved?
No, just the reason I invited you here and the reason you came onto the thread.
All right, yeah.
Is like, let's take it right back to basics, right? We want to know about the curvature, right? So my thing is, I'm trying to get people to give us the best method they have for measuring the curvature of water level in a canal.
Yeah.
A mile long, let's say.
That's too short.
Why?
There's very, very little curvature over a mile. You need to do about 5 or 6 miles.
No, how much curvature is there? Your calculator?
7.9 inches.
1 mile.
Yeah.
It's not a lot. The
Not a
drop
lot.
over 1 mile is only 0.66 inches.
0.66.
Yeah, that is 7
Is it?
inches, isn't it? Yeah.
Oh,
0.67 feet. 0.67 feet.
Okay, so that's
Over 1
noticeable,
mile.
like, isn't it?
It's hard to see.
So what would your... No, I'm not asking you to do it or anything. I'm asking you, what would be your method
That's a
for
good
measuring the curvature of said water level in a canal?
I would use what's known as the Wallace method. And the Wallace method uses raised targets. It's something that Jeranism did in Beyond the Curve at the end of Behind the Curve, their documentary, which you've all seen, I imagine. And basically what you do is you set 3 targets up. One is the camera, one is in the middle, and the other one is at some long distance. And you get them as high above the waterline as possible, but you make them all be the same height above the waterline. And then you look from the camera through the middle target to the end target. And you will see, if you've done it right, that the middle target is above the end target, which shows that the water is raised up in the middle.
Would you not, call a surveyor and use a level?
You could do, yeah.
Yeah. Do you think that would be a little bit more accurate than setting things up?
Essentially, it's doing the same thing. The same thing.
Looking or actually measuring?
Well, that's what surveyors do, essentially.
They measure stuff really accurately.
They do.
So then how do you handle the discrepancy when people measured across 25
0.04
miles and
degrees
measure from
drop.
From
in
their
water
boat
level?
and the laser are,
Yes, 0.04 degrees of drop of the horizon.
Of what? Of an apparent location.
No. Stop. No horizon. We're on water level in a canal.
Yeah, so
we're not going to the horizon. You don't need to do that.
Yeah.
We just have the best method for determining the curvature in the water
So
level.
that's then exactly what I said then. You would set up these targets high above the water so you get above any refraction or minimal refraction.
Yeah.
How high above the
And
water?
then you see where the line of sight from the first target to the last target intersects the middle target. And you'll set up like a
datum. The datum you are using is going to be your sight.
I think Jedi was asking how high above the water, because refraction is obviously to you guys a big deal. So we want to make sure.
No, you don't need refract. There's no refraction in when we're measuring the level of the water.
The reason why I'm asking how high is because the higher you get off the surface of the Earth, you're increasing the radius value. So, for example, if you have 3 lasers, one foot above the surface, one, pardon?
Enough to make a difference. It's like a thousand of an inch.
It will eventually, with altitude, start making a difference.
But
especially, hold on, I haven't finished. If you're presupposing on a curved surface, your target is going to be angled away. Also, if you have a low target, a mid target, and a higher target, because of the speed of light having to traverse a longer distance across an arc, you wouldn't necessarily notice this speed of light change or the time that light would take to get to the top target, because you've increased the distance between the two. Keep doing this with altitude, then that's exactly what you should find on your ball, and increasing the time it takes light to get from the laser to the target, and the target is curved and angled away over a distance of an arc.
We're doing 12 feet, all at the same height. So if it was flat,
I want this one now. I want this one now, because you're saying that we're on a ball. So if you increase the radius value of that ball, then this demonstration would take into effect, correct? You will be able to prove your curve if you could demonstrate with altitude it took the lights longer to get from a target which was further away, because it's on an arced tangent, right?
Yeah, you could do that, but that's not a very easy thing to do. Like we're talking about an easy demonstration, like which you can do if you've got a 5-mile long body of water. You set up these targets 12 feet above the water surface, and you look along them, and you see that the middle target's raised
What
up.
would your datum be, though? Like, in order to measure a curvature or a drop or something,
The water surface.
The what?
The water surface.
And I call
the water surface is level, being
because the ground's going to rise up as it goes out.
It smells like a lot of bullshit going on, man.
What you're measuring,
see, that's, the thing, that's perspective coming into play. So the object in the middle is going to look like it has risen up anyway.
Dude, did you not just hear what he said?
What did I just say?
The datum that you are using to determine drop is a level.
It's the water level.
Is the water, yes, which is horizontal.
It's level.
Yeah. Thank you.
No, it's level. Which is not horizontal, it's level. Sure. Different things.
Here we go.
Yeah,
There's
they are
two
the
types
same
of level.
There are two types of levels. What?
Yes.
What? The
There's
real
apparent
one and the
level.
fake one, right?
No. There's true level and there's apparent
The one
level.
you can see and the one you can't see. Right.
True level.
The one you
True
can
level.
see, and then the one that they
I've done
say.
construction since I was a kid. Level is fucking.
There's the one you can see, and the one they say is curved.
In construction.
There's the one you can see, the one you can see, and the one they say is curved that you can't see.
Construction, apparent level, and true level are pretty much
Probably
the
haven't
same.
lifted a fucking hammer in your life, by the way. I can tell by.
No, they haven't. Anyone who talks like this hasn't had a
I
job.
own a lot of hammers.
I can show you a
I
hammer.
don't believe you, bro. By the tone of your voice, you've never lifted a hammer in your life. I'm a worker.
I've got a hammer.
I probably have more hammers than you do.
Talker, and I'm a worker. You've never lifted a level in your life.
Can the real
I
level
own like
please
5
stand up?
different levels.
Doesn't matter if you own them. Do you know how to use them?
Yeah.
In order to say that level is curved, you have to prove R, which you failed to do tonight.
We're talking about like what water.
Bullshit is what we're talking about.
Water's always
Right.
right.
It's gonna be
Bro, I
relevant.
can,
It's gonna be
I can
relevant.
hear by the way these guys' voices cracking. They're fucking just feeding us bullshit, man. I can already smell the bullshit coming out of them, bro.
Think my voice is cracking?
I know it is.
No,
Mick,
he's the professor.
I don't think. Hold on, guys.
I was laughing
guys,
about a hammer.
guys.
Sharp ears can hear. People that are lying or just too dumb to realize that they don't know what they're talking about.
Vagabond.
Guys.
Give it a second.
Get all my
Don't you
hammers.
think
That's a bit
We
hypocritical.
all
Just have to
know.
go
We
through
all know.
insults.
We all know. Whatever. I don't know what you are. I don't know what you are.
You broke up though.
I don't know what you are. I don't know what you are, but you won the damn, and you know you are.
I'm a retired video game programmer. I program Tony Hawk's Pro Skater.
So AKA
Yeah, that's not all you are.
in your fucking life.
What programming
That's
language?
not all you are.
Video game programmer.
Hold on, what language
Hey.
you use?
Oh,
Guys,
since I retired.
Anderson Cooper, he's just a reporter, guys. Anderson Cooper is just a reporter.
What programming language you use?
I do actually
No,
have a lot of hammers.
He is a programmer. He is a programmer.
What,
That is
what,
true.
what programming language you use? That should have been like right off the bat. You should have been like, "Oh, I use C++, use C, use C
Sorry,
sharp."
you broke out. We use
Sure.
C++ in programming video games. I mostly program in JavaScript now, though. If you look at the refraction simulator link I posted, I'll post it again. You can do a view source on that, and it will show
time,
all the
Nick,
code.
we don't need your simulator. I'll just play Skyrim.
Out of your fucking mind, bro. I'm not gonna waste 30 seconds on that shit.
I have a question.
Doing
That long-
your own stuff.
What happened to Fallout 76, Mick? Damn.
Mick worked on it. That's what happened.
Hold on. He said he used C++. What was one
I'm
of the
blaming Mick for 76.
Hold on. What is one of the things you use in C++? Main things.
What do you mean? What do I use? I programmed in it.
The release.
That
the release.
Get him.
That is probably the only true thing about him is that he
Hold
programmed.
on. No, I don't. I haven't heard a legit answer on developing right now. I'm a developer. I develop in C#, but I know some C++.
C++ you use new and delete, or you can use malloc and free.
What is it called when you release resources? What is it? What is it? What is a deconstructor for that?
you're freeing the memory. So it could be a dereferencing, and it could be garbage collection. But it depends what you're talking about. There's lots of different ways of doing these things.
All right, so you give me the garbage collection. All right, what are pointers?
You're breaking up there, so
what are pointers? No.
He's
I'm trying to
he's
verified. We know he's a programmer.
How do you?
No, you're gonna.
What are
I like talking about
pointers?
programming.
Garbage collection is easy. One of the easiest things you can figure out. What are pointers?
Pointers?
Just ask him what's a stack.
That should have been a 2-second answer for you right
what's
there.
Buffer overflows?
No, sorry. You're cutting out, so I can't hear the question. So can you repeat the question?
You already repeated a question.
I hear everything.
You just repeated the question.
No, I was asking if that was a question.
Buying time.
Okay. Now you had the time to look for what is pointers.
You have the guy in his ear explaining.
What?
Yeah, your programming skills are very.
I can't hear what you're saying. Why don't you type it in the chat or something? Because I have no idea what you just asked me.
Yes, because you're gonna search and look it up.
I've got a website called Cowboy Programming. It's cowboyprogramming.com, and I've got loads of articles I've written in there about programming, and they're all really complicated and technical. So if you doubt my programming abilities,
don't make it real, bro.
And if you want, you can go and look at the credits for Tony Hawk's Pro Skater 1, and I'm listed there as the lead programmer.
My God, I could hire a fucking writer to write me a fucking article with a fucking neurosurgeon tomorrow, bro. Doesn't make me a neurosurgeon.
You could go to.
You're asking me I don't know, high school level questions like what is a pointer?
Exactly. So this should have been like, oh, dude, the pointer is this, isn't that?
No, I know what a pointer is. Like I started programming it in Z80 or 68K, well later 68K, and a pointer then was just one of the registers, like one of the address registers in 68K. It's a location of a variable in memory.
Order this now.
Yeah, but where's
you finally looked for the answer, did you?
Yeah, bro, but where's the curve?
You know what it is.
He knows what it is. We know that you're good at programming and manipulating stuff, and you can show it on your simulator, but you're not really, because you can't, list the variables. Like you're just gonna give us a simulator.
I'm telling you the variables. The variables are they're right there in the simulator. But the temperature gradient would be the one that you'd want for doing an experiment.
Yeah, but where's the curve at though, bro?
How come water is always flat in video games?
It's just the easiest way of programming it.
Or is it because
that's way more complicated?
Yeah, because
it's because it's the easiest way of programming.
It would be a little weird if you programmed it with curve, right? Because
it would be complicated. It would be hard to do because it's not real.
Yeah, if you want it to look like it does in real life,
find its
look at
own
the
level?
water.
It is actually programmed with curve in things like Microsoft's Flight Simulator or X-Plane.
But when
Actually,
how does it find its own level?
I've been tracking the simulator,
it's
not what you think it is.
With a lump in the middle.
It's like saying, how does a pendulum find its own level?
No, it's not. It's like asking how does a fluid find its equilibrium. That's what they do.
Because if it's in disequilibrium, then it moves towards equilibrium. That's just
it doesn't have a big lump in the middle, does it? I think that's what it means.
It doesn't have a big lump in the middle. It's a sphere.
Water curve? How does a body of water at rest curve?
By being attracted towards the center of the Earth by gravity.
Gravity. Here we go.
Gravity.
So how come gravity? So how come no scientists can demonstrate gravity and replicate it?
I've heard that word.
You can demonstrate the effects of gravity.
Sure
no, but they can't. They can't demonstrate what they're actually claiming. It only works at a planetary level.
Excuse me, Hollywood. We really wanted to give Most Mad the opportunity to ask a question as well. We seem to be veering off again.
I have to be going soon anyway. So
Next up.
Can I have one question?
If Matt doesn't want to go ahead.
Are you
Matt, you got something?
Sorry, he must be AFK.
Let's give Mick a little breathing room. How are you doing, Mick? You all right?
I'm fine. This is all fascinating stuff.
Yeah, it's all yeah. Okay, good. Professional.
Understand that people are passionate about their beliefs and they get angry sometimes. Not a problem.
Who's getting angry?
All right, next.
I heard a few raised voices.
Cool as a cucumber.
Yeah.
Yeah, there's some people who just yell all the time, so it doesn't necessarily mean they're angry either.
I just don't like liars when I figure
I'm
them out.
angry.
Oh yeah, I'm angry.
Does someone have a question?
Once I figured out this thing was a lie, oh, I'm furious. So anybody that comes in here, they better have their shit correct.
Waterball, go ahead and ask your question.
Hey,
man.
sorry, I was my phone got frozen.
There he is. You good? You good? If you got a question, go ahead, man.
Yeah, are you familiar with the heliocentric?
All right, go ahead, James.
I have a question, if that's okay.
James, hang on a minute. No, James is going.
Mad philosopher,
Go, James.
please. Mad philosopher, please.
All right, so Mick, you're obviously aware of everything that happened post 9/11, correct?
I wouldn't say everything, but I'm familiar with things. Yes.
Right. Sorry, I guess I should have reworded that question. Everything, like the wars that have been fought since then.
Yeah.
Since like we invaded Iraq, Afghanistan, Libya, Syria, all of them.
Against it.
Right. Well, I'm asking. So, do you know what those countries were doing prior to 9/11?
They were just sat there with a bunch of oil.
Right. No, that's not actually correct. That's not all they were doing. Each one of these specific countries, the ones that have been invaded post 9/11, all back their money. All of those countries backed their money in gold and silver, and denied central banking in their country, and denied backing their money with the U.S. dollar. Since then, every country that we've invaded, Iraq, Afghanistan, Syria, Libya, all.
Okay, someone cut out there.
He broke up.
Hey, James, we lost you.
Oh, sorry. Since then, all of these countries have backed their money in gold and silver, in U.S. dollars. They no longer back their money in gold and silver, and each one of them have incorporated Rothschild central banking. So, I guess my question to you is, how the fuck can you turn a blind eye to all of this shit and not see how evil the Federal Reserve and these Freemasons, the Rothschilds, all of them are, and you just go to all of these conspiracies trying to debunk them instead of seeing all of the evidence right in front of your face?
Good question, and I'd be happy to answer it. I think the reason I don't turn a blind eye to it. In fact, I think that things like that, the corruption that's endemic in the American system and their foreign policy, is something that we really need to look at. I might not agree with all the exact details of that link.
What do you think about it? Don't say we need to look at. Sounds like a political statement. What do you think about it?
You're asking, like, why do I debunk? The reason I debunk is that I think people need to focus on things that are real. I don't think the flat Earth is real, and I think people spending all their time. I know
you need to focus on things that are real, but you keep reifying things that are not actually.
Yeah,
real.
wait. This is
doing that.
Because what I see myself doing is I'm kind of like a force multiplier, for want of a better word. If I can actually help a lot of people not spend their time on nonsense,
well, then
they'll be spending their time on real news.
Wait, hold on.
Who are you to dictate what is nonsense and what is not?
Yeah, what's related?
The genius of the group.
This is related.
Obviously, it's what I personally decide to focus on.
Are you,
for example, like the flat Earth?
Save us.
Hold on. Do you not see this world,
my friend? Are you the intellectual that can save us?
Hold on, let me finish.
I'm trying to help.
Help.
So then, do you not see this world organization, this world secret society or world government trying to establish itself? Do you not see that?
I don't think there's a single organization. I think there's lots of people with their own self-interests. There's lots and lots of corruption. There's lots of powerful people who are doing things for themselves.
Cool.
Under one banner. They're all doing a bunch of things under one banner. Do you not? I'm asking you, do you not see that?
You think the Chinese are all doing the same thing? You think the Russians and the Japanese are all doing that?
Yes.
Yeah, bro. This guy just doesn't have the balls to wake up, bro. Fuck
it. Have you looked at the Forbes list of billionaires?
Forbes.
Dude, that one that has trillions in private.
I thought you were busy with important things, not Forbes.
Well, so look at them. Look at the variety of people that are billionaires. There's over 1,000 people in the world who are billionaires, and they're very, very different people.
Publicly billionaires.
Well, yeah, but that's all we have to go with, isn't it? So if you're just imagining things, that's just something I can't really comment on.
It's not
but what we actually see is that people who are in power are very variable. There's lots of very, very different people, and they all have their own interests at heart. So there's obviously a lot of corruption. There's a lot of problems, and that's what we should be focusing on.
All right, so wait, real quick. This is related to Most Mad's military kind of thing that he's talking about. So when we went into Iraq under the presumption of weapons of mass destruction, what's your opinion on that? Because you're like debunking stuff. So like at some level, so like what's your opinion on the weapons of mass destruction?
I think that they basically made up a case for going into Iraq, and that they essentially lied about the weapons of mass destruction by just exaggerating evidence that really wasn't there, like the stuff about Colin Powell said about the labs really wasn't.
So why
evidence.
can't you imagine them doing this at a different scale, a different subject? Why can't you imagine them lying to you
them doing it
about other things, dude?
Was that a conspiracy though? Was the weapons of mass destruction? Was that a conspiracy?
People, I think, conspired to modify the evidence to make it seem like there were weapons of mass destruction. Yeah.
The whole Iraq thing started with a secret conspiracy. You know that, right? The Sykes-Picot Agreement.
I'm not familiar with
the whole geopolitics. The Sykes-Picot Agreement was a secret agreement where France, Great Britain.
It's a secret. How do you know about it?
The Ottoman Empire decided that they were gonna divvy up Iraq. This happened in the 20s, right? So this
makes sense. I mean, they were doing that type of thing back then.
Yeah, so the current Iraq war is a base. That is the basis of the entire war.
The Middle East is completely fucked by
Kuwait, all that stuff.
The colonial system basically just messed up Africa and the Middle East. So it's
but that was a real conspiracy. That was a real conspiracy. I mean, you can Google it's called the Sykes-Picot Agreement.
I mean, there's lots of real conspiracies.
Oh, I'm just glad you admit it, because you believe in a conspiracy theory.
Yeah,
you believe in 9/11 was a conspiracy among
I wrote a book.
19 hijackers. It was a conspiracy of 19 hijackers, right?
Yeah, well, more than just 19 hijackers. There would have been a lot of other people. There's like who financed it. Then there was the organizational things. So yeah, there was a lot of people involved. So the conspiracy.
Well, I'm just saying the official story is a conspiracy theory.
Yeah,
is my point.
Yes, I'm not sure.
So calling other theories a conspiracy theory is just saying a different conspiracy.
There's a difference between a conspiracy and a conspiracy theory. I mean, a conspiracy theory is just essentially, in the scientific sense, a hypothesis, if you want to get scientific.
I believe in the lone wolf theory of 9/11, like Lee Harvey Oswald. Like there was just one person flying all three airplanes.
That's just silly.
I mean, I know it's silly. That's the point.
So why are you saying that?
Because when the government says it's a conspiracy, people believe it. When they say it's not a conspiracy and it's just some lone nutter, they believe that too. Like, you just believe anything that comes across the television set.
I didn't believe the weapons of mass destruction thing.
Well, it came across the television set that it was a big lie. But if
I didn't believe it.
If the New York Times didn't out that, then everybody would just believe there were weapons of mass destruction.
How you're going to go to Iraq and find them for yourself?
Well, they could just put them there.
You can actually
find them.
You can measure the curve of the Earth yourself. It's hard to do things in geopolitics for yourself.
May I just ask a question? May I ask a question quick? This has come from one of my friends that's just messaged me. What's your opinion on Jeffrey Epstein? Did he kill himself? I mean, considering we're talking about conspiracies. Just a quick one.
I think he probably killed himself.
You sure he's dead?
Good. Yeah,
he might have been allowed to kill himself, and that's about as far as I would go in terms of conspiracy there. But I don't think he was murdered by someone coming into the cell and strangling him.
And what about what about his overall setup? You know.
I think he was a
What
bit of a
about the
perv.
broken hyoid bone?
That broken hyoid bones happen quite commonly in older people with suicide strangulation because it gets more brittle with age.
Well, I've seen two forensic pathologists with a total of 50,000 autopsies between them say they've never seen it in a suicide.
I don't know, but I've looked at a bunch of
unless
actual.
It's at a very unless it's a height, you know what I mean, like 16 feet, something like that, not the 4-foot bunk.
There's been scientific studies that predate this by decades that show that the hyoid bone is commonly fractured in suicides, just by regular, like hanging from a bunk bed type suicides.
Well, thank you for your time, Nick. Thank you for answering.
Can I have my short question?
I should also say the hyoid bone wasn't the only bone that was broken.
Well, I'm not familiar with anything other than that right now. I could look it up, but
there was three. The hyoid bone was fractured, and the vertebrae underneath that had 2 fractures, and the cartilage had lateral tears in it.
The people who actually performed the autopsy say that it was consistent with the suicide. Now, the Epstein family hired another pathologist who attended the autopsy, and he is saying that he thinks that it might have been a murder.
Where's the video?
Yeah,
Where's
Michael Baden.
Conflicting opinions.
Real.
Any what?
So the independent one is saying it might have been a murder, but the one that's got paid by the government decides to say, yeah, it was.
Well, no, the one who is paid by the family is the one who is saying there's something suspicious. The family have already said that they think that there's something suspicious going on. So they're paying a pathologist, and he's giving them an answer that conforms to their suspicions. Now, does that mean that they've influenced his opinion? You know, are they going to fire him and get someone else if he doesn't give them what they want? Who knows?
Well, Cyril White, who's a famous forensic pathologist, saw the autopsy report, and he says that it's more consistent with murder than suicide.
Well, perhaps you should do a survey of all the different pathologists. But
well, yeah, that's why when something like this happens, you have a coroner's inquest, right? And then you get a jury of people to judge the evidence to determine whether it's a murder or suicide. That's what we used to do in this country. Well, we'll see if it happens, because I seriously doubt it.
It seems like the family is kind of heading in that direction, but I don't think they would win such a case because they don't really have the evidence to back that up.
Well, it's not really winning. It's getting people to look at the evidence. Well, I mean, from one perspective, I guess, but it's not really a win. That dude's still dead, suicide or murder.
Yeah, but then they can sue the government and bring down people in power, which would be pretty impressive.
Why was the photo of his body not him? It was somebody else's body.
No, it was him.
Yeah,
so the photos look very different in different situations.
Why did you recognize any birthmarks?
You're comparing it to photos from 10 years earlier, and also he's dead.
His left
so
ear
the blood
was
is
showing.
flowing.
You can compare it. You can compare it to his left ear.
The blood flows down to the lowest point of their body. It's called lividity, I think, because you get all this pooling and purpleness. And when someone lies on the side,
without even questioning it,
I'm questioning.
You're not even open. You're not even open-minded. You never thought about it. You just automatically. You're like automatic.
No. The reason it seems like I'm not thinking about it is that I've spent an awful lot of time already thinking about it.
That's pretty weird.
Like I was on.
Is your default position to support the official story? Is that your default position?
No, it's not. My default position is to go with whatever I think is best supported by the evidence.
I don't think you've actually seen the evidence. You haven't seen it.
Yeah, but what I have seen is it doesn't really suggest murder to me. Like there's things like the cameras being switched off or the guards sleeping on the job and things like that. Yeah, you can say that's very suspicious, but that's just something that's been happening constantly at that particular prison for the last 5-10 years or so, because they're grossly understaffed. It's a federal prison, and the federal prison budget has been cut, and they've got more prisoners there than they should have. All the prisoners.
Okay, well, name one instance. Name one instance where a person has committed suicide like that, and everything has been all the cameras from that location has been.
That prison has only had about 3 suicides in the last 30 years, and I think a very small number of actual suicide attempts. So
okay, he wasn't just any normal prisoner, was he? He was an extremely high-profile prisoner. This was an extremely rare case. So I get what you're saying if it was just another bloke coming through the prison system, but it was not. So, I mean, that's why what happened is highly suspicious.
I can certainly see that, yeah. And I think with hindsight, he should have been put on some kind of more full-time suicide watch. But
then what if those guys fall? But what if those guys fall? But what if those guards fall?
He was essentially.
Yeah,
well then they wouldn't if if he was put on a proper suicide watch. They've actually got much more rigorous checks and balances.
Yeah, but then those guys can fall asleep.
That's like saying the doctor would fall asleep.
Any guards can fall asleep.
You're making
hypothetical.
We got 3 theories. We got
before he got moved into the cell where he committed suicide. Someone did try to strangle.
We got conspiracy theory, coincidence theory, and incompetence theory.
So someone
You're
did
going
try
like
to
with the
kill him
incompetence
before he
theory.
actually supposedly.
I am going with the incompetence theory. Historically speaking, incompetence happens.
It's hard to make an argument against the federal employee not being incompetent.
Federal prison, and it was very underfunded.
Okay, look, basically the end result is here. If Jeffrey Epstein went into a court trial, they had evidence and would have subpoenaed or at least tried to subpoena Prince Andrew, who was one of the main people involved in this situation. So whether Epstein killed himself, was killed, or was relocated, that's the reason that he's gone now. He couldn't go into the courtroom. It would have opened up too much information on Prince Andrew.
Possibly, quite possibly.
It's not quite possible. The main woman testifying in this trial is the lady that's living in Australia. She was the one that was in the first initial case that was actually abused by Jeffrey Epstein on his yacht. And they've got the photographs of her with Epstein and Giselle Maxwell, or whatever her name was, the co-accused or the co-charged in this case. I mean, it's blatantly obvious why he had to go.
Okay, well, I really have nothing more to add on that. I think he probably killed himself. Maybe he was allowed to kill himself. I think it's unlikely that he was murdered, and that's
Wait, how did he kill himself? With what?
He hung himself with, I believe, a blanket. Or
with and you know how thin those blankets are, tissue paper, dude. There was nothing to kill himself with, but you think he killed himself.
No, he was in a standard cell at that time.
Yeah, no. There was nothing. No, he wasn't in a standard cell. No, there was nothing.
They said he tore the blankets into pieces and made a rope.
Yeah.
So he weaved himself a rope in the cell with the cameras off.
You could actually
a rope of tissue. Okay,
you could do that actually.
Okay, cool.
Nick,
but I don't know.
Have you ever stepped a foot inside of a prison?
Well, only in tours and things like that, like Alcatraz and Folsom Prison.
No.
But I've never been arrested or anything.
Not
like
an
that. Spent time in jail.
A fully functioning prison. Have you ever been in one? Okay, so the blankets in prisons, they are fucking thin. It would not be able to support Jeffrey Epstein's weight.
People kill themselves all the time with those blankets.
You just braid it up a little bit with a few things. Yeah, obviously people kill themselves in prisons. And they do it by hanging.
But here's the story though. We're talking about the McWest. We're talking about the official story, bro. Okay, so he hung himself with his sheets. Okay, now I'm telling you that those sheets are tissues. Okay, but you say that that's fine. You can hang yourself with tissues. Now, can you demonstrate this?
I'm saying that he hung himself with the sheets, so I don't know how he did it.
And I'm telling you that the sheets are tissues, okay? And you think that people can hang themselves with tissues.
Okay, hold on.
I'd have to.
Hold on.
I'd have to see the actual sheets.
Is it possible that he was told, can you threaten a man like that? Hey, end your life, or we're gonna do this to whatever your family or.
Possibly,
Is it
but
possible?
I think he knew what was coming down the line and he decided to kill himself.
So when are you going to decide to kill yourself?
Hey, Hollywood, chill out, man.
What if they do that to Mick and he's going to do that? Like, what? I don't know. What if that's like his, like, that's how they, I don't know, man. I'm just possibility. I've already told people.
They did it to me.
I've already told people if I get
nice.
suicided, don't believe it. I've already told people if you get a letter with my fucking handwriting or something, don't believe it. Like, I've already said that. So it's possible to anyone, dude.
I got a flat Earth challenge.
I'm still interested about aliens, though.
What we ought to do is do 200 proofs in 200 hours, and every hour on the hour for the next 200 hours, pull up the 200 proofs and debate them. One by one, each one gets an hour's debate.
Oh, any other conspiracies or theories?
Yeah, I really have to go, so if you got any last questions, then speak now.
I have a question.
Thanks.
If that's okay.
Thanks for your time. Yeah.
My question would be, what do you think people's criteria for evidence should be? So when you see a claim and some substance presented for that claim, how should people look at that substance and decide whether it holds ground?
Well, good evidence is evidence that's verifiable and testable. So if you can verify, like, you know, repeatable, testable, verifiable. It's the three criteria of evidence. But verifiable is probably the most important one. But then if you got reproducible, that kind of verifies it naturally. So things like, you know, I don't want to get into a big argument again, but like the observations of Catalina is evidence that is verifiable and repeatable, and you can test it. You can do things like change the where you view Catalina from, and you can go to Catalina and measure it. No, it's not every day, because the weather is sometimes quite often actually you can't see it, but on a clear day it's visible with the naked eye. So yeah, if it's those things, verifiable, repeatable, testable.
Mm-hmm. All right, thank you.
Anything else?
Thanks for coming by. I just want to get that out.
All right.
Thanks a lot. We appreciate it.
Yeah, thanks. Step by again.
Maybe some other time. And yeah, if there's anybody who wants to have a more extended one-on-one discussion about this type of thing, I do have a podcast, and I would like to talk to people, like more varied people than I have been talking to. So if someone was interested in being on my podcast, maybe have a quick look at it. It's called Tales from the Rabbit Hole, TFTRH.
Yeah,
and just send me an email if you would like to be on there.
The universe is also
just say rabbit hole.
We've got one of our members here, Dr. Science. He does Flat Earth Initiative and Friday Night Fights. So it's a more structured sort of debate. So that also might be.
It doesn't have to be a debate.
No. I know. I'm just saying it's a more structured format where
actually it's kind of a chat. Really, I like talking to people about where they're coming from and why they believe what they believe, and how their opinions change over time. Yeah, things like
I have a question for you. Have you ever thought of going to SLAC up in Menlo Park and going into the Stanford Linear Accelerator and look at that structure, which is probably the flattest structure in the universe, I would say. And you could do some tests in there, kind of go from the reverse angle. Now you have something you know is flat, and see if it then comports with the reality of curve or straight.
Well, I mean, if you know it's flat, then it would be flat. So I'm not sure what test you could do.
You get the plumb line at the ends that won't be, right?
Well, at each end it would be the same. Well, no, they wouldn't be. They would diverge from each other. But yeah, you could do that on the surface.
They'd be parallel, wouldn't they?
Right. And then the other thing,
they would
one way.
But you don't need to have a flat surface to do that. You just need two lines that are some distance apart. But the problem is, how do you measure this angle? Which you can actually do. You can do it with good surveying equipment on buildings. You can see that
just measure the water level. Just measure the curve in water level. It'd be easy.
That's a good point. Let's do that. Wallace experiment.
It's the same inclination that you'd have for the Nile River, right? We're talking about 8 inches, every 8 inches every.
The inclination for a river. Well, that's what rivers do, isn't it? That's what water does.
Downhill.
It finds its own level, doesn't it? It keeps going until it.
No, it doesn't find its own level, actually.
It actually flows down to the ocean, Zanuck.
it finds
Yeah,
stability.
the inclination is the same as that building.
It's called sea level. Have you ever heard of it?
Yeah, and the sea level is curved all the way around
Weird
the
that,
Earth.
and it's not level's horizontal.
Dude, how can water be curved? How can water be curved?
Okay, relax.
So Mick, the other question.
Let's fight the flat Earth.
Mick, the other question.
I'm going.
The other question. Still there?
All right,
I'm going now.
See you later.
All right, Mick, have a good one, Mick.
Nice try though.
Zanuck, be quiet. Zanuck, he
One
says
more.
one.
Last question. Let's
Zanuck,
finish one
Mick's
last
trying to leave.
question.
Come on,
then,
dude.
Jose.
The last question. You guys have had the whole 2 hours.
Last question. Go on, go for it.
Well, I haven't said anything personally.
Remember, we have a little relationship, Nick. We actually worked on your curve calculator and added one little bug on it. Remember that a while back?
Yeah, there's a few people who did that, but
Anyway,
thank
so
you.
what about looking at mountains? We're looking upward, getting away from the water refraction. Again, I like getting away from this refraction element and look at the angle of those peaks versus the horizontal to see if that comports with reality as well, or what they should be for how high they are and how far they are away.
You can do that. It does require a little bit of bit more math, for want of a better word, working out the angles and things. There's some very good examples though. I think like the twin sisters or the three sisters. What was it called? In Oregon.
Yep.
Mount Hood.
Mount Baldy, and then what's the other one over there? And
there's. I'll just post the link.
11,000 feet, and then you're sea level at some point, looking up at that mountain, saying, "Okay, does that have the right angle for how far?"
It's actually the best thing is to be on the top of a mountain, looking across the tops of other mountains at distant mountains. And I posted a link of that type of thing.
Right.
But it's essentially a very large-scale version of the Wallace experiment. But you do have to kind of accept what the height of the mountains actually are,
right?
Which not everyone can accept, because it's all based on numbers.
That's a great picture, by the way. Yeah, a lot of people here actually accept the altitude indicators and the air density measurements.
They just did the world. They just did the world record.
I don't.
326.
I don't.
Mick, who are you talking for? A lot of people.
I accept measurements of altitude. I don't accept the model.
So when you basically in a helicopter and the altimeter says 1,000 feet, you don't think it's correct?
I believe there's an error within a certain range.
All right, so I think I've answered that question, but
How long ago was that one? Anyone know? Is Indio here? No way to know. You're on your own, Sonny, on this flat plane.
Dead air Dave checking in and roboting any signs of the globe yet?
Only minor roboting right now, so.
Any signs of the globe yet?
Any signs of the globe yet? Well, you'd have to ask somebody besides me, because I've never seen any. I don't know. I don't know anybody in reality that uses a curvature of the surface of Earth anywhere. Only in the minds of children. Some of those children are full-grown adults that are still children. Now, in some ways, I may be in that group myself, but not about Earth. That's for sure.
Am I still roboting? Should I stay on mute?
No, you go ahead. You're fine, Dave. It's all good.
Really?
Sound good.
I'm way out in the country. I figure I'll be roboting right now. But anyway.
No, you're coming in
Just want
clear.
to shout anybody listening on YouTube or wherever. Come in here and discuss the shape of the earth. We've got information to share. Back to you, Sonny.
Yeah, no worries. When you say you're out in the country, I remember my father used to take me around down in all those southern states down there, Tennessee, Kentucky, Alabama. Like, I remember driving through those woods and stuff, and yeah, it's a trip. I have these stark memories of Kentucky, actually, and the roads there, and actually going to the Mammoth Cave, which I think is quite incredible. Since then, I've found a lot of information about many caverns underneath those states. And now apparently what's come to light is they're finding huge literal cities in those caverns. Some buildings 4 and 5 stories tall that are all underground. In some place, I think it was either Arizona or California, they found other underground cities where this one building, 2 stories, held 800 people. And one floor held 500 of them. Out of those 800, one floor held 500 people. So apparently there are underground cities here all over the place. All the stuff that was uncovered, I believe they already knew about all of this before they came here. There's quite a bit of evidence that they knew they were going to Atlantis. They knew they were going to the old world, the biblical old world, and the true Euphrates and Nile rivers were in America. Yeah. Like the depth of those lies. A lot of, even flat earthers can't comprehend that. But until you do your own research, you could call bullshit on me all day long. I mean, I'll do it myself. But I've done a lot of research and I'm coming to different conclusions. And I think it's one of the most fascinating topics there is, besides Earth actually measuring flat. I don't understand Globers because all they have to do is go to their own experts and find out. Yeah, like basically the experts are saying, we don't care what you tell those children in the school books. We're not using Earth as curved. Even when we shoot rockets, they're starting with a flat level plane. How else are they getting elevation angles? You can't get an elevation angle from a curved surface. Nobody uses Earth's surface as curved. No one. Find one person that does. A race car track, a freaking test range, a freaking flight school, like anywhere. Show me. Show me one single person with any technology that uses Earth as curved in reality. It has to be actuality. It can't be a Mick West program game. Even though all his games are all flat Earth too. Especially the skateboard ones.
Sonny, I'm doing a robot check. I'm definitely a robot.
A little bit, but go ahead.
Just want to encourage somebody else to speak up. Like Spake Face, I heard he went back to the globe. Why don't you tell us about that, Spake?
Stag, I think he's saying you're Gaba.
Yes, he's not near his mic.
I'm sure he'll stand up.
Ball kicker now thinks on spinning balls every round thing, nothing, don't you, ball kicker? Okay, Dead Air Dave is 0 for 2. Back to you, Sonny.
I'm just spitballing here. I wasn't even like really going to come on, but it's fine. I don't mind speaking up. Here you go. Like my kids used to skateboard. I did too when I was younger, but that's how I hurt my shoulder. Anyway, I was skateboarding with my kids, but okay, skateboard moves. Okay, you know what an ollie is, right? That's where you snap the tail and you jump up in the board. And I've seen people ollie as high as like 4 feet just from a standstill. But anyway, I digress. So when they're skating along, and let's say you're going to ollie or jump up over a curb, right? Now, when landing, why don't any skateboarders, even the ones that are aerial, they would be whacked when they hit whatever they were trying to hit, wherever they thought they were going to land on their skateboard. It would not be where they were actually landing if Earth was spinning and if Earth was curved. Think about that.
That's a good point, son. I'll robot now.
No, it's okay. I can still hear it. I mean, it's a little bit, but it's nothing to worry about. I can understand you perfectly.
Real quick, have we talked to Kaiser Soze? He's on the panel right now. Hello, Kaiser Soze.
Kaiser Soze, are you there?
Hey, what's up, guys?
Hey, how you doing?
Good. How are you guys?
Very good, very good. What brings you to the server? Have you been here before?
Oh, yeah. Yep, I've been verified, and I'm a diehard Flat Earth believer. I'm not a Flat Earth believer. I'm a Flat Earth knower, I would say.
Yeah, it sounds like you're on a track. I a lot of times I can tell. I mean, it may be flashes on my part, but somebody's voice a lot of times tells me a lot. When I first hear a voice, I don't know what that is. I think I have a high connection to intuition.
Yeah, I mean, the way I describe it would be Christ-like consciousness, and every different religion throughout the world talks about raising consciousness levels and your different chakras and all that stuff. So, yeah, absolutely. I know exactly what you're talking about.
Mm-hmm.
So, yeah, so I think I'm going crazy, but like, I know I'm not, but in my head, I think I'm crazy because this is what I've been told crazy looks like. But this website, have you heard of it? That I posted?
What? Let me see. I see youngandrecklessmusic.com. Is that?
That's it. So, okay. Have you?
I haven't.
You got to check it out. So what's cool about it, it's like a hidden message is what it is, and the music is what it pretends to be to me. It's talking about different types of biblical verses and how they tie into basically what this, wherever, it's like talking in code is what it sounds like. And again, I feel like I'm a part of Russell Crowe's movie, The Beautiful Mind, you know, like putting these together. But anyways, I would like you guys to check it out, and it's quite interesting to say the least.
Wow, like I've been involved personally in music my entire life, basically, and we know that they've transmitted messages to us throughout that whole music, through all the music we've ever experienced. There's always been a message there. I mean, there might
You're
be some
exactly right.
There might be some exceptions, and the exception would be like, let's say, I think there was a much more innocent time, and therefore the music was portraying a more innocent time. And I remember hearing those songs that just sounded natural and beautiful, and just had a good message, like something that made you feel nice or feel good. Yeah.
You're right. So here, let me talk about this. So go back to the days of slavery and look at plantation music. Have you so whenever you become awake and you see different things, you see different patterns and different things that they're talking about in old plantation music. And essentially what they're speaking about, in my opinion, is they're basically psalms to their creator. And they're basically scriptural references and biblical references that they're talking basically in code through these songs.
Mm-hmm. Yeah.
And so, like you said, this has been going on for a long, long time. And it just, again, it makes me feel like a crazy person because if I explain this to anybody that doesn't know the truth, you will sound like an absolute moron. But if I explain it to you guys that understand this, I think there is a deeper meaning. But again, I'm feeling crazy right now, and I just wanted you guys to take another set of eyes on it because I respect your guys' opinion so much.
Well, so what is it? The lyrics and the music that is hitting some kind of a chord with you, and that's what's making you feel that way. Now, what part of it is making you feel crazy though? Like because you're actually able to perceive these messages? Is that why?
Yeah, I think that's what I mean. Anytime that I've talked about any flat Earth to other non-flat Earth believers, you get painted as like a Gnosticism type of deal, where you've got this secret hidden information that no one else has. You know what I mean?
Right.
And that's what makes me feel crazy.
Well, dude, listen, we already have. Like, see, here's something that happened to me like that. Like when I started looking into all of this, you know, we learned a lot about like Freemasonry, right? I mean, we may not know the actual inside or being inside the society itself, but we've learned a lot about what their secrets were. And now I'm approaching the point where, like, you know, who else said America was Atlantis? Which now at this point in my studies, I'm finding overwhelming actual, not just correlation, but actual literal proof, archaeological proof, literal proof in the writings of these ancient people of America, and the languages of America, and the words that are used in those languages, such as atl. So the only place that word I'm digressing. So the Freemasons, they also believe America is Atlantis, and that's the proof I'm talking about. I believe there is the Garden of Eden. I believe this was the location of the garden, and that most of the old world biblical stories are from here.
Yeah, and you're cutting out right now.
Oh, okay.
You're like robot. But no, you're right on track with what I'm thinking about, and I've even started to rediscover like constellations and the stories that the constellations tell, and compare those to biblically. It's different things, and you're talking like the Star of David. Well, what did that actually talk about? Was that actually the constellation of Orion that was telling a story, or did it have nothing to do with that? And we're talking these different stars represent throwing or shooting arrows or throwing spears at different targets, and they're either hitting a target, or else they're hitting a bull, or they're trying to defend against a serpent or a dragon. It's all... Anyways, have you studied that, where the Hercules, and I think that one represents Jesus, which I don't think his name was that, but I digress. But it's basically Hercules throwing a spear, which Jesus was punctured by a spear, and it's going over the head of Draco, which is a dragon or a serpent, and it's hitting the target, which is the North Star. And anyways, it's talking about Jesus was the way, and he's the truth and the light, and it's all this talking about where Abraham was talking about, hey, look up in the sky, and this is my promise that all your descendants will be basically these stars. And whenever you start looking at angels actually being stars, which are basically born again men or women or whatever, it's just same thing. Like the Star of David in my little research is that Orion, in my opinion, which Orion has the belt and its head, which of course he hit Goliath in the head, but the sin offering in the Old Testament was to sacrifice a perfect bull, and that's what Orion is actually hitting, is that bull, that he's pointing at, that bull Taurus, which is the perfect sin offering. And it's just, there's so many different things that the stories that the Bible tells and the stories that the sky tells, and I don't know. Like I said, I feel like I have it feels like I have hidden knowledge that not a lot of people know about, but at the same time, it's making me question things and And saying them out loud, it does seem kind of crazy.
I don't think it's crazy at all. I really don't.
So, but anyways, yeah, that's why I mean, I've been researching the Bible a ton and talking about what when you look up stars and constellations in the Bible and the significance of every little story, even whenever Jesus walked on water, we're talking that how people in the old world, they used to look at the sky was they would get a pool, like a pool of water. And it would be, of course, contained and like the earth, and it would be like a reflection mirror. So they would actually look down to look up in the sky. And so like whenever Jesus walked on water, I think it was just a still day that and at the water that he saw his reflection, and then he was seeing himself up in heaven through that. And so anyways, it's just the mystery of being born again and how you're supposed to ascend into heaven and follow Jesus, which is the way. I think that it could be more literal than a spiritual sense. And the only way to get through the firmament is through light. You can't penetrate it any other way. And there's different tears in the firmament, like the comets. And I don't know if those were ascensions of people to angels. Same thing like the Milky Way. What it looks like a giant tear in the firmament. And
yeah, listen. We did book studies in here of Enoch, and we did the whole thing, and that was a couple of years ago. But it was very enlightening because you talk to, and not to get too biblical. Well, we're pretty much still on flat Earth. Elevation angles are the way we look up at sky. But anyway, I digress. But in Enoch, it talks about there's one of the wanderers, right? They're changed. They're changed because they went against their first order, like where they were supposed to stay. They left their house and they revolted against where they were commanded to stay. So they're still chained. Now, there's these other characters basically up there.
Yeah, I know.
One of those throws balls of fire at the other ones and torments them.
Yeah.
So when I heard that, I was like, the comets and the asteroids. There's actually a story for all of that, which is really quite incredible. Talk about feeling crazy. Like there's actually something going on up there in this world, in the spiritual realm or whatever, of somebody's like throwing fireballs at the other ones that are chained up. Now, I might have some of that a little bit off, but I don't think that far off from what the story says. But that's wild that it matches with what we actually see in reality. Now, that's the part that kind of trips me out. That like I never thought I was seeing like this world and there's spiritual things going on and they're actually manifesting in the material world. Wow. Like even if it is just up in this light show we see above us. Now, all of that is only optics. So, but regardless of that, like even just seeing something in optics that kind of matches the story that we're told in certain books, that actually matches what we see, is pretty wild.
Yeah. No, you're absolutely right. That's what's so. Here's what's cool about it. This journey for me, it started me literally making fun of this group is how I started, which a lot of you guys are the same way. And then I came here and it became an unknown place. And that's where you truly find yourself, in that place of unknown. And the more at first I would be scared of this unknown. And I think that's the whole hiccup in people coming over to this place, is that it is scary. And it's like, it's unknown, but that's the only place that you can find yourself. And then people like you, and it sounds like, and the way I feel is that once you see the truth, you just run to the unknown every single time, because you're seeking that more of that understanding and not just knowledge, but It's just so much more incredible than we ever thought.
I think it's going back to that childhood curiosity where now I understand, and I have a resolution to when I was younger and I was saying, no, I don't want to do that. That's not what I'm supposed to be doing. I was very adamant about that. Now, most of my life, I was a very good child. Like, I did what I was told to do. Like, I was good. I tried to do everything to please my father, you know?
Yeah.
Like, if he wanted me to do something, I did the damn best job I could do. But look, like, I don't know, that gets kind of personal. But
no, I'm a father too, and I understand what you're going through. I completely do.
No, I had those problems, like, challenges as a parent myself. I was not prepared for parenthood. Like, who is, though, right? I wasn't prepared for adulthood either.
You're right. Right.
So,
and that's what as a parent of 5 children, and that's my job. I see as them as that I need to prepare them for adulthood. That's basically my calling right now.
That's all you can do.
I mean, yeah. No, it's this.
I have a lot. There's a lot of grief and remorse, and let's see, forgiving myself for my part because of what I think, how horrible I think I did as a parent. But my kids, my 2 boys, they're doing actually better than both of their parents.
Yeah, right.
So there's no reason to worry, but there's other things going on where there's not that much of a connection, and I don't know if there's any blame to be had, but I just think our paths, like as whatever we are here, our paths are kind of ordained. I think, like, there's a lot that we don't have control over, like as far as our life paths, because we make these little decisions and we only see what the effect of that decision is years later.
Yeah.
And I go, holy shit, like I was going down this path. I made this one decision and that completely changed the trajectory of my life. And so trying to second guess that, to go like, okay, make the decisions so that I don't suffer as much, let's say, or I don't cause harm to myself or others. I don't know. It gets pretty heavy. But.
No, it does. And that's what the whole thing is, that I've been a truth seeker, and the more truth I've seeken, but the only way to find the truth is you have to like run to the unknown and be like, you have to approach everything with the Socratic method. I know nothing about this. I thought I did, but I know nothing. Let me learn it from scratch. And
Yeah. And I think a lot of people, like the Globers, are very insecure about that because, see, I think what you're saying is very profound, because I think what you're saying is that personally, I would run back to that curiosity stage. Wait a minute. Maybe there's more information I don't know. I wonder if it's this, or I wonder what else is going on. Just keep myself open to the curiosity.
Yeah. And I didn't start thinking about these stars, and through that lens and it just changed everything. I would just basically almost like drop my phone whenever I had that thought. And you have to look at the whole entire world I'm talking about, I play a video game here called Hearthstone, and what's crazy about it is that there's actually spells, and you cast literal spells. And the more truth I've been uncovering is that, hey, these spells are actually real life magic, and they actually work. And I don't know if you've gotten into that or not, but again, it just makes you go, man, am I crazy, or is the whole entire every single thing just that messed up that it's so corrupt and so evil, or am I going crazy? I mean, and what you think, you're like, you know what? I would rather be crazy than the world be this messed up.
Yeah, no, I think what it is that you and many others are realizing these inherent things within us, and this world is upside down. So we're just like connecting. We've been taken off of our reservation as well. Like it talks about the wanderers, right? We've been taken off our, like, I don't know how to describe this. Like so because we've been so programmed and trained We've been taken away from our true nature. So us here, I think, for the most part, have kind of rediscovered these hidden things within us that are, or that we find by going within us, that we see more truth what's outside of us.
Yeah, no, you're right. No, so like, and again, this is biblically speaking, but again, I think the Bible has a lot of truth in it for flat Earth as well. But if you think of the heavens and you put a flat Earth understanding on this, it's a lot easier to picture. But and of course, if you take like the old mountaintops that were essentially at one time giant trees before the flood, I guess you probably look like Devil's Tower and stuff like that, being old tree trunks. I guess you know what I'm talking about. Has anybody studied that at all?
Yes, yeah, I do. And
okay,
I was kind of responding to something in the chat also. That's why. So
okay, cool.
So look at my emblem is that picture. I think is it? It's a one close set. Never mind. I go ahead. Sorry about that.
Oh, no problem. So I think like the tree of life is essentially there's a tree of knowledge of good and evil, and there's a tree of life. The one thing I'm thinking right now, and I could be wrong, but I think there's only one tree, and how you use that tree can be either for good or for evil. So think of it as like you have a bow and arrow, which is another symbol for the tree. You actually craft the bow and the arrow from the tree, and you can either use that to hunt food, and the same thing that we're doing, searching and seeking, and you can hunt, and it provides food and substance and life. Or you can use that to attack another person, and that brings destruction and death. And you have the same exact tool that you use as a spear. You can use it to fight off predators. You can use it to scavenge for food. You can use it for good things as well. And anyways, it's just the whole tree analogy. And if the stars in heaven are actually the fruit of a life well lived, and that's your eternal promise, and the angels that fell, like the fallen watchers, were the ones that actually were up there, and then they actually literally just fell from heaven, and they were kicked out or whatever it was, and they're not allowed to go back. It paints the picture of all the mainstream media. They talk about this. All of these love songs are essentially ballads to the Most High Creator, and they're saying, "Hey, can you let me back up where it was in the beginning?" And like all these Coldplay songs, all the lyrics are fallen watcher lyrics. They're trying to get back into the heaven. They talk about demons and the color yellow, and sheets white of clay, and all these things that are actual spiritual. They talk about angels and demons and sin and all these things that are spiritual references. And like I said, if that is the truth, then even the sinners of the earth, they are fallen fruit. They've used their fruit for evil and not good, and sinned against God, and their dust becomes fertilizer for the tree, is what it is. And so, anyways, it's just kind of a crazy thing. Hi there.
Did you want into the building?
No, I didn't.
Yeah, I want in the building. Let me in the building. Just joking. Oh, man.
Oh, I'm sitting in a parking lot, and a guy came out and see if he could help me out. So sorry about that.
Oh, no, it's all right. I live vicariously through other people's conversations.
So no, the tree of life thing has been something that I've been looking into, and anyways, it's just very interesting. If you look at the whole world through the flat Earth perspective, it's kind of the lens you have to look through it, and it uncovers more truths and it leads to more truth. It's just like a vine; it grows into new truths, and it's contagious. It infects whatever, and it just. The plant analogy is just such the perfect analogy for that. Anyways, yeah. Well, thanks for listening, and I'll take this as a W for not feeling crazy at the moment. So I appreciate any feedback you've given.
Yeah, man, no worries. We're all kind of in the same boat.
Have you guys switched over to TikTok much?
No, I don't. I really don't go anywhere. Sometimes on my feed on YouTube, I'll see different shorts and stuff like that. A lot of that's the same thing you see on TikTok. I'm pretty sure, except I know TikTok gets quite vulgar. I think maybe.
So here's my experience with I'm pretty much exclusively on TikTok. I've deleted all other social media, but it's just a great tool. And you can actually go live with your followers, and you can have conversations, and you can go. There's a ton of debates on the flat Earth. There's a lot of great people over there. I would say that this community. I would say that this community is one of the most intelligent communities on this, and there's so much stuff on TikTok that goes over this stuff. I've tried to. There's people that talk biblically flat Earth, biblically not flat. I mean, it's just there's so many different conversations, and what's great is that the algorithm is so spot on. And that's what all the smear campaign on TikTok. Now, TikTok is still getting basically really. It's not a freedom of speech, anything. By all means, you'll get kicked. So there was a guy that was talking, and he had David Wise on, and they started talking about how the ISS is in constant free fall, and they're like, "Yeah, how stupid is that?" And their live ended, and both of their accounts were banned for like 30 days, and so that's why people have. So it's still censored, so you can't talk about the jabba jabba, and you can't talk about. Any of those things, and again, the flat Earth will get you kicked off as well.
Wow!
And that's why, that was what's so interesting to me is that any person that's a flat Earth conspiracy guy, whatever, he's getting kicked off. You get kicked off, you get banned. There's tons of them over there, and that's why this whole music thing was such a thing, because I see the freedom of speech that we do not have any longer. It's completely gone, and that's why this, again, it makes me feel crazy that I understand these things, what they're saying in these songs, and they're talking about all these things in code, and they're doing everything. I've been following state nationalists and stuff like that, and how they talk in code, and all this stuff is in code, and it's like it makes totally sense.
I'll take a listen to it.
But yeah, you have to subscribe. Yeah,
I got to get busy myself. So I can get out early. So let's see.
Yeah, okay, cool. Thanks, guys.
Hey, nice to hear you today. I sent you a friend request, so when you get a chance.
Yeah, thanks. See you, Sonny.
Information. Yeah, peace out. Anyone else want to chime in? I'm going to have to be moving around this area.
I'm just going to say hello, Sonny. How are you today, mate? You good?
Hey, Chris. I'm doing pretty good. That's always a relative statement, like, how you doing? How dare you ask me something so personal, like, how are you doing?
Yeah, sorry. I didn't.
No, I'm just joking. Yeah, thanks for asking. I appreciate that.
Yeah, of course, man. No worries, man.
Most time, that's all we want someone to do is just say, hi, how are you doing today?
Yeah, of course. Yeah, absolutely.
And check in. Someone check in with me sometime,
Yeah. Yeah, no, I feel that, man. I feel that.
Wave mixer, yeah.
For example, are you doing better than you were, say, 4 or 5 weeks ago?
Oh, my God. Horrible. Shit. This last month has been really difficult, too, but it's okay. I've just worked hard, tried to stay busy. And, yeah. Doing all right.
Good stuff, man. Good stuff.
Had a struggle yesterday with a flat tire. Not yesterday, the day before, with a flat tire. And I've gotten to the point in my cycling that I rarely ever get a flat. I've gone literally 2 years without getting a flat. And it used to be at least every couple months I get a flat. It was constant. So I got this flat. There's no reason to get this flat. A little tiny pinhole. I have these protective things inside my tires. They're tube protectors, and they're like, you could drive a nail through the tire into these, and you won't get a flat. So how I got a little pin prick somewhere in there in a brand new inner tube. So anyway, and then like, I don't know, I'm just talking about my day the other day. So then I have this struggle where like I take it out and I have to do all these things. I got to check the tube, right? So then I got to clean what's in my sink. And before I clean what's in my sink, I got to do this. And it was just like this cascading different things before I could even get to the project. I had like 4 or 5 other things I had to do that were crucial in order to get this other thing done. And then you sometimes are working with mechanical things where just about everything that could go wrong does. So listen, then I take the tube out. Oh, first I'm taking the tire out and I'm taking the wheel off. So you have to loosen the brake, right? Well, it's a flat, so you can take it out without without releasing the brake. But anyway, I'm releasing the quick release on the wheel, and the little C-clip pops off, and I'm like, holy crap. Then I get the wheel off, then I get the tire out, I got the inner tube off, and I happen to have found that a brand new inner tube that apparently the past life Sonny had left for me and didn't realize it. Didn't realize I had left something for myself for the future. So I find this brand new inner tube. It has a different stem length, but I go, it'll work. So I put that in the whole tire, get it back in, pump it up, and it's leaking at the stem. You get my drift? So then I got to take the stem apart. And I don't have the right tool because I never have to take stems out of freaking inner tubes. Like that rarely ever occurs. So then I get it out, and there's a little piece of paper on the inside of the stem that's blocking it from closing all the way. So I have to clean that out. I'm like, what? This all occurred inside the inner tube. So I clean it out, and it works perfectly. So after a little adjustment of my rear wheel bearing, because they constantly kind of tighten a little bit, seems to be. So I make another little adjustment, get it all back together, pump it up. It's perfect. And it rides like a Lamborghini. End of the story. You're like, why did they say all that?
I'm just going to say awesome stuff, mate. That sounds brilliant.
See, that's what I do. I have to stay busy because, like, if you ride every day or do something every day, you're pretty much going to have days where you're going to do nothing but work on your equipment. I mean, that's just the way it is. So I'm okay with all that. I had to walk back after I got the flat. Like I rode out 4 miles, so I had to ride back. I rode out 2 miles. I had to walk back 2 miles. But I'm always prepared to do that. I'm like, I'm glad I can still do that. And I just like smiled along the way and walked with my flat. And it was in the sunshine and awesome freaking day to be out walking. So I don't mind it all. And I get to, and I push myself, or not push myself as hard. Like, I don't know. I do enjoy pushing myself physically. I go up these big hills, and there's this one hill that I've fallen off of my bike, literally endoed it a couple times. So for a while, I didn't ride down some of these gravelly hills because I got thin tires. I'm just like not afraid. So, so I'll go down anyway. But but going up is a different story. I used to only be able to walk my bike up because this hill I go up is so steep and it's gravelly like a trail. It's like a road, but it's got little areas where the water is run through. And so you have to walk carefully, and I'm pushing my bike along the way, and my bike weighs about 70 pounds, but I have power assist. So now I used to ride up in first gear with the motor and make it up halfway and get off. Then I got to the point where I could go up in first gear halfway up, and actually to the most, right at the most steepest and kind of uneven kind of terrain, switch it to second gear. And when I do that, my front wheel, if I don't have enough weight in front over the handlebars, it literally starts spinning out. Well, I learned how to control this. And if I spin the rear wheel, like if I'm too far forward, and I spin the rear wheel because I'm pedaling still, then the motor stops. So it's this balance, and I've been able to get up this hill now in second gear a couple times. So I'm like wow. Stoked, man. It's like mountain biking, but uphill with a freaking motor. Like it's great stuff, man. I never had so much fun. Like getting this bike at that time when I put it together was like being a child again with something that you like. Riding a bike for the first time, it was almost like that. It's just so wonderful. Wow, and I get to go places. Like I get to go places where people don't get the views I do, because I can go any of these backwoods little trails, even off the trails in wild terrain, and go up to these peaks and hills where I can see 50 miles at least into Mexico.
Shit, 50 miles, man.
Yes, at least.
Do you ever take a camera with you?
I don't have a camera. All I have is a cell phone, and it's shit, pure shit.
As long as you can see it with your own eyes, mate, you don't need to prove it.
Well, actually, I shouldn't say shit. Actually, I have a picture I took at the last Flat Earth get together on Sunset Beach, Huntington Beach. And let me see, I'll post it. I just have to find my phone. Oh, wait a minute. I can look it up on here. It's in here. Hold on, let me do a search. And so I took this picture of Catalina with my phone, so I shouldn't say it's okay for full of places that long distance observations. I mean, on cloud cover is perfectly clear. Let me see. Images. Talking to myself here.
Talking to yourself, mate.
Oh, file. But it's very wintry here. Has been for a couple months. It's been raining for months.
Are you surprised, being as it's winter, that it's been wintry?
Yeah.
Okay.
It's like it's shifted. It's like shifted to the kind of weather I would expect in.
Oh, okay. Wow.
Because I've been surfing on Christmas Day before.
Oh, okay.
And New Year's Day and Thanksgiving. I would go surfing on those days.
The weather can't talk properly. What's the weather like with you at the moment? Snowy, cold, miserable. This is probably the moment on Discord where I wonder whether I'm actually talking to myself or anybody else.
It's all right. Here's my photo from Sunset Beach, and actually, this is awesome, man. You can see the lights from the city on the island bouncing off the water. Let me see. If you zoom into that, hold on, I'm going to post this other part of it. Here you go. Here's my black swan. Ta-da!
Oh wow!
Here's the larger version of the photo. Hold on. You can put this on a large screen and can zoom into it. This one. That's from my phone.
Oh wow!
Here's a picture from my phone while I was on the train going up there. Look at this flat horizon. How far do you think that is out? Wait till it comes up. Look at that. Look at that. How far out do you think you're seeing? I think hundreds of miles. You're seeing out into the ocean on clear days like that.
I don't know about hundreds of miles, man.
Maybe
but
not.
I'll give you
Hundreds.
definitely
That would be quite far.
10s,
Yeah.
20s, 30s. I'll give you that.
20, 30. Yeah, because there's a haze there, so that does limit.
Yeah.
Where's that, Sasha? Look at those rocks. That's not easy to walk on, is it? They're not going to get a bicycle on that beach.
In Croatia.
Where is it?
Croatia.
Looks beautiful, though.
That's a country in Europe, Sonny.
I know that.
You know where Europe is, don't you, mate?
I sure.
You know Europe exists. All right, I'm just being a dick, mate.
It's okay though, because it's true though, because you ask some people here in America, we're like the capital of their own state is they don't know, or where the Mississippi River is. They don't know. They live in America and they don't know where the Mississippi River is. Hello.
Name 5 countries. Oregon.
5 countries. Yeah, like countries, like there's people that go out to the street and ask people like, what's the capital of China, like, and they're like, is it
Peking?
Like they say something totally off the wall.
I know. I stopped watching those for a bit, to be honest with you, because it started making me feel bad that people and to be honest with you, it's not just America. You can go up the street in England and you can ask these questions to some British people and you'll get as equally ridiculous fucking answers, mate. Just the education system over the last 20 years or so hasn't done any favors for anybody, right?
Yeah. Here's a screenshot of one of Witzett's videos when he was down here in San Diego. He was at Mission Beach. But look at that line from the sun.
Oh yes, look at that. That's beauty.
Isn't that crazy? Look at that line. How could that right there, globe buster.
Yeah, that's just gone straight away.
You cannot have that on the globe, folks. Only occurs on over a flat plane of water. You can't have a line like that. Especially that's about 10 feet above sea level right there, I guess. Something like that. Maybe 20. Your geometric horizon on the globe should be about 6 miles or something. But some days you can see islands. Yeah, there's islands off the coast here that are 25 miles down off the coast.
Oh, really? Wow.
You can see those quite well on some days.
Wow, that's really cool.
Sonny, do you want to see the picture when horizon is not flat?
I can barely hear you, but you said...
Do you want to see the picture where horizon is not flat?
Right there, the one you showed?
No, I have another one.
You want to show me one that's not flat?
Oh, God.
Yeah,
well done, Sash.
Yeah, that's a mountainous horizon, isn't it?
Yeah.
But that's actually physical, though.
Yeah, right.
Yeah.
And
Topographically
it's curving. Look,
physical.
it's curving everywhere.
Topographical horizon. Thanks.
Yeah.
Mountainous horizons, sure. Desert horizons, mixed desert mountains, mixed beach mountains, mixed views of water and hills.
There is an awful lot of refraction in these images, guys.
All
I
that
love the way you
limiting
were
of your
silent.
vision, huh? Refraction.
Was anybody listening to the recorded conversation on the bot that was playing earlier between the Flat Earth Discord server and Mick West? Was you listening to that?
I was listening to that when I first got up. Yeah.
That was brilliant.
Mm-hmm.
I think that recording's somewhere around about 4 years old. Somewhere around there.
Really? Because I heard all the regular guys, a lot of the regular guys. You were in there.
There's a few blasts from the past for sure. Lemon Bird was in here. Wretch was in here. Jose Meza was in here, one of the old admins as well. Chocolate saying, "Where the fuck are you, Chocolate saying?"
What happened to
Yeah, Chocolate was there. He's still around. He's on FED. He's just not in here at the moment.
Nathan did some kind of GoFund for him.
What's wrong with your mic?
I don't know.
It's not.
The Nathan put some because
There.
Chocolate asking for some help. You know. I don't know what.
No, I haven't seen that. I had a conversation with Chocolate maybe about a month ago in messages and DMs and whatnot, kind of trying to get him to come back in here and poke his head through and have a conversation. He said he will at some point, but that was some time ago.
He was there almost every day on Nathan.
Yeah, for sure. Yeah, he's still there. He's still alive. That's the main thing. As long as he's happy and kicking, then I'm fine with that. I just miss the guy. But yeah, that conversation earlier with Mick West was the most definite blast from the past, and yeah, it was really, really good. Really enjoyed that. It was probably one of my top 5 favorite evenings on 24/7. That conversation with Mick West. If anybody doesn't know who Mick West is, Earth Curve Calculator. Yeah, he made that shit.
Yeah, he's been on here. I think I've spoken to him also, or I've been privy to some of the conversations. A couple of them, I think. Yeah, I've spoken to a lot of those guys myself. I flat smack them right away, man. They the globe ain't what it should be. Gonna keep flat smacking. Bum bum ba bum 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 ba bum.
I find half the time now they flat smack themselves. Don't necessarily need us to say anything. Just listen to them.
Just let them speak.
Yeah. Did you say you were going out for a cycle ride, Sonny? Is that what your plan was? Is that what you were doing? Or did I mishear you?
Yeah, I'm going to go out because I think it's going to rain later. So I better get out now. I better hurry. It looks like it's clouding up by the minute.
All right, then, buddy. You enjoy your ride. And no doubt we'll catch you later, mate. Yeah?
Thanks. I'll be back later. It's going to be another indoor day, I get the feeling. So I was going to look for a tune to play in the bot, unless you guys... it'll only be a couple minutes. Might be a good thing to do. I like having these little times where we have conversation and we listen to bot for a few minutes, like a transitional period.
Are you going to ride the bike?
What?
You're going to ride the bike?
Usually I go up to the park and ride on the trails, and then I cut through the trails and I end up in another part of the city, which is pretty fun. I usually do that in the daytime, and I find some nice sunny places out in the woods. But sometimes I'll ride up to the park, then all the way back down to the harbor and ride along the harbor because it's the most sunniest place, like brightest place, and warm along the water. But I might ride down by the harbor first. Go down by the sun first.
Go with some forest.
If I had a GoPro, I'd take a video of some of my rides because it's quite fantastic. You wouldn't believe I could ride the places I ride, like straight down hills and stuff.
You can even prove the globe with the bike. Did you know that?
Yeah, just take a couple of sticks with you.
No freaking way.
Take some sticks on the bike, man.
You
Glober.
can find the video of the guy on the bike proving the globe. And I'm not joking.
I know you're not joking, but the people who come and bring it in as evidence, mate, they're definitely not joking. They believe this shit. Man on a bike with 2 sticks.
Yeah, fuck. It was another one with that flying things. I don't know how to say in English. That like a, that has that only motor and you fly like a dragon. I don't know how to explain.
I'm not following you, Sash, sorry.
You can use that without motor to like I don't know how you call it in English. Or you go in the mountains and jump with that and
Glider?
fly. Yeah, I think it is.
Like a glider.
Yeah. And with that you have like a motor and you can fly with that with some kind of motor, yeah. And some guy was going up with that and proving the globe with Fish Island.
Oh, wow. Okay. Right then, guys, let's see who's jumping in the server. I've heard a couple of pings, so I reckon a couple of people have jumped in. Let's see who we've got. Oh, Jan's back. Hey, Jan. Or Jan. Sorry, I don't want to pronounce your name wrong, my friend, but welcome back, mate. You seem sincere, you have link images embedded role, and your voice verified. Mate, I don't want to butcher the rest of your name, so I'm just going to call you Jan. But welcome back to the server, Jan. Hope you're doing well. Yeah, I'm doing really well, thanks, Chris. Oh, good stuff, mate. Nice to see you. Oh, Jan is typing. Oh, he's muted. Shit. Sunny. Or some moderator or somebody gold. If you can unmute him.
Yeah, what?
Hello? Can you do me a favour before you cycle off?
Yeah.
Can you unmute Jan for me, please?
Yeah, I'm not ready for it yet. Anyway. Oh, yeah, I see him there. I'll unmute him. There we go.
Thank you, buddy.
There you are.
There you go, Jan. You got control of your mic.
Hey guys, how are you?
Yeah, really well, thanks, mate. What brings you back? You having a good day?
I'm just checking what's going on inside here.
Yeah, not too much at the moment, mate. Sonny and I and Sasha are just shooting the breeze about random stuff, waiting for conversations to spark up, usual sort of thing.
No problem. I will hop back in, but I have to go to shop. I was just wondering if some people are here.
There's always someone. Okay? Yeah, you nip down the shop and you come back and we'll have a conversation about your beliefs. Yep, no problem.
Nice. Bye.
Awesome. Right, mate. Take care. Still reckon I should get paid for this shit. You know? Thank you for that, Sonny. Who else we got in the server then? Kind of the regulars. So let's give a shout out to the regulars. Oh, hello. Who's Bush? Bum-ba-da-bum. Oh, sorry, Bush. Bush Baby number 1. So, hi, Bush Baby. How are you? What roles have you got? You don't appear to have any. So I'll tell you what, Bush Baby 1, if you want to go to voice checking number 1, if you want permission to speak, you and I can have a very quick conversation, and I will enable you to speak within the server. So if you want to join the conversation, you can by going up to voice checking number 1.
Maybe he's there.
Oh, wow, I did that quick, didn't I? That was good.
Well,
Don't do that then. My work is never done. Alright, hopefully I don't have to do this the old-fashioned way. Sonny! Are you still there, buddy? If not, I will do it the old-fashioned way.
Yeah, I'm still here, man. It's going to take me a while, literally.
Yeah, no, that's good. That's good.
Slow.
So I just had a quick conversation with Bush Baby, who's right at the top underneath the 24/7 live. He's good to go. He just wants to get involved in conversation and ask us why we think the Earth is flat and all that good stuff.
He
So
needs
if
to
you
verify.
could give him, if you could give him a voice verify, man, that'd be
I'll
big.
verify him. Yeah, 1 sec.
Cheers. Thank you. Let me know when you've done that, mate.
I'm working on it. 1 sec here. A little rusty. Let's go copy that. Copy that. I think I could do it right here too. Ta-da! Oh, that's simple.
Awesome stuff. Bush Baby, number 1, you've got control of your mic. Just unmute yourself, buddy, and we can have the conversation about the shape of the Earth and all that good stuff. So, Bush Baby, welcome to the server. Don't let me down, bro. You sound very cheerful and like up for a conversation.
Wait, hello. So yeah, hello. It just took a second.
Hello, my friend. No, you're good, mate. You're good.
Okay, so
well,
my main question is why?
Why what?
What's convinced you to think the Earth is flat?
Well, me personally,
just got into you in general.
Yeah. We'll ask everybody else in a minute, but for me personally, and you'll probably get the same answer from most people. If the Earth is said to be a ball, then there should be observable and measurable curvature over distance. Wouldn't you agree?
I would, yeah.
Awesome. Unfortunately, we don't observe it, and we do not directly measure any curvature over any distance of any water. Being as they say the surface of the Earth is over 70% water, we should be able to observe and measure it there. Unfortunately, we don't. So if there is no curvature to the surface of the Earth cannot be a ball.
Okay. So
sounds pretty simple.
Yeah, so that's interesting because I'm a physics student.
Cool.
And I have measured the curvature of the Earth. So that's interesting you say that because, with lasers, incredibly high. Sorry.
I'm asking in reality.
Yeah, no, in reality. No, yeah. You know Lake Geneva?
Yep.
It's a relatively large, Lac Léman, if you've been over there, I think that's what they call it. Well, if you be measured across the lake with a laser, and it's sort of difficult to measure because obviously the ripples of the water could disrupt it because you want the laser to be as close to the water as possible. But there was a curvature. It was interrupted a bit by the ripples of the water, but we did measure a curvature. That's for sure.
What was the distance, my friend?
Oh, probably a good 60 kilometers. Well, no, not that long. I have to look it up. I mean, this happened like 4 years ago, probably. So yeah, 4 years, 4 years and a half actually. I'm not sure. I believe I. Oh wait, I have to look it up. I need to find the actual 2 places that we were at. But have you ever thought about, aside from that, how everything works with a flat Earth? Okay, so aside from
Bash, you didn't give us any distance, any data for that.
You'll get that.
This is something that has happened 4.5 years ago. I mean, I'm gonna have to now bring it all up.
Oh,
but
you have some observation what you cannot present, but it's there.
No, okay, right, yeah. Basically,
to
be fair,
I wasn't coming.
Sasha's
Sorry.
Sorry, Sasha. He's done this himself, so it's interesting.
Not myself in particular. With other people, obviously, it wasn't just me. I mean, it was a thing, not just me. I was with other people, 15 other people, decent group.
That's fine. The reason why we're asking for the distance is we are just going to turn around to you and give you other laser tests of distances between 10 and 25 miles over distances of water where we hit the target that we were supposed to hit. And then what we'll do is we'll point out military targeting systems that use lasers over distances of water over 100 miles using direct line of sight targeting to blow shit up, which is called applicable technology. So it's interesting you bring up one laser test, but you say you've measured curvature of the Earth.
Sorry, you keep cutting out.
I know for a fact the militaries of the world use direct line of sight laser targeting systems. So they don't measure any curvature.
You're cutting, Jedi.
Sorry, you keep cutting out. I can barely hear what you're saying. Sorry.
Yeah, he will come back.
All right, okay. Hello?
Quick microphone check. Is that better?
Yeah, that is better.
Awesome stuff. So just to recap on what I said, it's interesting that you bring a laser test. We could give you up laser tests 10 miles, 25 miles. And then what we would do is we would compound the issue by bringing the Navy into the argument and point out their laser targeting systems that target ground-based targets of over 100 miles.
Okay, so with this, how powerful are these lasers that you're using? Because that's a big thing with the laser tests, is that because we're using to do this, the light will start to refract as it moves forward, as it moves further and further away. So although you may have, say, the diameter may be a meter at the source, it may also be several centimeters at where you're actually measuring it, especially if you're 100 sorry, especially at 10 kilometers away. So there's that problem part of it. So
yeah,
you've
that's
got to
what
account for all of that.
that's
So
what
when you say measure, when you do a measurement like that, often you have to use if the laser isn't that powerful, you can use how strongly is your mathematics?
It's all right.
Okay. So have you heard of differential equations? Potentially, maybe not, maybe. But you can solve one of those effectively to figure out where the exact center of the light is in respect to the larger diameter at a certain range is. And you'll find that if you do that for that particular laser, that you do measure the curvature. In these tests, how close to the water did you do them at? Have you done one personally, or at least witnessed one?
Right. So we could show you ones that are done, say, a couple of inches off the surface of the water.
Mm-hmm.
This was the one done in the south of England, down at Brighton, over a distance of 10 miles. A couple of inches, blue and red lasers opposite end of the spectrum. The ones that are done over Lake Bissell, I think it's Hungary or somewhere in Eastern Europe. Both laser and target were about 2 meters above the surface of the water. And then we can start talking about Navy ships, and I'll give you 20 to 30 foot above the surface of the water.
All right. Okay. So I actually haven't looked into all of this, because the reason why we did this test in the first place wasn't actually to debate flat earthers. It was more of a what's the word for it? We were actually originally at CERN, with as a trip, and it was just something that we were given the opportunity to do. So we decided, why not? Because we had a few days to burn in Geneva, so it was something that we did. But I'm just interested. I've never actually thought about what you guys have said with the lasers, with the different tests. So I'll have to probably have a little look into it to see what you guys have done. So other than that, is there any other evidence that you can point to the Earth to being flat?
Yeah, celestial navigation. Do you know what a sextant is?
Sorry?
Celestial navigation. Do you know what a sextant is?
No. A sextant?
Okay. Yeah, do you know what a protractor is?
Yeah, I am. Yeah,
awesome. It's an angle measuring device, isn't it?
Yeah.
Yeah, awesome. So a sextant is basically a glorified angle measuring device, right?
Right. Oh, is it one of those sort of like things that they use? I don't know what they're called. I'm not sure if it is, but carry on.
Okay, so they use them at ships at sea to, get elevation angles to stars at known times of year, so they can navigate across the Earth using the stars. Yeah, that's what it is. Awesome. You know that. You know what a triangle is, right? You sound like an intelligent man. You know what a triangle is, yeah?
Yeah. Carry on.
Yeah. No, that's fine. Can you measure an angle with a curved line?
No, you can't.
Awesome stuff. So understanding that a sextant is a glorified angle measuring device, and it's used on the surface of the Earth to measure elevation angles to stars. You will understand that, being as you just said, you can't measure an angle if one of those lines is curved. If you're doing it on a curved surface that would be the ball Earth, then a sextant would be non-applicable. You couldn't use this device on a curved surface, for example.
What you could do,
celestial navigation.
Sorry, I point something in. So there's a few things about that I would like to say. You heard of tangents? It's sort of like to do with tangents and circles. So you can.
Yeah.
Okay. There's a similar thing you can do with a sphere. Instead of using a tangent, you can sort of intersect it with a plane. Now, if the sphere is huge, the Earth, the curvature at your point will be so small that I'd have to look into the map, but I doubt, especially with quite a crude measuring device. Is it the thing that you hold in your hand and sort of bring to your eye? Is that what you're talking about?
Yes.
Yeah, that. Well, then I doubt that the Earth's curvature will prevent you from measuring an angle from that.
Okay. So, do you know what a GP is?
A GPS, you mean? I think.
Yeah.
Did you say? Yeah.
No, a GP. So a GP of a star. Do you know what a GP? Yeah, a GP of a star is. Do you know what that is?
A GP of a star. No.
Yeah, I'll answer the question. It's the ground position of a star.
Okay. Yep.
Now, the ground position of a star can be in excess of over 1,000 miles beyond the horizon.
Okay.
The ground position of that star has to be 90 degrees.
All right.
So, ground position of the star, 1,000 miles away, straight line towards you on that boat. Now, I understand what you said about tangent lines, but you'd have to understand how we use sextants in celestial navigation. In every single calculation, you will bring your... Well, I'm just going to tell you then. So, in every single calculation, you will bring yourself down to the plane of the Earth. Yeah, you can draw your tangent line from altitude towards the horizon, but your next calculation is going to bring you down to surface level. So your altitude is 0. Understanding that you are looking for the ground position of a star that you've just got an elevation angle to, and understanding it could be over 1,000 miles away, means that the surface of the Earth must be level for every single boat at sea all of the time to use these things. So not just you, but another boat 100 miles over there, and another boat 100 miles beyond him. Every single angle is done on a flat surface. Every single calculation will take you back down to that flat surface after you've drawn your tangent line. Now, you also have to understand as well that they were using these devices well before the Earth was a ball.
Yeah.
So they weren't doing ad hoc calculations because they thought they were on a ball. But the crux of the matter is you could only use this device on a flat Earth. You couldn't use it on a ball. And if you did use it on the ball, you would have to take yourself down to a flat plane. So laser transits and celestial navigation. Do you want some more?
I'm going. Yeah. I'm just carry on because I'm afterwards. I'm just gonna have a look at it myself and see if I can get the hang of it. But yeah, carry on. I'm just willing to listen.
That's fine. Yeah, no, that's fine. I'm still waiting for your evidence as well.
Yeah, no,
I know a few.
You carry on and then I talk, and then we'll see.
I mean, that's fine. We're just going to be talking about direct line of sight transits of signals as well. You know what a radar is, right?
Yep.
Awesome stuff. So you understand that was 2 journeys from the radar to the object and a ping back again, yes?
Yep.
Awesome stuff. Now you understand this is also direct line of sight technology used from boats at sea to other boats at sea up to a distance of, as far as I found, 450 miles.
Mm-hmm.
So that would be a 900-mile transit from the boat to the object and ping back again. Now, this would be impossible over a curved surface because the curved surface would get in the way not once but twice.
Yeah, but the thing is that waves diffract as they move through a medium. So,
yeah,
again,
that's fine.
They will.
Hold on.
Sorry.
Hold on. And that's fine. You said you wanted me to talk, so I'll talk.
Mm-hmm.
So I'm just going to be pointing out all of the technology that the navies use. The first instance was the celestial navigation. They've got to get places. They wouldn't be able to use this operation on a curved surface. We wouldn't be using sextants for that. I'm then going to point you to the laser transits, where we have direct line of sight laser targeting systems up to 100 miles. I've now just pointed out radar systems. But first of all, we're going to have to see the object, and that's why we use infrared cameras. Infrared cameras see the object. We then make sure with the radar that that object is actually there, and then we ping it twice with 2 different lasers, one blue, one red, to make sure that we've got a target. So 4 pieces of technology that would only be applicable on a flat Earth. They wouldn't be applicable on a curved surface. Keep saying
yeah. Okay, so that's...
There's 4.
Yeah. Okay, so have you got anything else, or should I do to talk?
No, let's go. Let's go to your stuff now.
Okay, so so the first thing that my personal biggest thing is actually gravity, because obviously, as someone who studies physics, it's something that is very integral to everything we do. So a lot of things that we do. So, and the way gravity behaves is not possible now on a flat Earth. Like, it just physically will not work. And you can you think about it. if a gravity, you understand that the vectors to the force weight, which is the force that is applied on an object due to it being in a gravitational field, point directly towards the center of gravity, as they call it, center of mass, I guess you can also call it, of the object.
Sorry, mate. Sorry. What's
okay.
gravity?
Gravity is, well, what is gravity? That's an interesting question. Well, the force that object experiences is weight, and that is because it is in a gravitational field. I'm talking about Newton's explanation of gravity, not general relativity, which is beyond. Well, I understand it at a reasonable level, but not enough to explain it to someone else. But
Bush baby, real quick,
yeah.
you know that those two are entirely incompatible on a conceptual level, right? Maybe they give the same outcomes, but they're incompatible. You do know that, right?
Universal gravitation, though, or Newton's laws of universal gravitation, help us. But the explanation. But Newton's laws.
Laws, but if you say they are laws, then Einstein was kind of wrong.
No. You got to listen. Universal gravitation doesn't explain why gravity happens and why we're seeing this. That's what general relativity does. Universal gravitation.
No, they're incompatible. But sure, go ahead. You need to look it up, mate, because you said it was beyond your scope, right? I guarantee you, it's entirely incompatible because they're conceptually different. It's not a force. It's not a force in Einsteinian gravity.
No. Yeah, I do get you, but that's the explanation. When Newton developed all of these.
But look, if you put a piece,
he had no idea. Okay,
no, mate, it's entirely different. If you put a piece of cheese on the floor every single day, right, and when you wake up, it gets taken away. There are two different theories. Either like a person takes it away, like your sister, or it's a mouse which eats it, right? Now, both of those theories would offer reasonable explanations to why the cheese vanishes, right? But they're incompatible.
Newton's. I don't know how to explain it.
Newtons and Einstein's are incompatible. A force is incompatible with Einstein's, where there is literally no force. It's just space and time curving. The whole point of Einstein was that Newton was wrong. That's what he said himself. So don't go saying that they're compatible, because they're not.
I never said they're compatible.
Okay, that's great.
I never did.
So
I never said
they're incompatible then, right?
Yes. Well, at a conceptual level, like you said, yes, they are.
Okay, nice. Yeah, sure.
I never claimed that. Newton's laws of universal gravitation explained what. I don't know how to explain it. They modelled how objects moved in gravitational fields, not why they move. That's Einstein's part, the why. The how, or not, how's a bad word, but what they're doing in the gravitational field at at our level. I don't know. It's very difficult to explain, but how they move, if you see what I mean, can be modelled by Newton's laws of universal gravitation. Why they move, that's Einstein. If you see what I probably butchered that horribly, but
yeah.
One thing that Newton's laws of gravitation, the equations that we can use, to predict where objects are and how objects fall, they do work. So Newton wasn't completely wrong. His explanation for why they worked was wrong, but the actual modelling of it wasn't. So if you think about it, if you think how we model, say, even an object falling towards Earth, a simple ball, we can model it using Newton's laws of universal gravitation, and we get a right answer, the same experimental answer that we do if we just dropped the ball and measured it, or performed a measurement on how.
Yeah, exactly.
Or how fast it was. So, yeah, okay. Well, the point being is that you cannot if you had a flat Earth, the Earth, and it's a giant flat Earth, like a flat disc, like us.
Hold on.
Sorry.
Done. All right. So I'm just going to give you a piece of advice. There's no gravity on a flat Earth, my friend.
Okay, but then what's the explanation?
Yeah, there's other explanations, but we'll get onto that. My question for you is, have you actually got a scientific experiment that's proven any of this, mate? And if you have, can you give it to us?
Yeah,
Yeah. Because, hold the fuck on.
All right,
so, when stop talking through me, mate.
I'm
we
listening.
talk. You're doing yeah, thank you. So when we go and, watch educational programs on TV, when we speak to any of these science communicators, they will turn around to us and say, gravity is not a force. You know who Brian Cox is, don't you? That's a question. Yeah. So you know who Brian Cox is? He says gravity is not a force. You know who Neil deGrasse Tyson is?
Unfortunately, I don't like the guy, but carry on.
Yeah. He doesn't know what gravity is, mate. So I can run through George Musa. You can think of gravity as a force, but it's not.
Yes, and that's exactly what I just said when I said
that's fine. It doesn't matter.
Versus
but
why
I'm giving you this hill, mate. Got a lot of backup from science community. Like people talking through each other, it's starting to really annoy me.
Okay, so the evidence for it is that if you have a vacuum chamber, and you don't even need a large one, you can have a tiny one actually, a meter. But not even that. You'll find that the objects will accelerate towards the Earth at the same rate, independent of all their masses.
Okay, what happens if I drop gas in the vacuum chamber?
Well, then you've put an extra parameter, which is air resistance into the.
No, I'm not. Sorry, I'm not dropping anything else. I'm just dropping gas.
What do you mean?
What happens to the gas vacuum chamber? Yeah. So you said all objects. Okay. Yeah. Gas then, right?
Yeah.
So if I was to impart gas into a vacuum chamber, which direction does that go?
How much? That's another problem. That's because then you get a thing called pressure, which also
some gas.
Some gas.
How'd you get pressure?
Because if you add.
Sorry. How'd you get pressure? How'd you get pressure, mate?
If you add a fluid.
How'd you get pressure, mate?
What do you mean? How do you get pressure?
Just so I understand, because you said pressure. So what is pressure? How do you get pressure for gas?
Well, pressure is the force that particles exert on the side of the container.
Awesome stuff. Thank you very much. We'll come back. Awesome stuff. We'll come back to that in a minute. But after I've imparted gas into a vacuum chamber, and gas moves freely and randomly in all directions, which way is the gas going?
How much? Because that's that again. You can't just say I'm putting gas into it. How much? That's the question. And how big's the vacuum chamber?
Tell me.
Well, if you put very little gas into a very large vacuum chamber, it'll be accelerated towards the Earth.
So it would fall down.
No, not necessarily. Not necessarily. Sorry, it will spread out. Spread out.
Yeah, it'll go in all directions, won't it?
Yeah, it will fill the space as best as it can.
Yeah. And it will also press up on the limitation of the chamber, which will be up with the ceiling. Right?
Yeah.
Awesome stuff. So, just a quick question. How in an open system do we have gas pressure adjacent to a vacuum?
You're saying, what do you mean? Sorry.
How do we have gas? Sorry. How do we have gas pressure on the Earth in an open system adjacent and within a vacuum?
That is a good question. There will be. Well, I cannot answer that question.
No. See, this is the problem. So we can talk about gravity all day, and I'll tell you what, I'll give it to you. But at the moment, it is observably not affecting gas because gas goes in all directions. You've already admitted that the necessary antecedent to gas pressure is a physical barrier for the gas to press upon. They declare the Earth is an open system devoid of containment and adjacent and within a vacuous space. According to the second law of thermodynamics, the gas will fill that space. The higher pressure will disperse into the lower pressure environment, unless stopped by a physical barrier. So, we've got a huge problem with what they tell us about the Earth and where it is, because you can't have gas pressure without a physical barrier for the gas to press upon. You've already admitted that, haven't you?
I have.
So I can give you gravity. Yeah, I'll tell you, whatever gravity you want to give me, that's fine. But observably, in science, we don't have the phenomena to even ask the question about, because gas moves freely and randomly in all directions. So you say objects, you can drop a ball and that will go down.
Well,
that's why I gave you gas.
Mm-hmm. Okay.
Mm-hmm. So understanding the second law of thermodynamics, understanding entropy, invalidates the heliocentric idea of uncontained gas bodies in vacuums. You can't have that.
I'll have to look into that. To be fair, that is a point.
It's one of the main reasons why I'm here, mate. It's a law of nature, right? Applicable always. You understand what a football is. You understand what a tire is.
Yep.
You know that when you impart gas into that volume, you will have gas pressure, the force of the gas exerted on the walls of its container. Now, you know what an open and a closed system is. In relation to thermodynamics and matter transfer, they declare the Earth is an open system, rockets to the moon and remote control cars on Mars. But that would also mean the gas, Jupiter, a giant ball of gas, uncontained from a vacuous space. That situation could not happen. Laws of nature trump unvalidated pseudoscience, gravity.
I'm currently thinking about this.
That's fine, mate. I urge you to think.
Yeah, that's what I'm doing.
Just for me and for everybody else, just slow down a little bit, mate. It's not a race. Enjoy the conversation, all right?
Yep.
I just wanted to add a little something on top of what you were saying. Keep in mind, in the heliocentric model, they're claiming that it's an expanding volume, that the universe, the edge of the universe, is expanding outwards faster than the speed of light. So keep in mind, they're not just claiming that there's a vacuum of space above our heads. They're claiming that there's above our heads an expanding volume while we have consistent gas pressure here on the surface of the Earth. And, as far as practical demonstrations go, if I were to have 1 cubic foot chamber, a chamber that's sealed, it's 1 cubic foot. On the inside, we have ordinary 14.7 psi, like at sea level. And if we were to somehow change around this container so that while it still keeps enough of a pressure seal, expanding the volume of it, it would be 7 psi. It'd be much less than 14.7 psi. So this is a practical demonstration of how volume and changing the volume has an effect on gas pressure. And so it's just think about this practical demonstration when you hear them and their story, their fairy tale, like, oh yeah, the universe is expanding, but still have consistent gas pressure.
Okay. Well. Okay. How?
Balls of gas just don't coalesce in vacuums. Gas disperses in all directions and feels the limitation of its volume. It will then press on the limitation of its volume and you will have the consequent of gas pressure. If you don't have a physical barrier, you will not have gas pressure and there will be nothing there to keep the gas there.
I'm just thinking, well...
Gravitational idea only applies to the Earth if it was a ball. Whether it is mass of the Earth attracting other masses to it, or the mass of the Earth bending and warping, a reification of concrete nouns, space and time. And that's not scientific, that's mathematical equations. But both instances do not have a fully verified scientific method experiment that's validated any of them. You can't do it with Einstein's shit because that's maths, that's not science. And Newton's idea, you can go to Cavendish, but that's not an experiment either, not according to the scientific method. But gravity only exists on a ball. doesn't exist on the flat Earth. There are other reasons why things go up and things go down. Scientifically, being as the only thing we vary and manipulate would be the density of the medium the object is in, then it's relative density in science.
Explain
like I
how
said,
relative density works in your, because there's a term that's thrown around the flat Earth community. How's that? What's the how?
Let's just put it. Let me put it like this, right? In science, the only thing that we ever vary and manipulate is the medium the object is in.
Yeah.
For example, if I was to have a boiled egg and I was to put it in a solution of water, the boiled egg would sit at the bottom, right? I add salt to the water, make the solution more dense, and the egg rises. Now, what have I varied and manipulated? Well, that would be the medium. I've made it more dense. So scientifically, that would be the density. We can have an anvil sitting on the top of liquid mercury, for example. Why is the anvil not falling through the liquid? Well, the liquid mercury is more dense than the anvil still.
Yeah.
Again, it will only be the thing that I can physically manipulate within a scientific experiment, which will be the cause. Now, there are laws of nature, things that are outside the scientific method experiments, that we literally get down to the one last thing and we just do not know. Like the cause of entropy, for example. Fuck knows why it is. It just is. Now, mate, I do not know why we have a directionality to our world. Don't understand that. But all I can do is very manipulate things within our reality, and they will go up, they will go down, or like gas, they will go everywhere. And gravity only applies to a spinning ball in space. And just think about it. I can drop a ball, and it will go down. Calculate the rate of fall. And within my mathematics, I can then say, I'll tell you what, there's a force that's pulling the ball down, and I can say that that force is the mass of the Earth. There you go. I have the phenomena. I have the rate of fall. I can just do some mathematics, and there you go. I've just made up a force. I could equally say the sky was pushing things down. Just do some mathematics. There you are. Because the phenomena will still be the same. And then I can make predictions with it. But the phenomena is still the same because the ball will always go down.
No, I'm just thinking. Sorry, you can keep talking if you want.
You're fine, buddy. Just notice your speed has kind of slowed down as well in the last 5 minutes. We get this a lot sometimes. People come in here with a shitload of stuff to talk about and they keep talking and they won't listen to anybody else. And they got 1 question, 2 question, 3 question, 4.
Yeah.
It's always nice when people slow down a little bit and listen to what is said. So I'm glad that bit got you, because it is something that is worth thinking about. And I guarantee you, mate, it's one of the main reasons why we're here. I've been in the flat Earth, for example, for the last 8 years. This argument, gas pressure without a container, is one of the main ones. The other one is there is no measurable curvature to the Earth, even though you're still yet to give us your laser test that you did in some place in Europe. I can't remember where. I do apologise. And we can look at that all day, that's fine, but we will just give you other ones. We will give you long distance observations. There is, in our mind, no measurable, observable, or practically used curvature to the Earth, which is why I brought up things like navigation and direct line of sight, because the curve of the Earth would get in the way, or you wouldn't be able to use these tools if the surface of the Earth was curved.
Yeah.
It's interesting as well, the majority of the evidence they will give you is from space. Here's a picture of the Earth from space, it's a ball. Well, that's a bit of a problem, being as you can't have gas pressure without a container, which will kind of ruin every single fallacious story they give you from this place. We may as well just start calling Narnia.
Yeah.
Now, we're not saying the sky doesn't exist and, hey, that's not the moon, and Mars doesn't exist. We will just debate the story about what we are told about these things. They claim that there's a vacuum. They claim this, that, and the other. When we try to verify these, find out that they cannot be true. You can't have gas pressure without a container.
Yeah.
Right, I've got a call. Go for 5 minutes and call my child. I'll be back shortly. Thank you, guys. Right. Everybody leave. What's happened? Oh, I see Jan's back. Cool. Jan's back from the shop. Hope you're doing well, Jan.
I have my groceries, so I'm okay.
Good stuff. We're just talking to Bush Baby at the moment. But yeah. Glad you're back from the shop, my friend. Sorry for jumping like that. I just had to give my child a quick phone call. So where you at, Bush Baby?
Yeah, I'm just thinking about the your atmosphere, the atmosphere dilemma.
I mean, I urge you to think about it, mate. For sure, but are you trying to come up with an idea of how you can have gas pressure without a physical boundary for the gas to press upon?
Yeah, that's what I'm doing.
Okay, good luck with that. You went to vacuum chamber in our conversation, right? Which is interesting because you need a physical barrier to separate the two vastly.
Yeah, but you do realise it's the atmosphere outside
pressure areas, right?
Barrier.
If you didn't have that physical boundary between the two, you wouldn't be able to have a vacuum, would you?
No, because the air from the outside of the vacuum would push into it.
Yeah, exactly. So the open system of the Earth, the gas would disperse into the vacuum, wouldn't it?
Wait, no. Because in the example that we had a vacuum, and you put a gas inside that vacuum, and it will disperse to fill that vacuum. That's true. But
yes, the
force that's pushing against that vacuum is there is going to be a force obviously from within the vacuum, a very tiny one, but the larger force is going to kind of crush the vacuum from all sides. That's going to be atmospheric pressure, right?
Yeah, the gas will fill the space. Yeah.
Yeah.
The higher pressure system will disperse into the lower pressure environment. Yep.
Bush Baby, can I ask a question?
Yeah, sure.
Can you now compare the size of our atmosphere? That's the paradox, but doesn't matter. With all this out of space vacuum.
Yeah.
What do you think? What is stronger, our atmosphere or that? You know how big is that vacuum space comparing our atmosphere?
Evidently huge.
Yeah, I cannot even imagine that. I cannot put that in my mind. With that given numbers of space and everything. I cannot even. This is something like. I will try, and this is nothing. This is even small numbers. Something like a lighter in the Atlantic Ocean.
Yeah.
Yeah. And that lighter has the small, around, big air, you know, and that water cannot go in.
Mm-hmm.
Yeah, that's the comparison. Of this open system in this out of space.
Mm-hmm.
And plus, that open system is going together with the Earth in orbital speed 66,000 miles per hour. Not only static, you know.
Sorry, what did you say with about 66,000 miles per hour? Sorry.
I'm saying that all this gas, it's also moving together with the air because it's going around this. Yeah. That's also interesting.
Yeah, but you're not going to feel a force because of that, because the speed is constant, velocity is constant even. Sorry. And the...
I'm telling you that open system is going through that, what Jedi explained it to you, what is that vacuum and what the gas will do in, let's say in some, if you put a little bit, do you remember when you said if you put a little bit in gas in some vacuum chamber? Now imagine how much atmosphere, how much that is gas for this vacuum of the space.
Yeah.
I told you, compare that and we are there. That's ridiculously small. Even if it's big, doesn't matter. You will still fill the space. Problem is natural law. You can now deny the natural law and say, yeah, okay, I'm not agreeing with the natural law. That's the point.
The size of the vacuum, are you saying the size of the vacuum increases the force experience, the force of... are you saying are you saying the size of the vacuum is proportional to the force?
I mean volume or... Do you mean the volume of the vacuum?
Yeah, the volume of the vacuum is proportional to the size of the force.
Not necessarily. Well,
then the argument about how big space is not relevant.
Well, no, that's just an aside to compound the issue.
Yeah, well,
if space is getting...
Well, the size of space and how large space is and how large the vacuum is itself is irrelevant. I believe, it will be irrelevant to the force experienced by the particles pushing against each other and then effectively trying to push against and escape and move away from each other.
Okay. Yeah, basically all we're doing is it's just an aside which compounds the issue. We're just saying the volume of the vacuum is increasing within the heliocentric model because of expanding space. But ultimately, it's irrelevant. Ultimately it's irrelevant. But the point is this: out there is a vacuum. Down here we have gas pressure. To have gas pressure, we must have a physical boundary for the gas to press upon. If there is no physical boundary, then the higher gas pressure will disperse into the lower pressure environment. That's entropy. So it's a big fucking vacuum. The rate of the vacuum is 10 to negative 17 torr, I believe. Whatever it is, there's an awful lot of... This is why they call it space, because there's a lot of space between whatever particles there are up there. But the point is, it's a lower pressure environment. Uncontained and open to the Earth's high pressure system. That cannot exist.
Jedi, how much we can produce on the Earth a vacuum chamber?
Sorry,
I think it's negative six.
Yeah,
it's 6, 7, something like that.
Yeah. But that's 10 to minus 17. That now that's not that it's between 11 zeros. It's not like a double. It's 11 zeros. That means 1
1 million times, 1 billion times stronger.
Stupid, isn't it? Yeah.
Okay.
Container. So I'm trying. Oh my days! I remember fluid. I hate fluid dynamics. Oh.
That's okay.
Yeah.
We understand how gas acts, don't we? We understand that when we contain gas with a physical boundary, the consequence of that is gas pressure. To have gas pressure, you must have a physical boundary. To keep gas in a space, you must have containment. Gas will disperse high to low. This is why it's in the law of thermodynamics, because hot goes to cold.
Yep.
It doesn't happen the other way around. My coffee's not going to spontaneously get hot. Yeah, exactly.
Yeah.
And exactly the same in this situation. High pressure goes to low pressure every single goddamn motherfucking time. So when they tell us there's a space vacuum out there and the Earth is an open system, for those who have critical thought, you must understand that that situation can't be true. I don't care who says it, how many badges they've got, how big their institution is, and how many of them are jumping up and down on their bandstand saying this bollocks. If you critically think about it, you will understand that you can't have gas pressure without a container. Every single demonstration of gas pressure is with containment. You can't demonstrate this in any other way. Therefore, that
Yeah, I'm just
probably at work or something, knowing him. If you're busy, my friend, good to meet you.
What up, Jedi?
What's up, Mayhem? How you doing, mate? We're just talking to Bush Baby at the moment. We've been talking for, say, maybe the last half an hour or so. We've just got up to, well, not just got up to, about 10 minutes ago, we got up to gas pressure without a container. And, yeah, we seem to have maybe reached a point where he's starting to think a little bit.
Okay.
Because he understands, he's a smart lad, right? He's a physics student. He's done all this type of stuff before. So we're talking about gas pressure without a container, and poof, he's gone quiet because he's trying to figure this shit out.
Yeah,
well,
no,
the practicality. Go on, Bush Baby.
No, I was gonna say because there is actually a point there.
The practicality should strike you, as in, it should cause you to pause a little bit, because if there's a narrative that says one thing and reality says another, then you should go with what reality is telling you. Because it doesn't matter what anyone says; it only matters what the truth is, right? So,
yeah,
the fundamental laws of our nature is what's going to govern. You should govern what your understanding should be, not what people are saying.
Yeah, I really want to do math right now, but I don't know.
Yeah, you go on.
Sorry, no, I was just the only real because obviously the point with containers and gas,
right?
That there is a point there.
Well, you can't have gas pressure without a container. It's a necessary antecedent. So, in order for their gas pressure to be there in the first place, you'd need to have a container. It needs to be contained. That's how you attain pressure in the first place. Containment.
Yeah.
And that's natural law. And of course, entropy would dictate that if you release the pressure from that container, gas will disperse into any and all available volumes and fill the space.
Mm-hmm. Yeah.
But that's I mean, it's almost common sense. Everybody on Earth can know that. Or it should be anyway. But it also, demonstration-wise, that can also be shown as well. So what we're saying can be followed up by demonstration. It can be falsified. It could be proven empirically. So there's no need for whether you and I believe in something or not. It just matters that it's true.
Have you heard of bromine? Or bromine, as in the BR2, the gas, heavy gas, very heavy gas.
It's a man-made gas. Yeah.
Well, it's an element. It's how bromine exists elementally.
Oh, bromine. But yeah, like you meant like go on.
Well, it's a gas, and if you open a container, it will stay at the bottom of the container. It will sink to the bottom of the container.
How long will it stay there for? Will you be able to have an open container of bromine forever? Or will entropy still take? Yeah, entropy will still take.
Sure.
Yeah.
The gradient.
So we have the same kind. We have the same kind of thing with sulfur hexafluoride. You understand that one?
Yeah.
So it will stay in an environment that is open to the atmospheric pressure for a short amount of time, but ultimately, in the end, entropy will take effect, and it will disperse.
Yeah.
Again, all we're doing is demonstrating that one dense gas, in relation to the atmospheric pressure, will do something, will sink because it is of a higher density. Whoop-de-fucking-do. Let's put that bromine or that sulfur hexafluoride adjacent to a vacuum without a physical barrier and see what happens. Oh, it will disperse into that available space until it reaches the
that's the
limitation of its environment. Going to have the same result.
Mm-hmm.
Yeah, I know. I know, mate. I know.
Look at that. Oh, this is actually really annoying now.
This is what?
I said it's really annoying now.
Oh, why? Why is it annoying?
Mm-hmm. I can feel it.
I haven't ever thought about
but like, hats off to you, mate. Usually at this time we're having massive arguments with people.
Well, you got a beat on this because I mean, if you're in physics, then you literally work with these elements.
Yep. Fluid dynamics.
Well, that's the thing, though. Nothing that we're saying is like it's something that you could say. No, you guys are going against like the laws of nature. You're just that's not what happens.
Yeah.
So basically, we're just keeping in line with what everything could be discovered, like what we already know. But it's weird that we're saying things against. It's contradictory to what they're saying about the globe, because in this open system that they claim with the globe, there is a vacuum of space, and so the vacuum, adjacent to this pressure air, is pressure. There has to, in order for the gas to have pressure, it needs to be contained. But you don't have containment in this open system because matter and energy can transfer in this open system of the globe Earth. Yeah. And that just can't happen when you have the dynamic system that we do have here with low and high pressures. You can't get these pressures if there isn't any containment. So it doesn't matter. Like, you can have a gradient pressure and it shifts. The dynamic system that we live in, these pressures are always interchanging, low pressure to high pressure, and weather systems happen and so on. But like, these are always mixing. They're always shifting, mixing. It's in constant motion. It's never something that's static. So the globe Earth has tried to give you explanations as to how things are, but when you start to like say, okay, that's an explanation, now let's go into the field and test to see if what you're saying is correct. Nobody's actually put them to the test, which is what we're doing here. We're saying, has anybody ever done that? Like, it's nice to say one thing about the Earth being a globe and it's got a vacuum of space out there and you got pressure air here and it's an open system. But the convenient excuse is gravity, the bending and warping of the fabric of space and time. They're saying that's what's holding the gas here, right? Gravity. But then again, it's like, well, then you're going to have to say, when does gravity hold any of the pressure of gases? Which every instance, even the one you described with bromine, will seem to like have a heavier than air kind of dynamic within the air that it's in. But at some point, it will disperse. It doesn't stay. I mean, you can even see that with liquid water. So water itself will be sitting in a cup for a while, and then
that's very true. That's very true. It does actually.
I mean, and this is kind of like what we're trying to tell you here too. This is like, yes, they do have their physical properties, but they interact within the dynamic system that you're in to always be in motion. There's not a constant where it's like always a downward vector. Because if the downward vector were true, nothing would move into any and all directions, which is the nature of like gases dispersing into the available space. They would immediately, if you let go of the nozzle of a balloon, like when you blow up a balloon, if you let go of the nozzle, the air would just go straight down if gravity was holding everything down to itself. But you know that in every instance of containment with gas pressure, you open up a nozzle, the gas disperses into the available space into any and all directions, all vectors. So there's no vector of down. It just it does go down, but it goes up and sideways in every which way. And so this is just a practical means of looking at the applications that you use, like in your line of work or whatever you're going to be using for your studies. It's like, we're not saying anything outside of real science, right? So if we are, then there's an issue with what we're saying, but there isn't. We're in line with everything that natural laws dictate.
Yeah.
So hopefully that, like what Chris was saying, Jedi is kind of helping you along. But it's not that you didn't know. It's just it's the indoctrination. It's what it is. You have this like educated idea of what people have been saying all along about the globe Earth. We all have, and it seems kind of like very strange that somebody would go against that narrative. And the reason why we stand against it is because it's not what reality dictates. Reality is that it's a flat and stationary Earth that presents itself to you, me, and everybody else.
Yeah.
And to say otherwise would be a grand claim that is unsubstantiated. And we're always asking, okay, if you have the evidence that the Earth is physically a globe by way of demonstration, go ahead and provide the evidence to us. I mean, if you're standing on a geometric shape, then that needs to be proven. If gas pressure is held down by gravity without containment, that needs to be proven. If the Earth is in motion some way and we can detect it, that needs to be proven.
Yeah.
We can go a little bit deeper, but like these are the grand claims that the Earth, or the people that would say the Earth's a globe. It doesn't matter who's saying it, whether it be a professor, your next door neighbor, your parents, like nobody's rivaled it. Everybody gets scared when we start talking about it. They get angry. Let's not talk about that. We already knew a long time ago the Earth's a globe. 2,000 years ago even.
Oh, that's a stupid argument. You can never use that as an argument.
No, that's what everybody's claiming right now. Foregone conclusion.
Yeah.
And you can look into that, Bush, if you don't believe us. If somebody proved that anytime in human history, and you can look into that and you will find out that nobody proved that anytime.
Yeah.
But it's hard because if you're in academia right now, you're going to find out really quickly, Bush baby, that you can't stray away from the paradigm that's already created. If you want to play ball with them, if you want to have a career, if you want to continue to work with within the scope of the realm of like what they want you to be in, like that's what you're choosing is your passion. If you stray away and you say anything outside of that, the thing that maybe you don't know at the moment, but perhaps you do, I don't know, is that if you start to think critically, then you're going to be outside of the curriculum, outside of the paradigm. And they're not going to like that very much. So this is why we're saying this is something you should weigh considerably if you're going to be staying in the field that you are, because I mean, a lot of people, a lot of good scientists might lose their jobs if they would say the truth. They would speak truth, which is like what it should be, right? Like you guys should stand up for truth, working in the fields that you do. But I mean, if you want a livelihood, count the cost, I guess. I don't know. Like, it's a tough deal, man. I guess if you, because it's like, well, stay in a really great career or speak the truth. You know, like, I mean, I wish it could be both, but I don't know if that's the world we live in.
Yeah, pretty hard to get that research grant renewed if you're going against the status quo.
Yeah. Yeah, no, you raised some good points. Definitely.
Either that or just stay a closet flat earther for the rest of your life. You know?
Don't be flat earther ever.
No, I'm. No,
let's.
Do you know what?
Let's see if we.
One thing is that you can be very respectful. That's for sure. I was actually surprised.
Try our best.
No, I was surprised that you, because the representation that you guys get online is that you're angry, delusional.
We can be, but not delusional.
Gotcha.
Well, we can be angry. It's more of a zeal, a passion for what we're talking about. Because imagine speaking to somebody about, your field, physics, right? Something that can be demonstratively true. That there is no, like, if you say that you're wrong by proving something that you're actually doing, then people are just batshit crazy because you're demonstrating to them in reality what's going on with physics, right? Like you're not just, there's not a theory, that you're working with tangible things. So if you're speaking about something that you've done with demonstration of, and you've maybe written a paper on it or something, you can demonstrate to someone how something works. That's the lunacy of somebody denying that is probably the same as what is happening in here, which is probably why we get the rep we do, because the delusion is actually on their side. They want to stay to the delusion of the globe. It's like it's a lot more fantasy than it is reality. So, and that's kind of the zeal that we have. But go ahead, Sasha.
We are grow up like that. I grow up like that. I grow up like this. It's obvious. It's a fact that Earth is sphere. That's my position. Without any knowledge about that, that was my position.
I'll tell you what, guys. Let's try and move this on a little bit further.
I mean, I don't have much time here. I've got to go in 5 minutes, 5 minutes. But I mean, yeah,
not a problem. I was just going to ask you a couple of questions, mate, and hopefully it won't take too long. I just want you to be honest with your answer, okay? If you know, then please, I'm going to ask you for verification of how you know it. If you don't know it, then just let me know.
Yeah, sure.
Obviously, we're talking about the shape of the Earth, my friend. So, just going to ask you: do you know at any point in history how the measurement of the curvature of the Earth was done and proven to be so?
Not the measurement itself. No, sorry, I don't.
No, okay. But would you say it might be a belief that somebody has done this, you just don't know how?
I mean, I guess so, yeah.
Cool, awesome stuff. Second question. Kind of the same thing, but with regards to the motion of the Earth, the actual spin and its orbit around the Sun. Do you know in any point in history how the motion of the Earth was measured and detected?
I think its spin can be picked up with a gyroscope.
You think? It's like first-hand knowledge you can give me all the ins and outs, or you just got a vague recollection of it?
Vague recollection, I guess, yeah.
Okay, cool. But would you say it's probably a belief that you've got it might have been done somehow with a gyroscope, but you're not sure how?
Yeah.
Okay. The third question I'm not necessarily going to go into because we've kind of covered it for the last 10 minutes, but I'll ask you anyway. Do you know any way that you can demonstrate gas pressure without a physical barrier for the gas to press upon?
Nope.
No. See, those are the three main claims that they make about the Earth. They say that the Earth is a ball with a known radius, diameter, and circumference, and this ball, Earth, spins upon its axis and travels around the Sun. and it does this within the vacuum of space.
Right.
Now, all you've done really, to me, mate, is kind of, you've been honest, and you've kind of just elucidated that it's more of a belief that you've got. It's most definitely not first-hand knowledge, is it? You don't know this first-hand. You just believe it, don't you?
I guess so, yeah.
Yeah, that's the honest answer, mate. And to be honest with you, it's the only answer anybody can give us. We only believe that we're on a spinning ball in space because somebody's told us possibly somehow that it's been done. We don't know it firsthand. For example, we don't feel any motion of the Earth now, do we?
No, but that can be explained.
Yeah, but that can be explained. But first-hand knowledge, we don't feel any motion of the Earth.
No, we don't, but that's because the Earth is moving at a constant velocity. I mean, I can explain that, actually.
It's not.
I mean, well, if you're talking, well, it's also change in velocity over time. If the time is very small and the change in velocity is tiny, the force you're going to experience is so small that you're not going to be able to, you will not be able to feel it.
Awesome. So what you're doing is you're giving me an explanation as to why we don't feel the motion of the Earth. You're not telling me how it's actually measured or that you actually feel it, right? You just give me an explanation, ad hoc one.
Well, so you can measure the force that an object experiences based on its change in momentum, and that's something that you can definitely measure for objects on the Earth, a car or whatever, plane or whatever. And if you apply that to the Earth, then if you apply that to the size of the Earth, then and you apply the same principle, then you would be able to explain why the Earth isn't.
Remember the second question that he asked you, Bush Baby?
Sorry, what? Repeat.
The second question that he asked you was about the Earth's motion.
Yeah.
And what was your answer?
I can't even remember what the question is. Sorry, I'm really tired. Carry on. Can you please repeat the question?
Yeah. He was asking you the question about the Earth's motion. So axial rotation, the Earth spinning on its axis, and its motion around the sun. Like there's different motions that he was referring to. So
yeah, I mean, in terms of is the Earth actually spinning? Then because you don't experience a force, that doesn't prove that the Earth is spinning. So I agree with what you're saying. Yeah, you can't know that the Earth is physically spinning. But the fact that if the Earth was spinning, you'd also not feel a force. I mean, it's.
But that you're telling me what it's not doing. I want to know.
Yeah, no, exactly. That's what I'm saying.
Well, so the second question was actually geared towards what your knowledge base is on its actual motion. Like, how do we know that it has been detected that it's in motion, and what I don't know, apparatus or device has been used to measure this, or can we know? And so the answer there was that you don't know.
No.
Right, and so that's the issue. The issue is that people that want to look at this logically and be able to detect physically if there's any motion, it's not able to be detected in any way, shape, or form by a device or an apparatus that can do this. Okay. But as far as ideas go, theories, I mean, that's anybody can come up with those things.
Yeah. So, I will go in right now, but
yeah,
I was just speaking to you guys.
That's fine. All right.
At another point. All right,
yeah, no problem. Thanks for stopping by, Bush Baby.
Right.
What up? What up? How y'all doing? John Navornik.
Hello, how are you?
Doing great, John. You're VC verified? Have you been in here for quite a bit, or?
First time I was here, I think it's about 3 years ago. I don't want to lie.
Okay. Well, what is your position on the topic of the shape of the Earth?
Well, I certainly don't believe that it's ball.
Okay.
And I'm preferring the flat curvature, the flat non-curvature.
Okay. Yeah, I'm asking around, see what you think because you're VC verified. Okay. Yeah. But we were talking with the gentleman, Bush Baby. It sounds like he was in college and studying physics. So.
Well, I have PhD in my chat right now. I told him that he can ask any question, but he didn't post any question yet. So let's wait. I was explaining to him that you were talking about the impossibility of having an atmosphere next to vacuum of the space. And I think he got a little bit startled, so I'll wait for him if he has any questions.
Gas pressure will do that to people, won't it, Miggy?
Yeah, usually. Well, gas pressure, but like I think he ran through the 3 questions pretty quickly without even thinking about it, because afterwards he started to kind of get a little pushback on the axial rotation side of it, like the motion of the Earth, because he got into his explanation mode where his brain was like, oh, I remember this. So he started to talk about his explanation as to how we wouldn't be able to feel the motion of the Earth. And it's like, but you're telling me what I can't feel. I want to know how I can feel it. That needs to be understood, right? Because if somebody's telling me what you can't feel, it's like, I mean, you could come up with it's like a train on a smooth track. It's like a car on a smooth road. Like, you could use all kinds of analogies that are not analogous to the idea that we're on Earth. Because every instance of me using an analogy, it's me entering a vehicle. And this thing we're on is not a vehicle, because you have to provide the idea. It's a begging the question fallacy. How do you know it's a vehicle? You have to first enter the thing to know that it is. Did we enter the Earth somehow? Did we open the door and shut it? Like, are we inside of something? Like, they're telling you you're in a vehicle. Well, they're going to have to prove that it's a vehicle first before they make it analogous like a vehicle. Well, it's like a train. Well, no. I always said this in the beginning. It's like, people want to let them have their analogy. I don't. I'm like, you can't let them have not even an inch in these arguments. The moment you do, they start to go into their like fantasy realm where all things can happen. It's like a train. It's like a plane. No, it's really like a car. It's on a smooth road. But I'm like, yeah, the analogy doesn't fit when you're talking about the thing that we're on right now.
Yeah, even the claim itself is wrong in the mainstream model, because Earth revolution around the sun isn't a circular orbit.
It's not circular either. Yeah,
it's elliptical. So his analogy of we wouldn't feel it anyway is not applicable.
Yeah, the idea of speed not being felt, I could understand that point, but acceleration is. You can feel that. And deceleration. So you'd be able to, because if it's on that path, then it would speed up and slow down as it's going around in that path that it is.
Exactly.
But that's what we're talking about. Like,
go on.
I don't want to bring that up with him here, but
yeah, I love all this shit. I'm just listening.
But there's too much to actually, like, we've been through these arguments, well, explanations, discussions. We've been through them so many times. Like, we know the ins and outs and how they want to think about their explanations and use them, because their mind enters into a state of cognitive dissonance. So when Jedi ran through the questions, he was unaware that he was already giving up the idea that he's believing. He's just like on a belief system. Afterwards, he was like, wait a minute, I have an explanation for the axial rotation. Mm-hmm. And it's like, and then he started to believe himself. He was like, well, yeah, you wouldn't feel it. It's like, we're not talking about what you don't feel. Like, we're talking about what you can feel and detect. And then apply that to like how we know that it's been detected. And this is where the globe earther always like they're hung up on this idea that they've been told it's like a train, it's like a car, you just can't feel it. It's like, well, that's very contradictory to like them discovering that it's in motion. Because obviously somebody somewhere said the idea that no, Earth's like it's spinning on its axis. Oh, how did they figure that out? Who's the first person to measure? Or was it just some crazy kook's idea that just came up with it like, well, Earth's in motion, guys, believe me. And everybody's like, well, you sound sincere, so I guess so. Well, what's the deal there, you know? Nobody ever like stopped to say like, wait a minute, how'd you come up with this? Like, you know, like how did that happen? And why does everybody now just believe that it's spinning? Do you know what I mean, guys? Like, okay, Foucault's pendulum. You can say whatever you want. You can use whatever device, whatever. Doesn't matter. But where was the critical thinking that fell apart in those? Like, who was the bully that says, "No, you're gonna believe me"? And then we're like, okay, like what? You know what I mean? Like, where was the caving into this knowledge? Like, I don't know. I guess that's the way that you have to get people when they're very young, they're very impressionable, and make them believe something, and then with that belief system, you shame them into believing. Oh, you want to believe that Earth's flat and it's not moving? You're so dumb. It was like back in the caveman days when everybody's dragging their knuckles. Like, yeah, you just want to live like that. It's like people are just scared of being shamed into it. And even more so today, because look at the way the society is today. Nobody wants to ask questions. They come in here. They're so timid and afraid. We have to create a safe space for everybody. It's like, it's crazy, man. Like, but that's what we're dealing with. So unless we have this place kind of like everybody's, you know, harmonious, we're all talking nice, and then people aren't just gonna, they won't, you know, nobody wants to debate. Nobody wants to really get into the thick of it and be like, well, why do I think this? And we're like, because, man, you've been fooled, you know, like nothing like that. So I don't know.
Sorry, Miggy. I enjoyed that conversation with that gentleman, Bush Baby. He came in first of all, let's put it like this. His timbre and his cadence were really, really fast. Right? It was kind of, you know, flat Earth was ridiculous-ish. I'm a physics student. I've done a laser test over water, measure curvature of the Earth. That's where he came in at. So he was kind of full of bluster and gusto right at the beginning. We had a conversation about 10 minutes, you know, why do you think the Earth is flat, measurements, long distance, you know, blah, 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 blah. And then he wanted to know what gravity was and how we would explain it. We had a bit of a back and forth with a couple of other guys. Sasha jumped in as well, talking about gravity. I think somebody else jumped in saying that you can't have both Newton and Einstein's model together, which was quite good. And then he jumped into a vacuum chamber. From that moment onwards, mate, I had him. And the difference in the way that he came in to that moment there where we started talking about gas and entropy was palpable. He slowed down. I think I even heard the penny drop. For me, mate, and you know how much I enjoy doing this. For me, that was a total pleasure because I stopped a guy from going 100 miles an hour to walking pace and stopping. That was brilliant for me. I hope everybody else got as much out of that conversation as I did. Because for me, it's one of the main reasons why I'm here.
When did it happen? Half an hour ago.
Those people at 100 mile an hour.
Yeah, he just left, Indio.
Oh, okay. Then I'll pull it off the stream.
Yeah, you could probably capture it.
I want to know more about this laser test that he never did.
Yeah. Yeah. He never brought that up. We never got to that.
Oh, man.
I mean, he said it, but we never got the distance. We never got the laser. We never got the heights. We didn't get anything.
Oh, my God.
Bush Baby One's his name.
Bush Baby One. Yeah. That sounds familiar.
Yeah, just rewind the stream. You'll hear. I came in towards the end of him.
No, that's fine, buddy. I mean, Miggy, you and I have worked together for 4 and 5 years. You would appreciate that. I think if you heard the whole conversation, mate, you would appreciate it. I've just been pinged in the live stream. Sorry, buddy. Thank you for that. Yeah. I've just been pinged in the live stream from Jan as well. He's been very patient. He didn't want to interrupt and cut off our conversation, but he did have some questions from his PhD friend. So, Jan, are you still there?
Yeah, I'm here.
Awesome stuff, mate. Thank you for being patient. I really do appreciate that. What are your questions, mate?
Well, you need to understand that he doesn't really know anything about the flat Earth, so those are pretty basic questions. But I just told him that he can ask whatever he wants. So the first question is, what's on the other side of the flat Earth?
What is his PhD in?
He's not physics PhD. He's chemistry PhD. I just wanted to say that he's PhD because even if he's smart, he can. If your worldview is completely different from the reality, you can have basic questions that flat earthers will consider stupid.
Yeah, John, can you do me a favor before anybody? Could he come in here? Yeah, I mean, or you know what? Anybody who has any questions, like your friends, can you give them a link to the Discord, or even just encourage them to come in here? Because we could answer them directly, and I think they would appreciate that.
Okay, no problem.
Way better.
That question is just so like, it's like a fifth grader question to me. When I hear like somebody ask that, I think this is a child. Like, does he think we think the Earth is a disk in space? And that there's like some other side, like the Earth is a record?
$1 to donuts, man. I bet you that's what he's thinking.
It's a freaking coin or a pizza or something like that.
Yeah, you are exactly right, because he told me. So does it look like a hockey puck or some?
Yeah, the paradigm in which he's operating in right now is still the vacuum of space, but we're just a disk instead of it being a globe. So he still thinks the cosmos are unchanged. The only thing that's changed is the Earth that we're talking about, and it's even worse than that. It's the entire cosmology, the whole thing. So it's not even just Earth; it's the entire cosmology.
So we should have faith in how PhDs think, huh? Okay.
Well, I mean, critical thinking is not their forte. It seems it's just like memorization and regurgitation.
Well, to be honest,
go ahead.
I expected some deeper cuts question, but he proposed 3 questions. The first one was if what's on the other side of the Earth. The second was if the sun is smaller than the Earth, and the third one was where does the heat came from on the Earth? When you have the geysers in the deep oceans that are hot, where does it come from, the heat? But I don't think if we are honest, we can't answer any of those questions. Just the best answer is we don't know.
Yeah,
geothermal heat, is that what he's?
Yeah. He was asking about thermal heat.
Yeah, I mean, nobody can truly answer that. What causes the heat of, lava?
Yeah, the source is
hot springs. Like, how would we know?
Well, that's what I told him. I just
I always use this as an example. The Hawaiian Islands. The Hawaiian Islands are a volcano. They're not on any plate. They're not on a tectonic plate. They're not on like the edge of a plate. What makes the lava in the Hawaiian Islands?
Nobody knows, honestly, I think.
No. You want to know what they told me when I was a kid? They said, well, there's a radioactive material underneath that's melting the crust.
No way.
Hell, bro?
Yeah, that's
really?
I'm dead serious. That's what they said when I was a kid, when I was like in 3rd or 4th grade.
Man, where did you go to school at? Talk to your...
Well, I had stupid things in school as well, so no problem.
It's probably just the teachers making up something in their head,
I think we all had something like that.
Yeah.
The point is like no one knows. That's really the point. What's the third question?
Well, the third question was about the thermal heat that comes from inside the Earth.
Right.
The second was if the sun is smaller than the Earth.
Well, that's.
He posed 3 questions that nobody really knows the answers. So.
Yeah, let's get to the unattainable. But because you know why? Because the paradigm of the globe Earth has explanations.
Yeah.
And so if somebody says something like, if let's say Flat Earth was to come up with explanations, then we have our explanations pitted against their explanations. But when are we going to find the verification for those explanations? Who's going to go verify if the sun is 93 million miles away or close and local? Who's going to be able to see a measured distance between those two, a known measured distance? Like, how are we going to know that it's falsifiable? It's not ever going to be. Two people are going to have ideas and they're going to argue till their cows come home. Like, 'cause there's nobody that's going to be right in those conversations. Everybody's right.
Yeah, you can argue forever, and you don't really will get any reasonable answer.
It's mental masturbation. That's what it boils down to. People whacking themselves off to like what sounds better, and it's stupid. Because I'm always like, okay, that's great. Flat Earthers came up with a great idea. It's 3,000 miles up. Good job. Now, how are you going to verify that shit? You going to do that? No, you can't. No, neither can you verify it's 93 million miles away. So no kind of theory or idea or stupid way of you saying this is going to make it true. So, and it just pisses me off because it's like, yeah, you can continue to make up any idea you want, and it's just going to sound as dumb as ever because, you know, no one's going to be able to verify these things. But we got what we got. And, you know, like at the beginning of when this came out on the internet, everybody was quick to come up with like the outer pond theory, like freaking, I mean, you name it. Flat Earth was coming up with it because they wanted a response to explanations. Like, how are we going to say, dudes? Because we're saying we don't know how far the sun is, so we got to say something. Well, it's close and local. We can say that, right? It's like, it's a false dichotomy, man. You're saying it's close. I don't know. It's just other shit. But
yeah, dude. It's like they're selling Diet Coke. We need a different drink. We need to sell Diet Pepsi. Like, no.
They don't like the response that falsification is independent of replacement, and they're looking for you to replace their story.
Yeah, exactly.
And oh boy, we got, and you know, people getting hot water with that shit too, man. It's like, you know, we started talking about like, what was it, Jedi? Remember as the higher you go in elevation, the different voltage that it goes into, and then some guy named MacGyver came in and was talking because he's like, what field did he work in? Jedi? Was he an electrician of some kind? Like he works in some sort of field where he's like, that's not true. And we're like, well, as far as we know, that's what we've been. We weren't hung up on it. It's just people were saying that as you go up in elevation, it raises in voltage, and it's like we thought it was static. That's you know, as you climb in elevation, that's static. It's going to remain going higher and higher in voltage, but it's not. It's dynamic and it shifts and it changes and it even goes negative. So it does not always stay positive like in voltage. I didn't know that shit, but it's like, has anybody ever like challenged that? So there's a lot of things that are gone unchallenged. Nobody's like verifying to see if this is true or not. So that's all I'm saying. It's like until people have these demonstrations and you know, falsification of it, then we're just led to believe whatever people's ideas are, explanations and so forth.
I agree. We learned so much, but we don't really know any of it if it's true.
Yeah, it's all theoretical, dude. Like, so the thermal heat that's coming from the Earth, you can come up with like, well, it's not the core of the Earth that's heating that. It could be like, you know, freaking orgs down there shoveling, you know, coal in a furnace, or you know what I mean? Like,
you can say
whatever you want.
It's the Balrog.
It's freaking Smaug is down under the dragon, you know, that protects the gold in Middle Earth. Like he's, I don't know. You can say whatever you want. Like,
well, the friend that I was who posed the questions, we were on holiday at Corsica. We were on the beach and we saw 3 islands. I wasn't flat earther back then. Well, we say, this is St. Helena, this is this island, this is this island. Well, then when I realized that the world is not a giant ball flying through nothing, I just go to the Google Maps. I find out how far those islands are, and there's no way we can see them if the world is a giant ball, because they will be behind the curvature. Yet we see 3 islands right in front of us.
There they are, and they're not loomed up over the curve. You're actually seeing the islands themselves.
Yep. So
he saw them as well.
So sad about geometry itself debunking the globe. Too bad they gave us geometry to work with. They should have kept that secret too.
They should have said, "Well, it's ambiguous. But we really don't know the size of the Earth." If they kept it that way, people would have still been guessing as to like, well, it could be a globe. Like,
Mm-hmm.
Oh, hold on. Wait, I gotta be a little bit of a contrarian to that. I think if they did that, people would be it would arise too much suspicion.
Yeah. That's a valid point.
Yeah, we got what we got then. I mean, we got them claiming that the size is a certain size. So
I actually, honestly, I think it's rather clever. The number that they gave, 3,959 miles. I think it's a clever number. I think that if they were any smaller, they'd have a problem. If they were very much bigger, they'd have a problem. I think they were very clever.
Here's how. As a glober, here's what I used to do to try to tout my knowledge of the globe. I used to tell people, "Do you know why the Earth is Well, let me see. The Earth is 8,000 miles in diameter. That makes a 24,000 mile circumference, a 24-hour day traveling at 1,000 miles per hour. 24 hours.
Yeah, you could find the ground speed on timeanddate.com for the sun's ground speed. It's traveling like at 980 miles per hour. It varies, but yeah, go to timeanddate.com. It'll tell you the sun's ground speed.
I never did that part. Wow.
Yeah, it shows the ground speed on whatever location on the Earth you are. It'll tell you the ground speed of the sun. Like it's traveling at close to about 1,000 miles an hour, which is close to what they say that it's going around the equator at.
That's funny how they match everything up, right? To just go along with their model. And of course, the globe works perfectly well inside of this fallacious model. Like it actually works. It actually works inside the model, but not in reality. That's
not in reality. Yeah. The values that they're giving the predictability about it is done with their reverse engineering of our reality. So they're just taking stuff that is well known, like that you see predictable in the heavens, and then using that and wrapping it or superimposing the globe idea around that.
What they do is it's a post-diction. They take the things we know and the things we see, and then they just reverse engineered a model that doesn't match reality. It's not that hard to do.
Geometrically, it's not doesn't line up. But but with them making the claims that let's say the sun is traveling at whatever speed, it lines up with certain visuals that people have. So in a way, it makes it believable, right? More believable than just, that's how the idea of, like, let's say the sun moving east to west on the equinox and so forth, like you could witness that. So they would say that's happening on a globe. And then you're like, well, yeah, I see sun moving east to west on the equinox, and sure enough, it's a globe. So they don't question the authority because some of what they're saying is partially true. But then it lines up with like what the superimposing of the globe Earth is, so makes it believable. That's why when people say the star trails, like they're spinning clockwise and anti-clockwise, that can only happen on a globe, is what they say. It's because that's how they're being told. That's can only happen on the globe.
I just posted in the live stream voice text 2 long distance observations from Corsica and to Corsica. Just Jan was talking about it, so I know that particular area of the world, there is a lot of long distance observations. A lot. That's in the area of Canagoo and all that. And the only reason, well, let me tell you what the reason that is because there's a little group that made this Beyond Horizons website, and that's what they do. They go out and they make long distance observations. So they've made it like, something like their hobby. There's like 4 or 5 of them, and over the period of, I think they started back in 2014, they've got hundreds of globe busting observations. And they're just apparently all mirages. Every single one of them.
India from Bastia. Is that where they're making their observation from Bastia?
Yeah, Bastia, Corsica to Appen Mines, which is a bunch of mountains.
So from Bastia, you could see any one of those. Like, let's say if you're panning across the way, you could see any like. I'm looking at the places here: Livorno,
So I just posted the image.
Rosiganano, like all these other places. Could you see anything else, or is it the only thing they'd see the 172 kilometer?
Well, I mean, I don't know. I mean,
could you pan across like the way and
these
see
mountains
more?
are all. This is supposed to be 20 meters of the mountain. You do the curve calculator, comes out that this should be 20 meters, which is like a couple. What is that? 100 feet? Not even 100 feet. 80 feet. If you think this is 80 feet of the mountain, you're on drugs. So like the farthest distance says this peak is 1765 meters. 1726 meters is supposed to be hidden. So that's like 30 meters. So 100 feet, basically.
That's 100 miles away, dude.
Yeah, I know.
100 freaking miles.
The horizon here is supposed to be just 12 miles away.
And you could see a lot of that mountain too. So it's Monte Pagna. You could see a lot of it. I'd say most of it actually.
This is probably at least 50% of the mountain.
I'd say. And that one's 165 kilometers, so it's roughly about 100 miles away.
But we're supposed to believe that this is an optical illusion, and every image that sees too far is an optical illusion. Is that we're just running around in a hologram? Which so I want to actually play something. That was actually a pretty good segue to something I was planning on doing anyway. So this is pretty funny. I'm gonna play some audio in the bot. Give me a sec. It's not that long.
What you're seeing here is a mirage. We typically would not be able to see this from the Lake Michigan shore. We talked about this last night. Conditions are right on the lake that we're actually seeing a mirage of the Chicago skyline.
We've covered presupposed Earth radius, pressure without a container, angular resolution, perspective hijacking Earth curve. We've covered Boyle's law. We've covered diffraction limit. The one thing we haven't touched on was mirages. Give us the most ridiculous excuse of a mirage that you've had.
Well, the mirage is an interesting one because this is probably one of my favourite points to make as a flat earther, especially when someone says there's no proof of flat Earth. So I'll give you an example. We'll use Ranty and one of his images. So he has a picture of a clock tower at about 20 miles at Barrow-in-Furness, and it's just a picture of a clock. Now, as a flat earther, I look at this picture and say, clock at 20 miles. That's the end of my explanation. As a flat earther, I can make that statement. I'll say it again. Clock at 20 miles. Now, if you're a fundamentalist religious zealot, then that's not a clock at 20 miles. That would be a slightly looming, non-standard refraction hyena holographic projection of a clock from behind the reified edge of a sphere based on an R value and a begging the question proof of nothing perspective hijacking curve calculator to turn a clock which seems to be there into a clock which is not actually there. That's what you have to assert if you're a globehead. So it's not a clock, it's a holographic projection of a clock from behind the reified edge of an Earth curve based on a begging the question proof of nothing perspective hijacking curve calculator. As opposed to me, that's a globehead explanation. I say clock, 20 miles.
You're the man, Nath. You are the man. I love the way it's the way you it's the way you say it. It's the way you say it. It's just you serve people like the Wimbledon final beautifully. It's poetry in motion. It genuinely is.
It is.
That's soundbite classic.
Well, you haven't heard Indio.
Yeah, but I mean, like that's like thanks. But point is, that's how many variables that they have to throw into the mix, right? That's the soup that they have to make in order to claim that is just an illusion.
Dude, it's one hell of a gumbo. You can say that much. The shit they put into that. Reverse hyena, like, how did they come up with this shit? First of all, like, are they just making shit up? Like,
so simple, just to say, I see a clock, therefore it's there, right?
Well, yeah.
To word salad, right? To word salad to tell us that we're hallucinating, that that's not actually a clock. That's the image of a clock projected from around the geometric horizon that nobody can see, which is apparent in an apparent location, based upon the Earth curve calculator. They look at the Earth curve calculator and say, "Oh shit, you're not supposed to see that." There must be the horizon.
Yeah, old Haas Rathborn said it right. The sunk cost logical fallacy is a strong one. They got to, man. They're in it, They're in it to win it. So they gotta go hard or go home. So
were you here yesterday? Who was in here? I ended up banning him. He's such a because he was in my he decided he was going to hide in my DMs. EMBO.
Oh yeah, I was here. I thought he spiraled and then he left, but he actually you booted him.
No, he got sent to Cogdis, and then we were smacking him around at Cogdis, and then he went in my DMs, and then I was just like, after playing tennis with his denials.
He's another educated person, right? Or so-called educated?
Well, I don't know what he said. We understand refraction so well. We know exactly what it does. That's how we can make this claim. Then when you ask him, okay, how about some predictions that have happened, right? You understand it so well, you can make predictions, no problem. Couldn't even start. Immediately starts backpedaling to, well, it's variable and we don't know what's going on, but we know it's happening. We know for certain that it's uncertain.
You're like, you're not gonna bring that same energy when it's crunch time, baby. You're not gonna do it. And it's sure enough, man. As soon as you tell them, prove it. That's what I thought. You're all talk, right? When it was all about you saying that you can prove it, man. Like the guys that come in there, oh shit, tons of evidence. And then when it's like, okay, go ahead and tell us. Pick out one of that shit ton that you got. Bring it forward. Let's talk about it. Well, it's late. It's 2:00 in the morning. Oh, yeah, I thought so. I freaking thought so. Like all you guys, every single one of you all talk about there's so much evidence for the globe. You come in here, and when asked about it, you have nothing to say.
Yeah, another thing he was doing was when he was in here, and he was saying it in Cogdis, and he was saying it in my DMs, that the only way, it's impossible for something to be cut off, like a boat or a mountain or anything like that, to be cut off visually from the bottom unless it's obstructed by a physical object. He kept saying it over and over and over again. So then I show him the RC boats, first he tried to, it's not the scale. And if you actually do the scale is, if it was so it's an 8-inch boat 700 feet away. That's the scale of a 50-foot boat being 2,300 feet away, or 23,000 feet away, which is like 6 miles, right? For a 5-foot person. Basically, if you rescale it, right? Rescale the small miniature size to a large size. So that argument fails. So I show him the image with, this boat cut up, and he's like, well, that's a mirage. That's an inferior mirage. Like, okay. Welcome to Flat Earth, dude. Like, what are you telling me? You're saying the only way that this can appear this way is a mirage. And then he sent me, what did he send me? Oh, he sent me Soundly's, what do you call it? The drone video where he goes up, right? And you can't see the bottom, and then when you raise the drone, you can see the top. And he's like, well, this wouldn't happen. And literally in the video I sent them, they do the exact same thing. They take the camera, they pick it up, and all of a sudden you can see the bottom of the boat, right? And I said, so now just admit it. Just admit that this can happen on a flat surface, and things can appear cut off at the bottom on a flat surface. Just could not admit it. Even though he said that that's what's happening, but it's a mirage, as if the causal mechanism somehow makes it all better.
Yeah, but he just finished saying it was the Earth curve. That was the only way that could be obstructed.
That's what I'm talking about.
Now it's a mirage.
Yeah, and because it's a mirage, it still must be Earth curve.
Yeah, love it.
Yeah, I mean,
the thing I like though,
that's when I had it. That's when I had to ban him. I'm like, that's it. Like, I'm not dealing with an honest person. I mean, we already knew that, but whatever.
EMBO, yeah, he sounded a bit educated to me. If I would have probably pressed him, he would have. Because I wanted to know. I'm like, dude, did you have some credentials or something? Because I did want him to say. Because it's sweeter, dude, when they have these they're high standing in the academia. It's so much better. Oh, just like it feels great, man.
Did,
like,
quite honestly,
because he kind of like sounded a little bit in the beginning.
I think he was. He has a PhD in anti-flat earther.
An anti-flat.
He has a PhD in anti-flat earth, and that's it. He didn't actually know how like any of this stuff actually worked. Because if you were in here, I asked him. I'm like, okay, so how does angular resolution work? Why did 2 points of light appear to be as one? He didn't know why, and it's because of wave interference. It's because they get too close together, and the light from the waves of light from each dot interfere with each other, so that they appear as 1 point. That's the technical reason, right? But he didn't know that. But he knew the fraction limit. But when asked what causes the fraction limit, he doesn't know, which means he's just parroting it from somebody else. You know what I mean? Like a PhD in anti-flat earther. He freaking watched all the MC Toon videos, watched all Professor Phil videos, watched all the Fight the Flat Earth videos, and yada, 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 right? All the characters.
So he was gassed up, basically, coming in here just full of all this nonsense.
Probably had notes.
Nonsense. Yeah, I mean, they think they know how to defeat the argument. They're going to run circles around us with their educated minds, and when it comes down to like, it's really simple to knock them down. It's like, okay, what you're saying, prove it, because you said it's an obstruction due to the Earth's curvature. Now you're saying it's not an obstruction. The obstruction that you're seeing is actually a mirage. That it isn't the physical Earth curvature in the way. It's the mirage effect that's in the like distorting the image so you can't see it.
All it takes is if you have a marine layer that's like, say, 2 meters high. It's just a layer of air where the light that's beyond it can't penetrate through it. And there's actual physics explanation to this. It's called total internal reflection. And even Danny has it on his website, though he's using it in a different context. So it's a recognized, known phenomenon. So say you have a 2 meter layer.
Mm-hmm.
If and it's like let's just call it 6 kilometers away. 60 kilometers away, 2 meters is going to block 20 meters, which is hundreds of feet. Because it's the air that the light's not coming through. It's not a physical obstruction. It's just because the air goes into this, the light goes into this and just doesn't come out. It can't come out to get to the camera. It's like a duct or like a fiber optic cable. You know what I mean?
It's also dealing with the angle, right? Like the angle of view that you're seeing from the observer height. Like that also plays a great factor in like the things we see in the far distance.
Exactly.
Along with that. So
and that's how
like
total internal reflection works. There's a critical angle. There's a critical angle that, like, even if it's more dense, right? So that you have light in a more dense medium, right? So whatever's closest to the water is going to be in the least dense medium. It will reflect off a less dense medium if that angle is beyond the critical angle. And if you do the math, you do it all out, it's the same thing, right? It's a 0.02 degrees at the horizon. Like, it's just another one of these weird coincidences where all the globe math lines up with flat Earth, and flat Earth lines up with the globe math. Like with the location of the horizon and where this obstruction should be and where this critical angle is.
Right.
So, like, the critical angle for like a temperature gradient of one degree per meter is 89.98 degrees. Which which the remainder 0.02 degrees. That's the angle you're going to be looking at. Because it's a total of 90 degrees if you're, perpendicular to the ground.
Well, they're not talking about that. They don't. Well, rather they don't know that information because they're looking at disinformation videos that speak against. They're anti-flat Earth propagandists that put this information out to speak against what we have to say, and then they're getting it wrong too. There's like they're making shit up. They're not even lining up with mainstream rhetoric because if they did, they would have known exactly what you've been talking about. He would have said something close to it anyway. But he didn't even know. So it just shows you.
I don't, like none of these anti-flat earthers have any actual credentials. I think the exception would be Danny, right?
Yeah,
and Matt. The rest are they're wannabes.
Perhaps.
No.
Well, I'm saying because
MC Tune and Fight the Flat Earther aren't wannabes. Come on.
But I want to let them keep their credentials because it just makes it that much. Like I said, it's sweeter that way because it's like they're talking utter shite, and then they're in here. Well, they're not in here, but they're in the conversation, and like Tartaria server, touting their knowledge as in, they know what's going on, but nobody ever holds them to a standard, and I think that's the issue. Because they're in other forums where nobody's going to hold them to a standard. It's like they have their own. They want to have a moderator stance so they can get away with this shit, and they're not going to get away with it here. And I think that's the problem.
Hey, Jan has another question. Go ahead, Jan.
Yeah, so my friend is asking, and as I said, you heard it 1,000 times before.
Where's the edge?
No, something similar. Why does it matter that the shape of the Earth? Why does it matter?
Well, I always reverse that, right? Why is it important to them?
It's pretty.
It's like we're not the ones. Listen, we don't go around and go on TV and go all over the internet and spam flat Earth, right? When I turn on the news, they don't show flat Earth, right? They show a globe spinning behind the newscaster's head. Listen, there's literally an electric company. They're electrical company. They're electricians. They go around. They wire electricity in your house. They're called Global Electric. They got a globe on their house, on their front door. Why? They're only in Cambridge. They're not like all over the world. They're only in Cambridge, but they're Global Electric. So like it's important to them. They spread it everywhere. If I type in,
Max,
you're hot, Mike. You're hot, Mike. Max.
Yeah, that's me. I'm sorry.
All right. Anyway, so it's important to them. It's like, why is it important to them that they spam space at us? I go on Netflix. The top 10 videos that have been shown, 8 of them are space movies, right? Like it's a. And then if you look at the relative importance to the everyday life of space, outer space, spacemen, satellites, all this shit. It has no importance. The number of astronauts that they claim exist, 600. 600 of any people in a world of 8 billion people. That's not a very important job, right? But they're everywhere. So, like, why is it important to them that they shove this globe idea down our throats?
I have an answer. I will text him that.
Oh well, but if also they're trying to look at, like, from our perspective, this is our home. This is the place where we're standing on. If they're telling us it's something that it's not, and we're believing them, then they're obviously lying to us and everybody. So if we can stand on something that they're claiming is something else, and we can see that it's not what they're saying, then wouldn't they want to know? Like, because obviously it's like they have the Earth is standing right under their feet. All they have to do is investigate it. There's, like, if they really want to, right? So this place that we're on, this is our home. So if somebody's telling your home is something else that it's not, wouldn't they be curious to know that it's not what everybody's saying? I could tell them that it's a spaceship flying through the vacuum of space, and it's somebody's at the helm, controlling it. But they're not going to believe me, right? But if I make it sound like it's this really complicated lore where you got, like, a bunch of people inside of the Earth, at the gears, and we're moving through. If I say some stupid lore, then it'll sound more believable. Just because there's more lore doesn't make it believable. Like they don't realize that.
And the
But
more
as-
boring, the better. Quite honestly,
Yeah,
the
'cause
more
that's what
boring the
happened.
technical details are, the better, because then they'll never look into it.
Yeah, that's what happened with the globe. It's so fantastical. Like it's just so fantasy, right? It's got like, galaxies and other planets and things, life in other planets, and it's fantastical. Like the whole lore of the globe Earth. So it's
There's
in
almost
one way,
two of
it's
them,
luring to the
right?
mind.
Miggy, there's almost two of them. There's like the space fantasy lore, right? Earth's a ball in space, spinning about the sun. And then there's the other side, right? The so-called physics, the mathematical models, the chalkboards full of equations.
Oh yeah.
There's that.
Well, of course.
And they don't talk to each other. Like they have nothing to do with each other. It's very weird.
And so it's easy for somebody to fall into the trap of wanting to believe, John. And that's all they've done right now. They're maybe because they're educated, they really love the idea, the fact that the lore is supported by other theoretical individuals who just love to think about new ideas. Their imagination is about inventing new ways to think about the cosmos, and they like that. And I guess perhaps
It's so funny,
that's
dude.
what's going to keep them there.
It's like, dude, it's so analogous to like witchcraft. It's like, yes, this is the supernatural reality you live in that you never experience. Well, how do you know? And then they flip over the chalkboard and they show you a bunch of magical symbols that you don't understand. Let me put on my wizard hat.
Well, I like both of your answers. I will trying to translate that to him.
It's hard to speak to the more educated types, I feel, because they're in the academia for a reason. They love the whole idea of they're captivated by it, right? Why would they want to pursue a field in such a thing? Is because it motivates them every day to think about what could be or what's out there, or and so kind of telling them that there isn't any of that, it's really letting them down. Like it's why would they want to? They live in a fantasy world already. And, some people that are actually in real world applications, like in physics and such, they deal with the really is level on a daily basis. So to them, tangible reality has to be something that is manageable, not like what is Mars made of, or Jupiter, it's raining diamonds. Like that's stupid. Like that's not something anywhere near like in our really is level. Like we're not going to use applications to harness diamonds from Jupiter. Like there's nothing real about that. It's just made up shit. But it was on it's funny because it was on one of the kids eat the yogurt. It's like Go-Gurt, and there was little fun facts about the universe on one of these little packets of Go-Gurt. And one of them was that it rains diamonds on Jupiter, and it was showing like diamonds falling off of the sky. Like it was really strange. But I mean, people grow up in this mindset, bro. It's just what it is.
Well,
They're intrigued by it.
I posed the question wrong, because he wasn't asking why does it matter, but how much does it matter. I think it changes quite a bit the
oh my gosh, bro!
meaning
Like
of the I'm sorry. It was
it does. It creates a cosmology where you know that there's nothing else out there. There's only this place. So it really narrows it down to like you're in a created environment. This is a very special place, and it is created. Like you can obviously see for most people, I could say there's a very small percentage of people who still think inside Flat Earth that there isn't a creator. But for the majority of people inside this created realm, we understand there is a necessary antecedent to creation as a creator. So we know that there needs to be a creator for this place. So it makes that real to us, 100%. Like there isn't a doubt that people have once you come to the realization that, creation needs a creator. It's antecedent.
There's also the aspect of denying your experience of reality and having to outsource reality to other people. So you observe a flat, motionless Earth, but that's not the truth. And you have to appeal to these wizards, tell you what reality really is. And only they can know, And the reason they know is because of a bunch of magical symbols on the chalkboard that you can't understand. You're not smart enough. You're not educated enough, right? But the fundamental idea is that you see a flat, motionless Earth, you see a flat Earth. That's not true to them. That's what they're trying to teach you. Your experience of reality is not real. It's actually, that is a misconception. You're looking at an optical illusion, which I already covered. But also the motion, the Earth not moving and the sun moving. No, that's not true either. You're rotating, you're spinning. When you see a sunset, you're falling back. When you see a sunrise, you're falling forward. Right? I mean, this is the idea you have to believe. You
become a contrarian to reality. Yeah, you become a contrarian to all things real. It's strange, but it's true. But it is very true. There's no creator. We are moving when we're not. There is a curve when you don't see one. Like you can't know everything because you can't know everything about your known reality. So therefore, you can't know anything at all. So it's like a all or nothing fallacy wrapped up in like this cognitive dissonance of like epic proportions. So you're just in constant confused state, and there's only certain individuals who can actually guide you through this confusion, and they're called experts. And those who are in academia lord their knowledge over the common people, which then the common people are like, well, I'm not an expert, I'm not a scientist. So therefore, they give up their own critical thinking to those who hold high standing in academia, and then that's it. Your world paradigm is dictated by them. The few
giving up your personal knowledge, and I'm convinced this is what makes you a 99%er, right? I can't know anything for real. I mean, I look at the Earth; it looks flat, but that's not true. So I can't trust anything I experience. I have to read it in a book, written by somebody I don't know, saying things I don't understand, checked by people I also don't know, who also have a vested interest in believing the same thing as that guy.
Well, thank you guys for the answers. My friend told me that the next time I will come here, he will come with me. So I think it will be better if he will ask the questions, not me, because I little bit messed up when I asked the last question. So have a good night, and I will come back. Thank you very much.
Have a good night, Jen.
Bye.
Yeah, have a good night.
I'd love for that guy to come in here.
I call it the tyranny of experts. We just went through that in case anybody was paying attention.
That's befitting.
We just went through the tyranny of experts. Well, I listened to this. Well, used to. He's passed away now. He had a radio show, and he had a kid every year he would do like a 1 week segment on the tyranny of experts and how the experts run around telling everybody what to do. Molding our reality.
And listen, man, I don't mind that some people are smarter than others, like in sense of like being able to understand and comprehend and all of these things, and IQ and all that. But like the problem I'm having is that when you're passing off information where people can't verify, like if somebody's saying some shit, right? Like take this and you'll be fine, or do this and everything will be all right. Like, and then nobody looks into it, and we're just all accepting what people say on faith. Like that's the problem I'm having, and that's exactly what they're doing, which would constitute for the tyranny part of it, because it's like get with the program or be mocked into shame, and that's.
Well, I think the expert thing is completely based upon self-serving greed. So back in the day, right, we had the guild system where nobody could practice like I'm a leather maker. You had to be in the leather makers guild to make leather, and they closely guarded their knowledge. Even Bong talked about this on in Samoa, like the knowledge of a particular trade. It was like kept in the family, and you kind of like that was like your thing, right? Your niche that like you didn't spread it around. And the experts do the same thing. The so-called experts, right? They create their own vocabulary. They create their own little clubs and groups, right? And then they say, well, you need us for this, right? If you want to do if society and the public want to do anything, they need to come to us and consult us. And of course, We're not giving away this information for free. We're also not giving you the fine details. You can tell us what the problem is, and we'll consult our crystal ball, and we'll write a report. We'll give it to you, and you can base your actions. And I'll pretend I'm not biased. I'll pretend that I don't have my own agenda. I'll pretend that I have no political ideas. And I'll just pretend. And I'll pretend it's not about money. And I'll just do this like this whole facade. So I have to create the facade of expert to give it value, because value is in scarcity, not abundance. So experts are rare. There isn't experts at running around at everything. So if I call myself an expert, I'm rare. I have value. I should get money. There's a whole nother layer to this. Like it's beyond just like I know more than you because I studied it. You're also protecting your trade.
Isn't that what academia is built on? Like these institutions are like gatekeepers, which you have to be in these clubs that you have to pay money to and be in debt in order for you to have some of this knowledge. But like I think about the information age, the age we're in right now. Anybody could be anything. If all the information for any kind of field that you want to get into, right? Anything that you want to study is readily available and probably in abundance. You could probably learn to be anything if you really wanted to freely without having to go through any of these institutions. If you so really wanted to pursue that, you could probably learn anything you wanted to with all the information that's out there in libraries and
like universities.
You know what I mean?
Weren't always a thing. Universities are like really something that's come around, I would say, in a major way, probably like in the mid 1800s, and slowly escalated to more and more and more. Now it's like, I almost say like
it's a part of the American dream, Indio. Like people nowadays were looking at like, well, okay, so the thing is, you go to school, right? You go to school through 1 through 12, grade 1 through 12, and once you're done with that, you go into college. You find yourself a nice career that you like. You get involved in that, and then you the American dream. You get a nice house, a nice vehicle, a wife, 2 kids, and 2 cats or whatever. Like, yeah, I mean, it's just all those things are part of the American dream. Like all of that stuff is what people are talking about to aspire to have in order for people in America anyway. Like so that you can have a good life. Like you have a part of that is going through these institutions, these gatekeepers.
How do you make your degree valuable? Think about it. How do I paid a bunch of money to go to university. How do I justify that expense? I need to make money. How do I make money? I have to make that degree valuable. So I'll call myself an expert. I'll say I've specialized knowledge nobody else has. I've found some knowledge and I'm holding it close to the chest, and I'm not going to give it to anybody unless they pay me.
Yeah,
that's really what's going on. And then you have fools like come in here and they're like, well, all the scientists think blah, blah, blah. As if that statement mattered or it was even true. And as if scientists are unbiased, moral characters, like they're just a bunch of Spocks. I got a PhD and I'm like Spock. I only speak logically. I only talk the facts. Come on, man. All of us know people that with college degrees, right? They're just like everybody else. They're no smarter. They're no dumber. Yeah. Like, there's some moral degeneracy there, but I'm not going to make like a broad.
I would. I would. Shit. Because think about it, man. Everybody has the capacity to do evil, right? Like that's just the way it is.
Yeah.
Like let's be real here. Like if push comes to shove, people can do some heinous things, no matter what standing they have in society. I don't care who they are, and so. That doesn't constitute because of the field that they're in that they're these moral, like enlightened beings. Like they're prone to like all the same things you and me are.
Yeah, and they're more invested into the system too. So and if the system's evil and they're invested in the system, then they're more. I guess they would be more prone to do evil.
Of course, because think about it. Like in the field that they're in, if they're needed to do some secret thing, for whatever governments that they work for. I mean, that's the field that they're taught in. So it's like, what else do they have? They'd have to fight against the powers that be. And it's like, well, they're already given an education by the gatekeeper. So, they're all in. Either that or just completely go all the way out with it, you know?
No, and
I
the
don't know,
funny thing is, a lot of people, they work very hard for their degrees, and I like. But that's the thing. I respect people working hard to get something, but they worked hard to, like, it's almost like digging a ditch for no reason, right? I'm just gonna dig a hole. Give me a shovel. I'm gonna dig a hole. There's no reason. I'm not going for water. I'm not looking for buried treasure. Not looking for fossils. I'm just gonna dig a hole. And like, I respect that. Like, it's really hard to dig a hole, especially a very deep one. But, you know, there's only a limit to my respect. Like, yeah, you put in a lot of effort. Congratulations. But you didn't actually achieve anything.
You just dug a hole. Yeah. No,
yeah, and that's what they do. They work really hard and they get a degree that's freaking worthless. It didn't make them smarter. They don't have any critical thinking skills. It's almost depressing in a way that there's so many people wasting their time.
But they're looked up to because.
But the good news is less and less men are actually getting college degrees. So, you know, that's kind of a good thing.
It's all about the successful like side of things. Like, these days, you can be successful without having to go to an institution, and that's a fact. That's an absolute fact. You don't need an institution to become successful in life. You absolutely don't. There's many examples of people that can be successful, and it really what it comes down to is like, what level of success do you want to have in life? Do you want to be successful, or do you want to have some knowledge of like what an institution has? Or, you know what, you can be successful, have the knowledge of some trade that you think that is only gatekept by an institution, but get it outside of an institution.
Well, it's also defined success, right? Is success a stack of money? Is success fame? Is it power? Like, what do you define success as?
Interesting. Yeah. Well, that would lie on that would be on the beholder, right? Whoever.
Yeah.
Whatever they think success is. But I mean, I don't know.
Because Bill Gates would be considered successful, but I wouldn't trade place with Bill Gates.
Yeah, no.
Right?
No.
If I had to assume his moral character and his actions and the things he does, if I had to do those things to get his stack of cash, I wouldn't do it.
Yeah.
I'm not selling my soul for that.
And you got to think about what is the end game, like, for everybody, anyways. Like, Flat Earth actually puts
exactly. What is the end game? Where are you actually trying to go? Like, when they start throwing dirt on you, right? Where do you want to be at? Like,
exactly.
How did you get there? How did you get to that grave?
People don't realize, like, when it all boils down to it, Indio, like, think about like the whole, even Flat Earth and everything, right? Just all of it. What is the whole point? What's the point to all of this? What is the point to spreading truth? What's the point to going to academia? What's the point of gaining all this stuff? Is it just to leave something better for the next generation? Or is that the hallmark of like what we're trying to do here? Like, or is it because the valuable knowledge of like what the truth is going to bring like peace and truth and justice, perhaps? Like, if you're going to see that people are not going to be like brought in by this lie and then be deceived. Like, but it's also to know that there is I think that the end game for me, it's an understanding of the knowledge of the Creator, because this life is but a moment. Like, we're only going to be here for a little bit, and the little bit that we're here, bro, we're struggling. Like, we're sick, we have issues. Like, there's never like, you're not going to live all of your lives on this earth like great. People are dying. Like, there's so much evil in this world. So the struggle that we have in this life is but for a moment. And then we have, all of eternity, if you so believe that the Creator exists, that this isn't the end. It's just the beginning. So I don't think the end game, we wound up in the end game, but I don't think the end game is just to amass great wealth and be successful and have all kinds of goodies here on earth. And then you die like a cockroach, like you're out, like, I think there's more to that. So Flat Earth gives us like a better foothold and like a knowledge of you don't have to be a Bill Gates. You don't have to be somebody who's just super successful or super intelligent or anything like that. It just, you have to understand what truth is and be satisfied with the things you have, and know that the Creator exists, and not put so much stock in this life but the next. Anyway,
being successful with money is like getting the money. It doesn't make you successful in the eyes of society. It's getting the money and keeping it. right? So you got like people that win the lottery, they become instant millionaires, and typically they're broke like within a couple of years. And the reason is because they give all their money away. They always say, "Well, they were bad at investing it and all that." Like, no, they were like, you know, people crawled out of the woodwork. This dude's got a bunch of money. Give me some. And they were like, "Hell yeah, have some money."
Yeah.
And they say, "That's stupid. You should tell all your friends to fuck themselves, tell your family to fuck themselves, and hoard that shit." Right? That's what they say.
Yeah, they do say that, man. Actually. Just keep all that shit in the bank.
Yeah, keep it in the bank, invest. You want to create a legacy and generate like all this crap, right? I mean,
buy some gold, dude. You're like, okay.
Yeah, great, but you could, or you can like, you know, enrich like 10 friends, right? They all have houses, and now they don't have to work, and now they can pass the house down instead of just like worried about your family. You helped out 10 families, right? Yeah. And that trickle, that's going to have a greater, as far as population-wise effect than just you and protecting your family, right? Because it's them and their kids and then their grandkids. So that's thousands of people you're going to have a long effect on.
Yeah,
but eventually you're going to be back down at your level because you're going to, you know, as they would say, blow all your money. But you didn't really blow it.
Yeah, you're investing in the wealth of having... you know, good people around you that are going to be appreciative like that. Most people would.
Even
like,
if they don't appreciate it, you make their lives better, right? So there's a lot of, I don't know how to say this. There's a lot of homeless people in Boston. They haven't been around, but during COVID, right? Like someone will ask you like $2, and I just give away money like crazy, but it's like, I know they're just going to go do something stupid. But I just know that in that moment of them getting that money, that just made them happy for a moment, even if it was fleeting, because it'll be raining out and they were sleeping outside for the last fucking week. And like, you know, their day totally sucks. They don't have anywhere to go. They never get to relax. They never, you know, you just giving them like a break for just like 5 minutes. And just that little bit of like, you know, compassion or whatever, even though it's like, it doesn't solve the problem, but it just gives them a break. You know what I mean? It's almost like, seeing a little old lady cross the street with a big heavy bag of groceries. Yeah. You grab the groceries from her and you carry it across the street from her and then give it back. Well, yeah, you didn't bring it all the way home, but you gave her a break. You know, a break is better than nothing. You know, so it's and like it's just, the analogy is like you gave like all these people money, like you gave them a break. You know what I mean? They got a break for a minute from some worry or some stress or some problem or something, even for a moment. And a lot of times that's all what people need, right? Because like life is like, you don't get a sub in real life, right? Like in a basketball game, you're like, "Oh, I'm tired, coach, sub me out." Right? But in real life, you don't get a sub like, "Oh shit, I'm tired. I'm going to go sit down, sub somebody and let them go to my job for me." Right? Let them go pay my bills and all this stuff. You don't get a sub in real life. And sometimes it's just cool just to get a break. Just to get a break from stuff.
And speaking of break, I don't want to ever interrupt
into the break
or the conversation, but I'm going to take a break out into the rain in the bright sunshine. So I'm going to go out and it's raining. I'm going to go out and I'll take some pictures. I'll see you when I come back.
Is it raining or sunshine or both?
Both. Usually it does both. Most of the times it rains, then the sun is shining and it's raining at the same time. It does that more often than not. So, yeah.
Have a good day, Sonny.
It's a myth.
I'll see you.
Whenever there's a sun shower, a witch is being born.
No way.
You've never heard that before?
Wait a minute, say it again.
Whenever there's a sun shower, a witch is being born.
Well, there must be a lot of witches. I don't know if that's regional. So I don't know if it can.
You're in California, so I'd say yeah.
So would the witch be born only in that location?
I don't know. It's somewhere in the world.
Right. I'll see you guys in an hour or so.
Later, Sonny.
All right, peace out.
Yeah, I used to hear that thunderstorms was God's bowling alley, but that's a good way to
look at the panhandlers, India. It's kind of inspiring because, once upon a time, I threw the bums a dime in my prime, and then I kind of got out of that. But, I do give people cash when I have it because you're right. $3 to someone who hasn't had a break from the constancy of poverty, or me having a 20-ounce soda for $3. You know what I'm saying? Like $3 is worthless, but invaluable. So, or I'm sure you're passing out bigger bills. But yeah, it's kind of inspiring to look at.
No, I don't give them a lot because I know they'll just get fucked up. Like, you know what I mean? If I get them $20, I'm really just giving the money to some heroin dealer. I might just give it to the heroin dealer and be like, "Hey, here's $20. Go get him some heroin." Like.
Yeah, and there's the difference between the hustlers who are asking every other person, and the person who's actually who's too beat down to even ask. So yeah.
Yeah. So, but the way during the pandemic, there were so many homeless people that off the chart. But I don't know if they shooed them away because they're not all downtown anymore. I mean, there is some, but there isn't. It isn't as bad as it was. But the thing is, that this person's day is going to suck from the time he wakes up to the time he goes to sleep. And even he probably isn't going to sleep good either, right? Freaking sleeping in a door or freaking in a subway tunnel, wherever the hell they go. He's going to have 4 or 5 moments in that day that are better than bad. You know what I mean? They still suck, but they're better than bad. So it's just because if you panhandle, maybe you can panhandle $20-$30 a day or whatever, enough to get you food. You might as well just be part of that, right? Just for that moment, they could go, "Oh, I got $2. I only have to make 2 more, and then I can get something at McDonald's or something." You just give them a moment of relief, I guess you'd call it.
And all that trickles down from you having the understanding that the earth isn't what you've been told, because you know that it's a created place, it's special, it's intentional, like all this that we're here. And there's a empathy for all of humanity, which is kind of the same way when you look at how people are being misinformed about the topics of critical thinking and just their confusion, man. Your heart goes out to these guys. You really you feel bad for the ones who are just innocent bystanders of the indoctrination. You don't feel bad too much for the ones who are actually doing the indoctrination. The ones who actually want to make themselves as professors to say, I want to teach this stuff. I want to be an astrophysicist. I want to be somebody who's teaching the masses this information. I want to be the guy. Those are the ones that you really don't like. The ones that you are you can find a little bit of empathy for, the ones that are just no, it's a globe, right? They don't know what they think they know.
Well, as Old Hoss was saying, I used to give people money, back in the late 90s, 2000s, and then I stopped because I saw someone that was panhandling in Boston. I went to Hampton Beach and I saw him panhandling up there, and I was like, "What the fuck, dude? How the hell did you get up here?" Right. So he would panhandle at the government center. There was an escalator. He'd stand at the top and ask every person that came by him for a quarter. And you got to think, Dan, 10,000 people are going to walk by him. And if even a small percentage of people give him a quarter, that's hundreds of dollars. So that person obviously wasn't broke. He was just panhandling to enrich himself.
Oh yeah, you've heard the stories of people owning semi-mansions in suburbia, and they have a licensed panhandling permit. So yeah, people are playing it, but but there are.
So I stopped for a long time, but then when COVID hit, and I saw just the sheer amount, whatever, I just started giving people money again.
We have Asian gangs here that do that. They send people out on the street, and then they they pretend to be homeless, and they collect the money, put it in the bank, and send it back to Asia.
Yeah, they had the issue here too with that, something like that. So there was a group. They were taking care of there was a group home for handicapped people.
Yeah,
and they were took care of them. They would take not only would they take their money, like their social security check, their disability check, and spend it on drugs or whatever, they'd made these homeless people go out and panhandle every day. And they were making something like, this is back in like 99. Like, this is when I stopped, because there was a whole slew of these like panhandling scams that came out. Someone was living in like a $5,000 a month apartment, and like but they were making something like $1,800 a day off of three people that they were forcing to go panhandle.
Yeah.
Yeah, so I stopped
taking
for a while.
advantage, taking advantage of the generosity of others is, you know, it's pretty bad. But I still do feel sorry for the people when I walk past them, you know, and people ignore them, you know, even if I've got no cash on me or anything, I always say hello. Say, g'day, mate. And they look up and smile and nod. And I was speaking to one guy one day, and he said, I know I look like wasted my life and this and that, but I've had things happen to me that, you know, that's why I'm in this situation. He said, I wish people wouldn't walk past and ignore me. I said, yeah, fair enough, man.
I'm not going to out the guy, but there's a guy that's homeless in Boston. Well, he was in a homeless shelter, and I met him through a friend of mine. And let's put it this way. He was a music producer for a major label, and he produced, if I said some of the records, y'all would know him, and you'd be able to find out who he was. So I'm not going to say. That dude was homeless because he got... he had a string of, unfortunate circumstances that eventually led him to be homeless. I think he had a little bit of mental illness too. But who knows what came first, the chicken or the egg, right? Did he go mentally ill and lose all his shit, or did he lose all his shit and go mentally ill? He was a multimillionaire, and now he's homeless.
Yeah.
So like, it can happen to anybody, quite honestly.
It's weird, man. I can understand that kind of situation, but at the same time, it's almost like it's weird to me, because it's like all you really need is a nice home. Get you some. You don't have to live in a mansion. Just get a nice home, really nice one. And some vehicles or whatever. I don't know. It's just weird.
Well, these
to me.
people, like, what ends up happening is like they end up in the street, and it's like a subculture. It is it's culture. You deal with other homeless people, drug addicts, like this whole thing. It gets to the point where you don't know how to deal with normal people, because everybody's fucked up, and all you're dealing with fucked up people. So like your social calibration of how to socialize with normal people gets all screwed up. You just don't know how to do it anymore from lack of practice. You don't know how to like go into a restaurant, you know what I mean, dressed in a 3-piece suit and eat your food properly and all that stuff. It's so like from everything going hand to mouth and living in a doorway, and you're doing that for years or like a couple years or even months. Your whole mindset changes, right? It's just your adaptive response. And it's hard to go back. To go backwards, right, into so-called civilized society.
Well, it's also so some of these people give up, and the difference between a homeless person and a poor person who rents a crappy home or something like that is that person who is poor, living in a rental home, they have the will to go out and work and actually do something to put food on the table for some reason. The other people don't. They lose something. They lose a will to
actually know homeless
better their
people that
life.
work. Yeah, but I know homeless people that work.
Yeah.
They actually have jobs, and they sleep in the street.
That,
but the thing is, it's different.
It's weird that they wouldn't want to go home to even if it was a room or something, go home to a comfortable place that's warm and it might cost them $100 a week,
Not here, dude. Not here. $100 a week? Hell no. Put it this way: if you were to just like the cheapest possible solution to live in somewhere is going to cost you at least, let me think, bedroom, 3. It's going to cost you at least $400 a week, at least. And if you want like an actual apartment, you need first, last, security, right? First some places. Then you also need to pass a credit check. Like it's like the housing here is it's like this. Well, I live in Boston. It's the second most expensive city living in the United States. So it's
Is that because of the universities, the colleges,
no.
or whatever?
Yeah,
No?
I mean that might be part of it. It's just like they're all greedy fucks, dude. Like they know that there's like a housing crunch, and they just like there's places. Someone explained it to me like this: a lot of the places that have apartments, condos, whatever, that they're actually owned by like corporations, right? They're owned by like some LLC, which is a limited liability company, some company, and when they can only rent a particular. They have more financial incentive to leave an apartment empty than to rent it below the market price. Because if they rent it below the market price, it's something to do with like how their corporate structure. Because they get like angel investors, and like they have to like when they like signed like whatever deal they made, right? Okay, we're going to start a company. We're going to buy a bunch of places. We're going to rent out apartments. Oh, we can only, and part of their like little structured contract, because they're like, because they have investors, right? And the investors get paid off monthly out of all the revenue of all the apartments. They have like only like 1% of the apartments can be like 10% below market rate, or you have to pay these penalties or like whatever. Or also there's tax advantages to saying, hey, oh, I have all these empty apartments, therefore, I'm going to pay this much taxes. There's a whole incentive structure to rent apartments at the highest possible market value. It's really messed up here. It's really, because there is a lot of empty apartments, but they're very expensive. Because you think that right when there's empty apartments, you lower the price to put somebody in there, but they don't do that here. They just don't do it for whatever reason.
Well, if you start lowering the price, you lower the class of the neighbourhood, and then the apartments aren't worth as much in collateral, I suppose. But wouldn't they still be wanting to make an income from a building that they own? I don't think that makes sense.
Well, I think they have their cost, right? They have the cost of operating the building. Like if you have an individual apartment, the cost that goes up, like say you provide heat and hot water, but not electricity. Like what's the cost of heat and hot water in an apartment when you're heating the entire building anyway, right? So that's always going to be heated. The only thing you're really paying for somebody is the hot water when they move in. You're really not paying any more money. So you're only losing like what? Freaking $50, not even $50, $20 a month heating an apartment nobody lives in.
Yeah.
And then like if everybody starts lowering prices, then all the prices start coming down, right? So it's like it's almost like right. I'd like to get that should be something that's like investigated, whether that there's some collusion going on, because there's companies that own like one company around here is Avalon, so they own like a lot of high rises, like condo high rises. But they're not just condos. They're condos that you can buy the apartment or you can rent it, and like, but they own lots of these buildings. At least in my area, they probably own like 7.
Yeah, so it would be in their best interest not to lower the market.
Yeah, that's right, because it'll lower like the prices on all their stuff, right? So the overall, like if you have 7 buildings with 200 apartments each, 1,400 apartments, you start lowering them, then the rent on all 1,400 is going to start coming down. Better just leave a few empty, right?
Yeah, it's probably, that probably points toward it being handled by some algorithm, where there's not some person at a desk saying, hey, if we do this and do this, we could. It knows that it has its thresholds of when it starts losing money, and it's not a human sensibilities being applied, it sounds like.
Yeah, and there's also a bottom, and the bottom is there's an artificial bottom that's created by like Section 8. So Section 8 has like what they'll pay, and they pay some percentage of the market. They'll pay like a for a 1 bedroom, they have like a maximum price. 2 bedroom, they have a maximum price. 3 bedroom, they have a maximum price. So that kind of sets the bottom, because people on Section 8 are like subsidized. How, like, you know, they're like their rent's paid for. Like the government pays a portion and the person pays a portion. So that's kind of like sets the bottom of the market artificially. But Section 8, every year they redo their thing, and then they go, oh, how much is the overall price? What has the housing market as a whole done? Right? And it either goes up or down. And they, whatever, if it goes up 5%, well, they'll pay 5% more. So if the bottom's being pushed up, everything else is being pushed up. Right? Because it's a market as a whole. The market is moving in unison. Right? The bottom and the top end are just like the top end, like I shouldn't say the top end of rentals, because like the top end isn't like rentals. They're like $1 million apartments on the Millennium Building and shit. They're not, you know. But it's like, this is why there's a lot of homelessness, because there's like not a lot of affordable housing in this area. It just doesn't exist.
Yeah, we got empty buildings all over the place in the actual city, and a big boom of apartments before the thing that happened over the last few years. And then we have a lot of international students and things like that, and they come in and rent the apartments in the cities, and they haven't come back. So so all these apartments are sitting there in the city just doing nothing, and then you walk through the city at night and there's homeless people everywhere. And,
yeah, that always burned my ass, dude.
Yeah.
Oh.
And they're also, people are still working from home here as well. So a lot of the office buildings, a lot of the companies have gone, oh, well, fuck it, we're getting more out of people working from home because they're working longer hours. So
I've been wondering why that hasn't, like, why the housing market hasn't crashed yet, or why especially the office space market, why has that not crashed?
Artificially propped up, yeah. They're not letting everyone know what's going on, because if they do, they're fucked. Our housing market just plummets. And then all the bank loans don't get paid out because they're paying off a house that's they've got a loan for $2 million, and then their house is worth $500,000, and then, you know, everyone's fucked.
Well, I mean, think about how easy this is to solve now, though, right? It's so less people are going to work and they're working at home because of the thing, right? So now you have all this empty office space. All that shit can be converted into housing, and then you solve the housing crunch, right? Then you make everything more affordable.
Yeah, speaking about that, yeah.
But people with the money operate in the system are greedy. They're trying to maximize profit. They're not trying to like help people. And that's the it's not how capitalism was set up to work. It really isn't. Like, people think, oh, capitalism's a maximum. No, it was never. A corporation is supposed to have a legitimate public purpose to even set up. A public purpose as in something that's good for the public. Having profits was the motivating factor to get people to invest capital to do this so-called public good that the corporation was supposed to do. But now people get involved in corporations solely to make profit, and it has nothing to do with public good. That's why you have limited liability. That was the whole point of limited. Oh, start a corporation. Oh, to incentivize you. So I brought this up. I want to build a bridge across the river. No one person is rich enough to do it, so we need a bunch of people to invest their capital to do it. But they don't want to do it because, you know, the liability risk, right? They could get personally sued if they put their money in and make a bridge. So we're going to make a corporation. So that's the public good, right? The public's going to benefit from this bridge. People are going to invest money, and incentivize people to invest money. We're going to let them have a profit. That's not how they do it now. Now it's like, I want to make a bunch of money. What scam can I think of? It's totally backwards from how it like originated. Yeah, but I don't know what happened to the homeless people here. They vanished. I don't know where they all went. Went from like hundreds to like maybe like, you know, if I walked in the same area like 20 or 30, but it went from like there was hundreds during COVID.
Wasn't there a thing where they like got a bunch of shots or like free donuts and stuff?
What?
Like I heard stories about this. Like the homeless people were actually like going to get the shot over and over and over because they would get free shit.
Oh, not here, but it wouldn't surprise me. They would do it no problem too.
Well, it was happening a little bit here, the donut thing and like gift cards. Like I was offered like a $200 gift card in a public park in downtown Portland to get the jab, and I was like, "Can I get it without taking it?" They're like, "No." I'm like, "Oh, no, thanks."
That's crazy.
I was asking the woman administering. I was like, well, where's the money coming from for these $200 gift cards that you're handing out for various stores? Like, who's paying for this? And she couldn't tell me. She's like, I don't know, somebody.
Right. So what probably happened was Pfizer was probably making $500 a shot and then paying people $200 to get the shot and still making $300. Nah, they wouldn't use their money. They got the government to put up their filthy money. Imagine, I can't believe people were giving away gift cards for something that was experimental. It blows me away. That's like the bioethics behind all this is really sketchy.
It's a fucked up world, man.
Yeah. So Samsung is faking moon photos. Did you hear this? This is just a bunch of times they did this. Oh man. So if you buy one of their cameras and you take a picture of the moon, it identifies the moon and makes it look better.
It has to go by some kind of algorithm. I know the cameras also recognize cats, other animals.
I've heard telescopes do this too. Like the modern digital telescopes. They actually enhance your images. Like if you buy a Celestron or whatever.
So the moonshot is blurry, but it kind of adds some kind of filter, I guess. Not sure how it.
Yeah, upscales it or whatever.
Yeah,
Has to be some kind of filter.
It has a space zoom feature.
Nice.
Dude, hey, that's funny. I wish that Jan dude was still in here. He asked why would they lie? Like, or he said, why isn't it important? Dude, so they can spell you space zoom features on your camera and you pay an extra $300 for it. That's crazy.
Oi, Smurf is back. How you doing, man?
I'm above the ground. How you doing, brother?
Still rocking around, flat smacking.
Oh yeah, all the time, brother. Thank God.
That's good to hear.
What's up? How you doing, man?
Oh, good, good. Just resting and just had a meal. Late night here.
Yeah.
You come across anything interesting lately? Another service, maybe?
Oh,
Globers.
brother, I'm getting my mind blown on a daily basis, man. That's what I'm used to.
Nice, nice.
I'm addicted to these servers, man. I just constantly learning. I don't even know what to say. I just get my mind blown all day. Yeah, I've been having a series of spiritual experiences, man. I mean, it all starts with you figure out the Earth is flat. Then you get 1,000 more questions. Then you gotta look into those things, and you know where that goes. Tell you, you know, when I was a child, I remember I used to believe in the spinny, wobbly spaceball thing. moving at 5 different fluctuating speeds, saying that like the world moving like what I forget, was it 65 million mile an hour around some star, moving 455 million an hour around some galactic core near the speed of light when the Big Bang, all this stuff, and they got all something about like moving away from some nothing exploding to something in this space time curving into orbital ball thing, whatever, sucking vacuums and space balls and big rocket ticks. I'm sorry about that. Pardon me. And all this, innuendo or whatever. Anyway, I used to believe in that nonsense. I used to believe in all that nonsense. And then one day, somebody said, "Hey, I heard somebody say that they heard a friend of theirs said that they heard the Earth is flat." I was like, when I heard that, I couldn't get that out of my head. I couldn't get that out of my head, dude. And I just kept looking into it. And I was like, no way. Really? Wait. Well, hold on. Everything just makes more sense now. You know, it just, because when I was a child, none of this made it. It just seemed so random. You know what I'm saying? It just didn't seem to make any sense. And I just thought, wow, the reality is so randomness. It's just everything's just random. It just appeared to be the way it is. But now I look at things like, of course, this is how everything is. You know what I'm saying? That makes sense. Nothing works in any other way other than the flat plane. Does that make sense? I'm saying it's the only way it makes sense to me. When I look outside there, it doesn't seem that the world is wobbling around. Everything seems mostly calm. There's some wind. The wind's like fluid. I think what I don't know if y'all can hear me. I think what happened was in the beginning there was like water and the water got separated. And I kind of think the air is something like a thinned out water. Can y'all hear me? Anybody here?
Yeah, we can hear you, dude.
Yeah, cool. So I think like what happened was kind of like a fish in water. We're made mostly of water. It's incompressible. It's everywhere. And you can modify it. Like it can be conductive or insulative, depending on. Hey, cool. Yeah. And so, I live in a mushroom. But the way this works is that to me is that water is everywhere. They claim that the known world is allegedly mostly water. You got carbohydrates, hydrocarbons. It can be conductive. Life is often fluid. It's always changing. And the way I look at things, well, I think when I type the word ether online, and I wouldn't even think of these things if I thought I was on a wobbly space ball. I type the definition of ether, and I get similar like definitions that have to do with liquid or fluid. Some is petroleum related. I see a common pattern with fluid dynamics or something, liquid. So I could be off. I can't believe. Hey, that's a funny joke. But I was saying, I see like a common pattern that. What I was saying is with the ether. Well, everything's in the ether. They say. Well, I just described how water seems to comprise most everything. Everything's, the world seems most stable, but the wind. Well, the wind, if you imagine, is like a thinned out air. It's fluid. It's constant moving. I think all energy is like vibrations condensed. It's like slow, like matter. I mean to say, matter is like energy slowed to condensed to a slow vibration. That's what I was trying to say. But everything there is a resonance to everything. That water, like the Ethernet, you know, the Ethernet that I'm communicating with you through. Well, we know that I got my Ethernet cable plugged in my laptop here, and it seems as the copper resonates fluid, like for example, how the Wi-Fi. I'm not using Wi-Fi, but We know that Wi-Fi resonates on a frequency similar to water. How the microwave oven works. It's only 1 watt, where something like that. Where a microwave oven is maybe like over 1,000 watts. But the point is that with the Ethernet, there's a resonant, like a harmonic. I think everything is harmonic. And like I think all the world's like a sound stage. If you were to imagine like a like a golf ball, but like a fish bowl or something. If you were to imagine, or like a micro cell, or perhaps even the mind's eye or pineal gland. I mean, there's a lot of things I speculate about what exactly the nature of the world is, but to simplify it, perhaps it's like a fishbowl. They have Operation Fishbowl. But check out, imagine like a speaker system, like the stars fixed to the firmament, pushing out, always talking, always pushing out resonant frequencies, right? And astrologically speaking, perhaps these energy fields are overlapping and create like a stabilization that we call reality. And so, well, these sonic vibrations I should say the world is like a sound stage. And so you have these sonic vibrations rippling, like ripples through the pond water, like these waves, like, and the way I look at it is that, I think of the, like a holographic mind of God and man. If you were to freeze my thoughts right now, if you were to freeze the air around me, you'd be able to see my thoughts visually, just as you would if you took a drop of my blood under a microscope. You would see holographically anything in my body that requires attention, because the way that is a multicolored hologram. That's why they use an electron microscope. But if you were to use an optical microscope, say, what would happen is that if I broke my hand, it would resonate multicolored way and to interface with the mind's eye or inside the brain. In the pineal gland, I think it is, in the mind's eye, that we have the crystalline structure. It would be the salt of the earth, the salt crystals that you can get, the astrological salts. There's a dozen of them that resonate with the zodiac. As we are like within the holographic, like the microcosm of the macro, you know. And what I'm trying to illustrate for you is that, to be the salt of the earth, if you have these crystals you can get from a variety of different meats like lamb and etc. They are kind of like lenses, like laser crystals that craft holograms in the mind's eye, or create the visualization or the imagination, as we're made in the image of God. So what I'm trying to say is that basically is that if I broke my hand, okay, the hand would resonate that it's out of equilibrium. What would happen is that if I were to eat kosher meat, like a high chakra above the cuts above the solar plexus, for example, steak. If I ate some steak, these dozen salts, what would happen is like a fractal geometric, like a resonance. What would happen is that the lenses and like the stars in the firmament, the crystals would redirect this flow of energy that would craft a new man from the inside out, basically. What I'm trying to describe is the tree of life. Because when I was an alcoholic, I was lost in the wilderness, like in the desert, like when you eat dessert. And so, I was born again, and I was born again like a child, right? Because I removed from my mind, I transmuted all lustful thoughts, the seed in the soul of man. What I mean is that the 33 degrees of the 33 vertebrae to become illuminated is that okay? The light in the mind's eye, it shines your eyes. What I'm trying to say is that this Kundalini spirit it comes from the desert, and it rises over the gut area. It's like Lower Egypt, and the spirit rises up to the 33 vertebrae and up past the solar plexus, and it rises up to Upper Egypt, and you find paradise where Adam and Eve, or the east and west hemispheres of the brain, or the good and evil, the masculine and feminine, or logic and reason and emotion. What I'm trying to say, you get what happens is this new the seed when you don't have see, when you have lustful thoughts. I have to back up and explain how when you have lustful thoughts, the cerebral fluid, which I say is like liquid mercury, the cerebral fluid seeps down the spine, so that when a man and a woman alchemically fuse, this is what happens. But basically, if you were to transmute, if you were to become born again like a child, to rejoin in the kingdom of heaven, what would happen? What would happen basically is this. I like to call it. I call it liquid mercury, because what basically the cerebral fluid, when you preserve it up in paradise, if you stay in paradise, what will happen? It allows you to resonate through the ether. The ether, I call it, is like the water. You know, it's like the water around us. If you were to freeze it, you would see my thoughts that I'm trying to illustrate to you through the Ethernet. Through the Ethernet, I'm trying to describe the ether world. What I call this L's mind, God's mind, or almonds, or tasty treat. Most of fat. The brain is made of mostly fat and some protein. Not much like almonds. Almonds look like brains. But anyway, if you get pure raw almonds, I like that. I like that a lot. I just ate half a paint can of almonds. Hey, Zach, that's funny, hilarious. But I try to say, I believe that the way to resonate with God and to tune into this to communicate, the interface with God, I put myself into a receptive or listening mode. And what I do is I know that God can see, that God's everywhere, that I'm in His mind, that in this dimension is divided. The body is like the devil, because what's happened is it's divided. Because what happens is that God's mind, the manna, man, the manna, marijuana is great, and the manna, what's happened is that it has been decentralized amongst each of us. And so we're made in the image of God. We've imagined that everything is made of the ether, and so what I'm trying to say is that there's an alchemical process from the holographic book of or the Holy Bible, or I meant to say that the it's an alchemy book, see, veiled in the language of symbolism, and there's an electrochemical process to prepare. I love you too, brother. There's a way to prepare this physiological modem, is what I call it. There's no Faraday cage, and what you want to do is you want to accumulate this liquid mercury, is what I call it. That I call it that. There may be a better way to. This a personal thing I call. But basically, like an analog modem is what I'm trying to describe is that to communicate with God. I hope I'm not deluded, but I know that God is everywhere. I'm like a fish in water, and I know He can see through. He knows everything. He's everywhere. He sees through me, dude. I'm made of the stuff. We're all made of the stuff. Everything's made of the stuff. And so hydrocarbons, carbohydrate, whatever. It's like a water world. I'm trying to say that I try to listen and be receptive, and I have this intention, that I ask a question in English sonically. I ask a question, and then I try to be completely still, like I switch my modem into receiving mode. But in this process, as I look at this Kabbalah tree on the living room wall, it almost like an anagram. It's missing one little angle that almost spells kefir. So I go to the store and I get the kefir, goat milk, highly nutritious. Combine that with the dozen astrological cell salts. I also eat steak and eggs and a lot of almonds. almonds look like geometrically, visually look a lot like brains, if you notice that. But anyway, so you know, I think there's like a alchemical method to optimize the physiology to prepare to resonate with the same wavelength, like the waves of the ocean, the waves of God. Is like we're all part of this thing, collective consciousness, decentralized. The body being divided creates the illusion of individuality, the ego. It's almost as if, to make it a parable, we are like possibly all. I like to make a parable, an example or analogy that maybe we're like holographic brain cells. And to make another example, it's sort of like how there's a school of birds or a flock of fish that seem to move almost electromagnetically in formation information. And so you don't see the the ethernet like tethered to them because it functions wirelessly, like ripples in the pond water. If you get where I'm going with that, is that people do the same thing. The more complex the creature, the more it filters out and creates the illusion of individuality. The more simpler the creature, you get very simple to vegetation and stuff like that. And then you have the hive minds, the multi-layered hive minds, similar to the internal bodily process. The answers are within. The internal bodily processes handled subconsciously in the background. Now, allow me to just, I'm kind of all over the place. Can I just simplify this? That perhaps in the beginning, Brahman, he was all things, and then he was instantly bored, all knowledge, all power. Instantly bored, of course. And then he decided to decentralize himself into all life forms at once. And for the sake of entertainment, being all powerful, and I asked God, I hope I'm not deluded, but I wish to share that I asked God, what is the meaning of life? And I feel he responded to me, entertainment. And then I asked another question, specifically, how are you, how are you entertained? And the response I got was surprises, you know? And what would be more surprising for the all being, Allah, all of Allah? I don't know. Hey, what would be for the all being? What would be most surprising than to hide, to centralizers and hide his true nature from himself? If he were to split himself into multiple, it reminds me of Gnosticism, whatever. I don't know about all that. But, if he were to split himself into first, well, you have the shining darkness under the plane. The Vatican seem to worship as Lucifer. But anyway, that's why they personify it in the hermaphrodite. Baphomet, I don't know. That's a layer of exoteric. But the truth is that have this cosmological, there's no ego at the basis of this reality. I mean, what it is that we're inside the mind of God, divided. The dimension is so you have the sun and the moon being like the masculine, feminine, and you have under the plane this shining darkness thing, the black sun. Well, long story short, we seem to be in this sort of geometry where everything you've ever thought is basically resonates out into this ether, and it overlaps as if we're all dreamers. And collectively, we dream this into stability, what we call reality. You know, well, you could be correct. I don't know that. I could be deluded. I'm just sharing a personal experience. I really don't know. I don't claim to know the meaning of life. But anyway, I'm just saying I asked God and I felt that I received the answer. But I could be, dude. I've had dreams before. I've personified astrological entities like the devil. It looked slightly different in two different. It made me question. I probably made all that up in my mind. But the reality is that everything's made. Life is but a dream. I think life is but a dream, and we're all the dreamers. experiencing itself subjectively. See? But my point is that everybody is one, and they know this. The Jesuits know this. Others know this. That there's only one energy, and this one energy is transmuted in different forms astrologically, like a Swiss clock. But anyway, in different forms is one. I call it the ether. You can do a lot with water. Life is rather fluid, but you can do a lot with it. You know, the whole world is nothing new under the sun. What I'm saying is that I don't know where I'm going with this, but I stopped drinking about a year ago, and that's my perspective. What do you all think about that? I could just go on all day. Sometimes I wonder if I'm just talking to myself. Well, I feel that I've ascended, and the way I mean is that I've accepted. If the reincarnation is that it's the same way, like how new brain cells, you know, you get new brain cells, dude. It shake off the old and with the new. But whatever happens for a reason. We all dream up this reality collectively, overlap, and it's stable. But I think we have two options in life: immortality or division. You could either lust and become fallen, and you can lust. You can divide yourself into multiple people, or perhaps you could just be born again as a child. See, you know, because as we already are children of God, God is eternal, and of course, I don't. I want to say I don't know how to say this, but if you were eternal, wouldn't you wish for your son to be eternal also? So, like, the method being is that if you just ask, you shall receive. And the way, but the way to do this, to lust is not of this world. You know, it's, to divide yourself. We already are divided into our bodies. You can continue this process like the beast of the field, or you can control this alchemical process. I argue that it's a 28-day cycle and part of a greater 7-year cycle. If you just could become born again and from the inside out. And if you embrace it, it's like reincarnation, like a micro and a macrocosm or a fractal reality. If you just, optimize the diet, yeah, have a dozen astrological salts. I advise that, but you do you. I just say as a foundation, become born again. You know, uh, it's 33 degrees of the spine. You see, this is how you get illuminated this way, like the mind, the holographic. We use the light, raw, like the light and the rays of light in the mind's eye. I could go on all day about this, literally, because you see, there's an astrological language um, written in the skies. And the Metatron's cube is one such language, but all major languages are written in the sky around Polaris, which is no parallax, never changes because the Earth is flat. And so, what I'm trying to say, they don't want you to know this, that all language is written in the stars. And as we try to adjust it, modify it, fake history, whatever, butcher the language, it always will resonate back that with the world, the whirlwind, everything fits together. If you just be calm and still and ask, you shall receive. You become born again. The world is eternal. We're in God's world. And if you ask, you shall receive. if you just be still and ask. And I could go on all day about this because all the answers are within. See, I'm just a modem, like a receiver. I'm just a receiver, you know. You know, or like a transceiver. Really, as start out in the path, I start out as a receiver of energy, then a transceiver of energy, and then a transmitter of energy on my path to be like the Father. You see, the Heavenly Father. To be like, you can. I'm not. Please don't misunderstand. I mean, you just. There are superstitious people who say. I'm close to saying the wrong thing there. Very close to saying one word off saying the wrong thing there. But I'm trying to say we're all sons of God and we're equally all siblings. And the body is a mental projection of your beliefs. You are your imagination. The body follows the mind. Sometimes I often wonder if I'm just talking to myself. Was I always just talking to myself? Or is it perhaps that you were always talking to yourself? And what if you're me? What if I'm you? And what if it's all just it's just fun, it's entertainment, you know? And what if you loved that neighbor as you love that self? What would happen then? What would happen then if we all holographically visualize a bright future for each other rather than sabotage, rather than rival competition, rather than hurting each other? What if we all imagined a better future and resonated that? Is that like prayer? When people come together, when a group like brain cells function to craft these beautiful holograms in the mind's eye, there's no Faraday cage, and this resonates out and it pulses out like a shockwave, man. When you get a group of people, like a group of brain cells, when you get a group together, you know, and you share the same visualization, what do you think happens then? Maybe you want to be the change you see in the world. You know, I just think we should start with love each other, you know? Just an idea. I don't know. Sometimes I wonder if I'm talking to myself. I could go on all day about this.
In here, that's possible.
Hey there, buddy.
How are you?
I'm above the ground. How you doing, brother?
I'm doing all right. Just trying to relax.
Had my headphones maxed out.
How am I coming in?
Oh, you're great. I had my volume maxed out.
Okay.
Yeah.
I've got my Yeti on right now, so it should be picking up really clear.
I hear you just fine. It's just that I accidentally, when I heard you, it was loud as hell because I had to turn my volume. Not you, it was me on my end here. I didn't realize it. But, hey, great. It's great to talk with you, brother. How are you?
Doing all right. Just relaxing.
That sounds good.
Trying to set up my sound here.
Isn't all the world like a soundstage?
I think it's like the theater stage, right?
Oh, yeah, I agree.
Sound stage is like backstage, right?
Oh, maybe I say it wrong.
You said the sound stage.
I just made that up because I think of the stars like speakers in the sky.
Bro, all the world is a sound stage, not a stage, man.
I don't know. Well, I think the world is what we make it, what we imagine it to be so. What do you think about that?
Well, let me think.
Well, your body is probably what you imagine it to be, like a mental projection. And so...
I think there's a manifestation going on. I just don't think it's ours.
I just imagine that we all collectively overlap. We visualize this reality to get like we all dream it. We dream this reality up, and that's how it's stabilized. What do you think about? Along with the stars.
You mean like the collective consciousness?
Oh yeah, that's what I'm talking about.
Yeah. No, I don't think that this realm is for that.
I have no idea.
I'm not saying that doesn't happen in another realm. I just don't think this realm is where that's happening.
You may be honest. Something I've heard of the concept of the demiurge. Is that what you think?
I definitely know the concept of the demiurge.
I only know some basic idea of it.
There's a couple different schools of thought on it. The imperfect creation, creating everything below it.
Oh, I so often wonder on this subject. Quite often.
On the other hand, it could be that it wasn't an imperfect creation, and that it was intentional.
Wow. I don't know. I wonder about this each day. What do you think about?
What do I think about it?
Yeah.
Well, I won't give you my exact opinion.
Cool.
But I will talk about the subject.
Oh, I thought
to no end.
I thought you said you will give your exact opinion.
Oh no, I won't give my opinion on it, but I will talk about it.
Why not? Is it offensive?
No, it's not. It's not offensive. I just don't want to give away. I might as well tell everyone the secrets of my soul.
Well, that sounds intriguing. Now you want me to ask. You want me to? Now I want to prod you further.
Well, it's like keeping a woman interested in you. You got to stay mysterious. Don't tell them anything, except you're beautiful, baby.
You got to keep the show going, buddy. Because if you tell them everything, then not mysterious anymore.
Then you're no longer interesting, and Chad Bronto Dick becomes more interesting.
You're hilarious. That's why I'm here. Because this place is hilarious. Entertainment, surprising,
Well, it's always entertaining when you find a bunch of crazy people who had a momentary glimpse behind the veil.
That sounded funny.
Well, that's what happens. See the truth, and you either turn into a lunatic or you embrace it and laugh with it. So.
What about both?
I don't know. I mean, we're creatures of duality.
Well, that is a way to simplify it. Yes. I think there's only one energy, but yeah, it takes a form like duality in the way it's routed.
Yep. Not crazy. That's reasonable.
Yeah.
And it's not contrary to any mainstream ideas either. It's just it's subtle. I think it's a mechanism and not a finality.
Wow.
So I think that duality is there, and I do think to some extent a collective thought is there, but I think it's just part of the mechanism, and that it's not the final reality that you experience. A lot of times when you don't understand the black box, what's in the black box or how the black box works, you just kind of start looking at effects of it.
Yes. I see where you're going so far. That's very interesting. I'm very fascinated with what you're saying. There could be we're describing the mechanism. Yeah. And you don't want to get lost looking at the effects.
Right. I think that's what a lot of spiritually minded people do, is they get stuck looking at the effects and thinking that the effects that they see are the cause.
The light show, but you're not seeing how the lights are functioning.
Yeah.
Yeah.
Well, too, you could know how the lights are made, too, but that doesn't mean that you know anything about the cause of how that happens or the why.
Very wise.
Right?
Very wise what you're saying.
Don't worry. When you die, you'll find out. That's when you get to find out.
I think you're on to something. I've died once before, but I didn't really find all these answers. I was only in awareness of seeing my body. No idea. Like I only caught a glimpse at being out of my body. Who knows where that spirit goes? I mean, I'm talking about my. I don't know. I mean, when I say who, I mean I don't know. Beyond that, I only briefly was outside my body once.
You mean you don't know the nature of what is beyond?
No, I don't.
How could you? The truth is, if you knew it, you couldn't live with it. I mean, if you think about it like this, you could never, the fish can't get outside the fishbowl and know and really understand what it means like to be outside the fishbowl. So there's no human frame of reference that you could ever think of that would make you understand the nature of the divine realm or the sea of souls, heaven, whatever you want to call it.
I see the logic you're illustrating. Yes.
Right. So we come up with concepts, and people get hung up on the concepts of the mechanism of how it works.
You have thought much on this subject.
I have thought a lot. I always found it more interesting than just. I mean, that's why I became a flat earther.
Yeah. I think a lot of the subject also, but I don't have all these answers. But I share similar questions.
Wow, there's a lot of noise, like background humming coming from my mic.
No, I hear you crystal clear.
No? Yeah. Okay. I know on my end, like there's a guy who builds race cars and drag cars who's like a couple blocks over from me. Huh. And I can hear them. I love the sound. They don't bother me.
Cool. Hey, your mic is doing a great job of clearing that out. I don't hear that at all.
Okay, cool.
Fine. But I think we both wonder similar things, and yeah, I wonder this each day.
Hey, the big questions are the important ones.
What's going on outside the fishbowl?
But you know what? Ultimately, it's a pointless endeavor to try and figure it out.
Why do you think so?
Because you're going to figure it out. And like we're all going to figure it out.
That seems very probable.
Yeah, well, when you die, you're going to figure it out.
That seems very probable.
So when you're in the profane world, the temporal world that we live in, you go through it, you level up, you play the game,
wow.
And then you find out how well you did in the end.
Wow. That is logical.
That's why I tell people there's nothing to be scared of. Everything, it's just a ride in the end.
Row your boat.
Gently down the stream.
Yeah. See, life is but a dream.
But whose dream?
Forgot about the merrily.
But
life is but a dream.
But whose dream is it?
Yeah, that's what I was wondering for a while.
I think it's all of our dream at once.
Is it our dream, or is it something else dreaming?
It might be the singular dream, the singular dreamer.
Yes. I think it. Well, I don't know, but I suspect it's one dreamer decentralized.
The one that created consciousness, the consciousness itself, viewing life through our eyes.
Yes, I can make an example that a man can divide himself into his children, as we are all children of God. And I think of it like, well, there's only one dreamer. But I've been trying to figure out, wouldn't this entire world itself be another layer in that same way?
Another layer of what?
In the same way, like how I'm a son of my father, and also we're all, we're all sons of God, and the world itself is perhaps like a son of, something.
For myself, I don't ponder those things too much. What I do is these days I just try to just be and experience. I want to be present in the moment in reality as much as possible. So I just try to experience.
I constantly wonder this.
Are you Smurf? Are you you, or are you the accumulation of a bunch of experiences?
Wow. Now that is, I'm leaning towards the latter.
Accumulation of a bunch of experiences. Well, if that's true, then how could you possibly review those experiences? Who's doing the reviewing? Who's doing the reviewing? Wait, let me finish. Who's doing the reviewing?
Yeah. So think about it like this: like you're an ego, you're a soul, right?
The body is.
Well, I mean, your mind. Your mind that's your soul, that's your spirit, that's your ego.
I agree.
So that had to exist before it had any experiences.
Well, my awareness did, and it happens to be in my vehicle.
Well, that's what I mean. Well, your awareness, that's really the same thing as the ego and the mind.
I'll give you that. Yeah.
So if you think about it, who you are is that. That's who you are. You're that spirit. And you're having all these experiences.
I like to think of it. I like to think of it as like the face that you see when you close your eyes. There's a face looking back.
Whoa.
That's you.
Wow. I have not noticed that.
You're actually, when you're closing your eyes, you're looking at your face. You're looking at your face from the inside.
I have never seen my face looking back.
It's actually, I know it seems strange, but it's just something.
I got lost in that one, but I am trying to imagine what you're saying.
I can describe it like this. Like, let's say you're standing under a little cliff and there's a drop of water, right? You don't lose yourself in a drop of water, do you?
No.
Right. So let's say it slowly turns into a waterfall and you stand under there long enough and eventually you can't tell the difference between you and the waterfall.
Wow.
So you're like an ego that has all the experiences, but the experiences aren't you. They're just things. They're memories. And they don't have to be who you are.
I agree.
That's why people can go through ego death and let an entire life go behind them and then move forward like completely born new.
That's highly logical. Yes. Makes sense.
One of my favorite topics.
Mine also. I think that's a necessary path to go through this.
Oh, I have a couple pictures to show you guys. One is it's a little off topic, but it's one is of a 118-foot long sailboat. Yeah, and there's a sailboat behind it, docked right next to it. Behind it, that's about 200 feet long. That one's a powerboat. So let me show you this picture.
The body's kind of like a sailboat.
And I actually was up at the park and I took a picture of one of these trees that has about a 3.5, 4 foot diameter that fell down in the park. It's a very old tree, probably at least 80 years old, 80 to 100 years old. And so I took a picture of that. It was raining out there. But I'm preparing for the zombie apocalypse. So, if you're running from the zombie apocalypse, then it might be raining sometimes. Got to be prepared. Go ahead. Sorry, Mima.
Sonny, how's my audio? Is it good to you too?
Yeah, it sounds perfect.
Yeah.
Okay, good. I have a very nice mic for my PC, so
sounds really good. Sounds very good. I hope mine sounds as good. Mine's pretty good as well.
I have to speak more quietly than when I'm using my phone though, because I know it picks up a lot of stuff.
Yeah.
I've noticed that your voice is crystal clear. I have a super cheap, economical headset, Logitech. It's brand new from Amazon, but I got the cheapest thing.
Oh, it's coming through fine.
Oh, cool.
Yeah.
This one is for like doing like voice work.
Mm-hmm.
I like it the way it's set up. I like that you have to speak quietly because it's calming. You know.
Is it a condenser mic like I have? I think.
It's just a nice Yeti.
Oh yeah.
I think it's cool if you think you've got to speak quietly. I don't know. I hear you very calmly.
Well, I've headphones in and I can hear myself speak too, so
I
it
heard the
quiets
Yeti.
me down.
I think the Yeti is very good. I did have the Snowball, but I broke that. Now mine's very similar to the Yeti. It's called it's a Tonor, Tonor.
Yeah,
it's about the same price too.
Okay.
Yeah, it came with all the suspension holder, the whole thing. I bought the mic stand. I bought a good tripod mic stand, and it's a standard microphone audio cable. You know, like you use when you're actually live playing, because I have to have everything sturdy, or else I'll break it.
Isn't it funny how you can speak and your sonic waves resonate into this copper that resonates through the Ethernet cable that resonates through my audio cable
With only pulses, yeah, and it somehow comes back out. Yeah, that's pretty wild.
Yeah.
and it's fast, very fast.
You know who invented it?
Oh no, I have no idea.
A Mormon from Utah.
Wow, when did
What was his name?
Well, that wasn't his name. It was a Mormon from Utah. I don't remember his name.
Was it the 1800s?
It was in like 1902.
What, the first telephone kind of transmission?
Not the telephone. The first electrical pulse sound signal.
Oh, I gotcha. Okay.
Right. Alexander Graham Bell. What he invented was the
telephone.
The telephone where it. What was it? Where it had the mechanism.
Yeah, for the transmission and receiving. Yeah.
Yeah, he was experimenting with the pulse that somebody else had discovered.
Mm-hmm. Interesting stuff.
Oh no, I'm thinking the Mormon from Utah. That was television. He invented. He was able to convert the impulses to visual waves.
Okay.
Yeah.
I recall seeing some footage of the Nazis, actually, which I can't verify, but supposedly the Nazis using television in 1930.
They did the first transmission. The first televised transmission was by the Nazis.
Mm-hmm.
Wow, learn something each day.
They were using telecom, voice and video transmission.
Transmitting voice and video.
So they had this. Of
But
course,
that was about when the technology started for voice and audio together.
Well, yeah,
just a little bit before that.
It coincides with when was the light bulb? That was around.
Oh, the light bulb. That was late 19th century, like 1890s, a little earlier. I think the light bulb might be a Victorian invention.
So with the light bulb, then the vacuum tube technology came in. That's how they found out about those things, and they learned a lot about electricity and light at the same time, and how electricity works through those. Now, the vacuum tubes that powered every kind of amplification, like radio sets, like antenna amplifiers, all those kind of things were tubes, that all correlated to the about the same time. So the light bulb led to all of that, and then the transistor, of course, which is very odd that how that all came about from the tube technology to the transistor is kind of strange.
That is something that's interesting. Things went from like analog to in that way eventually, digital, electronic. I mean, when you started out, like it was analog that way. Yeah, they had like vacuum tubes and stuff like that.
Mm-hmm. That's what I was talking about. Yeah,
that's fascinating. I don't know how any of that works.
It's very interesting.
What say? What? Sonny, what do you say? What do you say, Sonny?
Sonny.
I was saying I don't know how any of that works, and Sonny started to say, and I accidentally interrupted you.
Dude, this cloud, there's no metal touching.
Oh.
There's no metal touching, but this electricity, 400 volts, up to 400 volts are coming in to the cathode, or the anode rather, into the anode that are powering this thing. So that's going from positive to negative. It's a direct current. The AC that comes in through the front end, through the grid of the tube, goes through a space where there's nothing touching. And because of the differential, of the voltages, which you can adjust, you adjust the cathode so it's slightly, it's hard to describe. I'd have to do some reading before I do a presentation on it. But it goes through, and it goes through the opposite way. It goes through all the way from negative. The electrons fly off the plate to the anode in the opposite direction. They go all the way through, and that's what the AC is riding along the DC current. They're both coexisting on the same wire, same time, going in opposite directions.
That sounds more advanced.
Yeah, so the AC that's coming out from my guitar all the way through the wrong way through the tubes, and then to the output transformer or coil.
Done in a somewhat of a vacuum, like a low depressurized, or is there a gas?
They're vacuum tubes. Wow. Just like you. Yeah, it's an amplifier. So it's a guitar amplifier.
It sounds more advanced than digital.
It's just some magic is happening, just like Mima said. Like inside those tubes. I think that's how they discovered a lot of these things about light. Like I used to read about studies they used to do and tests they used to do where it's analogous to, they say this electron goes into this bowl, and when it enters the bowl, it disappears, and they can't tell where it is or how fast.
Sorry about that.
And then it reappears magically on the other side. Yeah, like it disappears.
I heard that, but it was very slight sound. You don't gotta apologize. It was very tiny, faint sound.
Oh no, that was me adjusting my mic stand.
I was just letting you know.
Yeah, it's all right.
But hey, it wasn't very loud at all. But hey, Sonny, that is fascinating. It makes me think a lot about. Well, I never heard this before.
Well, yeah, it's counterintuitive to what, like I could actually say, like if people say, is it objectively true that electricity goes from positive to negative? Well, you know what? I just disproved it. It doesn't. They can make the electrons flow all the way the wrong way through DC current. They can make an AC ride the opposite direction.
I didn't know that. I just believe you. You sound like you know a lot. I don't know anything, so I didn't know that. I was just saying I didn't know that before, but I believe.
When I started reading about how these tubes work, I'm like, holy crap! What is it doing inside there? That's really bizarre. Like how can it maintain the exact vibration, that frequency through this space where there's nothing but a vacuum? There's no metal touching. So normally how you think electrons are traveling through a copper wire, these electrons are going through a vacuum space. There's an actual gap.
Like an arc, like architecture.
They're arcing across, yeah. However that happens. Like,
do these things last forever, or if they're made if they're made properly, or do they like burn out eventually?
No, they burn out. Yeah, they have a lifetime, just like a light bulb. They are actually light bulbs.
Well, maybe they're slightly different than light bulbs, right? Or
no, they just have a couple different places where you can interject. Like it has a positive and negative, just like it has an element that glows, just like a light bulb, and it has a grid that goes in through. Well, it's hard to describe. You'd need to see an illustration or a picture of it.
Oh, I'm visualizing what you're saying just fine. I just never knew any of this. I'm rapidly. I believe I grasp what you're saying. This is fascinating.
Yep, and it's very fascinating because just a series of simple components like resistors and capacitors, you can make these tubes do pretty incredible things.
Probably anything a digital computer could do. I'm if you did to scale it up or down, you know what I mean?
It's just analog. When you're dealing with sound, it just has a different quality of sound. It has a different tonal characteristic.
Yeah, wow.
Yeah.
is like a harmonic. I don't know how to describe. I mean, reality.
Think about that. A lot of the cars in the old days used to be 6 volts, and they had tube radios.
I don't know about that, but of course, sure.
Even some of the early cars, well, not all of them had 6 volts, but the 12-volt cars back in the old days, from the 30s on up, they all had tubes and everything. They even had, I think they even had vacuum tube heaters or different kinds of devices in there, but everything was with tubes.
I've never heard a tube radio playing before. It's before my time. Have you heard of that before?
Yeah, I grew up during that period.
Oh, does it? You say it sounds different. Right? Is it clear?
Yeah.
Is it possibly clearer or the opposite?
Clear isn't really a term that I would use for it. It's like, it's hard to describe.
Different, yeah.
It has a different quality of sound compared to digital.
I don't think I've ever heard analog equipment like that.
Yeah, you've heard a lot of analog equipment. Probably.
I mean,
everything. Well, in the music in all the music that you've heard, most of a lot of the music is analog. Like only the newer music in the last like 30 years is digital.
Well, the thing was that analog music was recorded or digitized, and I wonder if that drastically changed the sound wave. You know, when I hear it through my digital speakers.
A little bit. I think what it does is it kind of strips it down to its bare basics.
Wow, that makes sense.
So, like, let's say, for instance, things that make music sound interesting, like live music, sometimes you'll hear room effects, you know, or you'll hear sounds from the room.
Well, yeah, I have listened to a lot of live music, so that would be all analog, right? Or a lot of it, or
yeah, that would make it more realistic, right?
I mean,
So
is all the instrument when I go to the bar? I don't drink anymore, but when in the past when I go to the bar and they're playing, is all that stuff analog? Even though it's digital, I meant to say even though it's electric, is all that stuff analog?
No, it's all digital because it's coming out of some modern output devices. And most people don't have tube amplifiers anymore. Some people do if they're an audiophile.
Oh, so I might not have actually heard before an analog electrical device. Or
If you've gone to live music, most of the modern live music are using tubes in their amplifiers. So yeah, you probably heard a lot of.
Please pardon my ignorance.
Most of your live music, like most of the people that appreciate good live sound of like say rock, blues, jazz, like they all use tube equipment. They've gone back. Actually, us guitar players are the only thing that's keeping the the tubes alive.
Cool.
They probably would have passed into obscurity by now if there hadn't been people that appreciate and like those.
I just find it fascinating. This is the first time I've learned anything about this technology. I never went down that rabbit hole.
Yeah,
that's fascinating.
See, no problem. The first TVs used to be these huge freaking consoles, and they normally had a TV set in the console and a phonograph and a radio.
Whoa.
And the speakers all built into this big cabinet that was about 6 feet long and 3 feet wide and about 3 feet tall.
That sounds super cool, man.
Yeah. I used to find them and tear them apart and pull out the tube amplifiers.
That sounds awesome.
I wish I could find more of them because now you don't see them anymore. Like very rare.
Oh no, I've never seen anything like that before.
Mm-hmm.
I'm a millennial.
Thrift stores. You've seen them. You just didn't know what it was, probably.
What store? Bookstore?
At thrift stores.
Oh, thrift stores.
Used appliance stores. So,
I've only been to maybe a couple of clothing thrift stores. I don't really shop much. But hey, that's fascinating, though.
Yeah, thrift stores where like people sell their junk like items like they don't want anymore. So a lot of times those used to be in thrift stores a lot. Those big cabinets. And before, like sometimes there were big TVs. They were huge too. Even I remember like when our neighborhood, when the first people in our neighborhood got the colored TV, it was like a celebration.
Oh yeah.
Yeah, I remember that.
mother told me how when microwaves were a new thing, that the neighbor would stop by to use it frequently. Like, wow, microwave.
We were afraid at first to use them. I was like, "Whoa, I don't know. I'm gonna get radiated." It was probably true.
Grew up with it, but as an adult, I've never purchased one, never had one, because I'm terrified of that stuff.
They were probably practicing. They were probably practicing with the technology. The early models may have leaked. Who knows, man? How would we know?
I went on YouTube. I meant to say Amazon. I don't know why. Well, that's fun. I went on Amazon and I typed in retro tube radio. But I'm wondering if they just looked at style. I'd have to really, I don't know whether or not they actually make tube radios anymore. But they at least they look cool on the outside. I'd have to figure this out. But they really look cool though, man. These retro radios. Man. Anyway, fascinating stuff. I wonder what would happen if we continued using only that technology into this day and age. If we never got into digital, I wonder what the world would look like, dude. Imagine if everything was like vacuum tube based, all this stuff you described, like automotive and everything. I wonder what the world would be like, man. Because a lot of time's gone past. We could have scaled that and hey, that looks really cool. I like the style of it. But I wonder what, because we tend to refine technologies. What if we just never thought of digital? I wonder what technology would be like today if we stuck with that sort of as a foundation. It'd be really cool. I don't know. I think you could make a computer with that sort of technology. I don't know how it would compare.
They did, dude. They did. In those days, in the 60s, they had like the first computers, like in the 60s, they filled up an entire room, is what I understand.
I'm ignorant, man. Of course they did. I must sound like a fool. Well, that's cool. I just like hanging out on these different channels, getting my mind blown. And I thank you for I never jumped down that rabbit hole, and I've never experienced that sort of technology, man. So thank you for sharing that, man.
Yeah, I'm gonna try to show you. I'm gonna try to find one of these huge cabinets. Let me see. I'll show you what these TV. Let's see. I'll go to TV, phono, and radio console. Let's see. They were huge, man. I mean, it took two grown men to like move these things around. Let's see. Yeah, they were giant. They usually look like something like this. Let me see. Here's one. Yeah, look at a Smurf. That's an old computer.
That thing.
It looks like. Wow. Here's a console.
That looks cool though, man.
That's a newer one actually. The older ones looked like yeah, this is like 50s. This is about 50s.
Are those like cathode ray tube screens? Is that what they're called?
Cathode ray tubes. Yep, exactly. Here's
I wonder, compared to an LED screen, which one are they equivalently safe, or is a cathode ray tube potentially dangerous? I have no idea. What do you think?
Wait a minute. A tube is a tube. A screen is different. So if you're talking about screens.
Well, I mean that like an old school, like a.
Oh, those. Oh, you talk about TV. Yeah, that big, huge tube. Well, it's radiation coming out.
Yeah.
So yeah, I mean,
that cabinet's cool, Sonny, with the record player and the.
That's how they all looked. Here we go. This is what I grew up seeing in everybody's house. Here, like this fabulous 1962. What is this?
You don't sound.
And what's that? Is that a?
Hold on. Here's
a radio on the right. Or
yeah. Look, hold on.
Receiver?
Here's. I'm going to post this. It's a 1960. 52 Magnavox Theater TV radio phonograph with remote control. 1962. This is what everybody had, this console.
Were the remote controls wired or wireless?
Yeah, they
They're
were
wired, yeah.
Yeah, they didn't have any. Yeah, they were wired.
That's cool.
And some of the older ones looked like this is like the early 50s, and it just looks like a cabinet. And it has a TV. Let's see, this one. I'm posting it now.
First one looks like a barbecue.
Here's what some of the older cabinets look like. Some of those were just radios. They were huge radios, giant. Like this thing right here is a radio. It's about 5 feet tall.
I'm going to assume that, I don't know, I assume it's harsher on the eyes. Like Jenna just said it's like an X-ray. But I don't know that. I mean, I would assume that it's bad for the eyes.
Here's a radio cabinet. That's probably from the
look at that.
Late 30s, early 40s. I bet that one is there. Let me see if it's a 1938 Art Deco style Philco tube floor console radio, model 38-31.
Did you just go to the museum or something? Did you?
No, I just typed in a search for tube radio TV consoles, and this one.
Oh, they look like photos you've taken.
No, I'm just. This is all from the internet. This one looked like. This one has a link. You can look at the details in that one.
Notice they used a lot of wood, and they did a great job polishing it with decorative pattern. We don't do.
Oh yeah, they were artwork. There was really good carpentry and finish work done. Yeah, they're pretty cool. Let's see. Vintage Silverton Magnavox consoles. Let's see. Pretty fascinating how everything changed, man. So here's what one of the amplifiers looks like inside of one of these. What I was talking about. What's going on inside these tubes? That's what the amplifier looks like.
Oh, that's neat.
That's what I used to tear out of those consoles when I'd find them. Sometimes people would just throw them out.
Did you just restore an old tube amplifier that you were playing the other week?
No, that one is a Fender. It's about a 20-year-old Fender Blues Junior that I highly modified. Yeah.
Pretty cool sound comes out of it.
Cool. Glad to hear that. I've worked. I got to the point where, okay, no more tinkering. Just leave this one alone now.
Yeah. Sometimes you can go too far, yeah.
Yeah. So they didn't tell us, but back in the old days, sometimes you could get back into those TVs. You could kill yourself if you touch that cathode ray.
Whoa.
That tube in there, yeah, has thousands of volts in it.
Whoa.
Yeah, it would probably blow a hole in it through you.
So these pictures you're posting here too, Smurf. My dad was into computers from pretty much when they started needing programs and stuff like that. He's been a programmer his whole life. I used to go to work with him sometimes when I was a kid in the early 80s, and we'd go to these big, like he was in these big offices writing programs, and he'd go, we just got to go down to the computer room. I go, what? And we'd go down, and there was a whole floor with computers behind glass panels, and the whole floor was air conditioned, like down to 18 degrees, Wow. And that's 18 degrees centigrade. So, and mate, the whole floor was a computer. These things were massive.
Back then, did your imagination? Did you ever wonder that such sort of devices would ever get anywhere, even remotely?
Nah, because I saw that, and then I saw movies like Terminator, and I was like, yeah, right.
So Timbo, what kind of what decade was that when you were seeing those rooms?
Oh, so this was early 80s, but
okay.
He was also, so he worked for the American military in Iran in the 70s. So he was doing the same thing there for the military. He said the rooms were even bigger then.
Yeah, outrageous.
So,
yeah,
so that
Tony,
was early 70s.
did you had? I posted it was called TV stabilizer, something like that.
Yeah, stabilizer.
Yeah, you need it. That is from 70s. You before you turn on the television, you need to turn on this machine, and you're somehow, I don't know what it's doing. It's heating or whatever. I think
I'm not
I
sure.
think something. I think it's connected something with the screen. You must, to first to turn on this thing for a minute, and then you turn on the television.
Yeah, it's like it takes all the white noise away or something, or the snow.
I'm not sure what that is.
Or static. Maybe it gets rid of static electricity.
It could be. I forget it, but it's.
It might
That's
have
funny.
only been. It might have been technology that was like really only in Eastern Europe or in those countries.
Oh, it might be. Yeah.
Could be because there is just some different technology.
Yeah. Like for example, in England, you have different kind of, how to say, electricity. The fucking everything. It's different here.
Yeah, you got to use a transformer. Yeah. Do you still have the transformers over there? So you've got things that work on old power, and then you've got to plug them into the transformer to convert them. Yeah.
Yeah.
I'll be back.
All right. Yep. So that big wall, that Smurf you post at 22F, those are all tubes. The whole wall is full of tubes, and the cabinets. That's why he's saying 19,000 possibilities. A bad tube, you had to look through 19,000 tubes. Can you imagine? That would take weeks. Weeks.
Yeah, those are things that are difficult to imagine.
Yeah, look at that thing, wave mixer.
It'd be like being inside the computer. Like a Magic School Bus stuff, man.
That looks like one of those German pictures. One of those German machines that wave mixer posted. I probably have a DM. I better check.
It looks like the old style. I think they call it retro. I don't know what it is. It's just like they put more care in it. These days, things are more economical, more into mass production, whatever. But it seems like things were more handcrafted back in the day, and they call it retro, I guess. They made everything artfully. I'm sure there was like factories where people had to assemble these things by hand, and that just makes a lot of sense. I mean, for a lot of reasons, For example, there's more jobs. For example, I'm all about free trade and efficiency. It just seems to me like things were more logical back then. We've sacrificed a lot of humanity for efficiency, or whatever. Like, hey, we made the products cheaper, but people lost their jobs, so they can't afford it anyway. At all. Like, hey, this product is, a multiplier cheaper. But if somebody doesn't have a job at all, then it's prohibitively infinitely expensive, actually. So what I mean? Anyway, I just think it's super cool how. I can imagine there's like these factories to make these retro TV, these old school TVs and radios and all that stuff, man. It must have been all handcrafted back then. And that carpentry, it just seems super cool, I just think it's cool. They got to keep making them vacuum tubes, man. I don't know. I just think it's really cool. These days, man, you could make everything out of like, everything's super centralized now, melted plastic and stuff. Was it like, perhaps, was it the 70s or the 60s, or was it the 70s when they started turning everything into plastic? I wonder. I don't know.
They actually started in the 50s.
Oh.
Yeah. The first plastics were in the 50s. And then they just, they used to make this thing called Bakelite. That was like the predecessor to the actual plastics that you see now. It was more like a ceramic. Like you ever see, sometimes these radios are made of Bakelite. like the radio I showed, that's really not plastic. Probably it's probably Bakelite, and a lot of the knobs and things are made of Bakelite. Old,
Is
yeah.
that made out of hemp or something? I'm just guessing. What is it?
No, I don't know. I'm not sure. Petroleum, some kind of petroleum product, just like plastic is now. It's a petroleum product.
You know, I don't really. I just don't like plastic. It's not as like aesthetic. If I use that word right, not as cool. You know, I just think the old style is way cooler. You know, with most everything.
Yeah,
Like just
yeah, because it's got what's
I mean,
called.
it's a bunch of plastic stuff anyway. But the stuff these days is not as cool.
Yeah, it's got mojo.
Yeah, that's a funny word. Yeah, I mean, could imagine going into the house back then. Everything beautiful, handcrafted stuff. It's got to be awesome back then. Nowadays, you know, half the stuff we use is plastic. I don't know. Even the automobiles were cool back then. Now they may not have, they may not have been very high performance, but they were cool looking.
Yeah, I'd rather have I'd rather have things around me like those days. Actually, I'd rather have those kind of cars and that kind of equipment than the junk we have now. I spend most of my time fixing things I've bought.
Yeah, I had a. It's very difficult to work on a modern car. I had a friend who had like an ancient Ford Falcon thing, and he opened the hood and it looked like a lawnmower engine. But I noticed it looked like something I could fix. It just looks something easy to maintain.
Yeah, we used to have a car like that.
Man, those cars are super cool.
My dad blew it up. My dad blew it up on Route 66.
Wow.
Shot a piston through the hood.
I've been on that highway long ago. That's that one from California, right, to across this country.
Yeah, it originally went directly from Chicago to St. Louis, and then all the way straight west to the coast in California at Wilshire Boulevard
I drove that highway one time.
or Santa Monica Boulevard, one of those boulevards. The 10, yeah, that goes the same place. That's sort of alongside of where Route 66 was, is where the 10 and the, yeah. And what is it? Further east, is it called? It's the 8, isn't it? Doesn't it turn into the 8?
Oh, I don't know. I'm not from the West Coast. I lived there about a year.
No, I'm talking about someplace in the Midwest. But yeah, you wouldn't know about that either.
Yeah, I live in Virginia.
Oh, that's right. I keep mistaking you for Flatman Kent because you sound Canadian a little bit to me.
Oh, you're funny. A Canadian, eh?
See,
I had a blast when I drove across the country. I would do it again. I think it took me about 5 days. I think I took a nap maybe a couple times. I'm trying to remember. But yeah, I think so. I think that's what it was. I did that a long time. I did that back in like 2011. But man, I would do it again. Yeah, it was fun. It's like a psychedelic trip to just cruise across the country. We're totally sober, but it's like that, to just cruise across America one way. It's mind blowing.
I'd love to do that now, actually, but I don't have a car. So.
Wow, you don't have a car? Is that by choice or what's going on, man?
No, it's because of finances.
Ouch. I don't have my own place to live. I'm working on that. I'm staying at a friend's house. But I do have a car, thank God.
And also before that, I lost 2 cars in 3 years because, the second one because I didn't pay registrations. So got away with that for a while. But eventually they took it.
I didn't know they do that.
Oh yeah, they just roll up in the middle of the night and steal your car from you. Yeah, that's right. Then extort money from you that I couldn't afford.
Would they be able to do that to me? I wonder. I have an old used car. Can they only do that to people making payment, or can they do that to me?
If you don't pay the registration, you don't display the proper registration.
Wow, I didn't know that's all it takes. Damn, I got a
Like
free.
you go pay your registration, you get a tag, right? You get a little tag, you put it on your plate.
Mine
Well,
recently
yeah.
expired, and I got to renew it. But I didn't know they could actually do that to me. Whoa.
Oh, they could roll up and just tow your car away. But I don't know about your area. Maybe they have a different policy.
Oh, okay.
Here they're like voracious. They're like land pirates, and they're freaking everywhere. You park your car in the wrong place, like they'll tow your car. Then all of a sudden you go to get your car. They say, okay, that'll only be a $1,200 for the first day.
They did that to me in a way. Not, I don't think it's as bad here, but a friend of mine borrowed my car to go to the store. On a mountain, and I didn't. It's a long story. He kind of stole it. I mean, I didn't give him permission. But long story, he got the car stuck in a ditch. This was many years ago. So the cops had it towed. It cost me $600 to get it out. They only held it overnight. $600. It's criminal. I think it's criminal what they're doing.
It is criminal. The whole thing is, you know why it's criminal? Because everything here in America has already been paid for and mortgaged by us from our ancestors too. Our predecessors, our families have paid.
Well, the
Like,
banks are taking it from us. I tell you, the car my neighbor was drunk. It's a long story. I don't need to get into a long story. But the thing is I showed up. I had two cars, so I showed up to pull it out. There's minimal damage, some dents. I showed up to, and I got a dent pull, but I showed up to pull it out of the ditch, and they refused to let me do it. They have their policies that they refused to allow me to just. All I had to do was pull it a little bit out of the ditch with a tow strap. They said, "Oh no, we're calling it a tow truck. Tow truck will be on the way to." And I had to pay $600. It's so evil that so evil. But I could have just pulled it out for free, or whatever. I could have. Anyway, long story short. So if I pulled it out for free, then I could have pressured the neighbor to repair it. But I actually ended up feeling bad for him, even though he stole my car, because he got DWI that messed him up for a couple years. And a man with a couple of young newborns and stuff. I just felt bad for him, So I never I just it's because of the damn government, you know. Anyway, tyrannical, man. Like you were saying, they're like land pirates. There's a joke out here in Virginia. There's a place called Guinea, and it's an area near Virginia Beach, and so they still speak Guinea speak, which it sounds like medieval. It's actually some sort of dialect of medieval English, and they call the cops revenuers. I think it's really fitting. The revenuers. They don't like the revenue. But hey, I love this place, man. Great to talk with you. I'm about to make myself some lunch, but I'm gonna take off my headset, switch the speakers on, and I'm gonna turn up the speakers and make myself something to eat. So it's great talking with you, buddy. I'm still here. I'm gonna still be here, but I use a headset. Otherwise, I make echo sounds. But I didn't eat today. I've been bouncing around Discord channels all morning, just getting my mind blown. But I'm
Likewise, I need to go. I need to go eat something too. So I'm kind of wondering about. I'm listening to.
I'm starting to starve here, man. But I love this place, so I'm gonna crank up my speakers. I hang out at roughly 3 servers at the moment, but just bounce around. But I was really awesome talking with Meme earlier. Meme is cool. But hey, I'm gonna make me something to eat right now, okay, buddy? Great talking with you too. I'll be back soon, though. All right, I'm gonna go away from keyboard.
Welcome, Flat Earth Debate Live. I'm your host, Creation Bear. And if you're new to this channel and you have not done so already, hit the subscribe button and the join and the notification bell to be up to date on when we go live and the rest of the usual. Please share the show on Facebook and Twitter. Sharing the show increases a more diverse audience and in turn increases a more diverse audience. Let's see. Today we are joined by Sunny, Aethergrass, Zarek, Smurf, Sasha, Morvis, Mike Power Swan, Michael Gleason, Jenna Massey, Effie Batman, and a whole bunch of people listening on YouTube. So welcome, one and all. Yeah, we'll see if we can get this panel cooking. Usually it takes gotta get the fire going. So we got a couple sparks in here. We'll see if get this conversation sparked up into something else. But yeah, we've had a couple of Globe opponents pop in recently. You know, the usual. Nothing you can't handle, of course. I I have a picture of a basket of loose cables. Let's see if I can find it. But I've used this example to sort of represent how a globe earther has a bunch of different unconnected points. And yesterday we noticed a gentleman who he was like trying to connect two that don't go together. So say you have a three prong, male outlet, and then you try to put it into a two prong, it's not going to fit. So he was trying to do things like that the other day. Let me see if I can find a picture of my cable basket. And hello, whoever just joined.
Mic check. This is Wave Mixer. I'm in my car trying to go ahead and listen in from Discord. I'm not sure if my mic is on or not. Can you hear me?
Sounds good. I got you 10-4. I found my basket. So I'm going to post in the chat this basket of loose cable. So yesterday this guy came in. He goes, well, I see curvature from a building. And we go, really? How? He says, Foucault's pendulum. So to tie this to the basket of cables reference, if you look at the picture, obviously there's tons of different cables, outlets, car chargers, USB, headphone jacks. So dude's literally just taking, and none of these are plugged into the wall. There's no power. And so basically that's what they try to do is they take this basket of cables and they try to plug things together. But the problem is nothing's getting any power. You just connected Foucault's pendulum to curvature. What the hell? Those don't even go together. So it's just funny how they operate like that. First, what they would have to do is get power. Plug one into the wall, then you plug something into that, and then you build on top of that. We call that, building on a foundation. But these guys have all these loose points. Gravity, Foucault's pendulum, curvature, it's all chucked in a bin, and nothing's connected, and nothing has any power. If that makes sense. So it's just funny watching them scramble to try to plug in a USB to this charger and then plug it into this. Well, you're not doing it. It's not really helpful. You just got a basket of loose cables. So yeah, that was really interesting. The Foucault's pendulum is how he sees curvature. I was shocked. It's like globe earth buzzwords. Just start throwing them out. Gravity. Refraction. Let's see. I have another screenshot from a comment I saw on another video. Nothing to do with flat Earth, but the comment says they never know the actual definition of the buzzwords they use. And this one was in reference to like, those types of videos you may have seen online where a guy or a girl will have a microphone or just walking on the street or some school campus or something. They go up to people and ask them questions. Oh, what do you think of this person? Oh, that person's a misogynist, patriarchal. It's like, oh, well, what does that mean? Well, so it's kind of common. The same type of mind viruses poisoned our globe opponents. Oh, refraction, gravity. What do those mean? Well, you look it up. Okay. So, yeah, just look out for the buzzwords. I noticed that when he said Foucault's pendulum. I see curvature from a building. Oh, really? How? Foucault's pendulum. Okay. So, yeah, that was just shocking. What else do I have? It's another good comment. Let me see. Yeah. Another comment I found, again, not flat earth related, but it ties to kind of the same type of people we deal with. But the comment says, she hasn't been trained, aka brainwashed, how to answer that. And I would say that's common when people come to debate the flat earthers. They haven't really been trained or brainwashed how to really combat our authentic arguments, because they've been brainwashed or trained how to debunk a disk in space, some strawman flat earth. That's the only thing they've been trained up on. They haven't really been told, hey, here are the flat earthers' arguments. They say this, that, and the other. Instead, they get like Professor Day videos. Well, flat earthers say 8 inches per mile squared. No, well, we don't say that, actually. That's the globe claim. It's not our claim. But so they, like I said, they've been trained how to debunk some sort of straw man. I thought that was a really profound comment, and it relates to the people we talk to. Let's see what else I have. You know, when you're surfing, folks, be sure to save stuff. I'm sure you come across headlines, so and so went to space, or globe related stuff. Be sure to save that. Get your screenshots, record a video or whatever, and save it, document it. And things get pulled off the internet quick. I was actually just looking for just a Pizza Hut commercial yesterday. The Pizza Hut commercial talked about they're advertising a pizza called The Edge. And man, I wish I had screen recorded it, because now the video is taken down. Can't find it anywhere, but it was just kind of like a subtle hint in there. He's like, we're going to take it to the edge, and no one has to know, just me and you. It was just really, felt like someone in the video, whoever made that, was poking fun or pointing to something. It was very subtle. Tell him you took it to the edge. It's like, what? So little things like that you have to grab and save, and we can talk about it here. But the memes are everywhere. So I'll just kind of go through my history and see if what kind of things I've found in the last couple of weeks that might tie to this. I did start a channel here in the server. I'm the only one that is using it right now, but at the very bottom in the other category, there's a channel called Articles, News, Clippings. So you're welcome to, if you do stumble across an article or like news clippings, just some ridiculous stuff from space or whatever. Go ahead and post it there. I got a bunch of funny stuff posted there that I find. Anything that I find, I'm gonna go in there. We can always refer back to it if we need to. But, continue through my history here. See what kind of stuff we got. Here's another comment. I thought this was relevant to the flat earthers, actually. Says, how to win an argument. Pre-counter every possible explanation. Doesn't that sound like us a little bit? We already know all their explanations. And so we don't have to create our new explanation, a replacement story. We just have like a pre-counter to their BS. So let's try to think of an example. Oh, we can explain sunsets. My counter would be something along the lines of, you think your house is moving? Like, how would you prove that the building that you're in is moving and going around the sun? Or some dude yesterday was saying the sun goes under the ground. I'm not sure if I have a screenshot of that. But yeah, I mean, that's how we roll. We just pre-counter their BS. Oh, you want to talk about outer space? Second law of thermodynamics. So, yeah, thought that was relevant to us. Oh, you want to talk about gravity? Oh, what's the scientific experiment for that? Oh, nothing? Right. Speaking of content, I did find this. I think I played it a couple times, but give me a sec. See if I can. And drop this in the live stream chat. And I'll play the ad real quick. It's only 6 seconds. All right. Yep, just a small clip from an ad that I found on Google.
It's not like we're sending people to the moon, but we act like we do.
This was like a golf commercial. They were trying to sell a golf club. This is Titleist. If any golf heads out there, yeah, Titleist commercial. And then so they, in the ad, they literally show like what looks to be like a freaking Globe Earth golf club hybrid. Old Haas says, "What's the channel you're posting these space adverts?" It is in articles and news clippings. I'm not sure if that's open to everybody. You might have to have certain perms to get in there, but if you can join, you're welcome to post anything you come across.
I don't know about perms, man. I heard they're bad for hair. Probably make me look funny. What's up, dude?
Hey, what's going on? Well, it's funny you say that, but because everybody, the grass is always greener, right? People who have blonde hair want to make their hair brown. People who have brown hair want to go blonde. People who have curly hair want to go straight. People who have straight hair want to go curly. Perm, yeah, it's just funny. The kids, the teen boys these days, they're super into like the curly hair or whatever.
What? Be happy as you are.
Not gonna lie, dude. My hair is actually I'm mixed, but my hair is permed like James Brown back in the day. So it's hilarious.
That naturally occurring thing.
Supercuts. Yes, Old Hoss. Yes, I've been meaning to save that one. I just for some reason when you click on the ad while it's running, it won't let you like pause or rewind or anything. But I've been seeing that ad all the time. So it's a Supercuts commercial, a haircut commercial, and that's funny you posted that because we're talking about hair. But so they're like, all right, divert the asteroid. Let me just play it. Actually, let me just play it. This should be a pretty short ad.
Okay, Mike, it's all you now. Take control of the satellite and divert the asteroid off its path. Mike? Where's Mike?
He's getting a haircut.
He's getting a haircut now?
Technically, it's not just any haircut. It's Supercuts.
Supercuts.
Supercuts? Supercuts. I'm in and out super quick, and they even throw in a hot towel refresher.
Yeah. So they're all like in a control room. Dude, he just pops behind the computer, presses, the space bar, and boom, done. That's a funny ad because I don't know, it's kind of ridiculous. It just shows how like they're not really doing anything. They're just sitting behind a computer. Everybody's clapping and jeering at a screen. Divert the asteroid. Oh boy. Yeah, Old Hoss gets it. Yeah, that's exactly what I meant. Those ads aren't that bad either. I got to give them some credit. They're not super annoying. But yeah, I've seen that one a bunch. But yeah, if you can post... actually, I'm going to post that link in there. But you guys are welcome to go and post some things in the articles room. Yeah. What else? What else have we got? There was a really good show called The Boys. And there was a...
That show's so bad, but it is good.
It's bad, but it's good. Yeah. It's
Yeah.
Someone told me that you need to be sort of already a little red-pilled before you watch it. Like if you are susceptible to agendas and stuff like that, maybe be a little careful. But I watched it and I was really impressed. I thought it was very good. But there was a scene... Let's see if I can find it. And I was watching it on Amazon Prime. So if you have Amazon, you should be able to go just watch it there. But if you need like the sneaky, you might maybe DM me. I might have some help for you. But there was a scene like it's like a cut scene. Actually, not a scene. It's just a shot. And you could see like 3 cities. It was such an amazing shot. I could not screenshot it. The Amazon Prime app just... I don't know. When you screenshot it, won't actually take the screenshot. It goes to a black screen. They don't want you recording stuff, I guess. So I had to like use another phone to take a picture of another screen. So if I can find that picture, I'll post it. But it was beautiful. So it's just a really high up, kind of an aerial view. But you could see like 3 cities. Maybe it was in Texas or something. It was beautiful. It's like kind of impressive. You would think that there would be some curvature, right? But let me see if I can find this. Yeah, so either you've seen The Boys. Yeah, if anyone out there who hasn't seen The Boys, I would recommend it. It's a fairly good show. If you're bored. I think it's only a couple seasons. But the acting is fantastic, man. It's really good. Let's see if I have this picture. I might not have it. It was amazing. I mean, you don't get those kinds of views here where I live. I'm here in Ohio. I live in a valley, so it's just trees everywhere, valley over here. So when I took my first trip out west, I was just like shocked how much you can see. And so that's what this shot kind of shows, is like you can see so much more in the distance when there's not trees and valleys blocking your view. I don't know if I have the shot. I'll have to try to dig it out somewhere else. Okay, a couple people popping in. Let's see who's joined us. Brandon Worrell just left. It's probably no rolls. Brandon Worrell and The Truth Acknowledged. Welcome, folks. Just shooting the breeze, getting this fire started. I'll take one more look and see if I can find this shot.
What fire are we getting started?
Well, the fire dies down every now and again. You got to put some logs on it to keep it going. You know what I mean? So
we got this trash bag filled with a bunch of broken globes.
Broken globes, yeah, they are flammable. So throw them on.
Can we fix these broken globes?
Nah, just
might be able to flatten them out.
I think it's always been flat, dude.
I'm just saying they wrap the flat around there, so I mean you might be able to salvage some of the maps, but nah, just chuck in the fire.
I was just looking at some
well
stuff.
Well said, brother.
Look what I found here. A Lego globe, but they actually have like a mini flat Earth on the bottom. Truth in plain sight.
Nice. It's weird though that it's built that way. Then again, that does kind of look like a footstool.
Oh, I found it. It's a really bad quality picture because it's a picture of a screen. It's like me taking a picture of my iPad screen, so it's not that great, but you kind of see what I was rambling about for the last 3 minutes. But yeah, you see city on the right. There's another city, and there's like 4 city, like downtown, metro areas in this one shot. It was amazing. I mean, I don't know how wide that is, but it looks freaking huge.
There might be a way to take a screenshot. Let me try something. Wait, I can't. Never mind. I'll try something later and see if I can.
Yeah, I probably could do it on my computer. I was on my iPhone, so the app has some type of code that doesn't allow you to screen record.
Yeah. And even if it blocks screenshot, like the print screen button, there's other programs on the PC. I just work around. We have our ways.
Yeah, right. So I couldn't get a great shot of that, but and I'm not even sure what episode that is, but amazing shot there. You see like 1, 2, 3, 4, pretty much 4 metro areas. I mean, that they can't be that close together, can they? I mean, I don't know. Where I live, there's only one of those, and then you have to go up like 90 minutes to Columbus, and there's another one, and then you go up again to Cleveland, and there's more downtown, like metro area. So we've got our 3 big metro type areas here in Ohio, but there's like 4 of them in the span of who knows how big that is, and I don't even know where that is. Let me see if I can figure that out.
I was thinking that if you source this from that show, we don't know if they've added in anything on the into the background or something using their 3D stuff.
So it says that The Boys was filmed in the city of Toronto, despite the series taking place in New York City in the comics. So this was in Canada, I guess?
That's in my city.
Toronto? Does that look like Toronto?
Where? Let me see it.
I see China.
I don't see the CN Tower anywhere. Maybe it's down Yonge Street. I don't know. Usually when I see a picture of Toronto, you're usually seeing it from the CN Tower.
I don't know. I had a couple. I had hit 1 or 2, puffs before I watched this episode, and when it popped up, I'm like, whoa, dude, that's a hell of a shot. So I was trying my hardest to try and capture it. And that's the best.
Oh no! Like, but honestly, like if you get up into some of these buildings in Toronto, and you get into the really, really high floors, it'll look flat like that everywhere. You can even see it from the buildings themselves. Like you don't need to go high up in a plane or anything.
Yeah, that's why it was funny. That guy yesterday was trying to tell us he was in a tall building and saw curvature. Hold on.
Like one of the days I was working in a tall building close to the lake, and I was seeing like across the lake maybe 8. Like I could see part of the lake like 8 kilometers out.
8 kilometers, yeah.
Yeah, I was high up in some building working. I could see far out.
And this guy saw curvature because he was on a tall building. What was he in? The Tower of Babel?
Maybe his brain's curved and the neurons are curving into each other and it's not letting him process properly.
Bent earthers.
That's what's so funny, man. You can really... We're basically doing like flat earth jiu-jitsu in here because you can take any random sample of however many globe earthers. I should take 10. And ask them, how high off do you need to see curvature? One of them's going to say, in a building. Another person's going to say, at the beach. Another person's going to say, in a plane. Another person say you can't see it at all. They've got mixed signals, so it's easy to tie them into a pretzel. The first guy that we talked to said that he sees curvature everywhere. It's always there, everywhere. The second guy was like, well, due to the surface area, locally... I don't even
surface area? What do you mean? Due to essentially, because this ball is apparently so big, it's going to be flat when you look at it from the ground.
Yeah.
And you can only see that it's a ball if you go up into fucking... out the atmosphere, close to the moon, look down.
Right.
Good luck doing that, though.
He was just using buzzwords again. Oh, well, surface area, due to the surface area. Like, what are you even talking about?
Due to the surface area. That's the most ridiculous way to put it.
So that's why I called him out.
You could just say due to the size. You'd have to be so far to see its curvature.
Yeah. He's like, well, when you get close, you see
due to the surface area. That sounds like something ripped out of Google.
Yeah.
And Neil deGrasse Tyson is correct with that statement, and people said he is not. If you're 2 millimeters above the ball, of course that you cannot see the curvature.
Right. Ah, man, they're crazy. Dude was saying that he sees curve at the beach. And his buddy was saying he sees it in a building. We're not even able to... At that point, you're not working on your flat earth skills. You're educating some dummy on their own worldview. Hey, just so you know that you can't see curvature at that height. You know that, right? Well, due to the surface area. Shut up. You don't have any reference to any surface area, goon. You see what you see. What we all see. So you don't see curve at the beach. At least not on the water, all right? Might be on the beach.
You could see maybe, but I'm saying only maybe from left to right. But only maybe.
I think Embo or somebody else said that. They were like, well, left to right, you can't see it, but front to back, you can. Stop.
Front to back, my brother.
Who's a certified flat earther here?
What does that mean?
Like, who's able to give me an answer, let's say?
Answer to what?
I have a flat earth question.
What would qualify as a certification?
Yeah, so
we'll just ask the question.
Where do you get certified for that?
So basically, the plane, right? So if you go from California to China, the plane GPS shows it going west, but the flat Earth model only shows it go like.
Whoa. Do you want to present that flat Earth model that you're talking about? Because I never offered you one. I don't think anyone here offered you any model to go off of. So, do you want to present that?
No, I'm not an expert in the field, so you present me one. Please.
Wait. You said on a flat Earth model, X, Y, and Z happen. So, what model are you talking
I've just seen a general one. I'm not an expert in the field, so
there is no flat Earth model.
Look, let's just try to answer your question in another way, okay? Basically, it boils down to how do I go from point A to point B? Now, if I were to ask you on a globe, how do you go from point A to point B? You would just say, I point in that direction and I head straight there, regardless of whether I'm flying, walking, driving, droning, whatever. So on a flat Earth, it works the exact same way, my friend. You just head in the direction that you need to go. You need to go to the grocery store? Head in that direction. You go from point A to point B. It's a silly question at the end of the day. But people tend to look at a specific map and they go, well, on this map, how does this work? But the problem is we're not talking about living on a map. We live in reality. So you don't walk around on a map when you go outside. So you just head in the direction you need to go. Point A to point B. The same way you go to the grocery store.
That means that you assume that we have some model, and then you're asking question about what we don't have even. That means that you need to ask some another question. Good one.
I don't think you understood the question.
No, I dude, come on, hold on. You gotta give us some credit. It's not that this is the first time anyone's asked this question in particular.
I understand.
It might be the 7,000th time. So we're trying to address it in a way that will at least give you our position, because I get what you're doing. Like you're looking at a specific model or a map, and you're going, okay, well, on this model, how does it work? We're telling you that's not the Earth.
Okay, I'm asking you. I'm not telling you what the Earth is, right? It's not like I'm a glober coming in here to argue against you. What I'm saying is, show me a map of what you think the Earth looks like.
No,
because every
that's the answer. Listen, no.
Well, you're not having it, or what?
Sorry, there is no map. That is.
What do you mean? There's no map. There's the map of the world, right?
Hold on a second.
Yeah.
Hold on a second. So I posted in the chat many maps. Could you tell me which one of these is the globe Earth map?
What chat? Let me open the chat.
Live stream voice text. Let me ping you if you can't see that.
Which one of those is the map you're asking me?
Yeah. So if the Earth is a globe, which is the one map that is the globe Earth map, the one true map that we're all supposed to use? Which is the one?
Not any of these.
Why is that?
I couldn't tell you.
Are you sure? Did you look? How would you know it's not any of these? It's a high quality image. You should be able to zoom in and read the names, search the name up. These are not made by flat earthers, just so you know. These aren't flat earth maps, dude. These are globe earth projections. So tell me which is the one map that is the globe earth map. Or we could just rip the Band-Aid off and help you understand that there is no one true map of the Earth, regardless of whether it's a globe or a flat Earth. So that's why your question's a little bit flawed. You're like, well, on a flat Earth map, you would go this way. Which map then? Which map are you referring to?
Okay, let me
even for me, this is new, because I thought that there is 8 projections, but I can see there is 200.
And again, these are not flat Earth maps.
Yeah, I know. Yeah.
So what you're saying is there's no one map for any model, is what you're saying.
Regardless, even if you're a globe earther. Remember when you were in school, I don't know if back in the day, my teacher had a chalkboard and there were like 5 maps you could pull down and be one map, then another map, and another map. So this list of maps that I posted, I don't know exactly which one, but your teacher had, a couple of these on her chalkboard. So these are not flat Earth maps or anything like that. I'm just trying to help you understand that there is no one true map of the Earth. So when people come here and say, well, give me a flat Earth map.
But there is one map for the globe Earth map. There is one if the ones you learn in school.
Which one then?
Which one?
Here, I'll post it on the same chat. That's typical.
The question is is this the one? Dude, that's not a map.
That's not a map. That's a globe.
That's a decoration, as good as a decoration. Yeah. You don't have one of those mounted on your dashboard. You don't spin one of those while you're driving around. Okay.
Stevie, one important information. Do you know X-Part that globe? It's not for educational purposes.
Also, I don't have the clip on hand. If you give me a second, I'll find it. But I have Neil deGrasse Tyson. He said those globes that you buy are gross exaggerations. So even they're saying that that's not accurate. So if you give me a second, I'll try to find that clip.
Let me take this. Might make more sense. Look at this other one I just posted for the specific question that I have.
Okay, yeah.
It shows you if you go from Australia to South America, you're actually going west. You're not going east, and that's what the globe Earth map shows as a plane ride. What I'm asking is, if you're going from California to China, you can't go west. You got to go east, right? In the globe Earth model.
In
the flat Earth model.
If you assume that you're going around the sphere, that is the path. But you are not going. That. You look at the picture. Is that the real picture, or that it's a?
But I'm not saying it's a real picture. I'm saying on the globe Earthers defense, that's their map that they're saying that's where the plane goes. So you get on an airplane, you look at the GPS. That's what the captain's showing.
I understand you. That is the assumption that Earth is a globe.
Right. So what I'm asking is, if you're a flat earther, how would you go from China to California?
I told you, bro. Level is posted as well. You just head in the direction. You just go straight there. Just like you go to the grocery store. You're asking us basically, how do you go from point A to point B? It's a silly question. You just go that direction. What do you mean?
Can I ask you like this? Is it possible putting this in mind only? Imagine that Earth is not a sphere from California to China.
Yeah, but you have a GPS on the plane that's showing.
Okay, but they're showing you a cartoon. All right, this doesn't mean anything. The freaking headrest in front of you showing you a little cartoon of curved Earth, and then you look out the window and there's no curvature. It's just a cartoon, dude. And also, here we're trying to help you understand that there's a difference between the representations of Earth and Earth itself. Somebody's got some nasty feedback. Wave mixer.
What is the okay, I guess the question is, if that's the case, this guy's thank you. I guess the question is, what's the motive for these people to lie about the
come on, dude. Hold on, let me try